everyone, today we bring you the Data Analytics Full Course, a comprehensive learning program designed to take you from data analytics fundamentals to advanced analytical skills used in real-world business environments. Now, as we know, data analytics focuses on examining data to uncover patterns, trends, and insights that support decision-making. It plays a critical role across domains such as business, marketing, finance, operations, and technology, helping organizations measure performance and optimize outcomes. So in this course, we will start with the basics, understanding data, analytics concept, and tools, and also gradually moving on to advanced topics such as data cleaning, visualization, and analytical problem solving. You will learn not just how to analyze data, but how to ask the right questions and communicate insights effectively to stakeholders. And by the end of this course, you will be confident working with data, performing analysis, creating reports and dashboards, and applying analytics techniques to solve real business problems. Having said that, let's take a look at the agenda for this course. We will start off with the introduction to data analytics. Then we'll talk about data fundamentals, moving on to Excel for data analytics, SQL for data analytics. We'll also learn about data cleaning and preparation, exploratory data analysis. We'll see how data visualization works and also learn about reporting. We'll also show you how to use Python for data analytics, statistics, and advanced analytics concept. Then we'll talk about some real-world data analytics use cases. And at last, we'll have a look at career readiness and interview preparation. Hope I made myself clear with that agenda. Now that said, if these are the type of videos you would like to watch, then hit the subscribe button and hit the bell icon to get notified whenever we host. Also, just that you know, if you want to skill yourself, master data science and data analytics skill and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various data science and data analytics programs. Simplilearn offers a variety of master's, certifications, and postgraduate programs in collaboration with some of the world's leading universities like IIT Guwahati and many more. Through our courses, you will gain business and leadership knowledge along with work-ready expertise in skills like Python, Tableau, Power BI, generative AI, and over a dozen others. And that's not all. You'll also get the opportunity to work on multiple projects led by industry experts working on top-tier data and product companies. After completing these courses, thousands of learners have transitioned into data science or data analytics role as a fresher or moved on to higher-paying job and profile. So if you're passionate about making your career in this field, then make sure to check out the link in the pinned comments and the description box below. So what are you waiting for? Hurry up and enroll now. Now before we get started, here's a quick small quiz question for you. Which step in the data analytics process focuses on identifying patterns, trends, and relationships in data? Your options are data collection, data cleaning, exploratory data analysis, EDA, data deployment. Let us know your answers in the comment section below.
And the two steps are analyze the data and then make decisions based on the data. Applications of data analytics. Now, the sky's the limit on this. In today's world, almost every business, act of life, your music on your Spotify are driven by data analytics. But some of the big players, when you go in there job hunting, are going to be your fraud analysis. If you want to go make a lot of money and you're good at it and you like dealing with numbers, go join the banks and track down the criminals who are stealing money. It's a lot of, it's a big thing to protect credit cards, protect sales purchases, bad checks, any of those things when you can track them down is huge. Healthcare, exploding. There is everything from trying to find cures for the COVID virus or any of the viruses out there, using your cell phone to diagnose different ailments. That way you don't have to go in and see the doctor. You can actually just go in there and take a picture of the funky growth on your arm. Hopefully it's not too big. And then they send it in there and the data analytics goes in there and looks at it and says, oh, this is what this is. This is the professional you need to go see or don't need to see. And that's just one aspect of healthcare. The databases being generated by healthcare and getting the right doctors and helping the doctors analyze whether something is benign or malignant, if it's cancerous. All those things are now part of the ongoing healthcare growth in data analytics. Inventory management. Think one of those huge warehouses where they're shipping out all the goods. How do you inventory that in such a way so that You maximize the stuff that's being purchased the most near the entrance and all the other stuff towards the back, or even pre-ship it. So it's huge to be able to manage your inventory, and pretty soon they'll just have a drone come in there and start picking up some of those boxes and move them around also. Delivery logistics. Again, this goes from getting from point A to point B. You can combine it with our inventory, so you pre-ship stuff if you know a certain area is more likely to purchase it. How do you get the delivery to the most destinations the quickest in the short amount of time? And then they even pre-stack the trucks going out, and that's all done with data analytics. How do we stack all that stuff so it comes out in the right order? Targeted marketing. Huge industry. Any kind of marketing, whether you're generating the right content for the marketing, who are you targeting with that marketing, researching the people, what they want, so you know what products to market out there. All those things are huge. And these are just a few examples. You can probably go way beyond this, from tracking forest fires to astrology and studying the stars. All of this is part of data analytics now and plays a huge role in all these different areas. City planning is another one. You know, you can see a nice organized city like this one where you can get in and out of the neighborhoods if you're a fire truck. Police officers need to be able to get in and out. You want your tourists to be able to come in, yet you still want the place to look nice, and you have the right commercial development, the right industrial development, like enough residents for people to stay. All those things are part of your city planning. Again, huge in data analytics. So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up in the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. If we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change. Data analytics process steps. So let's take a look at some of the basic processing and what that looks like when you're working with this data. So there's 5 basic steps. The 5 steps of processing, and this changes, and then there's a lot of things that go on when they talk about agile programming. The whole concept of Agile is you take some kind of framework like this, and then you build on it, depending on what your business needs. So the first step is data collection. And usually with a large company, you might have somebody who is responsible for the database management. You might have another one where they're pulling APIs and they're pulling data off of maybe the Census Bureau, maybe something very, very specific, domain specific. So if you're analyzing cancerous growths and how to understand them, then the data collection is going to be those measurements they take from the MRI. Or it might be even the MRI images. They've used those also. So there's a lot of things with data collection and how to control that and make sure it has what you need and is clean and you don't have misinformation coming in. Once you have the data collected, there's a data preparation. So stage 2 is we take that data and we format it into something we can use. Probably one of the biggest formats that you see is when you're processing text. How do you process text? Well, you use what they call a one-hot encoder, and each word is represented by a yes-no kind of setup. So it'd be like a long array of bits. That's one way to prepare it. And so, bit number 1 is the. Bit number 2 is has, or whatever it is. Other preparations might be if you're using neural networks, you might be taking integers or float numbers and converting them to a value between 0 and 1. That way you don't have one of them creating a bias in there. So there's a lot of different things that go into data preparation. That is 80% of data science. So when we talk about the data analytics, which is a little bit more on the math side, and they usually talk about a data scientist kind of being the overall preparer of this stuff, you're going to spend 80% of your data preparation. Data exploration, that's the fun part. This is where you're exploring things. And it is maybe 10 to 15% of what you do with the data you spend with the data exploration. It is probably the most important step, because this is where you got to start asking questions. If you ask your questions wrong, you're going to get some wrong information. If you're working with a company and they want to know the marketing values, then you really got to focus on, hey, how do we generate money for this company? Or fraud, how do we lower the fraud rate while still generating a profit? 4, data modeling. This is where we start actually getting into the data code, which model to use that predicts what's going to happen. And then result interpretation. We want to be able to interpret those results. You usually see that in your Matplot library where you create nice, beautiful images so that it shows up on their dashboard for the marketing manager or for the CEO so they can take a quick look and say, hey, I can see what's going on there. You want to reduce it to something they can easily read. They don't want to hear the scientific terms. They want to see something they can use. And we'll talk about that a little bit more when we start looking at some of this in a demo.
So, firstly, let us understand why data analytics. Can somebody here tell me why data analytics and why is it used in organizations? So let us understand why data analytics and what is the use of data analytics. As we all know that data is growing exponentially year over year. It is collected and it is also available everywhere. Data is no more just available in structured format, but it is also available in semi-structured and unstructured format. I'm sure you would have come across this term called as sentiment analysis pretty often, right? What does that mean? Can we perform that in data analytics? Yes, right? We use some natural language processing models, try to identify what are the good reviews, what are the bad reviews spoken by the customer, correct? So we try to classify the text based on the good, bad, and the neutral. So that is what sentiment analysis is about. So for that, to perform that activity, we have to also do some data analytics. Now that companies have realized the importance of these informations, not just structured but also unstructured data format, the companies have started utilizing these data to take some crucial business decisions, which can boost their business and also which can increase the efficiency of the business. So now that the raw data is accessible to the organizations, it becomes very important that the data is also stored well. I'm sure you all have pretty much heard about data warehouse. In the last few decades, the trend was mostly on the data warehouses, the business intelligence tools. So the data warehouse used to collect this data, pre-process the data, and also filter the data and make it available in a structured format for further analysis. However, now that is not the scenario. A term coined as data lake is available, and many firms are utilizing data lake because it is a central repository which stores the raw data in form of structured and unstructured data. And now let us take a scenario. Let us choose one of the participants here, Mark. So Mark has recently joined an organization as a data analyst, or in essence a data scientist. The business connects with him and says that, Mark, we have a business problem for you and we expect you to provide us a data analytics solution. So Mark sits with the stakeholders and he listens very carefully to the business question. So the business question says that we have a couple of products which are performing really well in the market and we see higher sales. And some of the products are just not catching up in the market and we experience lower sales. Can you help us identify what are the factors driving these higher sales and the lower sales? Now, Mark has to think with the data scientist mindset and be prepared to ask them right questions. Some questions such as, do you have the price of all these products available in the database? And can I also know what is the duration of data availability? And also, Mark can ask some questions such as, do you also have some features of these individual products already captured in your database? So these are some of the interesting questions that makes sense to the business, and the conversation continues, which also means that data is not only information. Data analysis is about unlocking insightful information from this raw data. And hence, data analysis plays an important role in discovering insightful information, asking questions or answering the right questions, and also predicting the future or the unknowns. And to perform all these activities, we use data analytics. So are you all with me so far? Are we on the same page? Yes? Great. Now the question is, what is data analytics? So can somebody tell me what is data analytics? So let us see what is data analytics. We understood why data analytics and the importance of it. But to perform any activities, there has to be a process, right? So data analytics is a process to extract meaningful insights from data. Now let us continue with the scenario of Mark. So Mark now understands the business problem, and he has also started asking some relevant questions to the stakeholders, and he has also got the answers in return. He may start thinking about what could be the suitable solution for this. He may have to perform some exploratory data analysis to unlock some hidden patterns, to identify some correlation between the variables, and to also know which are the key variables in the data set. And he may also have to view the market trend, which means he may have to see that how the sales has been performing across the years or across the months. There might be some insightful information there. He may see that the sales has been growing exponentially for some of the products, and some may be volatile, some may have some seasonality pattern or a cyclical pattern, etc. And also he may have to focus on the customer preferences via the customer reviews and do some sentiment analysis. So now let us understand what are those life cycles of data analytics. We will begin with the discovery phase. This is the first phase. Now that Mark has understood the business problem, he will also start focusing on identifying the resources, that is the data resources. Some may be internal data resources that is available within the firm, could be some transactional data, and some external data sources may be via web scraping, identifying and capturing some competitor price on the products. After gathering all of these right data, Mark will focus on data preparation, which is the next phase. Now Mark, either individually or along with the team, will start focusing on the data preparation, which includes data wrangling, which means cleansing the data, imputing the records if there are any missing values, or he may also go ahead by removing those records if they are not required, and also doing some exploratory data analysis, which can include some statistical analysis like looking at the data distributions, understanding the summary of this data distribution at individual variable level, doing some bivariate analysis, and also trying to figure out which are the important variables that might be required for the model building phase. After performing all of these EDA activities, which also include some visualization, Mark will now sit with his team and try to identify the suitable models. The suitable models could be simple statistical techniques, or it can also be some machine learning models. So let's say that Mark and his team has identified some 5 models that can provide the required result. And out of these 5 models, they will filter down and they will prioritize only 3 models. Now there are only 3 models that Mark and his team have finalized. After this, they start focusing on model building activity. Now for model building activity, they have a data set already in place. So this data set will be split into training data set and test data set. It's not only training and test, we can also do some validation in between training and test. But here let's focus on training and test data set. He will separate 75% of the data as training and 25% of the data as test. Now if your question is that why perform this activity of splitting the training data set and test, can't we just go with one single data set? What happens if you just utilize one single data set? Let us say that you have used the original data set and also executed this data in one of the selected model, and you will also observe the accuracy. Let's say the accuracy returned is about 98%. 98% is a very good accuracy percentage. And you may also be overconfident because of this. That may be a case due to overfitting. Now what will happen when you add some new records into this data set and you rerun it? The executed model may not return you the same accuracy what you had seen. The accuracy might be 72%. Now that's not fair, right? To avoid these overfitting issues, we ensure that some new records are tested separately. So hence we locate 25% of the data to the test data set, and then we predict these records, the unknown records which is located in the test data set. We predict them and then we test the accuracy of training data set and the test data set, and we make a comparison. Now let us say the accuracy result of training is 98% and the test is 97%. In this case, we can say that the model is performing really well. However, while executing the model, there are certain things that has to be considered. For example, inclusion of the parameters, tuning the parameter, which also will execute the optimal results. So this is very important. Now let's say after performing this model building, the time comes to analyze the results. That is the next phase. Now the team will sit and analyze the result, and they will notice that out of the 3 filtered models, only 2 models are returning excellent accuracies. They will sit with the business team and they will also explain them the result and what are the activities that they have performed to obtain this result. Some of the stakeholders may be technically savvy, some of them may be non-technical people. So it has to be very important that you also communicate these results accordingly. Alright, now that you have the results, you will also gauge them based on the business objective, which was developed in phase 1. Looking at the results of the 2 models, now the business might select one of the model and say that, okay, this particular model seems to be returning some right information and it also appears valid to us. Let's go ahead with this one model. So finally, the result and the model needs to be operationalized. And that is where the team will start documenting the business problems, the steps that were taken for executing the models, and they will include all the codes and the findings. And finally, they will implement this model so that the business can view the results and also utilize them for strategic decision making at your firm. So are we good so far with the understanding of the life cycle? Alright, great. Now let us focus on the types of analytics. What are the types of analytics? Can somebody tell me which are the types of analytics you are aware of? Okay, predictive analytics, great. Descriptive analytics, good. Alright, good enough. Now let us focus on this example of Google Maps. So as we look at this particular Google map, we understand that the blue color route is nothing but the route direction from Sacramento to Florin. And also we see a display of the duration estimated as well the distance to travel from Sacramento to Florin. As well we see another route here that is gray colored. This is a substitute route or the connecting route just to avoid the traffic, which is in orange within the blue color route. So the gray colored route as well shows us the estimated duration to travel as well the distance. Now let us understand what is descriptive analytics and why do we focus on this particular map example. As we understand the route map, the estimated duration as well the distance to travel via the blue color route as well the gray color route. This is one way of understanding descriptive analytics, as in what is happening. But there is another way of understanding descriptive analytics, that is by focusing on summarized past data. And this is a descriptive analytics. We see that what had happened in the previous year. Now let us focus on predictive analytics. What is predictive analytics? This type of analytics looks into the historical and present data to make predictions of the future. What does this mean? So Google has already suggested the best route, which is the blue color route, to travel from Sacramento to Florin, and the duration is 18 minutes and distance is 9.7 miles. Let's assume that Google Map has already collected historical data of this particular route, and based on the available data, their model has predicted the best route, and also the duration that will be taken to travel from Sacramento to Florin. Now let us focus on prescriptive analytics. Prescriptive analytics describes the solution to a particular problem. What was the problem in this case on the predicted best route? Some predictions on the traffic congestions. And that's when Google Map recommends the substitute routes, correct? Now these substitute routes are also prescribed by Google Map as a recommendation. So prescriptive analytics is nothing but a solution and a recommendation provided for a problem. So in this case, we have the best route and we also have other substitute routes. So let's quickly summarize. Descriptive analytics is about summarizing the past data or to see what is happening, for example, in the Google Maps scenario. Predictive analytics is about what would happen. And prescriptive analytics is about prescribing the solution, the best solution and the recommended solutions. Now let us refer back to Mark's earlier scenario. Mark along with his team identified the best model. They also did some testing and they identified the best results, and they also finalized on one particular model. Based on that particular model, now the results have to be provided in such a way that they are the best results and also the recommendations, correct? So it may not be just one single solution. It may be a solution with couple of other recommendations as well. So that is exactly what happens in the entire process of data analytics. I hope this has been clear so far. Yes? Okay. And now let us focus on benefits of using R. Why do companies extensively use R for data analysis, and why is it chosen? Firstly, R is an open source programming language, which means that there is no license required to work with R. And R does not require you to have a coding experience, which means that a non-technical person in your team can also learn R very easily and start coding or building models in few lines of codes. R can also be used with other programming languages such as Java, C++, and Pythons. And the integration of R with other programming tools or BI tools is very simple and easy. And various statistical models are readily available in R, which also means that there are plenty of inbuilt libraries and packages already available. And reporting the results of an analysis becomes easier by using these inbuilt packages and for creation of these models in just simple few lines code. With this understanding of the benefits of using R, let us quickly hop on to R Studio and start performing the hands-on exercise for data analysis. For this exercise, we will use a dataset named as demographics, which is in a .csv file type. Firstly, let us load the dataset to R Studio, and we will locate this in an variable named as demo. We also refer to this as a data frame. And now you will notice that a variable is created in an environment section, which is in the bottom right hand side of the R Studio window. And this particular variable comprises of 510 observations or records with 8 variables. Let us simply expand this particular data frame and have a quick check on the data structure and understand the data types. This particular data frame includes variables such as age, marital, income, the unit of income is dollar per day, education levels, the car price, car category with several levels, gender, and retired status. Now let us view the top 6 records of this particular data set. For this, let's simply type head of demo. And the result is now visible in the console section. If you're interested to view all the records, then simply type view of demo. And this new window will show you every single record that is being loaded to RStudio. You may also simply apply the filters and the filter section here on individual categorical variables. Now that we have loaded the dataset and also viewed individual records, let us focus on creating subsets of records by applying filters on individual variables or multiple variables. So firstly, let us apply filter on gender. We will only retrieve the records where gender is equal to female, and we will locate these records in a variable named as demo2. As you notice now in the environment section, the second variable is also created, that is demo. And this now is comprising of 250 observations, which means the records are filtered down to only gender female. Next, let us see how to apply a filter on income variable. Let us only retrieve the records where income is greater than 100. Let's view the result. As we see here, all the records include income greater than 100. Now let us modify this query, and we will ensure that the retrieved records includes income greater than 100 and also specific variables are returned. Let's say we only want to have the first variable, third variable and the seventh variable returned as the result. Let's have a quick check. So we only have the first, third and the seventh variable returned. How about we only exclude the variable 6 to 8? For this we include a prefix of minus sign. And now let us see what is the result. We have the variables from first to the fifth variable, however we don't have 6, 7 and 8th variable. I hope it's clear so far. Yes? Alright. Now let us see how can we apply condition by including both the variables, that is gender and income, and then we will filter the record and create a subset of data. Now let's view the result. Income is greater than 100 and the gender is only female. This is one way of creating subsets. However, now let us see how to use the subset command and create the subset. Let's create a subset of records by applying filter on marital status and age. We'll only retrieve records where marital status is equal to married and age is greater than 35. Let's now view the result. So here we have the age greater than 35 and marital status is married. Let's use the same code, and this time we will retrieve selected variables. Let's say variables ranging from 1 to 3. Let's have a quick check. So there are three variables. Age is greater than 35 and marital status is married. Now let us see how to structure the data by sorting the data frame in ascending and in descending order. We will apply this order function on the variable income. Firstly, let us see how to order income variable in ascending order. Let's do a quick check. And here we have income in ascending order. Now let's see how to modify the same code and view the records with income in descending order. So we have now the income in descending order. How about include two variables and sort the variables accordingly? Firstly, we will sort the records by ordering income and age in ascending order. Let's quickly view the result. We have income in ascending and age as well in ascending. Let's now modify this code. This time we will order income in descending and age in ascending. Let us view the result. So the income is in descending and age is in ascending order. So hope this is clear on how to sort the data frame by ascending and descending order per variable or by using multiple variables. With this, we will focus on learning statistical analysis. How to perform statistical analysis on individual variable or multiple variable. Let's start by understanding the data distribution of variable income so that we identify what is the minimum value of income, what is the maximum, what is the range, what is median, what is the mean, and we will also focus on the quantile distribution, which is also analyzed in a box plot. What is the minimum value in the variable income? It's 9. And what is the maximum? So we have the maximum value. Now let us see what's the range. So the range shows you the result with minimum and the maximum value. How about the difference of maximum and the minimum? Now let us focus on other summaries of data distribution for this variable income. Let's identify what is the mean value of income. The mean is 78. Let's also understand what is the standard deviation. Alright, so the standard deviation is $112. Let us see what is the variance. The variance should be larger than the standard deviation. Now let's see what is the median absolute deviation. As you notice here, the median absolute deviation value is lower than standard deviation. Why do we make this comparison? From this, it is evident that median absolute deviation is robust to outliers and standard deviation is sensitive to outliers and also to the change in the mean value. Now let us understand the quantile distribution. This is the same analysis that is visualized in a box plot, ranging from 0% to 100%, identifying the individual data points. And we can also refer and compare this to the min, the max, and the median values. Let us quickly see what is the median value of income. As you notice here, the median is 45. As well, the 50th percent of quantile is 45, which means 0% is minimum and 100% is the maximum value. Now, if your question is what is 25% and 75%, this is again used for identifying the range of interquartile. The interquartile range is nothing but the difference of 75% minus the 25%. Let's quickly see what is the IQR of income. The IQR of income is 58. Let us do a quick check. 75% of quantile is 86 and 25% of quantile is 28. And the value is 58, which is equal to the IQR result. Now that we have focused on the statistical analysis of the individual variables data distribution, let us focus on the data visualization. In this, we will have a pictorial representation of analysis to identify the outliers, to see what is the minimum and where do we see the data densely populated and how is it scattered, etc. We will begin with creating a histogram. Now, histogram can be used for univariate analysis, which means in this scenario we will consider income variable and we will see how the count of income ranges gets distributed in a histogram. For this, we will have to install a package called as ggplot2 and also call this library ggplot. Let us install the package. Now let us call the library. Alright, and we are ready now to begin with visualization. For this, we will use the geometric object histogram on the data demo data frame. Let me expand this window so that the code is visible, and also use an aesthetic mapping for variable income. This will be helpful for filling colors or filtrations, etc. And only include 30 bins with individual bin size width of 100, which means there will be 100 incomes in individual bins. Let's quickly look at the distribution of this histogram. As you notice, there are a couple of outliers. The counts of these income range are very limited. However, we see the densely populated income ranges with higher counts between 0 to $200 per day. This is also a way to identify and segment the customers based on their income ranges. Now let us see how to change the color of this histogram and also the border of the histogram. For this, we will include some additional options such as fill with blue color, and the border color is black. Now, as you notice here, the executed code provides us the histogram with blue color bars and black color border lines. Now we will focus on creating a facet grid. Facet grid is also an aesthetic mapping object. we will see how to enable the multiple histograms across the marital status and the genders, so that we identify how the income is distributed for individual marital status as well the genders. Let's zoom this view and have a look at it. As you notice here, there are some interesting outliers here in the data distribution. Female unmarried drawing higher income, and male unmarried and married also drawing higher income as compared to the females. Whereas if you notice that the female unmarried is drawing much higher income than the male. This may also be very much related to the age. Now let us see how to create a stacked histogram. When I say a stacked histogram, I mean instead of filling the color, we will fill the gender, so that there is a stack within the histogram. So as you notice here, I have made couple of changes. I have included fill equal to gender within the aesthetic mapping. Now let us look at this histogram. As you see here, the gender is filled in the histogram, hence we have stacked distribution of female and the male. Now let us focus on creating a bar chart with education versus income, where we can identify the education levels and the income ranges for these education levels. As you notice here, we are going to create a visualization where we have the aggregation in form of mean, and the geometric object used here is bar plot. Now let's zoom this view and understand which education level have higher average income. So as we see here, the blue color bar is the post-undergraduate degree, which means this education level draws higher average income as compared to other education levels. Now let's create a histogram where we will see car price and the number of cars for individual category. Let's look at this visualization. This visualization provides us some interesting insight. Just by looking at the distribution of the car prices and the counts of the cars at the car category, economy, and even the luxury. Luxury car category or car price is pretty much distributed, whereas economy car category is dense, which means that we could also look back into the income and age variables and try to figure out further more insights, and then segment the customers for further targeting of these customers. Now what happens if we simply change this bin width to 30? As you observe here, changing the bin width or increasing the bin width will also reduce the number of bins. Now we only have 4 bins here, and the car category is filled. That is what we have enabled within the aesthetic mapping. And we see some more interesting insight. As you look at the standard and the luxury car category, The car prices are pretty much overlapping for the car category luxury and standard. This could be the starting car price of the luxury brands. Now let us create a clustered bar chart. Let's look at this visualization. In this visualization, as you observe, though we have enabled fill equal to gender in the aesthetic mapping, we do not have the view in stacked form, but we have the bars one besides the other. It is also because we have enabled a position called as position equal to dodge in the code. Now, what is the insight that we can draw from this visualization? As you see, postgraduate degree with female gender is drawing higher average income as compared to any other education level. Now let us see how to create a box plot for variable income across the genders. So the box plot can be enabled if there is a bivariate analysis to be performed on a continuous variable and a categorical variable, or multiple categorical variables with a continuous variable. Now let's look at this visualization. What does this say? We have data distribution of income for individual genders, that is for female and the male, and we also notice outliers here. Anything above this whisker is considered to be outliers. It might make more sense if we also include some coloring for these outliers, maybe also enable shape. So now we have colored the outliers and it's colored orange. Let's see if we can also enable the shapes. And now we have here the outlier color as well the shape enabled. Now let us see how to enable a violin plot. What is the utility of violin plot? With a box plot, we understand the analysis and the distribution of the data points is to identify the outliers, to know what is the minimum value, what is the max, what is the median, and what are the outliers. But what is the purpose of a violin plot? Let us have a quick check. As you observe, there is some concentration of data points in the bottom of every car category. However, the concentration is higher for standard car category as compared to economy and the luxury. Now this is an interesting insight that you wouldn't have come across in box plot. The box plot is a very good representation for identifying outliers. However, violin plot will help you focus on the nuances which is not captured by the box plot. We can also simply combine the box plot and the violin plot together. Simply include this geo object. Let's zoom this. Now you have a representation of box plot and the violin plot, both combined in a single visualization. Interestingly, you notice the outliers as well the concentration in the bottom of this violin plot. So this could be some interesting insights that you draw and focus on these data points and understand what exactly is happening there. Now let's focus on the density plot, that is density estimate of the histograms rather than just viewing the frequencies. Now we see the frequency in the y-axis across the income distributions. How about enabling the probability as true so that we enable the density instead of the frequency? So now we have the density in the y-axis and in the x-axis we still have the income distribution. This is the way of also adding a line plot, which is a density plot on the histogram. Now as you observe here, the density plot is not in the same level as the bar. So let us adjust this line. For this we will include adjust, let's say equal to 3, and now let us see how the visualization appears. Now the density plot is on the same level as the bar. Now let us see how to create a cross table for car category and gender. For this, let us call the library DESCR. Now let us create the visualization, enabling cross table for car category and gender. Let's look at the result in console. As you see here, now we see the counts of the gender for individual car category. The values over here represents that there are 67 females falling within the car category economy and 80 males within the car category economy. And for luxury, we see that the count of female is higher than the male. As well, the proportions. Now, how do you understand what proportions are presented here? We may simply turn off some of the proportions like the t-test, the chi-square, etc. Let us see how to enable that. Now let's look at the result. This looks better. Now that we have the counts, the female counts and the male counts across individual car category, we also see the percentages rather than just looking at the absolute value. So there are 45.6% of female within the car category economy and 54.4% of male within the car category economy. Similarly across rest of the car categories. This kind of cross table or a contingency table is also helpful when you want to analyze the different categorical variables and identify the counts or the proportions. Now let us see how to use a scatter plot of age versus income. Scatter plot is a visualization used for bivariate analysis. When you want to perform some analysis between two continuous variables at a data point level, rather than performing the analysis at an aggregated level, such as sum or mean. And now we have a scatter plot of age versus the income, age in the x-axis and income in the y-axis. Though we do not see any kind of a positive correlation or a negative correlation, but we still see some interesting insights over here. Some of the data points are pretty much scattered and much away from densely populated data points. I hope the learning has been informative and interesting so far. We have covered the concepts of data analytics. As well, we have performed some hands-on, doing some statistical analysis and also creating interesting visualization.
The humble Microsoft Excel still stands as one of the most trusted and widely used tools for data analysis. Even in the age of artificial intelligence, automation, and advanced analytics platforms, Excel stands tall. Despite the rapid rise of technologies like Power BI, Tableau, Python, and machine learning, Excel continues to be the starting point and often the finishing line for millions of professionals analyzing data around the world. Whether you're a financial analyst building forecasts, or marketer tracking campaign performance, or a student learning statistics, chances are Excel is where your data journey begins. Now, let's start with the first module, which is about what is data analytics and its purpose. So let's start with a simple but important question. What exactly is analytics? At its core, data analytics is a process of collecting, transforming, and examining raw data to uncover meaningful insights, patterns, and trends that help support decision making. It's not about numbers, it's about turning data into stories that drive actions. For example, imagine you work for a retail company. Every day, your store generates sales data, customer feedback, and inventory records. Data analytics helps you interpret that information to identify which products sell best, when sales peak, and what marketing campaigns are most effective. In a sense, analytics transforms confusion into clarity. It helps decision makers understand what's exactly happening in their business rather than relying on the gut feeling. The purpose of data analytics goes far beyond just collecting and storing data. Anyone can have data, but not everyone can make sense of it. Analytics helps organizations to identify opportunities and risks early to improve operational efficiency, optimize marketing and sales strategies, enhance customer experience, and ultimately make data-driven decisions instead of assumptions. As the saying goes, without data, you're just another person with an opinion. That's why analytics has become such an essential skill in today's digital world. Now, let's go to the section 2, types of data analytics. Now, data analytics isn't one size fits all. It actually comes in 4 major types, each one answering a different question and serving a unique purpose in decision-making process. Let's go through one after the other. First one, descriptive analytics. What happened is the question here. So this is the foundation, the starting point of any analysis. Descriptive analytics looks at historical data to summarize and understand past performance. For example, you might generate a sales report for the last quarter, calculate average monthly revenue, or track website visits over time. The goal here isn't to explain why something happened, but simply to describe what happened. Tools like Excel are great at this, using formulas, pivot tables, and charts to make data easy to interpret. Now the second type, diagnostic analytics. This answers why did it happen. Once we know what happened, the next logical step is to ask why. Diagnostic analytics digs deeper to uncover the causes behind the trends and anomalies. Maybe sales dropped in July was due to seasonality, pricing issues, or reduced marketing efforts. Diagnostic analytics helps pinpoint the reasons using techniques like correlation analysis, variance analysis, and drill down reporting. In Excel, you can easily explore relationships between variables using charts, filters, and regression tools. Followed by that, we have predictive analytics. what might happen next is the main purpose of using predictive analytics. Predictive analytics uses statistical models, forecasting, and machine learning techniques to anticipate future trends. For example, an e-commerce company might forecast next month's revenue based on historical sales and market spends. In Excel, you can build predictive models using functions like forecast, trend, or even more advanced methods through Power Query or Excel's built-in AI tools. Predictive analytics transforms historical insights into forward-looking predictions. Now, the next one, which is prescriptive analytics. What can we do about it? Finally, prescriptive analytics takes things to one step further. It doesn't just predict outcomes, it suggests actions. It answers questions. Given what we know, what should we do next? For instance, if predictive analysis shows a potential drop in customer retention, prescriptive analytics might recommend increasing loyalty rewards or adjusting pricing, while Excel has limitations here compared to specialized AI tools. So, its what if analysis, goal seek, and solver add-ins allow users to test scenarios and determine optimal decisions, making it an accessible gateway to prescriptive modeling. So these four types, descriptive, diagnostic, predictive, and prescriptive, form the foundation of modern analytics. Together, they help organizations move from simply knowing what happened to confidently deciding what to do next. Now we enter the module 3. Why Excel is still relevant for data analysis. Now, you might be wondering, with so many modern tools like Power BI, Python, R, or Tableau, why does still Excel still matter in today's world of advanced analytics? Well, the answer lies in its balance of simplicity, versatility, and power. Let's break down. First one, accessibility and ease of use. Excel is one of the most widely available tools on the planet. From students to CEOs, almost everyone has access to it, and that universal familiarity makes it incredibly powerful. You don't need to be a programmer or data scientist to start analyzing data. Excel provides a low barrier to entry with drag and drop features, pre-built templates, and intuitive functions that allow anyone to learn. It's often the first step in a person's analytics journey. Many professionals use Excel as learning environment before transitioning into tools like Power BI or Python, and because of its available on virtually every operating system, Excel remains a democratizing tool, bringing data analysis capabilities to anyone, anywhere. Now, powerful analytics capabilities is the second reason. Behind its familiar grid interface lies a surprisingly advanced analytical engine. Excel supports a vast range of functions, formulas, pivot tables, data visualization tools, and automation features. Here are a few examples. Pivot tables summarize and explore large datasets instantly. Conditional formatting highlights trends and anomalies. Power Query allows for efficient data cleaning and transformation. Power Pivot enables advanced modeling and relationship between tables. Charts and dashboards communicate insights visually with ease. And let's not forget Excel's AI-powered tools such as Analyze Data and Ideas, which automatically suggest insights, trends, or patterns. With these capabilities, Excel isn't just a spreadsheet, it's a comprehensive analytics environment in itself. Now, the third reason, integration and compatibility. Another major strength of Excel is how seamlessly it integrates with other platforms. You can connect Excel to databases, APIs, Power BI, Google Sheets, SharePoint, or even cloud services like Azure and AWS. This flexibility makes it a perfect bridge between simple data analytics and more advanced analytics platforms. For example, a financial analyst might export or import real-time data from SQL database, clean it with the help of Excel, and then publish the results to a Power BI dashboard for interactive visualization. This smooth workflow keeps Excel at the heart of many enterprise analytics ecosystems. The fourth reason is real-world use cases. Across industries from finance and HR to marketing, logistics, and education, Excel continues to be an indispensable tool. A few examples: finance budgeting, forecasting, variance analysis and KPI tracking, marketing, campaign performance analysis, ROI calculation and customer segmentation, human resources, workforce analytics, attendance tracking and salary modeling, operations, inventory management, scheduling, and performance dashboards. Even in organizations that use sophisticated BI tools, Excel is still used for quick exploratory analysis, ad hoc reporting, and presentation ready summaries. It's like a Swiss army knife of all data analytics. Simple enough for beginners, yet powerful enough for professionals tackling complex business challenges. Now, with that, let's dive deeper into data analytics. Excel continues to be a cornerstone for analytics around the world. In the next module, we will dive into Excel's interface and explore the key functions that make it such a reliable tool for any data-driven professional. Some of these essential functions include the following: trim, to remove unwanted spaces and text; clean, to remove unprintable characters; text, to format dates, numbers, and values; average, median, standard deviation for statistical analysis; index match and lookup to perform advanced data searches and relationships. Mastering these functions will take your Excel skills and your analytical confidence to the next level. Now, let's dive into the demonstration of building dashboards with Excel. So now, let's get into data analytics. On my screen, we have a banking data set. So here we have the customer details: gender, marital status, age, education, occupation, contact numbers, the state, the PIN code, bank IFSC, region, account number. And apart from that, we also have bank related data where we have the same customer details, and I have added a few more columns here. So the reason is we will be attaching these entries to this particular sheet so that we have all the data segregated in one place. You'll learn that on the go. We'll be using some lookup functions for that. And now here you can see the bank details. So here we have a few more details based on the account type, the account balance, what are the type of transactions happening in their account, transaction type, is it check transfer, card transfer, net banking, phone related transactions like Google Pay or Phone Pay, and is it any other transaction like NEFT or RTGS, or is it about EMI options, and a lot more options here. So all these data sets that I'm using today are not real data sets. Those are created data sets. So you might find some names here which are not real names or doesn't belong to any of the real customers. Even the customer IDs and all the phone numbers, those are not real numbers. So you're just using this data set created by artificial intelligence for analytics purpose only. And all the names of the banks are also created names, not the real names. Let's take care of it. Now, so here we have the account balance and transaction type. Is it a wire transfer, check transfer? And we also have a payment network which we have considered. We are having Maestro, Visa, MasterCard, etc., Rupee, and also the card type. Is it contactless card, virtual card, or a student card, premium card? The card type as well. Is it a debit card, credit card? And then you also see here we have loan types, and not all customers have loans. A few of them have savings accounts or current accounts or business accounts, and a few of them have loans here. And also we have a wide variety of loan types available, which is term loan, education loan, business loan, etc. And here we have the principal amount, loan tenure in terms of months, and rate of interest, and the remaining balance they need to pay. And if any of the accounts have converted into NP or non-profiting or no, we have the details over here. So you can also have some blank cells, which means that these customers do not have any accounts or loan accounts related to this particular bank. Now that we have a brief understanding of what exactly are we dealing with, let's get started with data cleaning, data segregation, and then some data analytics. Now, if you see on the first row, we have customer details. So AI created customer details in this particular fashion, which has the customer ID along with the customer first name and the last name. But in real time, this might not be the good scenario to work with, right? So we will be cleaning this particular data set. So for that, let's insert a few more rows. So here I'm using maybe one or two different rows. And now the cleaning. Select the column that you want to be split or cleaned. Go to data, and here we have text to columns. Now what does a text to column operation do? So here if I click on or hover onto this particular option, it says split a single column into multiple columns. For example, you can separate a column full of names into separate first and last name columns. You can choose how to split it up, fixed within or split at each comma, period, or other character. So it is nothing but a delimiter. It can identify the delimiter, and then based on the delimiter, it will split a column into one or more different columns. So here we have a delimiter set as hyphen. Now there are multiple ways of cleaning this data. Let's go with the first option, which is text to columns. So I'll click this text to columns, and here I am selecting delimited with. Characters such as comma or tabs separate each field, right? So in our case, we have the hyphen, right? So we will go with delimited option and then go to next. Here we have preset delimiters like tab, semicolon, comma, space, and others. So we have a hyphen, so we'll go with the other option, and we'll mention the delimiter, which is hyphen. And you can already see the preview on the screen. So we have the customer details column, and then the first name column and the second name column. Once you're happy with the preview, you can just click on next, and then you will have this particular data format, general, text, etc. So you can always go with general, where Excel decides the data type based on the data present in the columns, or you can also choose the type of data item or data type which you want for your data set. So I want text here, so I'll go with text. So all the customer details, which is the customer ID, is a text format, and first name and last name is also a text format. So I'll go with text option, and then you can click on finish, and as soon as you do that, you will have the data already available. So replace it. So there you go. This is one way of doing it. Let me quickly undo it. And the next way is flash fill. Now that's one intelligent feature where you don't have to manually check for the option which is text to column and all those things. You can copy this particular first customer ID and paste it over here, and then select the first name and copy it over here, and then the last name, copy it and paste it over here. Now you have a template which Excel understands. If you double click, right, let me just quickly undo that. You can see an option, a small box, right? That is flash fill option. If you double click it, Excel has automatically understood a pattern. It means it now can segregate the first names and the last names along with the customer ID all by itself. Now, let's quickly perform that flash fill option. Let me expand data a little bit. I'm just double clicking on the square box like this. I think there has been a small mistake, but not a problem. It needs a little training. So what I'm doing is I'm trying to copy and paste the elements a little bit so that it understands what to do next. Yeah, that's the flash fill logo. There you go. I think there has been a small error, but that's resolvable. Basically, that's how the flash fill works. Now, let's go with the initial approach of text to columns. Not a big deal. So I'll go with delimited option, then comes next, and our delimiter would be hyphen, that's the preview, and go to next, and my data format would be text, and then finish it. The data already exists. Do you want to replace? Yes, I want to replace it. Now I'll rename the columns. So instead of customer details, I'll have it as customer ID, and then this will be customer first name, and this will be customer last name or second name. There you go. So far so good. Now here we have gender. I'll delete this column, we don't need this anymore. And we have gender, marriage status, age, education, occupation, phone number, and all those things. That's good. Now I see we have a lot of unique ages here. We have 30, 39, 24, 19, etc. But when we are dealing with creating visualizations for transaction based on age types, this might be a lot clumsier, right? You'll have a wide range of barriers. Now, what if I segregate them into age groups? Something like aged between 25 to 60 are middle-aged, and above 60 would be senior citizens, and below 25 would be like students or something like that. It makes a lot of sense, right? So let's try that. I'll insert a new column here, and I'll expand this a little more, and I'll name it as age groups. Now we have a wide range of opportunities to do this. We will go with if condition. So I have an if condition. If. So you have the syntax readily available from the Excel here. So you can see if function works with a logical test, and if the logical test passes, what should I value it as? Value if true, and if it doesn't pass, if it fails, should have a value for that as well. So value if false. This is the syntax for if condition. Now the logical test is we will have to provide the data for the logical test. I'll go with the column F2. If this particular value is greater than 25, then middle-aged, else I'll term them as students. So don't forget to add the double quotes because this particular data is text type data. So we should not forget the text representation, which is double quotes. And apart from that, we were also supposed to add the senior citizens. So I'll add another if condition, and the same value will be considered. The cell is greater than 60, okay, greater than or equal to 60, then senior citizen. So let me make a quick change here. So I think we had a small error with the formula. Let's quickly try that once again. So if condition, logical condition is the cell value should be less than 25. If this is true, then we will term them as students. This is my condition. If they are not, then we will have another if condition. So there is an age barrier where we will have students, and apart from the student's age, which is more than 25 to 60, we can call them as middle-aged. And for that, we'll write a new condition. So it will be encapsulated inside another if condition. So I'll open an if condition and we'll consider the same cell. And this should be less than or equal to age number 60. If it's true, then they are, okay, let's not take 60, let's go with 55. 55, then we can call them as middle-aged. Else, we can call them as senior citizens. Let's consider 55 for retiring age. Actually, it's 60. For the sake of data set, let's go with 55. And I'll call them as senior citizens. There you go. And you can go close the first if condition, then the second if condition, once you're okay with the formula. Enter. Now we have the first middle-aged entry. Now remember the flash fill that we were trying to separate the first name, second name, and the customer ID? We can also use this here. So you don't have to manually write the if condition to all these cells. So let me show you how many number of cells we have. So we have about 5,000 entries here. So we don't have time for writing 5,000 entries. So for the sake of saving time, we will use the flash fill. So here you have the small box. So just double click on it and automatically the formula will be applied to all the cells. Now you can quickly check that as well. So here we have a senior citizen, and followed by that we have all the middle-aged people and also a student entry. So all these are the ones. Now we have data segregation for customer first name, customer last name, age groups are also created. And now comes the bank IFSC. So if you check the dataset properly, we don't have bank names. Even in the banking details, we don't have the bank names. So here you have account numbers and account types, but no bank name. And also in the customer details. Now, how do you extract the bank name? That's the main question. That can be done, don't worry. So let's create a few more columns and let's make use of some basic functions like left and if conditions again. So here you can see we have SBIN, AXIS, ICIC, and PNB and a few more entries. So what we are going to do is we are going to extract the first 4 letters of this particular bank IFSC, and based on that we will deem or we will term that particular bank first name to be the complete name. Based on the first section of this IFSC code, we can name or term that particular bank's name. That's the idea. So basically, since I created this particular dataset, I have a clear idea that we have about 5 bank names here. So based on that, let's go ahead and name the banks. So I'll use the function left and text. So this is the text I want to go ahead with, which is in M2. And how many number of characters you want to extract? So SBIN. So we have about 3 to 4. So let's go with 4. I'll go with 4 and enter. We have the name here. And based on this name, we will consider the name to be given to this particular bank. So we will use the same if condition here as well. So equals to if, press tab to select the function. If this particular entry is equals to SBIN, then name it as State Bank of India. Or if this particular value is equals to AXIX, which is Axis, then name it as Axis Bank. Another if this value is equals to HDFC, then name it as HDFC Bank. Similarly, if this particular entry is PNP0, I think we missed the cell address, equals to PNB0, then name it as Punjab National Bank. And I think we have covered 1, 2, 3, 4, and one more is remaining, which is ICICI. If this particular value is equals to ICIC, then name it as ICICI Bank, and there you go. We can close the brackets. First bracket is done. First if condition is covered. Second if condition is also covered. Third if condition is covered. And fifth if condition. No, I think we have covered the fourth one. Last fifth, yeah, that's the one. There you go. Now enter. Now we have the first bank name, which is State Bank of India. Now we will quickly use flash fill to extract this left function to all the entries, and similarly another flash fill function for filling the bank names. So we can use the double click option. There you go. We have all the first 4 letters of the IFSC code, and similarly based on the IFSC code's first 4 characters, we'll also have the bank names. So we have bank name provided, and the first 4 IFSC. Let's name it as this. Okay? There you go. Now we have a better cleared data. We have a dedicated customer ID. We have a dedicated first name, second name, or the last name, gender, marital status, age and age groups as well, and their education, occupation, phone numbers, state, regions, bank names, etc. Right? I think that's good enough. Now let's also check this. Do we have any other details to be added or not? That's okay. So we added bank name based on formula of if and left, right? Now there was another method, okay, this is just for learning purposes only. There's another method where we could have added these names manually to all the banks based on the IFSC code. Now let me explain you how that can be done. Since we discussed that this dataset is created by me for learning purposes only, and we know there are 5 different banks, so let's add the names of 5 different banks here. ICICI Bank, HDFC Bank, State Bank of India, Axis Bank, and lastly Punjab National Bank. There you go. And these will be my banks, right? Let me quickly arrange that in the form of a table. So here we are learning table formatting, right? So that's how you can color and you can create a table, add borders, etc. Now, let's say I have an option called bank name. Select the bank name. So do I have a drop down option where you can manually select the bank name, and can we create it? Yes, we can create it. And that's called data validation, where we can validate the data, and based on the selection, you can have a drop down menu. So to do that, you need to first select the cell, go to data, and then here you have an option called data validation. So you can see it says pick from a list of rules to limit the type of data that can be entered to a cell. For example, you can provide a list of values like 1, 2, 3, or only allow numbers greater than 1000 as long as it's valid entries, right? So here we have that option. So you can click on data validation, and here you have the settings. So we have a wide variety of options to go ahead with. You can go with numerical values, add any value, or you can go with whole numbers or decimal numbers. You can also have a list of options like we have here. You can see we have ICICI, HDFC, and all the bank names that we're using in this particular data set. And you can use a list. And also you have an option to enter a calendar. You can provide a specific date and a calendar there, and you can select the date from the calendar. So there are a wide range of options in data validation. For learning more details on data validation, go through the tutorial on data validation from Simplilearn. So now we'll go with the list as we discussed. So here you can provide the source. You can manually type the source like ICICI like we typed here, or you can also provide the location where you have this particular source. So I have the location over here, so I'll select the location and then click on OK. So we have the location ready. Now, this is not just done yet. You can also make some modifications to it. So let me delete this particular validation. And here, let's not delete, you can also directly edit here. You can add an input message. So let me provide the title, select a bank, and we can also, okay, this can be the input message, and this can be banks list. Now you can also have an error alert as well, just in case if the user tries to enter any manual name apart from the provided list, then it should be an error, right? So I have an error message here. So I can use stop, warning or information. I'll go with stop, and the title should be saying wrong, or the you can say bank not found, and the message will be please select from the list provided only. There you go. So I'm done with my data validation and also the error messages. Click on OK, and there you go. You can see when you hover on this particular icon, you can see a message. This is a bank list, and you can select the bank name from this particular list. And let's say I select the list, and there you go. Using the same flash fill, I can extend this particular list of options. And now this particular cell has data validation. Now, apart from the available banks, let's go with some other bank name which is not provided in my list. Let's go with random bank. And if I press enter, I'll find an error. And the error says, please select from the provided list only, right? So this is the error. Now what this does is, this avoids any kind of misentries into your dataset. That's one good functionality of data validation. Now you can select the list entries only, and you can add the list, whatever you want. There you go. Now that's how you do data validation. Now the next job is to segregate all the data into one place. Then we can perform the filter operations. We can also eliminate the duplicates, right? We have about 5,000 different entries. So there might be a possibility or may not be a possibility. Both could be possible, right? You may have a duplicate entry or may not have a duplicate entry. But the best thing is, before you start with any data analytics on any platforms, whether it is Excel, Power BI, or Tableau, or any platform, The first step is data cleaning and segregation. So that's what we were doing so far. So we have segregated all the data that we needed. Now the remaining part is we need to collect all the data into one place. Since you're working on Excel, it's not so complicated. But if you're working on an analytics platform like Power BI or Tableau, that is called as data modeling, where you connect all the different data models in one place and they have a relationship established between them. Now, it's simple in Excel. All you need to do is just copy paste in the best way possible, or you can also build a data model in Excel. So both are possible. Let's go with the simpler version. Now, what we need to do is copy all the data and paste it in one single place. So far I'm comfortable with the data whatever I have. So let me create a new sheet, and here I'll copy the bank details. So I have year here. I'll copy this and paste it here. Let's call this sheet as worksheet or workbook, and now go to the customer page. So we have selected all the data. So back to the workbook now. Before you paste the data, make sure you select this cell and then go to the paste options here and just click on the drop down, and here you have the option of paste values only. Why we are going for the paste values only? So you might be having a question. So if we go back to the data set, and here if you check the particular cell here, we have a formula, right? And apart from this, we have a formula for majorly all the cells over here. So when you're copying and pasting the cells with formula, then you will face the reference error in the worksheet. To avoid that reference error, we will use paste values only option, so that it gives you all the values without any kind of formulas in the cell and without any complications. So you have the customer's data and the first name, last name, and all the details that we had in the customer details. And now let's head back to the banking details, and we don't want these cells that I've inserted. So let me eliminate these cells, or you can just delete them. This one as well. Yeah. Now what remains is we needed the account number, account type, and rest of all the data entries which are present here. And we'll copy these. And again, the same approach. Go to paste, special, and here values only. Now we have two entries of account number. We can delete one, not a big deal. So there you go. So again, before you perform any analytics, the first important major step is to clean and segregate your data. Now you can see the rows and columns are not properly aggregated, or not aggregation, basically organized. So you have a simple shortcut for that. All you need to do is select any one of the cells and click and Control A, which selects all the cells in one go. Then you have a shortcut key. Remember this. Press Alt and release once. Then alphabet H, press and release once. And then comes the alphabet O, press and release once. And lastly, alphabet I, press and release once. There you go. Now what this does is it organizes the cells width and height. So this one was for width, and there's another one for height, which is for Alt HOA will be for height, and Alt HOI will be for width. Now we have organized the cells in width. Now Shift, Control, and arrow key for selecting all the header cells. There you go. Now the header cells are also done. Now select all the cells, and we have the borders. Now the data is correctly aggregated. And another important step is save the data after each and every iteration, so that nothing is lost on the go. Now we have saved it. Now we also have some important statistical functions like sum, count, average, mean, median, mode. So let's also go through these ones. So the name itself speaks, not too much complicated. So we have account balance. So let's freeze this particular column. You can freeze this by selecting the column and going to the view option, and here you have the freeze panes. Freeze the column. You can select the columns that you want to freeze. I'll freeze all these, or you can simply shift this particular column so that you have a better readability. Press and hold, and there you go. You have moved it over here. Now you have a reference column with numbers to implement all these statistics functions, aggregate functions, which are sum, count, average, median, mode, minimum, range, standard deviation, variance, and quarter, percentile, etc. So let's go with this one after the other. Now let's go with sum. So sum function. So why are we doing this? So that we have a quick idea on sum, sumifs, and all those functions, right? So sum and select the range. It will give you the sum of all the entries. Give it a small error. Sum function. Enter. Okay, there is a data type error. Okay, let's consider a different column. I think it is due to the currency format, and here we are selecting the whole number format. Not to worry. We shall now explore with this particular function so that we can also have a filter. Go to data and here apply the filter to this particular column on and eliminate blanks. Just paste it here. Now we'll have the filter, eliminate blanks. There you go. Now you can work on, there you go. It will give you the sum of overall numbers present here. And you also have the count function, which basically counts the total number of cells. We have about 2000 entries. So basically out of 3000 employees or 3000 account holders, more than 2000 account holders have gone with taking a loan with the bank. Now let's find the average tenure period provided to all the account holders. So you can do that by considering the average number, average function, and then providing the cell entries, and you can find the average amount of time given to clear the loan is about 96 months, and you can also convert that to years. And now here you have the median function, which is similar to average. So median of the cell entries, have the median here, so equals to mode and the numbers provided. We have the values. So now what do you mean by mean, median, and mode? So let's have a definition for it. So mean is the sum of all values divided by the number of values, and it will give you, or it will represent the average value of the data set. And similarly for median, the median is the middle value when all observations are arranged in ascending or descending order. If there is an even number of values, the median is average of all the two side of middle values. And lastly, the mode. The mode is the value of that occurs most frequently in the data set. So the data set will have no mode, one mode or unimodal or multiple modes. So basically, the maximum number of repetitions for a dedicated number is called the mode. So here you can see 120 is repeated most number of times apart from the other provided number of months per dedicated loans, right? So maybe it could be a home loan or a kind of a car loan or a bike loan. So most commonly taken loans are given the 120 tenure period. So that's the most repeated one. So in our terms, mode is 20, median is most widely considered as the average number, and mean is similar to average. So that's how it goes. Now we have the next two functions, which is minimum and maximum. So it is self-explanatory. So you can provide the function minimum, min of all the provided numbers here, which gives you the minimum number of tenure, which is 12 months, and also the max number. So you can just type down max and press tab to select the function, give the range of tenure numbers, and you have the maximum as 240 months tenure period, so which is that one. And you also have range function. So what is range? So range is a measure of how spread out or diverse or dispersed the data values are. It shows the difference between the highest and lowest values in a data set. So it's like a maximum value minus the minimum value. So you can perform it in two ways. You can select this cell, which is the maximum value, minus the minimum value, or you can simply use the range function from the available formulas, or you can just imply this particular one which we have gone with. And the next one is the standard deviation. So standard deviation measures how much the data values vary or spread out from the average. It tells you how consistent or scattered the number of your data sets are. So you can perform standard deviation using the formula STD-DAV. So you have two different types of standard deviation. So it is based on the entire population, and the other one is based on a sample. So you can just go with the standard formula, which is standard dev here, or the entire population one, or the one which you have over here, right? And you can provide the range of numbers of the entire population in your cell, and you have the standard deviation value here. Now next we have the variance. So variance measures how far each data point is from the mean on average. It represents the average of the square differences between each value and the mean. In short, it shows how spread out the data is, just like standard deviation, but without taking the square root. So you can also use the variance formula. We have covariance and covariance P. We can go with this one. We use the covariance in a wrong way. So next we have percentile, and you can provide the percentile, and K is the percent you want. Let's say I want 25% of the range, and you can provide 25, enter, and you have that. So if I wanted 21% of the entire period provided for tenure, then I can provide the number as 0.21, which gives me 21% of the provided tenure. That's how you implement the percentile. And similarly, Q1 and Q4, this is also the percentile functions, where you can provide a quarterly basis function. If you want the first quarter, you can provide 0.25. Similar to this one, you can go with 0.50, 0.75, and 100% or 1.0. So that's how it works. So basically you provide 0.25 here, 0.5 for this one, 0.75 for this one, and 1.0 for this one. This is the quarter 1, quarter 1, quarter 4. That's how it works. And variance. Now let's go back to the, that was a quick scenario on the aggregate functions or the statistics functions in Excel. Now let's go back to the pre-worked workbook, and we are all good to go. Now let's also create a duplicate of this workbook, move or copy. So why am I creating a copy? Because I want, let's say I want to work on the loan section only, right? In that scenario, I don't want the other regular accounts. So for that, let me quickly apply a filter for this one. Go to the data section, select the filter, and a filter has been implemented. Now what I'll do is I'll unselect all first. Now I'll select only the blank entries. Now all these blank entries are about 3,000 entries of all the customers, and I can quickly delete all these entries without affecting the master workbook sheet. Now what will be remained in this particular sheet will be related to the data of only the customers who have taken a loan with the particular bank. That might take a while. We have about 3,000 entries, right? There you go. All you have to do is just delete these entries. And now you can go to the column where we have applied filter, or just clear all the filters. And now you have all the data related to the customers who have taken a loan with any of the banks that we are dealing with, right? Now you can quickly rename this workbook as bank loan dataset, and you're good to go. Now it's your choice. You have completely finished workbooks for both the bank loan dataset and the overall customer dataset with 5,000 entries, where you have the data for both the customers who have taken a loan and who did not have taken a loan with any of the bank. I'll go with the bank loan dataset. So we have all the entries along with the loan details. So you can do some projections as well. Now the best part is you also have a data analysis feature, which is an AI feature from Excel, which creates the datasets visualizations for you, right? You can just click on the dataset and then click on OK. You have two-factor replication, two-factor without replication. You have covariation. You have descriptive statistics as well, which you want to perform. You can also perform Fourier analysis and a lot of analysis that you can do with Excel. So I want to go with descriptive statistics and click on OK, and it will give you input range. You can provide the range. That's your range. Click OK. So I need to change the range. Okay, there has been a small error, but not to worry. Basically, I was trying to provide a forecast number, which can be done directly via the forecast sheet option right available here. So you can select the ranges, rate of interest, and remaining balance. Based on that, you can go with forecast sheet, and you need to also provide the years. So I'll take the years column and also the remaining balance so that we can forecast what are the possibilities, right, for the remaining balance. So the thick line provides you the forecast for remaining balance. This is the duration on which, right, so many number of months they might take to repay the balance. This is the worst possible scenario and this is the best possible scenario, and this is the predicted scenario. Based on this graph, they will repay the loans entire customers. So that's the forecast, and you can create this chart and use it, or you can just choose to cancel it and perform all the pivot table analysis all by yourself. So that's the next part, creating pivot tables and pivot charts and an entire dashboard which is completely interactive, and you'll also have slicers, filters, and everything included. Now that we have a readily available data, the next step is to go ahead with the pivot tables. And apart from that, let me quickly show you different ways to load the data onto workbook, right? So every Excel workbook is having a wide variety of options to import the data. So let's say if you wanted to import the data, you can get the data from a wide variety of sources. It can be an Excel workbook, it can be a CSV file, XML, JSON, PDF, folder, right? And you can also connect online data bases like SQL Server, Microsoft Access, Analysis Service, and a lot more. You can also connect data from cloud like Microsoft Azure Data Lake, and you can also have Power Platform and other sources like web, ODBC, JDBC, etc. And combine queries, you can merge different queries like different data sets as well, right? There are a lot of variety of options to load data onto the Excel worksheet. So this was supposed to be discussed before, but not to worry, we did not miss anything major. We already started off with a data set which was created for us. Now, the next part is about building pivot tables and pivot charts. So building pivot tables and pivot charts is not a big deal. You can just click any of the cell and then control auto select all the cells available on the data set. And then you can create a pivot table by entering into the insert option here and then selecting the pivot table. So here, easily arrange and summarize complex data in a pivot table. For your information, you can double click a value to see which detailed values make up the summarized total, right? So now we choose to select to create the pivot table in a new worksheet or the existing worksheet. So I'll go with the new worksheet, and we have provided the range of data that we are working with, and then click on OK. So here we have a fully functional pivot table or pivot page. So we will name this particular sheet as pivot 1. So why 1? We'll be creating a lot of pivot tables in this particular tutorial. Why a lot? Because we will be creating pivot charts. So here we have an option which says pivot analyzed, right? So we'll be creating a lot of pivot charts, and then so we'll be copying all those pivot charts into one single dashboard sheet, and then create interactivity between all those pivot charts, and then we'll have a fully functional dashboard. That's the overall agenda. Now let's get started. Now I want to know a few things. So I'll add age groups to the rows and account types to values. So now we have a detailed pivot table here. So middle-aged people have about 1046 accounts. Senior citizens maintain about 311 accounts, and students have about 359 accounts, right? So we have a pivot table for this. Now you can select this particular data and then go to pivot chart, and you can create a pivot chart for yourself. By default, we had a column chart, and then okay, based on age groups. So this is our first pivot table, and here we will insert another pivot table, and let's name it as pivot 2. Now I want to know the loan type, so I'll add loan type to rows, and then if I drag and drop the loan type once again to values, so I'll have the count of loan types as well. Now we will know you will have the count of loan types. You can select the entire data set and insert a pivot chart, and you can have a pie chart, and you can also choose which type of pie chart you want, and then press OK. Loan type. Now go back to loan data set and insert. Now based on gender, you can do a gender analysis as well, gender distribution, and you can name this as pivot 3. You can also provide a dedicated name for your chart, but the time's sake I'm using pivot 1, pivot 2, pivot 3. You can also name them as loan types, and the first one would be account based on age groups, and pivot 3 would be gender distribution, right? Based on your requirement, you can feel free to use the names for your pivot charts. Now go to pivot table once again, and create a new pivot table. So here we have year-wise data. You can add years to rows, and then you can see the number of loans provided in each year, right? So you can see the count of loans, if the loans are increasing or decreasing, right? And you need to work on if the loan numbers are decreasing, then you can market something so that you can see a potential growth in the number of loans distributed yearly. And since you're working with time period, you'll go with the line chart. So this is the one. You can name it as year on year growth. So I'll name it as Y on Y growth on loans. And then you can name it as pivot 4. Go to the bank data set again, and here you can insert a new pivot table again. And here we have age groups. We have done the age groups, and you can go ahead with education right now, education to the rows. So we have 3 different types of education: degree, diploma, and schooling. I've kept it minimal to avoid confusions. And you can also do region analysis, you can do state-wise analysis, and a lot of things that can be done. And here we have the loans. You can have a bar graph for this one. Let's quickly name it as pivot 5, and this one should be loans based on education or qualification. So you can already see, if you are from a schooling background, you can, I meant to say, if you have less qualification, if you have not done your degree or diploma, then the chances of getting a loan could be low. Again, getting a loan is just not based on qualification or your education. It can also be based on your credit score, or you can also call it a CIBIL score, right? So if your CIBIL score is good, and if you are having good amount of income, or if you have a good hierarchy of assets, then you can also get a loan. But for this particular data set, let's go with education. So we have not considered the CIBIL score in the data set. We have not considered the hierarchical assets you have. That's not included in the data set. So for the data set's sake, well, let's go with the education purpose. So if you don't have a good qualification, it automatically leads to lower chances of getting a loan in this particular aspect. Now, based on qualification is done, now let's go with the region-based analysis as well. You can go with the insert option here and insert. And then what I'll do is I'll go with the state, and I'll drop it down to rows, and I'll have a loan type into the values. And based on states, we have so many loans. Now, state-wise loans pivot chart. We can go with a map chart. Build map is not available. For some reason, it is not recognizing can't create this chart with the data inside the pivot table. Okay. For some reason, it is not recognizing this as a geographical location, but not a problem. Let's go with the tree map. I think tree map should also help. There must be some problem unexplainable here. But yeah, you should have been identified this as a geographical location, and it should have given us a geographical location, but not a problem. Geo-wise, loan distribution. You can also have bank name level distribution. You can basically have this as KPI or KRA, right? I think it's called KPI. So based on KPI, you can have the numbers, which bank has provided how many number of loans, right? And so that could be a good KPI for you. And let's see if the card option is available here. It's not, but it's okay. Bank level and done. So most of the charts that we created are column charts and bar graphs and line graphs and pie charts. So not a problem. For some reason, the data in the pivot table is not recognized as geographical location. But to create a dashboard, we need pivot charts. So let's continue with what we have. Now that's one way of doing it. So now let's create a fresh sheet and call it as the dashboard. So there are a wide variety of chances of creating many more extractions or insights from this data set. You can also go ahead with occupation based chart, right? So let's do that as well. You can insert a pivot table, and here you can have occupation on the rows and loan type. Go with a donut graph for this. Now let's go to the dashboard, and here let's select these cells and combine them, and you can also color code them. Write it down as ranking dashboard, and you can also choose to increase the copy and paste it to dashboard. So make sure that you're selecting a new cell when you're pasting the pivot chart. If you're not selecting a new cell, then the previous pivot chart will be replaced. So make sure you select a new cell on the dashboard when you're pasting. So this might take a little time, but we'll do it slowly. Now the gender distribution. So this will also be added to the dashboard. And to create interactivity, we'll also be adding slicers to this particular dashboard. That will be done on the go. So this was gender distribution and year-on-year growth as well. So since this is time-based analysis, we need to paste it in the form of line graph. Now, once you're done with this particular arrangement, you can also adjust the height. Slowly, we have a couple of more pivot charts. So here we have loan qualification. So here we will paste it in the new place. This is where I would like this to be present. And geolocation wise and bank level. So we have two more. Go to the dashboard, select a new cell. I would like to expand this a little because it is geographical location, right? So we need to cover about all the states present in the country. And now let's make a little room for our slices as well. I think one more chart is left out, which is bank level. So I'll place this bank level in the last location, or you can also choose to expand this particular section. So I'll choose this location to be expanded. There you go. Now what remains is adding the slices and interactivity with the dashboard. We can minimize the size so that every aspect of the dashboard is clearly visible. There you go. So we need to go to the pivot chart, analyze, and click on the insert slicer option. So we have a wide variety of slicer options available in this particular window. So we'll go with the year, and we'll go with the gender. So basically what we did with the pivot charts, that's what we're going to do with the slices as well. So we will be going with gender, we'll be going with year, we'll also be going with geographical location wise, so state, and we'll also be going with bank name, and we'll also be going with education, and we'll also be going with occupation. And once you are okay, I think we can also go with age groups as well. So once you're comfortable with the slicer options, then you can quickly choose OK, and you'll have all these slicers readily available at your disposal. Now, the next job is to arrange all these slicers. So I'd like to select all the slicers once and select their height adjustments. Once I'm okay with the height adjustments, I can drag and drop them to the locations where I want them. Basically, what I'm doing is adjusting the height, width, and length of each and every slicer so that it fits in the window of my dashboard. So it might take a little while. Not to worry, let's do it slowly. So far we have done with 1, 2, 3, 4 slices. So we have about 2 to 3 more slices. So let's do that accordingly. And I have the gender slicer here. So I'll send it to this particular location near to age groups. And I can also adjust the height of this particular slicer. And what is remaining is the last one, which is year-based slicer, and which will be placed here. There you go. And now it's not done yet. Let's say if I select, right, let me adjust the gender slicer. Let's say if I select the data for Andhra Pradesh, there will be changes in only one particular, state, right? So it will not give me the entire changes in the overall dashboard level. Now, what do I do to get that interactivity? So for that, you need to right click and select an option here which says report connections, right? Now, what this does is it helps you create connectivity between all the slicer options available on your dashboard. So far, you have about 6 to 7 slices, right? So you need to create the same for all the slicers. So the first state level slicer is being connected with reports. So I need to do this to all the slicers. It might take a little while. Let's do it slowly. But doing this will help you maintain an interactive dashboard. That's the main agenda. So click OK. Similarly to this particular education slicer. Let's undo that. I think I deleted it by mistake. So we need to do report instead of remove. So let's restore. There you go. Now similarly to the occupation one, right click, report connections. Select all the available pivot charts in your dashboard. There you go. And press OK. Now let's check this particular one if I had reported all the connections. Yes. And now we are done with I think almost 4 connections are reported. Now we have 3 more, just 3 more, and our dashboard will be completely interactive. So let us select 1, 2, 3, 4, 5, 6, and 7. Basically all the pivot tables and pivot charts that we have created in the dashboard. And similarly to gender, go to report connections. Allow all the connections to be reported. So whenever you click on an option provided, you get complete interactivity on the dashboard. And the last one is year. And here, click on 1, 2, 3, 4, 5, 6, 7, and 8. There you go. Now, if you clear, you have a completely interactive dashboard. Now, this one also, let's clear this. Now, let us say I want to know the data for Goa region alone, with the candidates having a degree as education and business as occupation. And I want the data of only State Bank of India, and for male data, middle-aged person only, from the year 2022. Now I have the entire report, right? And similarly, if I wanted a few more entries for male and female as well, then you have the interactivity here, right? So if I clear all the filters, you'll have a fully functional dashboard back again. So this maintains an interactivity on your dashboard. Basically, you'll get all the details let's say I want to go ahead with another different state, let's say Maharashtra, then I have the details of Maharashtra since past 5 years of data and all the age categories and all the educational qualifications on the geo-wise distribution year-on-year growth. So you can see Maharashtra is developing. So you can see from 2021 to 2025, you can see a stable increase of growth of loans. So people are taking many loans and investing in better businesses and all those things, or home loans, right? So there's a business development in terms of this particular data set here. So that's how you create a fully functional and interactive dashboard in Excel.
So there are four different products that are there in the market from Microsoft. Okay. So what are the four different products that are there? One product is the Microsoft desktop, that is we have downloaded right now. So why this product will be used? Any report that we will be developing, okay, will be developed in this tool. So what is this Microsoft Power BI desktop? It is a tool that we have downloaded in our local system to develop the reports. Okay, that is first thing. The second thing is Power BI service. This is not written completely, but it is Power BI service. What is Power BI service? So guys, once you have developed this report will go on server. Okay. The Power BI service is nothing, but it is the server where your report will be published. Okay. And your users will use the report on this service. The third component of Power BI is Power BI Mobile. What is this Power BI Mobile? The Power BI Mobile is the desktop and service. Both are the web-based and the laptop-based. But what if you want to use your report on mobile? If you want to use your report on mobile, there is one Power BI mobile app. Okay, so that is Power BI Mobile. Embedded is something that we will cover a little later, but embedded is, have you ever seen in the websites? In the websites, there are some graphs that are appearing, okay? On the website, there are some graph appearing that shows the trend or that shows the percent of total. So that is called Power BI embedded. Embedded means in the website, you are embedding your graphs. So that is the advanced concept we will cover. But there are four offerings from Power BI: desktop, service, mobile, and embedded. Most used will be the desktop. The second will be service. Third will be mobile. And fourth will be embedded. Okay. So if there is any difficulty in understanding the high level of it, let me know, please. If there is any difficulty in understanding high level of it, let me know. I hope there should be no issues. Okay. Now moving along. Embedded sample, Deepa, embedded sample, like I mentioned, I will take it, but towards the third or fourth session. Embedded is when you have developed everything and then you embed it in a website. Okay. But we have not developed anything yet. So how can we embed? Okay. If I am trying to explain, if I will explain this example embedded, we will not be able to understand right now. Okay. Okay, everyone. So now the next thing that we will be understanding is the Power BI desktop architecture. Okay, very important thing. Please make sure you understand it in detail. Okay. So what is there in the Power BI architecture? Power BI desktop architecture, how Power BI desktop works. Okay. So there are n number of data sources that are there in the market. Okay. there are 100 plus data sources that are there in market. The Salesforce is there, Microsoft SQL Server is there, Redshift is there. So in the Power BI desktop only, you connect to Power BI desktop only, you connect to these data sources. Okay. So first is the data source. Second is you connect to the Power BI desktop, the data source. The third thing is Power BI service. Once everything is connected, once everything is developed, you publish it in the Power BI service. Okay. So if I develop a report, if I want to share it with the broader audience, I will publish that on the service. Now, the most important thing here to understand is the gateway. What is this Power BI gateway? Now, let me frame some example. I'm first drawing an example. So, just give me 20 seconds. On 28th of Feb, okay, on 28th of Feb, I extracted the data of sales. What I did, I extracted the sales data on 28th of Feb. Now, what I did is I created a report on top of the 28th Feb data. Okay. What I did next is I created a report on this 28th Feb data. Okay. Now, the next thing is I published this report on the cloud. What I did, I published this report on the Power BI service. So, a question to every one of you. If I am watching this report on 10th of March, okay, if I am watching this report on 10th of March on the Power BI service, will the data be updated? Will the data be updated or not? Will the data be updated till 10th of March or not? So the answer is it depends. Okay, it depends. Why it depends, guys? Because there are two connection mode in Power BI. Okay, try to understand this very properly. In the Power BI desktop, when you create the report now, when you create report, what happens is, when I create a report, what happens? I pull the report locally. I pull the data locally. Okay. So a snapshot of the data is pulled locally. Okay. And then on the top of that data, a report is created that I publish on the service. This is the first way. The second way of doing it is I connect live to data. I connect live to data, these data sources, and then publish the report. Okay. So the first way is, yep. So the first way is I can create locally. Okay. The second way is I can use the direct query. Okay. I will explain you in some seconds. So what happened, guys, when I create a report? Okay. For example, I am creating a report in desktop. There are two ways how I can connect to data. The first way to connect to data is I bring the data locally to the report. What I did, I bring the data locally to the report and then I create the report on top of it and publish that on the service. Understood? What I did, I brought the data locally into the report, create a report on top of it, and then publish it. The second way is I created a connection. What I did, I created a connection to the database. I created what? A connection to the database, then created a report, and then published on the service. So both ways we are publishing on the service, but one time we are bringing the data locally in the environment. Second, we are utilizing the connection. Okay. Is it clear till now? Locally means in your desktop. Locally means in your desktop. You are importing the data. So for example, like you download a file, na, there are some files on the SharePoint. You download the file, like you download the song or you download anything, any image in the phone. So that image is in your phone. Okay. That means local. Correct? So what happens, guys? In the first case, the data is not updated. The data is not updated until and unless you force it to do. Okay. So when you are using locally, or I would say you are importing the data, importing is also a good word. When you are importing the data, you are not creating a connection. In that case, Power BI data is not refreshed on the service automatically. Not refreshed on the service automatically. Why? Because you have imported till 28th of Feb only. Correct? And then you publish it on the service. How will Power BI know that you have to pull the updated data? Correct? How will Power BI know you have to pull the updated data? So the gateway is the solution. Gateway is the solution to do that. Gateway tell Power BI service. Gateway tell Power BI service what? That please keep the data updated. Please keep the data updated. So if I have to simply explain Power BI gateway, a Power BI gateway is an intermediate layer between your Power BI service and the data sources. Power BI service and the data sources that help us to keep the data updated in the report. Is it understood now? Vilasni, synchronous and asynchronous, there are two type of gateway, on premises and the off premises. We will cover that, not right now, but it is always synchronous to answer your question. For rest of the folks, is it clear what is a gateway? Everyone else? Okay. Anuja is saying repeat again. Okay. So I'll repeat very quick. Anuja, you have created a report. Okay. What you did is you have imported the data from a database. What you have done, you have imported the data, means you have downloaded the data. So if you publish this report on the service, what will happen? Your data will not be updated. Your data will not be updated. Why? Because you have downloaded the data till 28th of Feb only. So if you are looking at 10th of March, the data will be old only. The data will be old only till the 28th of Feb. Now, how we can update this data? With the help of gateway. With the help of gateway. So gateway is the functionality in Power BI which will help us keep the data updated on the report in Power BI service. Is it clear now? Perfect. We need to schedule a refresh. Nilima, I will tell you the option how to schedule. But yes, okay, I will tell you the option to schedule a refresh, but it is required. You are correct. Your thinking is correct in the correct direction. Now allow me 15 seconds. Everyone, can you please open the Power BI desktop? Can you please open the Power BI desktop? Please everyone open the Power BI desktop. How to open it? If you have not already opened, search for the Power BI desktop. Okay, Power BI desktop. It will be opening like this. It will take a couple of seconds. So everyone, please go and click a blank report. Okay, there is an option of creating a blank report. Please click on this blank report. Please click on this blank report. So what we are doing is we are creating our first report in Power BI desktop. Okay. Now what we are going to do next is we are going to connect to data. So everyone, this is very important step. Okay. We can connect to n number of data sources. So if you look at this section, this is the complete data section. Okay. So if you click on this get data, please click on this get data. UI UX Selvarani, I'll just be able to show you the UI UX after the data is imported. Complete UI UX is only possible once any small data is imported. So doing that activity only. Okay. So every one of you, after the all, you can see there are n number of data sources that are there in the Power BI desktop. So there are file-based data source. First is the file-based data source. Second is the database type data source. Okay. Let us first know what are the different type of data sources. If you click here on the file base, if you click here on the file base, you will notice that there are Excel, text CSV, folder, PDF, Parquet, JSON, or the SharePoint. So what is this? What are the file-based data sources? So file-based data sources, as the name suggests, are the data sources which are in the form of files. So you can have an Excel file in your desktop, correct? You can have a .csv file in your desktop. You can have a PDF file in your desktop. So any data set that can be stored as a file is called a file-based data set. Okay, so you can connect to this file-based data set from this navigator. Second is our database. I'll give you a very high-level overview of database. What is a database? So a database is a storage engine. What is a database, guys? A database is a storage unit. I would say storage unit of a organization. So for example, everyone, if I am working for an organization that is called Hindustan Unilever Limited, I'm just taking a rough example. I am working for Hindustan Unilever Limited. Now, if you talk about that company has sales department, correct? That company has the IT department. That company has the supply chain department, correct? And likewise, that company can have n number of department. Okay, can have n number of department. So these all department are generating the data. These department are generating the data, million of rows daily, million of rows daily. So that data is stored in a place that is called a database. So a database is a space where every record of an organization is saved. Now, there are different database that exist in market. Okay. So if you talk about the messaging apps, for example, let's take a messaging app example. We have WhatsApp, correct? We have WhatsApp. We have Hike. Okay. We have then Snapchat. Okay. So there are n number of options that are there in the market. So similar to that, for the database also, an organization can choose from the n number of options. So you can connect those n number of options from this database example. So if you click on database, you will see IBM DB2, Oracle, SQL Server, Teradata, Amazon Redshift. So basically any database you can connect to. Your UI is different, Manoj. You might be on the all. Okay, you might be on the all. Samya, everyone is able to hear me, correct? I guess there is some issue at your end. Okay, so what we will be doing right now, we will only be connecting to a file-based data source as of now. These examples I will tell you, but a little later. Okay, I have one like we need to import this data to explain the UI UX. That's why I'm importing it, just for the sake of it as of now. So please click on file. Please click on file. What I have done is I have shared one file with you. So please click on text oblique CSV, where you will be clicking text oblique CSV. Let me see what is the extension of that file. Hold on for 1 second, please. Let me see. Let me, so, okay, got it. Now, this is our Excel workbook. So please click on Excel and connect. The moment you will click on connect, it will give you a window. Okay. So please select the file that we have just downloaded. Please do that. Please connect to the file that I have just shared with you all. Sample Superstore updated data. Yes. Okay. Nilima, Microsoft Dataverse and all, I'll explain, but we are just connecting to a raw data right now. Can't go from 0 to 100 on the day one itself. So building gradually. Every one of you look at this window. What this window is called? This is called a navigator. Okay. Navigator will give you all the sheets that are available in your workbook. Okay. So this is an option of sheets in your workbook. But what is there in the database? Imagine if we are connecting to a database, it will show us the list of all the tables. Okay. In the case of database, what will happen? All the tables will be listed here. If there are 100 plus table, all the tables will be listed. So what we are going to do right now, we are going to import everything. So please click on these three, 1, 2, and 3. Please click on these three, 1, 2, and 3. Please click on this and click on load at the bottom. There is an option of load at the bottom. Please click on this. So what happened? We imported the data. What we did? We imported the data for the reporting purpose. This is not in the course repository right now. Let me just share it with you again if you are able to download now. Check please. Yeah, load. Could not download anything from the chat. Okay. Okay, Gopi, do one thing. Download from the web. Just download from the web. Meanwhile, everyone, it is loading for you. I'm just telling Gopi what to do. So please go on the web. Okay. On the web, there is one file. Why it is not coming for me? If you type sample superstore data download, okay, click here. It will give you the sample superstore data. So you can go to any of the website and download this file. Go to any of the website and download this file. I'm sharing a link with you. You can go to Kaggle or you can go to any XYZ website and see there is the data. Okay. Is it working for you? If it is a CSV file, please use the CSV option. Okay. I can see that this is a CSV file, so you can use the CSV option. Try this. If you are not able to sort this out, then we will work together. Okay. Everyone, have you loaded this data set? Once you are done with loading, you will see these three files here: orders, people, and return. You will see these three files. What to select in Navigator? There will be three checkboxes. Okay. In the front of the file name, there will be three checkboxes. Select those. Select all three of them and then please click on load. Now we will look at the UI part of it. Okay. Everyone, once you are done with loading, let me know, please. Perfect. Okay. So what each section of this UI represent? Okay. The first thing is here. This, this, this. These three are very important. Okay. So what are these three? Once you hover over this, please hover over this. Please hover over this one by one. The first is the report view. Second is the table view. Third is the model view. What is this? First is the report view. Second is the table view. And third is what? Model view. What do we mean by each one of these? So, report view is the UI part of your report. So, any visual that you will create will be created here. Okay. So, if I will drag any chart from the list of these chart, it will be dragged to which view? It will be dragged to this view. Okay. So this is report view. Any UI element will be dragged here only. My screen is stuck. Yeah. Now the second thing is the table view. If you click towards the very left side, okay, the second icon, it is called what? Table view. Please click on this table view. Please click on this table view. Try to explore with me. I am trying to explore with you. Try exploring with me one by one. Okay. So if you go on this table view, guys, it will give you the table layout. Okay. So we have imported what? We have imported order sheet, correct? The people sheet, and the third sheet is the return sheet. So we have imported these three. What it will do, it will show you the data inside these sheets. So it is right now clicked on the order. If you see right now, orders is highlighted. If you see, it will show you all the orders data. Please try if you are able to see. Devashri, you are stuck at which point? Let me know, please. Now, every one of you, we are on a table view. Devashri, can you please message everyone? That's best way to do it. We are looking at the table view. Okay. As the name suggests, table view will show you all the data that is there in your data source. So if I'm clicked on the order table, everything that is there in my order table will be shown as a table, okay, as a table here in the table view. Uh, Divyashri, have you downloaded the Power BI desktop? Have you downloaded the Power BI desktop? Okay. So, everyone, just quickly allow me 1 minute. Divyashri, follow with me. Okay. You are on this window right now? Yes. Please click on Get Data. Please click on Get Data here. Now, in the Get Data, I have sent you a file, Excel workbook, correct? Click on this Excel workbook, connect. Now that Excel workbook, you will open. Let me know if you have reached till this window. Okay, let me proceed. Now in the table view, guys, what we expect. In the table view, you will see a Excel-like interface. What you will see? A Excel-like interface. So play around with it, go and check the drop downs. You will be able to see the data. Now you will be telling Pranav, what is the use of this? What is the use of this table view? The use of this table view is to look at my raw data. So guys, when I am creating the report, I sometimes need to look back to my raw data. So this is the option where you can look. Okay. Now, one more thing, any filter that you will be applying here, any filter that you will be applying here from this will not be saved. It is only for the UI perspective. Okay. Only for the UI to see the data, these drop down exist. Otherwise, not. Okay. Now I have explained you the report view and the table view. The third view is, guys, the model view. The third view is what? Model view. So please go on this here, model view, please. Yeah, Devashri, please load now. So everyone, are you able to play in this table view? Are you able to apply the filter and see the data? How to apply is go to these drop downs and apply. Go to these drop down and apply the filter. It's the UI, Excel-like UI. Everyone, can you please confirm if you are able to play around with this table view? Now, moving along, model view. What is this model view? So model view is where you will see your data model. Where you will see your data model. Now, I would request every one of you to please open the Excel file that I have shared with you in the Microsoft Excel. Please open this file I have shared with you. Now, once the file is open, guys, please look at the data. Please look at the data. Try to understand what is there in the data. I will first explain to you. You only look. Okay. So this is a sample superstore dataset. Sample superstore dataset is the data where we are looking at the sales figure, we are looking at the quantity, the discount, and the profit. So it is the sales data of the different products. So you can see there are n number of products here, correct? This is Wilson, this is Cardinal, this is Logitech. So there are n number of products. For this n number of product, we are looking at the sales. Now, once we are looking at the sales, what other dimensions we have? The product name we have, the category and the subcategory of the product we have. So I will filter on one category. You just need to look at the data. Guys, don't do in your screen. Please try to look at it. So we have certain category of data. For example, we have the furniture, we have the office supply, we have the technology product. So inside the technology also, we have some subcategories. So inside the technology also, we have accessories, copiers, machines, phones, etc., etc. Okay. So what we understood right now, we have category, we have then subcategory, and inside a subcategory, we have a product. Okay. I will take very one simple example. You eat Lays in your life, correct? Lays is the chips. Okay. Lays is the name of the chips. But it comes under which segment? It comes under the uh, packaged food segment. Okay. If you look at the company level, it comes under the packaged food subcategory. But inside the packaged food also, it is coming under the solid food. It is not coming under the beverages. So it is like this only. We have the category, we have the subcategory and the product. Okay. After this, each and every product has a product ID. Okay. So it's one-to-one mapping. One product has one product ID. The postal code, state, and region. Let's try to understand these fields. So for example, guys, if you visit to some store, if I visit and go for shopping, I purchase one product, but I purchased in which region of the country? I purchased in the west region of the country. The store might be in the east region of a country. The store might be in the west region of a country. So the region tell us which region of the country the sale was in. What was the postal code of that region? What was the state? What was the city? The country. So basically, demographical information is there in these 5 to 6 column. Which information? Demographical information is there in these 6 columns. In the 5 column that we were talking about, the product information was there. Product ID, category, subcategory, product name. Now, the next thing is customer information. So if you see, customer ID is there, correct? Customer ID, customer name is there, which contains what? Customer information, yani my information. I purchased, what was my name? Okay, that is the kind of information. The column A to E tell us the order and the ship date. Okay. So what is the order ID? What is the order date? What is the ship date? What is the ship mode and blah blah. Okay. So this is the orders information. Now look at the return sheet. You see there are order ID and returned. So when you order, guys, it happens that sometime you return also. So if there is any order that you are returning, it will be in the return sheet. Okay. If there is any order you are returning, it will be in the return sheet. What is there in the people sheet? If you go to people sheet, the people and region mapping is there. For example, West region manager is Anna. East region manager is Chuck, Central region manager is Kelly, and the South region manager is Cassandra. So these three sheets contain these informations. Let's move on. Okay. Okay, not a problem. It was not deliberately, might be your questions have been missed. Okay. You selected only technology. Uh, okay. Why I selected only technology? It is not returning any filtered result. Okay. So if you look at this, if you look at the workbook, if I select the technology here, it is not applied. The filter is not applied. It's just for the viewing purpose only. That is why that doesn't make any sense if we apply any filter. That was just for the view purpose. Okay. Now, everyone, are you familiar with the data now? Everyone, are you familiar with the data now? Everyone, please. Okay. So why I asked these question? Why I asked these question? Now, if I ask you how orders and returns sheet will be connected, how orders and return sheet will be connected, the answer will be, tell me how, if I need to connect the order sheet with the return sheet, with the returns sheet, how I will connect it. Order ID. Order ID. Yes, yes. So there is one common field that is called order ID, correct? So if I need to connect these two tables, I need to connect via the order ID. Now similarly, tell me if I need to connect order with the people, how will I connect? If I need to connect order and people, how I will connect? Region. Yes. If I have to connect these two, the people and the order ID, it will be on the region because that is the common field only. Now, there is the relevance of these questions. Okay. So this is exactly what is happening in the model view. So if you go to the model view in your workbook, can you please go to the model view here? If you see right now, the tables are not connected here. In a ideal Power BI workbook, in a ideal Power BI file, these tables are interconnected with each other, which we are going to do tomorrow, okay? Which we will do tomorrow. But this interconnection of the tables is called what? Data model. What it is called? Data model. A data model is the connection of the different tables in the data set based on the common field. Correct, guys? Any difficulty in understanding these three views? They are very important. The page view, sorry, the report view, the table view, and the model view. Is there any difficulty in understanding these? Let me know. Okay, seems like there are no other questions. Any reason why people and return model shows column? Okay. Night just, yeah. I'll come to that. That is a different thing. Okay. That is a different thing. I will come to that. Don't worry about it. That's the part of data transformations. Okay. Now, once we are clear with it, let's move along. Okay. Now, these three are the report view, table view, and the model view. Now, I want you to focus here on this part, this region, please. Please look at this part. What is this? This is the visualization area. So any visual that you are going to create in Power BI will be available here. So I would request you to please click here on any visual for now. You don't have to follow my approach. You just click on any random visual. Click on any random visual and drag any random field. Okay. Drag any random field in that visual. Just try to do this. Okay. See if anything is appearing. Play around with it. I want every one of you to play around with this area, visualization area. So what is this visualization area? Any chart that I am going to create will be done from this area only. Okay. So for example, I'm creating a profit by region. You need not to create it as of now. You just need to see. So you will see a chart will appear. Now inside this only, there is this formatting area. Okay. There is one formatting area. If you click here, if you click on the formatting, click on a visual, click on a formatting. How this is appearing, guys? I click on the visual first, then on the formatting. You will see n number of options appearing. Okay. So what this area is doing, helping us in creating the visuals and formatting it. Okay. Now I will move along. You need not to focus much on it right now. Okay. The next thing that I want to focus on is the filters shelf. Okay. Please look at this filter shelf. What is this? A filter shelf is an area where you restrict your report. Okay. So for example, I have 5 visuals on this report. Okay. I want to only show these 3 visuals for the West region. Okay. I only want to show the visuals for the West region. So what I can do is I can apply the filter. Okay, for example, a region. I can move this here and select West only. I will teach you all these, but just giving you a high level overview of each area. So if you need to restrict, you will restrict from here. If you need a visual, you will pull from this visualization area. And why we imported the data in the very first place is you can see there is the data pane here. Okay, there is what? Data pane here. So if you go and expand this, I would request to please go and expand, collapse this. Please try. Please try expanding and collapsing this. We have covered the filters, we have covered the visualization. Okay. Now the data. Okay. The important thing about data is you see there are different icons here. Just keep in mind as of now, only just keep in mind as of now, there are different type of fields inside my data. Some are measures, some are columns. I will explain it a little later. Just telling you to remember only. Okay. Now let us go to the next topic. Guys, what are the Power BI desktop components? Okay. So what we are doing right now, we are looking at which tool? Power BI desktop only. Okay. We have not looked on the service. We have not looked anywhere else. So Power BI desktop, inside Power BI desktop, there are 3 components. The 3 components are, first is Power Query, second is Power Pivot, and third is Power View. Okay. Now let us try to understand what each and every component does in the Power BI desktop. Okay, let's talk about the first component. The first component is Power BI desktop. Power Query. The first component is what? Power Query. What do we mean by a Power Query? Power Query performs the data transformation. It stored the result in an Excel file or in a Power Pivot model. So what you can understand from Power Query? Power Query is the subpart of PBI desktop. Power BI is the subpart of Power BI desktop that help us to perform the data transformation. What it help us in doing? Data transformation. Okay. So what do we mean by data transformation, every one of you? Is my screen not shared? Hold on for 1 second. Okay. So what do we mean by data transformation? Data transformation is a very important step. Okay. Let me give you 1 or 2 examples. Let me give you a couple of examples. Okay. So for example, there is a column age. Okay. There is a column age in the file. I am taking the example. In our file, it is not there. Okay. So age contains the value like this. I'm just writing some sample values. Okay. 10, 15, 12, -3, -5, 14, and 20. Just tell me two things. Are these two values, -3 or -5, valid? Are these two values valid, -3 and -5, for the age column? Correct? It is not valid. Then my second question is how to remove them. How to remove them? You might not be knowing this. Okay, you might not be knowing this. Now, the answer is data transformation. The answer is data transformation. So what do we mean by data transformation? Data transformation means we just remove the data that is not needed, or we perform some operation on the raw data. Data transformation means we perform some operation on the raw data so that it is useful for our reporting. Now, these transformations are done using Power Query. Power Query can be opened via this option. Let me tell you. So, every one of you, do one thing. Can you please click on this transform data here? Can you please click on this transform data here? Yes. So we need not to do anything on it right now. Okay. Can't be possible that Samson, if you click on the transform data, this option is not open. So if you click on this transform data, it will short open a new window. Where you need to click on is here, transform data on the top. So what it will do, it will open a new window. So guys, just you need not to do anything on this as of now. I am telling you this is Power Query interface. What is this? This is Power Query. So you can crunch your data here on this window. Okay. You can do any operation. You can remove the first row, you can merge, you can append, you can do n number of steps. Okay. But we will be doing that tomorrow. That is the part of tomorrow's class. I was just showing you how to do it. Now you can close this from the top. Close this, please. we have covered Power Query. So Power Query data transformation will be done. That is one subpart of Power BI desktop. Any doubts? Okay, no doubts. Samson, I'll help you out in some seconds. Okay, I'll help you out in couple of minutes, maybe not seconds. Because this is not a blocker. I'll give you the screen share in some time. The row what you had with chart like was not there. Not a problem, Vilasni. Not should be done in query editor. Yeah, it should be done in query editor. Not a problem, it's not there though. Right now it's fine. We will cover each and everything, but gradually. Okay. Now, second thing is everyone, the power pivot. What do we mean by power pivot? Power pivot means performing the data modeling. What power pivot does? It performs the data modeling. It builds the relationship. It creates the user defined field. So only remember this one line from me. Power pivot help us to create a data model. Okay, Power Pivot is the sub area of PBI desktop which will help us in creating a data model. So remember we looked at which area? This data modeling area. Correct? We looked at this data model view now. So this data model view is the area where Power Pivot will be automatically applied. What I'm saying, it will be automatic applied. We need not to apply this. Okay. So when we will be creating the relationship, Power Pivot will be automatically running in the backend. Like we were doing in the transform data, we were doing separately. Here we need not to do separately. It will be doing itself in the backend. Okay. Now the third component. The third component is the Power View. Okay. What is the third component? The third component is Power View. Power View help us connect to different data sources, create view, and add interactivity. Okay. So how Power View will be used? It will be automatically used again. It will be automatically used in the report view. The moment you will be creating a visualization, the moment you will be dragging a filter, Power View will be automatically used. So in short, you will be using the Power Query. Okay, you will be doing it. But Power Pivot and Power View will be used by itself. Okay. Now I'm going again on one PPT and I want you guys to read it, please, every one of you. Meanwhile, I'm looking at the doubt sections. Okay, so Vilasni, I said that we will be using the Power Query. Okay, we will work on the Power Query. In the Power Query, we need to interact. That is why M language is written here. Okay. You mentioned we will work on the Power Query alone, and pivot and view will be reflection on that by itself. I have mentioned the M language inside the Power Query, correct? Power Pivot and View will work by itself, but in the Power Query we need to interact, correct? Is it clear to you? Vilasni, can you please respond? DAX we will use in Pivot. So what I intended to tell you at that time is anything that you will be doing while creating the report, you will not be opening a separate tool. In the case of Power Pivot and the Power View, a separate tool will not be opened. But in the case of Power Query, a separate tool will be opened where you need to perform the data transformation separately. But in the Power BI desktop, if you are creating decks, the Power Pivot will be called itself. Okay. If you are doing drag and drop, Power View will be called itself. Is it clear now? Is it possible to publish a dashboard using Power BI desktop? Is it possible to publish using Power BI desktop? The answer will be yes. The answer will be yes. You will publish to the Power BI service. The answer is yes, because you will publish to the service, okay? But from the desktop, you will publish from desktop to service, okay? So if you go and see in your workbooks, there is an option called publish here. Can you see there is an option called publish here? So clicking this option in the Power BI desktop will help you publish to the Power BI service. Okay, so answer will be yes. Now let us move forward. Allow me 1 minute, please. Now tell me this, which type of device can be used to access a dashboard designed using a web layout? Designed using a web layout. The answer is C. Okay, why the answer is C? Because anything that is designed for web layout will be accessible in mobile also. Okay, anything that is designed for web accessible in mobile. I'll give you one example. So you have seen many sites open in mobile. If you talk about any website, they open in mobile, but there is an option of request desktop site also. For some of the website, if you open in mobile now, sometimes there is an option of request desktop site also. So the website that is opened in the desktop will be opened in the mobile and vice versa. Okay. Now, what are the key takeaways? Uh, let me know if there is any doubt in these. Let me know. Okay. Just look at these pointers. If there is any doubt, still let me know. So what are the key takeaways of this session? We have understand the concept of business intelligence. We understood the basic architecture of Power BI, where we understood the gateway, the connection to data sources, the Power BI service, and desktop. Now, after that, we install the Power BI desktop and look at the subcomponents of Power BI desktop. So I think so there should be no doubt in these topics. So now we will talk about the various terminologies of Power BI. Okay. So the first terminology that we will be covering is a data set. What do we mean by a data set? So anything that we will be importing as data in Power BI desktop will be referred as Power BI data set. So if we look at the formal definition of a data set, the formal definition of a data set is collection of data. It is what? A collection of data which you connect to or import from. Okay. So in our case, what is a data set? Our data set is Excel. We have connected to which workbook? Excel workbook. So Excel is our data set. This data could be placed in a single database or may come from the disparate source system. Look at this very good example. Okay, so right now what was happening, all the three sheets, correct, order and the returns and the people, these all three were coming from a single database, correct? Single database means Excel. Only Excel was there. But it might also happen that one file is coming from Excel and the second file might come from a database. Okay. The database could be Amazon. For example, this orders data is coming from which Excel, and this returns data might be coming from the Amazon database. So it can very well happen. Interoperability between the data set is there in Power BI. Okay. Now, what is this third thing? The field section in the Power BI desktop shows available data set. So we have not covered field as of now. Everyone, if you go to your Power BI, please go to your Power BI, everyone. So this entry, this city, country, customer ID, every single field, every single name here is called a field. So what is a field? A field is a column of a data set. A field is what? A column of a data set. Now, you can use the data in these data set as parameters and new measures and columns. For now, ignore this line. You will not be able to understand this. Okay. Or you can use this to create the visuals. So what is a data set? In short, a data set is a collection of data from one or multiple data sources. Okay, these data sets will have the information in fields and we will be using the data set to create reports. So any doubt in this data set, please everyone read the definition of the data set. Now let us move to the next thing. So what is called a report? A report is a collection of one or more pages of visualizations. Okay. So if you go to Power BI, everyone notice at the bottom of the screen, there is page one. Here is plus icon. So if you click on plus icon, there are multiple pages created. So what is a report? A report is a collection of multiple pages. A report is what? A collection of multiple pages. Okay. Now moving to the next line. In Power BI desktop, you can see tabs in the bottom while viewing a report. Correct? The tabs are the additional pages of a report. Correct? We just saw that. And you can add, rename, and duplicate. So it's easy to understand. Now the next thing is visualization. So what do we mean by visualization? Visualization means visual insight of data can be viewed using various building functionalities known as visualization. So visualization means we are looking at the insights. Okay, we are looking at what? Insights from the raw data. This can anything be ranging from a map to a tile to a matrix. It can be anything. So if you go to visualization area here, you can see the visual can be anything. The stack bar chart, column chart, the table, the decomposition tree, etc. etc. So you can create basically any visualization. Vilasni, the questions might not be exactly on the definitions, but you should have a fair understanding of each and every concept. Because while asking the question, they can refer to any terminologies and there can be conflicting terminologies. So you should have a fair understanding of each and every terminology. For example, let us take example of report and dashboard. Okay, we just saw report on the previous page. Now, what is a difference between a report and a dashboard? The only difference between the report and a dashboard is report is multiple pages. Okay, if there is a multiple page, then it is called report. If this is a single page, then it is called a dashboard. So what is dashboard? Dashboard are created from a subset of data set and customized as per business requirement. They will always be single page. So let me rephrase this. So dashboard are what? Dashboard are the subset of report. They will always be single page, okay, and they will always be created on Power BI service. Okay, the dashboard cannot be created on the Power BI desktop, only created on Power BI service and single page. Parameter and custom visual, let us not take this. I want every one of you to please read this DAX definition. Can you please read this DAX definition? Deepa, I'll explain in some seconds, please. Can you please, everyone, can you please read this DAX definition? Meanwhile, I'm explaining Deepa the dashboard definition. So, Deepa, the dashboard is something that we create on Power BI service. Okay, it will be a single page report. Okay, it will be what? A single page report created on Power BI service. How it will be created? Either it will be created based on the data set that is already published on the Power BI service, or it will be created using the report already published on the Power BI service. Okay, so it will be a single pager report created on Power BI service. I will create a dashboard in the session number 5. Okay, so don't worry about it. I'll explain you this in detail. Meanwhile, everyone, have you read the definition of DAX? So what is DAX? DAX is the functional formula language of Power BI desktop. So basically, every formula that we write will be using the DAX internally, okay? Internally or explicitly. We can explicitly write it, or internally it will be using the language that is called data analysis expression. The function used in Excel are like DAX functions, though DAX offer much more functionality. So this line, every one of you. So you guys might be aware of the functions in Excel. You might have written equal to sum or equal to average. Have you ever used these kind of functions in Excel? Equal to sum, equal to average, or like this? Similarly to this, we have the functions in DAX also. So if I have to write the DAX, we will make use of function. Here it is given a very simple example of today's date. So for example, if I have to create today's date, for example, I have to create what? Today's date. So I will be using today's date equal to today. Just I will use the today function and we will be able to create today's date. Okay. When it will be processing it, when this part will be processing, it will be giving me what? 28 Feb. Okay. If I'm running it today, it will give me 28 Feb. If I'm running this report tomorrow, it will be giving me 1st of March. So that is DAX for you. Now it is important. Next thing is drill. It's a dynamical formula. Yes, it's a dynamical formula. It evaluates in the context given. So Mohit, when we will be diving deep into DAX in the session number 3, you will understand this much better. It is dynamic one. Now, the next thing is very important. This is called drill down. Okay, drill. So, for example, I'll give you a basic example. I am showing the data. Okay. For example, guys, for example, I am showing the data like this. There is category in our dashboard, correct? There is category in our dashboard. Then there is subcategory in our dashboard. Okay. Then there is what subcategory in our data. Okay. Okay. Now the second thing that we covered is the table view. Okay, whatever the data you have imported in Power BI will be visible in the table view by default. Okay, you can play around with the data and see how the data looks like. Okay, in the model view, we have seen whatever data we have imported, how it is related to each other. We will discuss more upon it. So in the model view, we are looking at the relationship between the different tables that we have imported, and this model view uses which component. uh, there are three options. So guys, tell me, this model view uses Power Pivot or Power Query, Power Pivot, Power Query, or Power View. Tell me which one it uses. That's a question to every one of you. If I talk about the modeling, which component of the Power BI it uses? Samson, I'll be clearing the doubts one by one. So allow me some time, your doubt will be clear. So that's a Power Pivot. Yes. So everyone, it is Power Pivot. Okay. So that was what we were majorly covering. Okay. Now, one more thing that we have covered yesterday is importing the data. So I would request every one of you to start from the scratch. Okay. Yes, Shrikant. So we are starting from the scratch. So have you downloaded the Power BI desktop? Okay, then you can follow me. Okay. Guys, if you have downloaded the Power BI desktop, there was one more person who had the first session today, Kavita. So Kavita, you also have the Power BI desktop in your system? Perfect then. You guys will not be missing much of the content then. Okay, mostly the content will be repeated. Now, every one of you, we are going to create a blank report. So please click on the blank report. Please click on the blank report. Now, in the blank report, let me explain you what each and every data component here depicts. Okay. So let me tell you about get data. So get data is the main component where you can import any data set from. Okay. You can import any data set from this button. Second button is Excel workbook. So if you need to connect to Excel workbook, it's a shortcut kind of thing. Okay. If you want to connect to Excel, directly click on this button and you will be able to connect. The third option is one lake catalog. So there are one lake option. There is a database that is called one lake. That database can be connected directly from here. So what are these buttons? These buttons are nothing, but they are the options to do the connections to our raw data. There is one option that is particularly interesting, okay? That is called the enter data. This option is enter data. What do we mean by enter data? Enter data means you can type your data and that data will be stored in Power BI. Okay. For now, we will be using get data only as of now. We will be using the other option of enter data little later in the session. Okay. So please click on get data, every one of you. Please click on get data. Now, yesterday, I opened one PPT. Hold on for 1 second, please. So this slide tells you what are the different data sources supported in Power BI. So there are roughly about 60 different type of data sources that can be connected from Power BI. Okay. To name a few, we have the PostgreSQL, we have the IBM DB2, MySQL, Oracle, and Excel type of data. Now, we have to understand this thing very, very well. Okay. there are two type of connection. One is data import and one is connecting live. Okay, I'll explain this concept in next 2 minutes, but just think of the connection as of two types. One is the import mode, second is the live connection. I'll explain you in some time what these type of connections are. Okay, now inside this, you see file are there, database are there. I explained you these two yesterday. What are the file? What are the data sources? But what I didn't explain yesterday is the Azure, Power Platform, online services, and other. Okay. So what are these options? There are many tools that are available in market. Out of those tools, one is what? Microsoft Azure. So if your data, the base data is in the Azure systems, then you can connect from here. So if I click on Azure, you can see there is Azure SQL database, Azure Blob storage, or any services that is using the Microsoft Azure tool, you can connect from here. Okay. Now, the next thing is Power Platform. In the case of Power Platform, we have the data flows, we have the data flows legacy. So, what I want to say is you don't emphasize much on it. It is organization to organization basis. My organization, the one that I am clear right now working in, is using the Snowflake. Okay, they are using the Snowflake database. For some of the data, some of the company, it might be Azure SQL database. So you see Azure SQL database. For some of the companies, it might be Oracle. So you can connect to Oracle database. So it's how your company is using which database. In our case, we have a Excel file. What we have? We have the Excel file. So what you are going to select? You are going to select Excel workbook and hit connect. Now, please select the file that I have shared with you. Okay. So please click on sample superstore updated data. What's the file name in the repo? It is sample superstore. It is sample superstore. I'll share the file once again. Gopi, the file name is sample superstore updated data. Mohit, you might have joined a little late. So may I know what will be the agenda for today? The agenda for today will be majorly Power Query. Okay, so we will be understanding the ETL part of Power BI. How do we transform the data and make our data reporting ready? So this is what we will be covering today only. Okay, we'll not be creating any visuals as of now. Visuals will be covered in the third or fourth session. Today we'll be just looking at the data crunching. Okay. Now, every one of you, the same step like we followed yesterday, we will be selecting these three sheets, 1, 2, and 3. Please select these three sheets. Please select these three sheets. Now, there are two options. One is load data at the bottom, and there is transform data at the bottom. Let me explain you what each component means.
The files which you have shared, it was in the same name, like week 1, 2, and sample source super data.
Yeah. Is it uploaded under the portal?
Yes, it is uploaded. So long as you can check it under the session materials. So
Yeah.
whoever is facing the issue, just click on the session, yesterday's session, and you can scroll down. You can see session materials, and you will be able to get all the files.
So, Krishnan, it will be in the session materials of yesterday. So if you check the yesterday session, it will be in the session materials. Okay. Please check and confirm if it is there. The rest of the folks can confirm it is available there. Okay. So every one of you, I was explaining you two things. One is load and one is transform. So what do we mean by load and what do we mean by transform? If we load the data directly, the data is seen here in the view. Okay, if we load the data directly, your data will be visible here towards the right hand side of the screen. But what do we mean by transform? If we want to perform some operations, okay, some operations on our data, then it will be the transform data. So I use the term ETL a lot. ETL a lot. So I like to explain what is ETL and what are data transformations. Okay. We will be on this window only right now. So first of all, what are the data transformations? Let us look at couple of examples. So in the case of data transformation, some of the data transformation could be renaming, okay, renaming a column. So for example, we are having a column that comes by the name of column 1 and column 2. You are seeing here now, there are the column coming by the name of column 1 and column 2. But this is not acceptable for reporting. So renaming is one kind of transformation. If we want to filter, then we can do the filtering. If we want to do the aggregation, okay, we want to do the sum, etc., we can do the sum and all on the Power Query layer. So what we can safely assume, if we want to transform our data, okay, if we want to transform our data to make it reporting ready, it is called the data transformations. Now, data transformation include three things, okay. Data transformation is done using the three steps. One is extract, okay, one is extract, second is transform, and third is load, okay. So what we were doing yesterday, we extracted the data. Extract means you connect to the database, okay. Extraction means you connect to the database and you pull the data from a database, correct? So when we connected to Excel file, that was what step? Extract, okay. The second step is transformation, third is load. So what we are doing from load is directly we are loading the data for our reporting use. But what do we mean by transformations? I just explained to you. If we want to crunch the data, that will be the data transformations, and it is always used by every PBI developer. Okay, so data transformation is a three-step process: extract, transform, and load. Right now, what you will be doing is select these three options: orders, people, and return. Now transform the data. Where you will click transform the data. Click here, please. Perfect. Okay. So what is this? This is a separate tool that has opened. So you can see Power Query Editor at the top. What is this? Power Query Editor. This tool will help us do the transformations. Now, let me tell you a quick, let me give you a quick navigation, tutorial about the navigation of this. Okay. On the left hand side of it, this part will show you the query. This part will show you query. So what do we mean by query? What do we mean by query? Query is a table. Query is nothing but a table. So we imported three tables: order, people, and return. They are nothing but the tables that we have imported. Okay. The next part, applied steps. Important part here. So if you click on orders, I would request everyone, please click on orders here. Okay. Now, orders, under orders, you will be seeing something like this: query settings. Okay. You will be seeing something like this. What is this? Each and every query has some query settings where the name of the query is there. So our query is orders, and very important thing, guys, applied step sections are there. So what are these applied steps? Applied step means when we connected to our database, when we connected to our database from Power Query, from Power Query. Power Query did what steps? Okay, Power Query did what steps to connect to this order table in our database. So this order table was residing where? In our Excel. So what Power Query did? It navigated to source. It navigated to source in these two steps and promoted the headers. You need not to understand this in detail. Okay, right now, some queries have the by default step. So you will see inside each queries, there will be some steps by default. Please navigate here in order, people, and return. Try to click around it, and you will find that there are some default steps here. Now, there are two things. I was telling you, one is data import and one is connecting live. Okay. Now, what is data import and what is connecting live? I will draw one example. Okay. So let me go to my data sheet and open a blank PPT. Okay, open a new slide here. So what do we mean by import and what do we mean by direct query? For example, guys, there is your database. I work in which company? Hindustan Unilever Limited. I mean, I don't actually work in that. I'm just taking example. I work in Hindustan Unilever Limited. So what I did, I had a data set. I had a data set that has 100 million rows. Okay, 100 million rows. I have one table. Okay, that has 100 million rows. Or let's take one more example, one better example. I work in ICICI Bank. Okay, not in the HUL. I work for ICICI Bank. You will be able to relate it better. That's why I switched this. That your table has 100 million rows. Now you want to create a report where you will be using this tables. Okay, where you will be using this table. Now what we can do is we can download this 100 million records in the Power BI. Okay, we can download this and then do the reporting on top of it. Okay, this is called import. This is called what? Import. The second option is we can go and connect to this database only. What we can do? We can go and connect to this database only. So there is a connection existing between a report and the database. In that case, what will happen? These 100 million records will not be downloaded. So not downloaded. Okay, now there is the mixed reaction here. Some are saying CSV, some are saying the imported one, and some are saying direct query. Now I would explain this in next 2 seconds. So what is happening, guys? This report R1, this is my report R1, where the data is locally in my report. Okay, so what is happening? If I am creating a visual, there is a visual V1, there is a visual V2. So what is happening? When these visuals are created, they don't have to go to the database. Okay, they don't have to go to the database to fetch the data. So we don't have to go here. The data is available locally in the report R1. So there are no calls to our database. That's why there is no latency. Okay, there is no latency. This is the reason why import mode will always be faster. Import mode will always be faster. Okay, now what will happen in case of R2? Okay, let me draw the figure then. In the case of R2, the data will be separate. Okay, so this visual V1, this visual V2. So what will be happening? The visual V1 will be sending a request to where? To the database. Okay, sending a request to the database, it will return the result. So here what is happening? The network latency is happening. What do we mean by latency? We have the calls, okay? The data is not local to my file, it is somewhere else. So it is slow. Direct query is slow. Tell me, tell me, uh, there are 100 plus DAX function, okay? There are 100 plus DAX function. Which file will support more DAX function? Just think of it. Which file will support more DAX functions? Import or the direct query? File that will be supporting more DAX functions will be import mode. Why? Because you imported the data in the file, okay? So the data is where in file embedded inside the file, okay? So any function that is running on top of data is running inside the workbook, inside your Power BI file. But what is happening in the second case? Any DAX function that you are writing, it will be executed where? On the top of database. On the top of which? Database. That is why some database can support some functions and some database cannot support some DAX function. So import is much better. So what we understood till right now is import is faster, okay? It is faster, it is having high file size, and import support more function. But then you will ask me, Pranav, what is the use of direct query? What is the use of direct query then? Can someone tell me what is the use of direct query? So guys, what happens now? Most of the reporting are on the day -1 basis, okay? So sometimes if you are doing a reporting for a company like ICICI Bank, okay, I am doing the reporting for ICICI Bank and I am tracking the number of complaints, okay, I am tracking the number of complaints. So this is the KPI which business is fine with if I show them the D-1 data. So the business is fine if I show them the number of complaints till yesterday, correct? Till yesterday. But in some cases, what happens? The data has to be shown live. Like which case? Stock market, okay? Where everything changes within second. Like the sports analytics. If a cricket match is streaming and a report is on top of it, then these are some option where we need live reporting, correct? So where the use case is, if my use case is that we are fine with the D-1 numbers or with the numbers that are previously loaded till yesterday, then we will use import mode. But if my reporting says that the data has to be updated live, then we will use which storage mode? Direct query. Now the questions are welcome. Please ask your questions. So, Vilasni, according to your question, but usually in business scenario, they will have the DB support with data. So, how this import is suggested? So, I told you the Power BI report will slow down. Okay, Power BI report will slow down if I use what? Direct query. Remember, I told you we have 100 million of records. So, if you use the direct query, it will slow down. So business prefer fast report. What do business prefers? Fast report, okay, that loads in less time. That's why import is suggested, okay. In both of the cases, gateway will be used. So we will imagine, okay, right now I'm creating a figure. There is a report R1 using import, okay. There is a report R2 using direct query. You publish both of them where? On the service. You publish both of them where? On the PBI service. Now, imagine there is a PBI file here. But how it will connect to the database? You will use the gateway. Okay. How it will be done with the help of gateway. Now in the second option, we have the PBI file. The data is there locally. It will work fine, but the data will not be updated. Why the data will not be updated? Because we have not set our report to update the data till now. So what I'm saying, if I need to update the data, I will have to connect to a database and set the refresh. Okay, I will have to give Power BI instructions that Power BI, please refresh my data every day at 4 p.m. So what Power BI will be doing? Every day at 4 p.m., it will connect with the database with the help of gateway and refresh the data for us so that we can get the updated data in the imported report. Is it fine now? Does I answer your question, both of you? Kishan, to answer your question, it is not available for us to connect to direct query. Why? Because let me give you the answer. Okay. You are 40 participants there on the chat. Okay. What we will need a database. Okay. What we will need is a database to connect to the direct query mode. Okay, so it will need the credential and it have some cost implications. That's why I'm not able to show you the direct query mode, but let me tell you how to configure it. Okay, I will show you how to configure it. Okay, so every one of you, please go to your Power BI workbook. Please go your Power BI workbook. Please go to your Power BI workbook and do one thing. Do one thing towards the right top, towards the left top. Okay, go to towards the left top. There is a button, close and apply. There is a button, close and apply. If you click here, please close and apply. Please close and apply. It will take some seconds to load, so bear with it. Yeah, it will take some time. Why it is taking some time, everyone? Because it is importing. So it is importing the data, correct? That is why it is taking this much of time. If this would have been the direct query, it will not take this much of time. So what happens in import? All the rows will be imported. You see, yeah, Samson, just a second, please. You see, after this is imported, it is written that 9,994 rows are imported. You see, when that finished, it was saying there. So what did I apply? Close and apply in the Power Query Editor. Samson, in the Power Query Editor, towards the left top, here towards the left top in the Power Query Editor, you will find an option of close and apply. So please click here and do close and apply. Click on any of the table. Go to the model view, click on any of the table and expand this advanced section. Expand this advanced section. Expand this advanced section. So you will see the storage mode is import right now and it is disabled for you to change to direct query. It is disabled for you to change to direct query. Let me know if you can check it. In the Power Query Editor, there is no option of closing and applying. Shrikant, click on any of the table, please. Click on any of the table in the model view. Okay, go to the model view, click on any table. Click on any table and go to advanced here. Once you click on the table, only then it will be available.
Good afternoon. So, basically, when I did the transformation initially, when you said we should transform, it was showing query. So it said you should close it. That was why I closed it.
No, you need not to close it. You have to do close and apply. So everyone just wait for 1 minute. I'll help him out. Go to the get data once again, please. Go to get data once again quickly. So what you might have done, you might have directly closed it. Go to the Excel workbook, yes. Select all three and now transform data. Transform data, it will open the Power Query window. So guys, everyone for you, okay, you already have the orders query. You have already imported the data. You already have imported the data, so I'm not able to understand why. I mean, what is the issue at your end, Samson?
Right.
There
You
are
said
no.
it's
Mhm.
because I closed it. I closed. I thought you said I should close this here, and I did close here. So
Yeah,
I
close it.
didn't know.
Close
Yeah,
it.
I did. I should close it now.
Yeah, close it now. So you
You,
want to
I
see
close
the
the query, the whole query now again.
yeah, yeah, close it
This
because you have
was what I
already.
did. This was what I did before that you said no.
No, you already have the data imported, so we need not to import it again. Okay,
Okay.
that is why we need to close it. No, not now, not now. Yes. So now go to the model view. Go to model view.
Why is model view?
Uh, in the left, there is a model icon. There is the third icon on the left. On the left.
Why is model view?
Uh, okay, I'll show you. You stop sharing. You stop sharing. I'll show you where it is. Let me do that. Okay, so if you see this icon,
Okay.
this, yep. So can you mute yourself, please?
Okay.
Yes. So on this icon, everyone, once you click on any of the table, if you click on any table, then only the advanced property will be visible. Okay. See, if I click outside, advanced properties are not visible. If I click on any table here like this, it will be in the green boundaries, correct? And you will have the advanced properties available. Okay, now moving along. So your storage mode is import by default. Why direct query is not there? Direct query is not there because some data sources does not support direct query. Why? Because the Excel is there. Excel is what? A flat file. So Excel cannot be directly queried, only it can be imported. So if the data source is like that, it can only be imported. So the direct query mode will be grayed out. Here you can change the configuration if needed in future. Okay, everyone clear? So Ramya, yes, you are helping him correctly. So okay. Now, Samson, there is one button you might be seeing here on the top, apply changes. So please click on those apply changes. Apply changes, please click on those. Okay, so now moving along. Okay, now let us move to the next concept. I would open the PPT once again. Hold on for 1 second. Everyone, can you please quickly read it for next 10-20 seconds and then we will move forward. And let me know if there is any doubt on any of the concept. We will discuss it. Now there is one point, has the limitation on number of refreshes per day, unlimited refresh. Okay, why you have the limitation on number of refreshes per day? On a on a data import, okay, you can only have the 24 refresh. Okay, 24 refreshes can only be there in a day. So basically you can refresh your data every 1 hour. Okay, not more than that. Samson, oh, okay. So do one thing, Samson, wait for some time. I'll help you out. Okay. Let us move forward with the session. There is no blocker on your side. Okay. As of now, there is no blocker. So please understand rest of the concepts. When I'll get some time, I'll help you out. Okay. Hope that works. Now, if I move forward, okay, uploading the data is there. We will understand the next thing. The next thing is data type. What are the data types? Okay. So every one of you do one thing. Go and click on the transform data here. You also, Samson, go and click on the transform data here. Please click on transform data. Again, the same window will be open. Okay. Again, the same window will be open for you. Now, where we need to look at is this section here, 1, 2, 3, ABC, and this calendar-like icon. Please look at this section. Okay, Samson, I'll help you out in 5 minutes. Please allow me 5 minutes, then only I'll be able to help you out. Okay, so every one of you, there is one data type section. So what do we mean by data type? Data type means what kind of data we might expect in our column. So in Power BI, there are 5 to 6 data types. Okay. What are these 5 to 6 data type? The first is the text data type. So what is a text data type? It contains the sequence of character, and how the data type will be shown? ABC. So the column that has the ABC symbol contains the text, which is the sequence of character. Okay. There are the second data type. So if a column is storing anything, that is date. Okay. So for example, today date, day minus one, anything that is storing the date will be of date data type. Okay. The third thing is date or time. So if we are storing time also with the date, then the data type will be date and time. Okay. The fourth data type is number. So if we are storing any number, so for example, sales, for example, quantity, for example, anything else that we are seeing will be a number. Okay. The fifth data type is Boolean. Boolean is a true or false data type. It can only store the logical values, which is true or false. So for the next 2 minutes, I would request you guys to look in your Power BI. Okay. Look here in your Power BI, identify the data type, which all data type is there on which column. Okay. Meanwhile, Samson, just please quickly share your screen. Please quickly share your screen. Yes. Okay. Now go to the report view. Go to report view. It is already shared. It is already shared, so don't worry about it. Go to the Power BI, please. In the Power BI, if you click on the report view, you click on the report view. Samson, this is not expected. I clearly told yesterday that you have to be, yeah, click here, please. You should know these three icons: report view, table view, and the model view. I'll be using that again and again. So when I say go to report view, you have to click this icon. When I say go to model view, you have to click on the third icon. Okay. So in the report view, only you will have the transform data, correct? So please click on the transform data here. Please click on transform data here. Yes. Now you will see the screen. Okay. So please follow me properly. Now you can see the screen, and now explore the data types within the table. Okay. Now let me share. It's working fine for you. Okay. It's just that you are little messing up between the windows. Now every one of you might have, okay, hold on for 1 second. Yeah, every one of you might have explored this by now. Okay. Now you might not be getting these bar values as of now. So don't be worried about it. I'll show you how they will be occurring. Okay. Till now, I guess you are clear what are the different data types of the column. Now, one thing I would like to show you, there are the different data type in the numeric. Okay. So if you scroll towards the very right, of orders table, go to orders table, please use this scroller. Okay. Please use this scroller, go towards the very right. There are two values that are shown here, 1.2, okay, and 123. So what do we mean by that? 123 means the number is not having any decimal places. Okay. 1.2 means the number is having the decimal place. Number is having a decimal place. So everyone, please do one thing. Please do one thing. Let's try to do one thing. Go to sales. Go to sales. Please click here on 1.2, where 1.2 is written now. Please click here on 1.2. Now I will show you how to change the data type. So what we will be doing is the sales number. If you look at the sales figure, guys, some have the 2 decimal place, some have 3 decimal place, some are having the 3 decimal places. Okay. So what I am saying fixed decimal. I want to do fixed decimal places. I want the number only till 2 decimal place. So how can we do that? This is called a type conversion. What is called type conversion? Type conversion means when you change from one data type to another. Okay. So how this can be done? You click on sales column. Click on sales column. Then make it fixed decimal number. There is second option, fixed decimal number. Now it will be asking you, shall I add a new step or replace current? So what is this window, everyone? It might be asking to some, or it might not be asking for some. Okay, that is perfectly fine. Now what do we mean by replace current or add new step? What happens, guys, when you change the data type or when you try to do any operation, when you try to do any operations on the Power Query, that operation will be recorded as what? A step. Okay. This operation that we will be doing will be recorded as a step. So it is asking us, Pranav, you are clicked here. Do you want to change this step or do you want to add a new step? I would say add a new step. So I did add a new step, and then you will see it is up to 2 decimal place. Confirm me if you are able to do it, guys. Perfect. Okay. Now, one more thing. Power BI automatically detects the data type. Power BI automatically detects the data type. Now, you might be asking, Pranav, how it detects the data type. Okay, how it detects the data type of a column. So Power BI scan the first 1,000 rows of your data set. First 1,000 rows of your data set, Power BI internally scans, and then whatever data type is best suitable for that column, it will apply. So in the rare cases only, you need to do the data type conversion. Okay. Now let us move forward. Let us try to do the knowledge check. Tell me the answer to this question, please. ABC means Vilasini, it can include any alphanumeric. Okay, it can be ABC, it can be 1, 2, 3, alphanumeric. Okay. Okay. So guys, the next thing that we will be performing is called the data modeling. The next thing that we'll be performing is called data modeling. Now, allow me 15 seconds. This thing is covered, correct? I have explained you data view, I have explained you relationship view, and I have explained you size is 1 GB. And we have the different licenses. So based on the different licenses, we have the different sizes. Okay. Now, every one of you, the next thing that we will be discussing is called the data modeling. Okay, it is very important concept. Allow me 15 seconds. I'll show you what is called the data modeling. Okay. Now, till now, what we have done. First of all, I'll request you to please read this slide for next 2 minutes. Please read this slide. Please read this slide for next 2 minutes. Kindly enlarge, sir. We can take before we begin this topic. Okay, we can. That's not a problem. Okay, guys, if you have any doubt, do let me know, please. Let me go to the PPT view. So please read this slide and then we will move forward with the data modeling. Ramya, just 10 minutes and then we will take a break. Okay. No, not yet. Not yet. Data modeling is the part of transformation. Data modeling and transformation will be covered by end of day. Okay. So let me explain this. Guys, data modeling in Power BI is the structuring and organizing data. Correct? So how we are structuring our data, how we are organizing our data, that process is called data modeling. Why we are doing this? We are doing this to efficiently analyze and visualize our data. Okay. What does it involve? It involves connecting to different data sources, defining relationships, creating calculations. Okay. Now we will be explaining one by one how we can create the data model. So till this point of time, you guys are aware what is a what is a table. Okay. We have imported 3 tables in our data set as of now. The first table that we imported is orders. The second table that we imported is returns, and the third table is people. Okay. So the data model have 5 important components. The first component is the table. Second component is the relationship between these table. Second component is relationship between these table. Now I will tell you what are the relationship. So please go ahead. Okay. And go to your workbook. Okay, please go to your workbook. In the Power Query, everyone, okay, Now focus with me what we have to do. We have to do close and apply. Everyone never click this button directly. Okay, don't click this button directly. You have to close and apply. So the moment you do close and apply, any changes that you made here will only be saved. Otherwise, your changes will not be saved. Okay, so please click close and apply. It will open a new window, simple new option pop up, close and apply then. Okay, so it will apply your changes. What will happen? It will apply your changes. If you directly close, your changes will not be applied, which Ramya or maybe Shrikant pointed out. Okay, so Samson, specifically for you, please follow that process only. Now everyone, please focus with me. Oh, we missed one step. You missed one step. Okay. So guys, we missed one step. What step we missed? Please only listen to me. Don't try to do it right now. What we missed is in the people table, we are getting column 1 and column 2. In the return table, we are getting column 1 and column 2. We are not getting proper headers. Okay, what we are saying, we are not getting proper headers like we are getting in the order table. Okay, so please hear me properly. Whenever these kind of situation happen, you have to go to transform data, make the changes, come back again. So the process of transforming data and closing and apply will be happening a many of time. Okay, so again you will be clicking where? Transform data. Again transform data, and where the problem is? The problem is in the people table and in the return table. The problem is in the people table and the return table. So please click on people table. Please click on people table. Shrikant, that's not the proper way to do it. I guess I know that it is showing the apply changes, but not a proper way to do it. So every one of you in the people table, please click here, use first row as headers. Okay, please click this table only once. Please click this option only once, use first row as headers. Then you will go to return table and same operation will be done here. Use first row as headers. Okay, now everyone, please confirm if you are able to see the proper headers in both table. In both of the table, you should see the proper headers now. Yes, and again close and apply. Perfect. Yes, again close and apply. Whenever there is a change, you have to do the close and apply. Okay. Now, guys, do one thing. Okay. Please go to model view. Please go to model view after applying the relationships. Please go to model view. Now, what are these? Every one of you, these lines are called the relationships. Okay. These lines are called the relationship. What do we mean by relationship? Relationship means how one table T1 is connected to the other table. So this is called a relationship. Okay. Now, why this is useful? Only with the help of relationship, we can use the column from both of the table. So only with the help of relationship, we can use the column from both of the table. So for a moment, do one thing, guys. For a moment, do one thing. Go to report view. Go to report view, every one of you. Go to report view. Now, on the right hand side, do one thing यहाँ पर. Do one thing here. Expand the people table and expand the order table. Expand the people table, expand the order table. Why only in people and no line in returns? In returns also you need to do this. Missed first step and struck. So Krishnan, are you able to do it now? You have to go, okay, let me tell you. You have to go to transform data, okay, that was the first step. There in the returns table, or in the people table, the header was not coming properly. So you have to click on first for people, then you have to click on return. On both, you have to click use first row as headers. There is one option on the top ribbon, use first row as header. So you have to click this and it will be appearing properly. Then hit close and apply. Okay, then hit close and apply. From the order table, you have to select the sales. From the table is fine, not a problem. The visual type can be different. For some, it might be table, for some, it might be graph. Okay. So you have selected sales from here and region from here. Okay. Everyone, are you able to see any type of visuals where there are 4 regions coming and the sales are coming? Okay. What I want to show is you will be seeing the numbers. The sales number are coming corresponding to a region. Okay, corresponding to a region. Every region has a different sales number, correct? Now try one thing. Go to model view. Go to model view, please. Go to model view, please. Please click on this relationship here. If you click on this relationship, it will be highlighted in bold black. Click the relationship highlighted in bold black. Please hit the delete button. Please hit the delete button. Please hit the delete button. So what will happen? This line will be vanished. Now there is no relationship. Okay. So what we will be doing? Again, please go to report view. Again, please go to report view. And did you notice any difference? Did you notice any difference, guys? Okay. So guys, where to delete the relationship? Go to model view. Again, relationship will always be in model view. Go to model view. The two tables will be connected with the help of a line like this. So click on that line and hit the delete button. Okay, hit the delete button. Now, very important concept. Why all the bar have same numbers? Why all the bar have same numbers? Because guys, the Power BI is not able to identify which sales is for which region, which sales number is for which region. The mapping is not there because we have deleted the mapping, correct? That is why the sales is not properly mapped to the region. Okay, that is why the relationships are important between the table. Okay, now there are two ways to create the relationships again. One way to create the relationship is to go via the model view. Okay, the first way to create the relationship again is go via the model view, or there is one modeling tab on the top. Okay, now I will click on this modeling tab on the top. Okay, click on this modeling tab on the top. Please click on manage relationships. Where you are going to click? You are going to click on the manage relationships. Manage relationships, the moment you click here, it will be opening one window. Okay, it will be opening one window. Now, let me know if this window opened for every one of you. Let me know if this window opening for you. Samson, I guess you are not properly following me. I'm sorry. Every one of you, are you able to follow this? Where we need to do? Go to the model view. Okay, if you are on the report view, go to modeling. Click on manage relationships. Click on Manage Relationship. So this is where the window will be open. Okay. Okay, now, so guys, there are two ways to create the relationship. The first is auto detect, and then there is a new relationship. So you remember by default, there was a relationship between two tables. Okay. When we created the model, there was a relationship between two tables. How it was possible? Because Power BI have automatically detected the relationship. Now, please click on auto detect. Everyone, please click on auto detect. It will say found new relationship. Okay. You will see orders and peoples. The relationship has been created. Now, how this is created? So if the two tables have the same column name, okay, there was a column that was region in the people, and there was a column that was a region on the orders. Okay, two tables were having the same column name. Then it created the relationship by default, Power BI. Now you might be having a question, Prana, why there is no relationship between the orders and the returns? Okay, orders and the returns. So Power BI is efficient enough to create some relationship, but sometimes it scrambles and it is not able to create the proper relationship. There is when we need to interrupt. Okay, now please click on new relationship. Please click on new relationship. There should be this window that should be open for you. Let me know if this window is open. So if anyone is not able to follow, let me know on the chat window. Okay. So relationship, there are always two tables involved. In the relationship, there are always two tables involved, T1 and T2. So here also you need to mention from which table you want to create relationship to which table. So I'm saying in the from table, I want to create the relationship from orders to returns. Okay. From orders to returns. Now, for now, please look here the cardinality. Okay, please look here at the cardinality. The cardinality, you have four options by default. Okay, I will explain what are those options. The options are 1 to 1. Okay, I'll explain you in some seconds. The option is 1 to 1, 1 to many to 1, and many to many. Okay, just remember that there are four options in the cardinality as of now: many to 1, 1 to 1, 1 to many, and many to many. So what is cardinality? Cardinality means how many rows of one table, how many rows of one table are connected to how many rows of second table. Okay, in our case, there is a table T1 and T2. So how many rows of table T1 is connected to how many rows of table T2? Okay. So it could be one row connected to one row. Okay. One row connected to many rows. Many rows connected to many rows. Or many rows connected to one. I will explain in detail, but just for now, try to understand this, how many rows connected with how many rows of second table. Okay. Any doubts, guys, as of now? Now, everyone who are not able to do it, don't worry about it as of now. Now, please focus on a very important concept here that I am trying to explain. Okay. I am showing you two tables. Okay. Let's look at the order ID here. Okay. I am just pulling some order IDs. Allow me 10 seconds. Okay. So let me take a snippet of this one. Not the snippet of this one. Uh, Guys, look at this order ID. Hold on for 1 second. Order ID. The order ID is CA2014100363. And again it is coming CA2014100363. Okay. This is the order ID of which table? Orders. Correct? Correct? I now went to the returns. Okay. Allow me 15 seconds. This is important to explain. So let me phrase a proper example. This is not returned. 707. Hold on for 1 second, please. I'll have to explain properly. In the orders, let me pull the IDs. Okay, let me clear all the filters and 129707. Let's look for 129707. 29707, and then let us find one more order ID. 152345. It is not helping me. 153153 822. Okay, so let's take the example of this one. The order ID is CA2017 and 153153 822. So you see this order ID is repeating how many times? This order ID is repeating many times, 153822. Coming 4 to 5 times here. Coming how many times? 4 times here. Now look at this order ID in the second table. What is our second table? The returns table. Okay. Our second table is returns. Go to returns. Let's go to returns and let's go for this order ID. Everyone, please go to this order ID and search for in the return table and the order table. Look in your systems also. The order ID is displayed on the screen. It is 153822. So please everyone go ahead and look how many records are there. In my system, 4 records are there in the orders table and only 1 is there in the returns table. Can you check and confirm if this is the case? Is there anyone in the class who is saying it should be 1 to 1? My assumption is it should be many to 1. It should be many to 1. Correct? Now you guys know by yourself what is cardinality. Okay. If one row is there and only one row on the right table, then 1 to 1. Okay. If one row in the left table, multiple in the right, 1 to many. Multiple in the left table, 1 in the right, many to 1. And if multiple rows in both table, then many to many. Okay. So that is called the relationship. So our data model is ready now. Okay. I'll again open and show you the relationship. Okay. I'll again open and show you the relationship. So there are two things that I need to explain also. make this relationship active, and cross filter direction. Okay, what are these? Make this relationship active means, guys, okay, we have very small data set right now. Okay, we have very small data set right now. It might happen that two tables are connected via different column. For example, people person and the region column is there in the people table, correct? It is right now connected on which column? Region. So if person would have been there in the order table also, then it is a possibility that it is connected on person also. Okay. So two relationship can exist between two tables. But the catch is only at one time one relationship will be active. Only at one time one relationship will be active. There cannot be two active relationships in the Power BI between two different tables. Correct? Is it understood? Okay. So you need not to respond. If you have the doubt only, then respond. Okay. If I ask any question, if it is not understood, then tell me. Okay. Now you see cross filter direction here. There is one cross filter direction here. If you click on any relationship now, it will be given cross filter, single or both. If you click on single, that means a field from this table can filter a field of this table. Look at the arrow. You guys, please look at the arrow here. Can you look at the arrow? Means return filters order. What do we mean by this? Return filter orders. For example, if we are creating a filter on the order ID, that filter will be applied to orders table also. Correct? But the case is not vice versa. Okay, if we create the filter of the country, then that will not work on returns. Why? Because the cross filter direction is only set towards the order. You see, it is set towards the order. If it is set to both, then the filter will work both ways. Okay, if I do it both, the filter will work both ways. Is it clear, guys? How the filter works? The cross filter direction, did you get it? Ramani and Kavita. Okay, you didn't get it. Okay, allow me 15 seconds. So let me tell you one example. So guys, on the report view, what we did, on the report view, we created two slicers, okay? Two filters. What is a slicer? A slicer is a filter that filters the report, okay? One slicer is category, okay? One slicer is coming from the category field. The second slicer is coming from where? It is coming from this region table. The region table, what is the region table? Hold on for 1 second. Or it is coming from the people table and the column is region, okay? Coming from people table and the column is region. Correct? Let's go and look at the relationship between these two tables, okay? The relationship between these two tables says the people is connected to orders. Okay, the people is connected to orders. So this is coming from the orders table. This is coming from the people table. People is connected to orders and the direction of the filter is this. Okay, means any filter that is created from people table will affect the orders table. So if I click the region East, that filter will be applied. That filter will be applied to order table. But the case is not vice versa. Category filter, if I select in the category technology, that will not be filtering the people table. It will not filter the people table. Is it clear now? Ramya, don't worry about it. It will be covered as a part of slicer. Okay. When we'll be covering the slicers, it will be covered. So not much of the issue here. Now let's do the data transformation. Important part and very important. Okay. So every one of you, let's go to the model view. Okay, not the model view. Let's go to the transform data. Everyone, please go to the transform data. Here the transform data will be in the report view, transform data. Now, let me just first adjust my window. Allow me 15 seconds. Let me make it like yours. Okay. So we are going to do the data cleaning. What we are going to do? Data cleaning one by one. Okay. So let us do transformations first. Okay, let us do this transformations part first, one by one. So what I want to do, my use case is I want to split my customer name. What I want to do, my use case is I want to split my customer name. Okay, so please split this customer name into two columns. The first column will be the first name. Okay. The first column will be first name. The second column will be last name. Okay. Second column will be last name. So which functionality will be using? We will be using the split column. So split column is a Power BI functionality which help us splitting the column into two or more columns. Okay. So I'll request every one of you to please click on which column? Customer name. What we need to do is split the customer name. So please click on which column? Customer name. Now, once you click on customer name, click on split column. Click on split column. So in the drop down, you might be seeing that many options are coming. The first option that is coming is by delimiter. Okay. Second option that is coming is by number of character. Third position is by positions and blah blah. Okay. Right now, what we will be doing by delimiter. Okay. What is our delimiter? You see in the customer name, guys, the names are coming like this: Mike Palantir, John Lee, Anne Space Bloom, Jamie Space Kunitz. So we have a delimiter called space. So please click on by delimiter. Please click on by delimiter. Now there are other options that are there. Okay. In the delimiter, you need to choose a delimiter. I am saying my delimiter is space. Okay. My delimiter is space. It could be anything, guys. Right now we have the space, but it can be comma, it can be tab, it can be anything. Okay. Equal to sign. So it is asking me, Pranav, shall I split your column on the leftmost delimiter, on the rightmost delimiter, or each occurrence of the delimiter? I will say the leftmost delimiter. Okay. For example, the names are like this. Okay. I'm just typing two names, my Pranav Garg. Okay. And Shruti Kumar Reddy. Okay. There are two names. Okay. There are two names. there is only one space here. Here there are two spaces. So what we need to do is only at the first occurrence of delimiter we need to split. So I said leftmost delimiter and I clicked on OK. I clicked on OK. Are you guys able to do it? Are you guys able to do it? Let me know. Yes? Are you guys able to do it? Yeah. Now what I want is I want to rename this column. Okay. You see customer name 1 and customer name 2. There are two columns that came now. Okay. You can see in your view. What I need to do is I need to rename these columns. So how I can rename this column? You can simply right click on this. You can simply right click on this or you can double click. Okay. What we can do? We can double click and we can right click. So I am double clicking on it and typing first name. I am clicking first name. Similarly, customer name 2 will be last name. Please try and rename them. Please try renaming the column. Okay, I'll go to ship mode, split column by delimiter. Again, my delimiter will be space and the leftmost delimiter. Click OK. Click OK. Now, this is something that I told you to do like that only, okay? That doesn't make any sense. I wanted to explain you one thing. So guys, can you hit Control Z on your screens? Control Z. Can you hit Control Z on your screens? Is there any undo that happened? You just did some operation. Is there any undo that happened? No. No, na? Correct? There is no undo. Now, what is the problem, guys? The problem is if you do some changes and you need to undo, how you will do it? How you will do it? The simple way to do it is, you see there is a applied step section here. What the section is? Applied step section here. So what we need to do, the last step we need to delete. Okay. Please delete the last step, the last two steps. Until the moment you reach the previous state, please delete these steps. So I deleted the last two steps. Now, can you do it, please? Okay, so perfect. Now, do one thing. Click on the any random step in between. Click on any random step in between. Okay, try closing this. Try closing this. Now there will be a pop-up that will come. There will be a pop-up that will come. Are you sure you want to delete this step? Deleting this step may affect the subsequent step, which could cause your query to break. Okay. Now, what I'm saying, our query can break if I delete the subsequent step, if we delete the intermediate step. So never ever delete the steps that are in the middle if you don't have any knowledge of the subsequent steps. Okay. That was just for the demonstration purpose. You don't need to click yes. Okay. Now, any doubt in the last 5 or 10 minutes of the session? Not 5, 10 minutes, last 30 minutes of the session. Any doubts? What if you clicked yes and data is broken? then no one can save you. You will have to import the data again and do the steps again. Looking the step one by one. I hope there are no doubts. It was pretty straightforward. Everyone, are you able to understand the splitting of column? Now let us move and look at the next operation. Okay, the next operation is replace value. The next operation is replace value. What do we mean by replace value? Sometime in a column there can be junk values that can come. Okay, so to delete those, not to delete those junk values, to replace those junk values, we can say replace value. For example, I'm just taking one example. Okay, for example, there is one person, Mark Pecker. Okay, there is one person, Mark Pecker is the customer name. Okay, now hold on for 1 second. We are at the last step. Okay, give me 15 seconds, please. Okay, go to the product name column. Everyone, please go to the product name column. Please go to the product name column. In the product name column, what happened? Someone has to enter the product name like Xerox. Okay, someone has to enter the product name like this, Xerox. But what they did, they mistakenly enter Xerox 1964. What they did, they mistakenly entered the value Xerox 1964. So what we need to do, we need to clear these values and replace this with Xerox. Okay, that is our scenario. So how we are going to do? We are going to click on the product name column. Okay, on the product name column, please click on replace values. Where are the replace values? Here are they. Please click on replace values. Now, once you click on replace values, there will be a window that will pop up. Okay. Now do one thing. Type Xerox 1964. Type Xerox 1964. Okay. Please type it properly. Why? Because this is case sensitive. This is case sensitive. So if you enter it like this, if you enter it in Xerox like this, uppercase, or you give one extra space, this will not work. Okay. So what we need to do, we need to make sure we are properly giving the value. So enter 1964 Xerox properly. What is the value that we need to replace it with? We need to replace it with Xerox only. Okay. Xerox 1964 should be replaced with Xerox only. Now, please hit OK. Please hit OK. Everyone, are you done till now? Okay. Now, please validate if this is done properly or not. How you are going to validate? How you are going to validate? Please go to product name column. Okay. Drop down. In the drop down, search for Xerox. Xerox. Now, what should happen? The Xerox 1964. If you search for Xerox 1964, the value should not be coming. Is it coming for any one of you? after the replacing? If you need to do many values at once, unfortunately, Prerna, there is no option of doing this. You have to do it one by one. Okay, every one of you. So split column and replace value, I guess it's clear to you. Now, I have to explain you. Just give me 15 seconds. Okay, I have to explain you the text transformations. Okay, what do we mean by text transformations? For example, let me go and show you one column, that is the ship mode. Okay, go to the column ship mode, please. So what we need to do, we need to apply some text transformations on this column. What do we mean by text transformation? We need to make it proper case, or we need to make it lower case, or we need to make it uppercase. So please have a look at these transformation once, and I'll explain you one by one. What are these? So these are called the text transformations. Why these are called the text transformations? Because they work on the text data only. Sides I was prompted for insert a step, so answer and then came down at the last step before doing replace. Okay, so if you do it intermediately, then don't do it the insert step. You have to do it at the end. Okay, so the value is not replaced, Samson. I'll help you in some seconds. Okay, I'll have to see if you have typed the Xerox properly or not. Okay, it should be case sensitive. Now, every one of you, let me explain you the text transformations. So what are the text transformations? They are the transformation that will occur only on the text column. So if you want to do a transformation from uppercase to lowercase, okay? So what do we mean by lowercase? For example, my name is written like this, PRA and AV. So if I want everything in lowercase, that will be the lowercase function. Uppercase means every letter will be converted to the upper word. Okay. Capitalize each word means if there are multiple words in the sentence, I should capitalize each and every word. I'll give you one example of this. Okay. Now, what do we mean by trim? Trim means why trim is used and what do we mean by trim? Trim function means, for example, my name someone entered like this, PRANAV and space, space, space. Okay. So what he did, he entered my name with a lot of white space characters. Okay. In the starting and in the ending. So what the trim function will help us do? It will help us remove the white space characters. Okay. Now clean function not used much, so don't worry about it. What do we mean by length function? Length function means it will give me the name length. Okay. So for example, if you apply the length function on Pranav, it will give you 6. Why it will give you 6? Because there are 6 characters. Okay. There are how many characters? 6 characters. So length function will give us 6 values. The next 3 functions I'll explain you in some second after doing the starting 5 functions. Okay, let's do them one by one. So every one of you, please go ahead and click on the product name column. in the product name column, please go in the transform. Please go on the transform. Where the transform is, it is on the top, okay, here on the top. So click on the product name column first, then click on the transform, okay. Now what we need to do, we need to click on this format. We need to do where? Click format. Please click on format, and in the format, please try to capitalize each word. Please click on capitalize each word. Now you will see the result is same. You will see the result is same. Why? Because this capitalize each word will capitalize each starting word of a sentence. Okay, that's why. Now, what I want to do is I want to find the do one thing, guys, every one of you. Can you please do uppercase in the category and the subcategory column? I want the category column to be uppercase and I want the subcategory column to be uppercase. Can you do that, please? Please do the category column uppercase and the subcategory column uppercase. Once done, let me know, please. The step will remain same. Okay, is there anyone facing problem in that? It's simple. You have to click on category column, format, and uppercase. Subcategory column, format, and uppercase. Perfect. Okay. So these are called text operations. Now, let us try and do the next thing. Allow me 15 seconds, please. Applied steps I have explained. Combine and merge, I'll explain you. Fifteen seconds, please. Rename, I have explained. Okay. Now, what I want to explain next is the go to home, everyone. Go to home, please. Dinner break will be in 5 minutes from now. Okay, Mohit. So every one of you, what we want to do is manage columns. Everyone, please go here and look at this. In the home, please look on these columns. What are these? Manage columns. Please go here. What do we mean by manage columns? So guys, there are some columns that are not necessary and there are some columns that are absolutely necessary. Okay, so this is the way to choose and delete the columns. Now, why someone will be deleting the columns? Because Power BI saves the data in local. Okay, Power BI saves the data in local. That is why you have to utilize the space properly. So if there are some columns that are not going to use, please delete them. So I would request every one of you to click on choose columns. Please click on choose columns here on the top. Where it is here on the top. Now there will be a pop-up that will be opening. Divyashri, just remove the last step that you have applied. So it will make it proper. So every one of you, there will be this window that will be open. Okay. Now what we need to do is we need to remove the unnecessary columns. So you might not be knowing what are the necessary column right now, but let me tell you, please remove the row ID. Please remove the row ID. Please remove the last name. Please remove the row ID and please remove the last name from the data and click OK. So what is this concept? It will only help you keep the necessary columns. Okay. Let me know, guys, once you are able to do it. Perfect. You guys are good. Fast learners. Now, what is this remove columns? So everyone, can you please click on this postal code column? Please click on this postal code column. Now click on remove columns. Click on remove columns. So what it will do, it will remove the selected column. What it will do, it will remove the selected column. So why I don't use it often? Because choose column is much better. You can only keep the column which are needed. So if you have to remove the column, you will have to control select them or remove them one by one. So I don't prefer this. That is why I only prefer choose column. But they are just vice versa. So please delete the last step. Please delete the last step that we have applied. Yeah, remove from applied steps. Devashri, are you able to do it? Did you remove from the last applied step, the last step? There is a cross button that is coming here. Okay. There is a cross button that is coming here. You need to do that. Okay. Are you not able to click on this cross button that is there here? Divya, are you not able to click on this close button that is there on this? Okay. It will delete what? No, it will not delete completely. Everything will not be deleted. Just the step that we messed up with, it will be deleted, that step only. Okay. Let me know if that is done. Okay, so let us move forward. There is, let me see, it is asking to delete. Yeah, delete that. Delete that step only. Yes, yes. Okay, so guys, now please hit close and apply. Or. Hold on for 1 second. Let me tell you the difference between close and apply and apply. So guys, sometime what happens, okay, like we are going on a dinner break right now. We want to apply our changes. How to apply our changes? Just click here on close and apply, only apply. If you don't want to close the window, just want to save, so please click apply button. Okay, that's how you are going to save it. Now let us try to do this. Okay, first of all, let us try to do this. How we are going to do it? Do one thing, every one of you. Right click on orders. Right click on where? Orders table. Just allow me 15 seconds. Right click on the orders table and create a duplicate query. Create a duplicate query. There is an option here of duplicate. Please click here. Please click here. So once you click on this option, there will be a duplicated orders table created. Yep, there is a duplicated orders table that is created. Now, what I need, guys, I only need 6 to 7 columns. So what I'll be doing, I will be using choose columns. So guys, can you please click on choose columns here? Please click on choose columns. Now in the choose column, guys, do one thing, just unselect all the columns first. Please unselect all the columns first. Only select category, subcategory, state, segment. Select these columns: category, subcategory, state, segment, profit, discount, and average. Profit, discount, quantity, and sales. Please select these 8 columns. I will be on the screen for next 30 seconds. So please only select these columns. Now, once you are done with the selection, hit OK. Once you are done with the selection, hit OK. How to duplicate? Okay. In the orders, click on orders, right click here, and there is the option of duplicate. There is the option of what? Duplicate here. Please click on duplicate. So a duplicated query will be created. So a duplicated query will be created. What we need to do next is we need to select only the relevant column. So there are 4 columns like this and 4 columns like this. Let me know once you are done till this step, every one of you. So Samson, it's not like I attend to people in my region more. The thing is, you are just having a doubt every 2 minutes, and I cannot hinder the session every 2 minutes. Now, what I'm trying to convey is the group by option. Okay. So what happens in group by option is we try to group by the data on the different dimension. So what we have 4 dimensions right now: segment, state, category, and the subcategory. These are the 4 dimensions, and we will be grouping on those dimensions. What do we mean by grouping? So if for this 4 combination, home office, California, office supplies, and binders, if for this combination, there are more than one row. What I want is I want only single row for these combination. Home office, California, office supplies, and binders. I want only the single row for these. Now, what will happen? What will happen to the other columns in that case? What will happen to other columns in that case? We will have to aggregate those columns. So, for example, what I need to do is how I'll group. So, go to advanced, please. Go to advanced here. Go to advanced, please. In the segment, please add grouping. State, add the grouping. Category, add the grouping. Subcategory. So, please add the grouping 4 times. Why so? Because we wanted to aggregate on these 4 columns. Am I making sense to you guys? Let me know. Yes. So if you have the idea of SQL group by, it is exactly like that. Now, what I want to do next is on the basis of these 4 dimensions: segment, state, category, and subcategory. If I want to group by on those basis, I will do the aggregation. Okay. So what aggregation I want to perform? The sales will be sum. The sales will be sum. Quantity will also be sum. Discount will be average of discount. What is the average of discount we offered? And profit. What is the total profit? Okay. What is the total profit? Now, I would request you to please give a new column name: total sales. Okay. Now, total sales will be what? Sum of which column? Sales. Okay. The next thing is quantity. Total quantity. Total quantity will be what? The total quantity will be the sum of quantity. The total quantity will be sum of quantity. My bad. It was not moving. It was paused for some second. So, Ramya, is it moving now? Can you see? Yes. Okay. So, total sales, we created one column. The operation sum, sales, sum of sales. Okay. Total quantity, sum of quantity. What I want to do is next, the average of discount. So, average discount. How it will be done? The function that I'll be using is average, and which function I will be using? Discount. Now I want you guys to do the profit. Okay. Anuja, you are not getting the fields under drop down. Okay. Let me add the aggregation. So, okay, what might be happening is, can you start typing the name here? Okay, start typing the column name here. Total profit. Total profit, sum of, you have to select the function. You have to do first two selections, total profit, sum, then only the drop down will come. Then only the drop down will come. So it should look like this. Please, everyone, do till this point. So everyone, once this is done, please ensure only one row is existing for one combination. One row existing for one combination. Check this, please. Now, Anuja, yes, you can share your screen. Now I'll be giving the screen share permissions to a couple of folks. Okay. So, Anuja, you can screen share. After that, Samson, you can screen share. First of all, you are not doing in the orders. You have to do it in the duplicate orders. Okay. So you first have to duplicate the orders. Okay. Cancel this. Cancel this. What I told everyone is, right click on orders. Right click on orders. No, it's order ID. Baba, you are right click on order ID. Right click on orders table. Orders table. Right click on orders table. Yes. Right click on it. Duplicate. Duplicate. And then try to do the operations. Okay. On this duplicate query. On the orders to go to orders to, then do the group by. Do not touch the original query. Okay. Okay. So everyone of you, this is what we call group by. The other name of group by is called aggregation. Okay. So how the aggregation helps? The aggregation helps in removing the unnecessary duplicate data. Unnecessary duplicate data will be removed with the help of group by. Okay. So the next thing that we will be doing is merging and appending. So merging and appending. comes under the combined data. Merging and appending come under the combined data. So first of all, let me explain you what is appending and what is merging. Okay, let me go to the new sheet and give you some example. So for example, there is a table like this. Okay, in this table there are two columns. The first column contain date. Okay, the first column contain the date and second column contain the sales. Okay, these are the two columns. We get the date like 1st Jan, okay, 2nd Jan, and so on till 31st of Jan, and sales for each day, correct? Likewise, we get the data in 12 different tables for each month. So, how many total tables are there? 12 different tables for each and every month. Okay, for each and every month, we are getting different tables. So, what is our problem statement? We don't want these 12 tables to be separate in Power BI. What I want to do, I want to create a consolidated table. What I want to do, I want to create a consolidated table that contain all months of data. Okay, so all months of data should be there in the consolidated table. Then what are the basis of doing it? Means we have to keep all the table on top of each other. Okay, if we stack every table on top of each other, that is called appending. Append means stacking the data on top of each other. Okay, so if we combine these 12 tables, then our yearly data will be there. So what are the prerequisites of combining the table? The first prerequisite of appending the table is the number of columns should be same. The number of columns should be same in all the tables. The second thing is data type of the column should be same. Data type of the column should be same. So it should not happen that on the table number 1, first column is integer, second is date, and in the table number 2, the first column is date and second is integer. It should not happen. Okay, they should have same data type and they should have the same number of columns. Did you guys get what the append operation is? Any doubt in the append operation? Just the theoretical definition of it. We apply, generally Vilasni, we apply when we go getting expression error. This is something interesting, getting expression error. Mohit, I'll help you in some seconds, okay? What you might have done is you might have done some changes here on this. It might have happened, okay? So what I want to do is append queries now. Follow my cursor, every one of you. Where this append query is, it's in the combine section. So please click here. There is an arrow on the side. There is an arrow on the side. Click here on the side arrow. Now there are two options that are appearing. Append queries, append query as new. Okay. What do we mean by append query and append query as new? So the first option, append query, will do what? It will append the existing query. So what will happen if I click on this append queries? There will be one query that will be created, only append to. There will be no new query created. No new query created. What it will do, it will just tweak this existing append to query only, this table only. So what we are going to do, we are going to append query as new. So if you click here, append query as new, click here please. Now try to understand what interface it is giving us. Concatenate rows from two tables into a single table. So what it is telling us? Okay, you did some changes to original data, Mohit. Okay, I'll help you out in some seconds. So what happened in append is concatenate rows from two tables into a single tables. So guys, what I told you, in the append there are two prerequisites. First, there should be number of same columns. So we are appending which table? 1 and 2. The number of columns are same in both of them. The number of columns are 8 in 1, and in 2 also number of columns are same. The second thing is the data type should be same. So what we are doing, guys, we are duplicating it only. The append 2 is a copy of append 1 only. That is why both condition is satisfied. These are the prerequisite of doing the append. So it is telling us, do you need to append two tables or more than two tables? For now, we are only appending these two tables on top of each other. Okay. So we select only two. So append 2 and append 1. What table will be second table? Append 1. Okay. Click OK. Click OK. Click OK. And look at the append 3 table. So the append 3 table will be what? It will be the concatenation of these two tables. So if there are 80 rows in append 1, there are 80 rows in append 2, the total number of rows will be 160 in append 3. Okay, both of these rows will be in the new table. Is it clear now? Any doubts to anyone? Please let me know if there are any doubts. Where is the append? Okay, so it is here. So let me give you the direction. If you look here on the top, combine append queries. Look at my screen, please, red cursor. So it's just combining data of two table into one without merging. Correct. Yes. It shows append 2 for me again because you might have used append queries. Okay. If you click directly on append queries, Divya, that's where it will not create a new query. Okay. Append 3 will not be created. Only append 2 will be edited. Append is done with the data combined and not on data. Correct. Yeah, correct. You are seeing only one box in your append query, Samson. Okay. Append 3 table is new table from table 2 and table 1. Yes, that is the combination of table 2 and table 1. So what you are saying, Samson, hold on for 1 second, please. You are only seeing one box in your append in the append query. So if I do like this, append queries, for example, let me try to do it. So what you are trying to say, okay. Two tables. Okay. Why you are getting one box? Guys, please listen to me properly. So if you click here only on append queries, what will happen? The first table will be automatically taken. The first table is append 2 now. Okay. first table automatically taken and it is asking for you the table 2. But when we select the other option, when we select this append query as new, there is a drop down on side of it now. If you select this as new, it will ask you both of the queries. You tell me which is the first query, which is the second query. But if you use only append queries, it will take first query by default. Okay. I hope I'm able to explain now. Yep. Shital, yeah, that's the solution. I have already told him. Okay. So guys, now let us move towards the merging of the query. Okay. What do we mean by merge query? Now, let me create an example for you. Okay. Guys, we have two tables, correct? The one is orders. The one is order. The second is people. Okay. We have these two tables now. There are n number of columns in this, n columns in this, okay, 10 to 15 columns in this. There are two columns in this. So what we did in the append, append was vertical stacking of data. Append was what? Vertical stacking of data. Rows were getting combined. So if there were 80 in the first, 100 in the second, the result will have the 180 records. Okay. So that was called vertical stacking. But the scenario is different now. The scenario is different now. What we want to do is we want to do the horizontal stacking. Okay. What we want to do the horizontal stacking. I'll give you one example. So, for example, in the orders and people table, what I want is in the result, what should happen? There should be all column from orders. If I merge these columns, if I merge these two tables, what should happen? In the result, all the orders column should be there, plus one column from people table that is called the person name, okay? The name of the person. Are you getting my point? So this is called horizontal stacking, where there are some columns from table A, okay? Some columns from table A and some column from table B are joined together side by side. Are you getting what is the I'll give you some example. Okay. Append row on top of row is the merge column with column. Perfect. You have understood it correctly. So now let's try to do it. Okay. One by one. Now go to Power BI. Okay. In the Power Query Editor. In the Power Query Editor, do one thing. Click on the orders. Click on the orders. Now every one of you, every single one of you, don't make a mistake on this, okay? Otherwise, you will not be able to work on the next session, okay? If you make a mistake in this step, you will not be able to work in the next session. So what I want to do is merge query as new. How? Go to the drop down. Go to the drop down here. Don't directly click on it. Okay. Go to the drop down here. Merge query as new. Everyone do it with me simultaneously. Do it with me, please. Please do it. Merge query as new. So what is my left table? I will say left table and right table, guys. Okay, I will use the two terms, left table and the right table. Now, left table will be orders. Okay, the table 1 will be orders. What is my second table? My second table is the people. Okay, every one of you, first table is orders, second table is people. Now, try to understand one thing. Okay, how the two tables will be joined or merged. Merge and join are same thing. Okay. Now, how the two tables should be joined? We should have one common field. We should have what? One common field between these two tables to merge. So the requirement of merge is common field. In our case, which is the common field? Region is the common field. So please click on region. Please click on region in the first table. Where is the region? Hold on for 1 second. Here is the region. So now click on region here. Okay. Click on the region on both table. Please, every one of you, do it with me. Click on the region of both table, please. Now you will see a join kind. You will see a join kind. Now it is very, very important to understand. Okay. I will create one diagram for you. Okay. Let the window be as it is. Now, every one of you, please leave your screens and see here. Okay. We are having two tables, order and region. I have played around with the value. I have changed the value a little bit. So the order table has 4 regions. Okay. The region table has 3 regions only. Okay. The order table 4 regions are north, east, west, south. In the region table, we have north and south only. East, west is not there, but central region is also there. Okay. Now, if I choose, there are 5 options here. Left outer, right outer, inner, full, left empty, right empty. So there are 5 to 6 options, but I will explain 3 options that are most prevalent across the industry. Okay. Now focus here. If I say inner join, if I say inner, if I select the inner from the drop down, so what will happen? Only the matching record from both table will be there. So if this is order, this is region, only the matching records should be there. So if the result is there, then only which regions will be there? North and south. Are you guys getting my point? If I am doing inner, only the matching records from both the table will be there. Are you clear? Every one of you, please. Those who are aware of SQL, it will be easy for them to understand. Okay. Now, what happens in the left? What happens in the left outer? If I select the left outer option, each and every record from the left table will be there. Each and every record from the left table will be there. So every region from the left table, that is called order, will be there in the output. If I select right outer, every region from the right table will be there in the output. Okay. Are you guys getting my point? So if I have selected left outer, what will be the region? North, east, west, and south. Now if I select right outer, north, south, central. Okay. Is anyone of you, does anyone of you want me to explain this again? I know guys, it is little exhausting for you also, information overload, but let me know if you want me to explain it again, I'll do that. Okay, so Prerna is saying all good. I think everyone is good. Santi, you are saying repeat. I have not been able to group by and append. Okay, Anuja, I'll help you out in some time. I'll give you the screen share permission. So, okay, now let me repeat it again. What I'm trying to say, I guess inner is clear to everyone. There are four different regions in the left table. Okay, that is order table. There are three different regions in the right table, that is region table. Out of these two tables, these are the common regions, north and south. Okay, these are common regions. So if I select inner out of the drop down that I am showing, so if I select this join kind equal to inner, only matching rows will be there, correct? But if I select this join kind left outer, if I select this join kind left outer, all the rows from the left table will be returned. So what will happen? This north will be returned also, east will be returned also, west will be returned also, and south will be returned also. All four will be returned. Everything from the left will be returned. Now, the third option is if I select right outer, okay? If I select right outer here, everything from the right table will be there. So north, south, and central, these three values will be returned now. East and west will not be returned. Am I clear now? I should be much clear now, guys. Vilasni, okay, yeah, okay, perfect. Now, every one of you, let's do a 5 to 10 minutes of doubt clearing session. Okay. Many of the folks have the doubt. I know I have to cover one or more topics also. I will cover one or two topics also, but let me know if you want me to. Yes. So what you want to do is append. Okay. Orders and orders too you have created. Not a problem. Okay. Now go to append queries. You are not able to do grouping also, you are not able to do grouping also. Okay, so on the orders to table, go to orders to table, select the column, choose columns please, choose columns please, choose columns, yes. Okay, and you have already selected the relevant column. Please click OK. Please click OK. Now go and do the group by. There is a option of group by na, correct. Do the group by. Advance, add the column one by one. Add the column one by one. Add grouping, please click add grouping. Yeah, one by one, please add. Samson, I'll help you out. So guys, you can go on a break of 10 minutes and come back. If there is anyone who want to ask the doubt, stay back. Okay. If someone wants to come back in 5 to 10 minutes, they can come back. We will cover one or two concepts also. Okay. So yeah, add grouping, please. Go drop down. Oh, it's very strange. Can you cancel this, please? Can you cancel this? Select somewhere outside. Don't check the segment. Don't check the segment. Your segment column is highlighted now. Highlight any single value. Highlight any single value. Click inside it. Yeah. Now try to do the group by. Yeah. Advance. Add grouping. Select the drop down. It's very strange for you. Go to the orders table. Can you try to do that in the orders table, please? Try to, yeah, go to orders table, go to group by, please. Just try to do it. Advanced, add grouping, drop down. So Anuja, I guess there is something wrong going on in your system. Your drop downs are not working. It's not like there is something wrong that you are doing. Uh, I'll have to check this workbook because seems like it got corrupted and your drop down is not working. Do one thing, once this class is over, completely close the Power BI, restart it, okay? Restart it, or you can do it right now after 10 minutes. We will be explaining anything after 5 minutes. So there is something corrupted in your system and it will be fixed after the restart or so. So try doing it once. If that doesn't help, we can continue. So, Divyashri, can you please share your screen? You have deleted one column. Samson has started the screen sharing. Okay, not a problem. Yep, Samson, you need the help in merge. Okay, let me give you unmute access. Hold on for 1 second. Yeah, please try to speak more.
So not only merge process, I also need help in appendix too. I don't know if I've done it rightly. So let me
Okay,
close this. Let me close this.
yep, please close this. Yes. Now go to the append. Yep.
Or order, right? It's order.
It will be append one. Have you already done the append or not?
No, no.
Not? Okay. Allow me 1 second, please. Okay. Do one thing. Click on append one, and there will be a append queries option towards the right, toward the rightmost. Don't, yeah, click on this. Click on this. Append one and append two. The second table will be append two. Yes. Both have the same structures, that why. And click it OK. Yes. So a new query will be created by the name of append 3, okay, or append 1. So this is created. It is done correctly. Okay.
So I
Now,
also have the what about the grouping group by?
group by, you are not able to perform group by.
Yes.
Okay. Do one thing then. Go to the append 1. Go to append 1. Show me what all columns you have pulled. Can you go to choose columns once, please? Choose columns. Choose columns.
Okay. Hmm. Let's choose
It's in the
column.
merge columns. Yeah. Choose columns, please. Yep. Choose columns and select any 6 to 7 columns. Unselect all. Unselect all once. Yes. Select category, subcategory, segment. Category, subcategory, segment. Sales. Scroll bottom. Scroll towards the bottom. Yeah. We are just doing it for learning purpose, so you can select any column. Scroll down, please. So select quantity and discount. That should be it. Quantity and discount. Okay. Now we have selected the relevant column. What I need to do is now group by. So where we need to click? We need to click on group by. On group by. So advanced, go to advanced. and you have to select every dimensional column. So everything that has a descriptive value, you have to select that here. So segment, the second column will be, go to drop down, please. Yeah. Select all the descriptive column, category and subcategory. No, not this, not this. Delete this, please. Three dots, delete. So they are the descriptive column. Anything that is numerical, we have to create the aggregation of it. So total quantity, total sales. So for now, do only total quantity as of now. Total quantity will be what? It is sum of quantity, correct? So what operation will be doing? Sum. Operation will be what? Sum. And which column? Quantity. Quantity column will be summed up. So likewise, you can do the aggregation and hit OK. Okay.
Okay.
Okay. So type total sales here and do the sum of sales.
Mommy needs the system.
Click OK. Average of discount. Average discount. So average of discount column and OK. Yes. Yep. So that's it. Now explaining you the merge. Merge again, you have to go to merge queries. Which queries will be merging? Orders and people. So merge query as new. What two queries you will be selecting? Yes, orders, and the second will be people, and column will be region. Column will be region. So select the region column on both of them. Region column on both of them. And hit OK. You can select any kind of join you want that I explained you. So you can select any kind of join. It is just for the demonstration purpose. So click OK and you are good to go there. Now,
Thank you.
yep, anytime. You can please stop screen sharing. Let me cover the other concepts, please. Okay, so every one of you, I hope you are there. So we merge this and hit OK. So once we merge this, you guys will be seeing a new query with the help of merge one. Now, every one of you, are you there? Are you guys there? Okay, perfect. So merge one, you please go towards the very right. Every one of you, please go towards the very right of the column of the table, please. You will be seeing one thing here. What is that one thing? This is the people. This is the people. So you please click on this small thing here. Okay. Please click here. What is this? What is this? This is telling us that Pranav, out of the columns that you have merged, which one you want to keep. Okay. Which one you want to keep. I am saying that region is already there in my left table, correct? Region is already there in which table? Orders table, it is already there. Why I merged? I merged because I wanted to bring the person. What I wanted to bring? Person. So I will uncheck region from here. I'll uncheck region from here and uncheck it from here also. So uncheck original column name as prefix and region. Please uncheck both of them and click OK. Click OK. So after doing this operation, you will see that a column person is added in the merge table. Okay. Now let me know if there is any doubt. Let me just see if there is anything that is left. Okay. Relationship I have explained, transformation explained, data query explained, modeling explained to you guys. Okay. Remove columns, advanced is left. Okay. So every one of you tell me the answer of this question. Tell me the answer of this question, please. There are some doubts on the chat. What kind of join selected? Any kind of join. You can select left outer, inner, any kind of join, guys. You can select any kind of join. You can select. So no problem there. Tell me which data combine option is used to club rows coming from the different queries. Yes, append query is the option which will help us to bring the data from different queries. Okay. Is it possible to selectively undo a applied transformation? Tell me, is it possible to selectively undo a applied operation? Every one of you, tell me. The answer is yes, because in the applied step section, guys, after each and every step, there is a cross button. You can do, but you have to have a proper knowledge what will be the effect in the subsequent steps. You can do, but you have to have the knowledge. Okay, so yes is the answer. Can Power BI auto detect relationship between queries coming in from different data source? Yes, the Power BI can auto detect the queries coming in from the different data sources. Okay. And the answer is A and B. So it is our error that we have not given it multiple choice. Which of the following refers to summarizing data? Summarizing data, we got it. Power Query, group by operation. And the second thing is presenting it at a higher level. When we say presenting, that means we have to create the visualization. So visualization is possible only where it is possible only in the Power BI layer. So it is our error that it is not the multiple choice question. Okay, it is multiple choice and answer is A and B. Okay. Yes, presenting is Power BI and publishing. No, we are not asking publishing. Publishing is different. Dashboard is different. So Vilasni dashboard is on the Power BI service. We will be creating a single page report. That is a called dashboard. Okay, that is dashboard. Okay, so with this, I think so we are done with today's session. Let me just see one more time if we have anything that is left. Yes, there is one thing that is left. There is the one thing that is left. Remove rows. Okay, every one of you, this is the last topic that we will be covering. Remove rows. Yes, you can expect the questions on the same line. We cannot tell Vilasni that this is the exact question coming, but they will be on the same lines. Okay. So every one of you, go to the append query, append 3 query that you have created. Remember, you have created the append 3 query. So what happened, guys? What we did in append 3, we just put it one on top of other, append 1 and append 2 on top of each other. But do you know these two are the same table? Do you know these two are the same table? So they have what? Same data, exactly same data. How we can check? Give me 1 second, I'll tell you. So every one of you, please click on segment column here, okay? And then click on sort here. There is an icon of sort A to Z descending. Can you please click on this icon, A to Z descending? The way I'll help you in some time. Duplicate data, yeah. Now duplicate data, yes. So everyone, are you able to do this? In the append, please sort the segment column in this order, A to Z ascending. Can you click this? After clicking the segment, can you click this A to Z? Are you able to do this? Guys, respond, please. Now, look at the rows. Look at the row number 1 and row number 2 in your screens. Yeah, you can right click and sort. It's same. You look at the row number 1 and 2. Do you see these are the exactly same rows? Exactly same rows. You might be getting the same rows in your data. Correct? So what? There is no use of this data because this is exactly duplicate. Correct? This is duplicate data. So how we can overcome the duplicate data? There is an option of remove rows. There is an option of remove rows. So if you click on this option, there is an option of remove duplicate. So please click here on the remove rows and remove the duplicates. Every one of you just remove the last step that you have applied. Remove the last step that you have applied. Why I am saying so, guys? Because I only selected segment, okay? So it removed the duplicate segments and only gave me 3 rows: consumer, home office, and supplies. But what I wanted is I wanted to remove the complete duplicate row. So how I can do that? How to get query segment? In the right, yes. In the right, if there is any step that is remove duplicate rows, please remove that. It is not available. Okay. For some of you guys, it is not available. Then what you have to do? Go to view here. Go to view, please. And there is an option to show the query settings. This should be checked. Only then the query settings will be available. Okay, Gopi, you should be now fine. So guys, what happened when I only selected segment and remove duplicate? It only removed duplicate segment, but I want to remove the duplicate rows from complete data. So please copy entire table. How you can do copy entire table? You can click on this and copy entire table, or do one thing, select here, from here, shift select all column, please, from the headers, and then remove duplicates, okay. I'll explain this. So every one of you, what we have covered in the last session is generally we have covered the Power Query part of it. Okay. So if you go to transform data, guys, I will be going with a little more pace to just wrap up the concept that we have covered in the last session. So what we did in the last session is we imported the sample superstore data set. There were the three tables in that sample superstore data set: order, people, and return. Okay. Majorly, these tables will only be used in developing the dashboard. These three tables. Rest all of the tables were just for the learning purpose. Okay. So everyone who have missed the last class, only if you are able to use these three tables, that should be it. Okay. Now what we did is to look at the append and the merge query features. Okay. There were two features, append here and the merge query. So we covered this feature by creating the duplicate queries. So we created two duplicate queries, append 1 and append 2, and then created the append 3 as a result of them. So what do we mean by appending? Appending means stacking the data on top of each other. Okay, what do we mean by appending? There are two data sets, data set 1, data set 2. Okay, so stacking that data on top of each other is called appending. Okay, the format of data should be same and the number of columns should be same. Okay, number of columns should be same. So that is about appending. What do we mean by merging? Merging means if I have a data set A, I have a data set B. Okay, if I want to horizontally stack them, okay, if I want to merge them horizontally like this, then we will be using the merging. Okay, in merging we have two or three different types: inner, left, right, and the left outer. So if I open this option of merge here, you will see here. Allow me 1 second, please. I I merged the two table and the join kind was these: left outer, right outer, full outer, inner, and etc. etc. So any doubts in merging and appending, please let me know. For the people who can't find the queries at the site, okay. So guys, there is one thing that is called view. Samson, focus with me. There is one thing that is called view here. So if you click on the view, there are query settings. So please click on them and you will be able to see the queries towards the right. Okay. Now I'll be closing this. So these were the important concept that we covered last. Everything else was just very easy to follow. Okay. Now we will be moving ahead with today's session. Night now, every one of you remember when we discussed the Power BI, there were three components. Power BI desktop. Okay, one was what? Desktop. The second one was what? Power BI service. Okay, what was the second component? Power BI service. And what is the third component? Power BI mobile. Okay, so we have understood the very basics of Power BI desktop. The next thing that I am going to tell you is about the Power BI service. Now, remember when I talked about Power BI service, I told you that there will be the organization email needed for the Power BI workbook. But having said that, there are temporary ways to generate the email. So what are these temporary ways to generate the email? I would request you guys to please go ahead and do one thing. In your browser, everyone type dummy email. Please type dummy email. I'll request you to please type the dummy email. Samson, I'll help you in some seconds. Okay, that is not relevant right now, so I'll help you in some seconds. Don't worry about it. So everyone, you will find one link at the top, temp mail org. So please click on that. Please click on that. Now just wait for one more minute and you will see one email generated here. So everyone, there is one email generated here. Let me know if you are able to do this, please, on the chat window. Everyone, I am telling you, don't tell this method to everyone. This is not the legitimate way to do it. Okay. Power BI does not allow this. Okay. This is just for the trial purposes. There is a workaround that I'm trying. Okay. Sorry, my bad. Okay. Now, if this is done, go to one more tab, please. Open one more tab, everyone, and type Power BI service login. What you are going to type? Power BI service login. Hit enter, please. Okay. The moment you will hit enter, you will find the link here, app.powerbi.com. Please click here. Please click here. Now, your window will not be like this. Allow me 1 minute. I have already been logged in, so I'll sign out. Okay. So let me just go back to Power BI login. So the window will be somewhat like this. Okay. So you will find a window to find the account, to enter the account. So are you landed on this window, everyone? Can you just show the previous step? My system got disconnected. Okay. So Shanti, there is one, you can type dummy email on your system, or you can open the link I have shared with you. Just open the link, nothing else needs to be done. Okay. Just open the link in one window. Now, on the second window, please type Power BI service login. Okay. Power BI service login. Samsung, the link is in the chat window just above. So once you log in, please click on this. You will be able to open this window. Okay. Now I'm waiting for everyone to land on this link for next 1 minute. Yeah, Ramya. So it is asking for the email ID. The window might be like this, correct? Shanti, it's like the regular window. Okay. No. While waiting, can you quickly put me to, okay. So I would request, it's like the regular window. It's like the regular window. Okay. It's a different window. Okay. Do one thing. Do one thing. Hold on for 1 second. Any one of you who is finding the different window, can you please share your screen once? Can you please share your screen once? Any one of you? Any one of you? Yeah. Okay. So this is the email that you want to enter. Okay. So everyone who is presenting, Sridhar is presenting, if I'm not wrong. Yes. Okay. So go to the 10th email one. Please go to the 10th email one. There is a copy button on the side of it. You see the green copy button? No, not this one. There is a copy button directly. Yeah. Copy to clipboard, please. Everyone do this. Now go to the window that has been opened. Yes. Enter the email on this window. Yeah. Submit this, please. It will take you to the next screen. Hold on for 20 seconds. It will take you to the next screen. Did you submit it? Please submit. Yeah, it is loading. It is loading. The page is loading. Now you will be landed to the window that is recently opened. Night, I'll be connecting with you. Okay. What happened? Why it didn't open the window? Yeah, verification is completed. Okay. So yeah, now now in this you might be seeing this window. Okay. Everyone, are you seeing this window after entering the email? Yes, yes, yes. Okay. Now you choose the option. I got it from my organization. I got it from my organization. Click next. Click next. Kavita, I'll help you in some second. Okay, you might not have entered the email correctly. Okay, so enter the information here, everyone. Please enter the dummy information here. Everyone who is there on this screen, please enter the information here. Please don't enter the correct phone number. Please don't enter the correct phone number. Now, everyone, please enter the password that you can remember. Okay, there is a paid password button. Please enter the password that you can remember. Now, please wait, Shri. Please wait for some seconds. Everyone, did you enter the information like she has entered? Samson, okay. Allow me 2 minutes. I'll help you, Kavita and Mike. Okay. Those who are facing the problem, I'll help you. Let the majority of people do this. Everyone, are you done with this? Verification code, I'll let you know how to enter. Okay. So now go back to the temp email one. Please go back to the temp email tab. Scroll a little down. Please scroll a little down. So yeah, please hold here. Please hold. So you see there is a message, Microsoft Azure message. There is 6-digit number that is there, 785463 for you. So please copy and enter in the verification code. Everyone, please copy and enter this in the verification code. I would like, please check this button and click next. And everyone, please paste the password somewhere so that you can remember in the upcoming sessions. Okay. Get started. Get started. Divya, in the temp email, there you can find the verification code. So can you please go again? Yeah. So here you can find the verification code in the temp email. If you scroll down a little bit, yeah, you can go back to the other window, please. Yes. Now next, please. Okay. So everyone, please download the Microsoft Authenticator app in your mobiles. Please download the Microsoft Authenticator app. Meanwhile, you guys are downloading the app, I am helping the other folks. Okay. Please download Microsoft Authenticator. The icon of the app would be like this, that is shown on the screen. Okay. Now, please, anyone, can you share the screen? Whomsoever is facing the problem. Yeah, Samson or Kavita, who is sharing the screen? I'll help that person. Yeah, please go where you are facing the problem. Go to that point. Yeah. Okay. You copy this email. Now go to sign into your account. Next. Okay, tell me, do you have the organization laptop? Kavita, do you have the organization laptop? Yes, okay. Then might be your organization has provided you the email ID. Can you enter your organization email ID? And you might already have the Microsoft account. Let's try to see if you are able to enter. Okay, so your organization has restricted this. Yeah. Try one more time, please. Yeah. Yes, every one of you, apologies that I wasted the 5 to 7 minutes of yours, but just everyone focus here for the next 15 minutes. Okay. So what is this screen? This screen is called Power BI service. Okay. So anything that you will be creating in your Power BI desktop, you will be publishing here. Okay. Now let's take concept one by one. So everyone, you are seeing this workspaces section here. Everyone will be seeing this section. Okay. So what is the usage of this workspace? So think of workspace as what? A folder. Okay. The workspace nothing. It is a folder. So how does a folder help you? So anything that you will be creating will be inside this folder only. So if you are publishing your workbook on the Power BI service, it will always reside in a folder. So I'm taking one example of a company. Let's take an example of a company, Airtel. Okay. So Airtel is a very big telecommunication company in India. So this Airtel company has the HR department. Okay. This company has the IT department, correct? And so on, that company has 20 different departments. So a question to every one of you, can HR people see the sales report? Can HR people be given the permissions to see the sales report? Tell me, will that be a valid thing? No, correct? Similarly, IT people cannot see the HR reports. Otherwise, I'll get to know the salary of my boss. Okay. So you should not have the permissions to see the multiple. Yeah. You don't have the permissions to see the content of multiple workspace until and unless they have the permissions. Yeah, Silverani, you have like you have perfectly pointed out. So, for example, I am the HR guy. I am the CHRO, Chief Human Resource Officer. Then I might have the capability to see the complete HR workspace and complete IT workspace or some other workspaces also. So, generally, what happens? A PBI developer has the access to 2 or 3 workspaces. Now try and understand the roles. There are 2 roles, okay? Power BI developer, that means a analyst who is developing a report, okay? There are the Power BI viewer, that means the business person who are seeing the report, correct? So the viewer, the business person will have access to maximum how many workspaces? 1 or 2 workspaces, because there might be some overlap between the departments. But a Power BI analyst, me as an analyst, who is developing the report for HR also, IT also, sales also, I can have the access to all the workspace. So the security is conditional based on the organization role. Now you got why the workspace is used. Okay. So the first point why the workspace is used is to put the reports and semantic models into a folder. I will help you what is a semantic model. And second is to provide conditional access. Okay, these are the two things that is very much required. And the workspace solve that purpose. Now we will try one by one the feature. Okay, I will collaborate with you and show you the feature one by one. Okay. Now everyone go to the Power BI desktop, the file that you have created the last week. Okay. Please open the workbook and the file that you have created the last week. Now you see one thing, there is a publish button here. There is a publish button here. Can you please click on this publish button? Everyone, you will be seeing this window, correct? You will be seeing this window as a pop-up. So you see right now only there is my workspace because we don't have the permissions. We don't have the permissions to create the workspace. Who can create the workspace? The supreme owner. Who is the supreme owner? Who is maintaining the server, correct? Now try understanding one process. Every one of you understand this process. There is Power BI service, correct? The Power BI service is managed by a server administrator. Okay. Who manages this? Server admin. Just allow me 1 second. Who manages the Power BI service? Server admin. Okay. The next level is the site administrator. The site administrator. Site is nothing but a workspace. So a site admin do the workspace management. Now you can only see my workspace because you are in which role? You are in contributor role. You are in what role? You are in contributor role. So who is a contributor? Contributor is a person who can only create reports and publish. Now echo with me again. Contributor is a person who can publish the report. So I am the contributor. I cannot create workspaces. Just asking to enter the email ID. Himanshu, have you joined the class late? Please let me know. Let me know, guys. For those who have joined the class late. So Himanshu, then enter the email ID. Yeah, enter the email ID. Not a problem. Enter the email ID that we have just logged in with in the server. Can you please enter every one of you? That will work. I'm waiting for the response. Yeah, when we click publish, this will open. If not, it will ask for the email ID. Don't follow me on the screen. Just allow me 20 seconds, please. It was taking my previously logged in account. So I am just going to my new account. So guys, if it is asking you the email ID, so please publish and then it will ask you the email ID. Enter the email ID we have just logged in with. Okay, continue, please. It will work now. Okay, so what happens with me now? I use multiple accounts. That's why I sometimes gets confused. Yeah. So Samson, just open the Power BI workbook, any Power BI workbook that we have created last week. Samson, I request you to please open the workbook that we have created last week. Then you can use the publish button in that workbook only. Use the publish button in that workbook only. Okay. So select my workspace. Everyone, please select my workspace. Now select Samson, then just please wait for some seconds. So not some seconds, it will take some time to come back to this topic. So everyone, you will see the success window here. Okay. Let me know who all is able to see the success window. Sheetal, what error you are getting? Sheetal, what error you are getting? Okay. So got it. Trouble in sign in. Okay. Okay. Trouble in signing. I'll help you in some second. That is a common issue. Now, everyone, please go to the Power BI service. Please go to the Power BI service. Now, follow me. Click on the workspaces. Click on the workspaces. Click on my workspace. Click on my workspace. Now, please make sure what I am telling you. Okay, please understand this. Guys, whenever you publish a workbook, there are two things that got published. The first thing is the report, okay? The report itself. The second thing that is published is the data model, okay? The second thing that is published is called the data model. The data model, other name is semantic model, okay? What do we mean by a semantic model? A semantic model is nothing but the other name of data model. So if you go to Power BI desktop, you don't have to go there. I'm just showing you. You see, you created a model here, correct? You created a model and you have defined the relationships. So what happens to make the Power BI report work perfectly fine? The Power BI needed both the report and model. So they are published simultaneously. Okay. Now, enough of the Power BI service. We will keep on publishing it again and again. But just remember, there are two things. Okay. So please go back to your workbook. Okay. Please go back to your workbook once again. Now, I want you guys to please do one activity. First thing is, this is the first thing. Create some random visuals on Power BI. Okay. Then publish on Power BI service. These are the two things that you have to do. So what we have to do, just create any XYZ visual. So for example, just pull any visual table from here. Okay. Drag some fields from the table into the table. Okay. Just any random stuff you try to do and then publish it on the Power BI service. Okay. Publish it on the Power BI service, please. Okay. Create 2-3 visuals and then publish. Now, I would request a couple of people who are facing the problem, share your screen. Okay. Everyone who was facing the problem, if someone wants to share the screen, let me know. Sheetal, you want to share your screen? Let me know. Please share a screen. Then I'll go to Samsung. Okay, Sheetal, I think so you're able to proceed. Yeah. Tell me what's the issue. Sign in. What is the trouble in signing in? Cancel this, please. Cancel this, please. Yeah. Publish. Go to publish. Enter the email address that you are using. Did you complete the sign in process for this? Tell me, did you complete the sign in process for this? Yes. Okay. No, you have not. No, no, no. You have not completed. You have not completed. Go to Microsoft Fabric quickly, please. The previous step. Yeah. Get started. Yeah. Now it is completed. Try again. Symmetric key derivation function is valid. Update the device for the latest updates. What's the error? Okay, can you close this and reopen it again? Cancel this, please. Cancel this. Go to the workbook, go to top right. Top right, there is an option of sign in now. Yeah, yeah. Please click here, enter the email. Scroll down in the troubleshooting, what is happening? Did you use the Authenticator app, Sheetal? In the Authenticator, everything is set up? I think so, yeah, probably yes. Uh, then why this is happening? Yeah, go here, please. Uh, okay. Are you sure that you are entering the correct email there? Yeah. Revilasni, replace the dataset. Everyone, please replace the dataset. That's not a problem. Yeah. Copy this and paste that there.
Yeah, the password was saved on Google Chrome. I didn't save it. I didn't copy it.
So you'll have to enter the password. Otherwise, it will not be able to.
Okay, I have to go.
Yeah. So once you enter the password, you should be able to.
So from where? Let me go back. From where I was trying to look at the publish. The publish is not coming up. Yeah. Why?
Because you have not logged into the server and there is nothing in the workbook. So did you can't you open the workbook that is shared by me on the chat?
Yeah, this one. You mean this one?
No, there is one workbook that is shared by me on the chat. If you
This
look
one.
in the no, hold on for 1 second. I am sharing one file. Allow me 10 seconds, please. You please download this file. Okay, please download this file. Copy from the temp email one, please. Yeah, go to temp email tab. The second tab, please. Copy the email. Copy the email. Yep. Now go back to the screen. Yes. Guys, you might be thinking why I'm wasting a lot of time on this because it is very important for you. If you are not able to publish, then you are not able to share your work. Okay. Again, enter the email, please. Next. Enter the password, please. The one that you have entered. Sign in. password is incorrect. Okay, tell me one thing, Divya, were we able to set up the Authenticator app? Yes. Okay. Now you'll be able to publish. Okay, don't worry about it. Then please stop sharing and you'll be able to publish once this is completed now. Okay, so let me share again, every one of you. Now, interestingly, I'll publish this. Okay, I'll publish this on the Power BI and I'll show you one thing. I'll publish to my workspace. So it will take next 2 minutes to publish, maybe. Replace. So let me refresh this and it will appear in a minute. So everyone, please do one thing. On the Power BI, please open the dashboard that we have recently published, workbook that we have recently published. Okay. How to open it? Just click here in the week 1 March. Please click here in the week 1 March. You will be seeing a window like this. Okay. Now you don't have to do anything. Just follow with me. Okay. Look at this top ribbon. Look at this top ribbon. Now I want to explain you two things. Subscribe and set alert. Okay. Subscribe and set alert. So I apologize in the interest of time. Next 15 minutes, I'll not be taking any doubts. Then I'll be taking all the doubts. Okay. So guys, what is subscribe? What do you mean by a subscription? You guys have a Netflix subscription, correct? Or you might have any other OTT app subscription. So what do we mean by subscription? Subscription is a service in which the content land to us at a set frequency. In which a content lend to us in a set frequency. So if I go, everyone, if I go and subscribe here, it will ask me for a Power BI paid license. Right now, what we are on is a free license. But once I click on this, it will ask me email. Okay, it will ask me emails. That Pranav, on which email should I send my dashboard to? Should I send my report to? So subscription is that service. Okay. Now moving on, what do we mean by set alert? What do we mean by set alert? Okay. If you click on set alert, I am talking about one KPI. Okay. So let's talk about complaints. I work in Airtel, and my complaint threshold is 100K per day. Okay, I should not get more than 100K complaints in a day. So what business wants from me that Pranav, if the complaint is more than 100K, if the complaint is more than 100K, please send me a trigger. What they want, if the complaint is more than 100K, they want me to send a trigger. Okay. Now, what I will do, I will set up a alert. So alert means if a value go above and beyond a certain threshold, if a value go above and beyond a certain threshold, then the trigger will work, alert will work. What will happen if this complaint goes 101K? Email will be sent to the concerned people that your number is not good. Okay. That means subscribe and alert. So subscription is what? At a defined cadence, you get the email in your inbox. What is alert? Alert is at a condition met. So at a condition met, you will get a email in your inbox. Okay, that is the two topics. Now, what I'll be doing is I'll be sharing my screen. Hold on for 1 second, please. Yeah. So the answer to question number 1 is the workspace are used to collaborate on report, dashboard, and datasets. Okay. Now, this is a important topic. Everyone, look at the roles. Okay. I told you, what is a viewer? A viewer can only view the report. Okay. For example, the business person. They cannot make the edit to the report. They cannot make what? Edit cannot be done by them. Okay. Now, this is the least privilege. Okay. The viewer is the least privilege. The second thing is contributor. What do we mean by a contributor? The contributor is a person who can create the report. Who can create the report. The people like you and me who are the engineers. The third person is the member. Okay. Who is a member? Member can edit and publish content, cannot assign roles. Cannot assign roles. So, what do we mean by cannot assign roles? For example, everyone, look at it. Hold on for 1 second, I'll explain. What are the roles? Roles are these four things, okay? So, what viewer can do? He can only see. What contributor can do? Contributor can publish and contributor can assign the roles to the different person. For example, if someone in my team come, I can give him the role viewer, but member cannot give him the role. So contributor and member only difference is the member cannot assign role. And the last is admin. Admin is having the highest privileges. Okay. He or she can do anything. So the answer to second question is what role must the user have to publish an app from a Power BI workspace? From a Power BI workspace. The answer will be no. The answer will be D. Okay. The answer will be D. Let me tell you one more thing. Guys, we have not covered app, correct? We have not covered app. Do you know what's a Power BI app? No, we don't know what's a Power BI app. So, how can we answer about the app? So, let me explain you what's a Power BI app. Guys, let's talk about the HR Analytics workspace. There is a workspace called HR workspace. In that HR workspace, there are 10 reports. Okay. There are how many reports? 10 reports. Okay. So let's go to Power BI service once and go to the workspace. Go to the workspace. So how these 10 reports will be appearing to my end user? The 10 reports will be appearing to the end user listed here one by one. Okay, report 1, report 2, report 3, report 4, and report 10. So, what is app? App is nothing but a page. App is a navigation panel. Okay, let me open this one for you. Okay, Power BI app. I will open image. Images. let me show how the Power BI app looks like. So how the Power BI app look like is this. Hold on for 1 second. What happens is there is a navigation panel that is provided. There is what? A navigation panel provided to us on the left hand side. So you see there were 6 reports in our worksheet, in our workspace. 1, 2, 3, 4, 5, 6. So there is a navigation panel created for that reports and the business can see properly these reports. So it is the intuitiveness, okay? It is only for the better presentation of the work and only who can create the app is the admin. So the answer to that question will be admin. Any doubts in what the app is? Any doubt in what the app is? Okay. Divya, to create a Power BI app, okay. Let me explain this once again. So guys, there are 10 reports in your workspace. Imagine, right now we have only one, but what if we have the 10 reports? The interface of Power BI service is quite clumsy. So if you look at this interface, hold on for 1 second. If you look at this interface, no business owner will like to go here one by one. He has to remember the name, correct? Remember the name of the report to go to that report. Okay, so he will have to take the extra navigational steps. So what we did is for the better navigation, we created a app. So app is nothing. What will happen? These 10 reports will be listed one by one on the left hand side. And what user can do is click here and open the report on the side. Click here and open that report on the side. So like you see in the image here now, that if I'll show you this image, what we opened last time, no, not this one. Here, okay. So if you open this app, these 6 things, these 6 links that are being shown here on the left hand side, these are nothing but the 6 reports of the workspace. So a user can click here and open that particular report on the right hand side. Click on details and open the details on the right hand side. So it's the better UI UX thing. And now who can create the report? Coming to the second question, only admin can create the report. Why so? Because yeah, if there are multiple apps existing, then the business will get confused. Okay, what will happen? Business will get confused a lot. If I give the capability to create the app to every developer, everyone can create their app. So the limited permission is given. Now, any doubts? Okay, so everyone, let me explain you one by one. Okay, let me explain you one by one how this is done. What is the column quality? Okay, I'll uncheck this for me. You don't have to uncheck. Okay, what is the column quality? So if you see, there are 3 values that are coming: valid, error, or empty. So looking at this value, you will get a fair idea. So in our data set, there are 100% valid values. empty are 0% and error are 0%. So let me tell you what are the empty and error and valid. So for example, guys, this order ID you have given, okay? You have given this order ID as the ABC, okay? That is the alphanumeric value. Now, every row should have the value, okay? If there is any row that is not having a value, that will be considered empty, okay? So our 100% of the data is populated. No value is empty. Second thing is error. What do we mean by error? So what will happen if I enter the value 111.21, okay, 111.21 in this cell? This is not alphanumeric. This is what a decimal, okay, this is what a decimal value. Now what happens is the error will be generated. Since it is not of the correct data type, a error will be generated. Okay, it will show you that this data is error. Valid is valid only. Okay, if all the columns, all the rows matches the criteria, then that's the valid value. Now you might be thinking, Pranav, what is the need of this one? The need of this is sometimes what happens, guys, your data is not clean. Imagine you are a data analyst, okay, in your company. Your data engineer give you the data that my data is good. He is claiming your data is good. His data is good. But the moment you imported, you see 40% of the value is having errors. So you can straight away flag him that boss, do your work properly, okay? You can say that to him. So that is the purpose of column quality. Any doubts in the column quality? Perfect. Okay. What is the same error for you, Devashri? Okay. Now, Ramya, coming to your question. See, if there are 1,000 values in this column, okay, I'm just imagining there are 1,000 values in this column. The data type of this column is what? ABC. That means it should be text. Now, what if the value is 101? This 101 is not text. It's what? A number. So it is not a valid value for that column. Correct? It is not a valid value for this column. So that's why it will fall under error. Empty will be if out of 1,100 rows are empty, then 10% of the values are empty. If out of 1,000 there are 10 values that are numbers. So 1% of the value is having the error. Okay. And the use case is you got to know the quality of the data and you can tell your data engineers to work properly. Unable to upload this Excel sheet. Okay, so Desh, I'll help you in some time. Allow me 15-20 seconds. Not seconds, minutes. Okay. I hope this is clear to everyone. Column quality. Now coming to the next topic, the column profile. What do we mean by a column profile? So if you click on column profile, please look towards the bottom. Okay, please look towards the bottom. Now, why this column quality is used to understand why this column profile is used to understand what type of values are coming in our data. Is there any duplicacy in my data? Okay, is there any duplicacy in my data? So how can you identify this? You see there are 1,000 values here. Error and empty 00. Distinct is 904. So that means there is good amount of distinct value in my data set. So my data is not repetitive. My data is not repetitive. That means 904 values are coming only once. Okay, coming only once. Okay. Now, what do we mean by unique value? The unique value means, my bad. Okay, I just plot here. So what happened is, in the case of this, on the case of unique value, it will tell you how many unique values are there in your data set. So let me give you one example. For example, F101, F102, F103, F104, F105, F106, and again 101, 102, 103, and F108. Okay, there are 10 values like this. Okay, everyone, imagine there are 10 values like this in a column. Now, how many unique values are there? How many unique values are there? Unique means the values that are occurring only once. The values that are occurring only once. So tell me how many unique value are there in this 10 values. चार पाँच छः आठ. Okay, 104, 5, 6, 8. So what's the answer? Only 4 unique values. Now, what are the distinct values? Distinct means even if this is coming twice, 101 and 102 is coming twice, it will be counted 1. So 4 plus 3. Why 3? Because 101, 2, 3 is repeated twice. So they will be counted only once. Okay. So 4 plus 3, the 7 is the number for the distinct. Okay. So distinct means even if the value is repeating twice or thrice or many number of times, it will come at least once. Okay. Unique means that is only occurring once in your data set. Any doubts in this? Unique and distinct? Any doubts in this unique and distinct? Sheetal, do you have the doubts or is it clear? Okay. Now let me explain the distinct once again. Tell me one thing. How many values are there in this data set? Okay, how many values are there in this data set? There are 10 values in this data set. Okay, there are how many values? 10 values in this data set. Now, if someone is asking you, tell me how many distinct values are there. So you will see row by row. F101 is coming once here, second time here. It will only be counted as 1. Similar, 102, it will be counted as 1 entry here. So if there is any duplicacy, it will be counted as 1 value. So 1 plus 1 plus 1 is 3, and rest of the values are unique. 3, 4, 5, 6. So 4 plus 3 is equal to 7. That is the number of distinct values. Is it clear now? Anuja, is it clear now? Perfect. Okay. So now everyone, I'm launching one poll activity. Okay. So we will be going on a dinner break post that. So everyone, please rate here, and then you can go on a dinner break of 20 minutes. Just 30 seconds, and then we'll be starting the break. Now, please go to the last step, change type 1. Change type 1, go to the last step of that only, applied step section. Yeah. It is working fine. Go to the last step, please. Yeah. Now, yeah, it is working fine. Same step you do for orders and close and apply. It will work. Okay. You can do it. Same for orders and close and apply. This way you can stop sharing and you can just close and apply. It will work for you. Okay. Hit close and apply. Go to the last step. Go to the last step of this query. Go to the last step of this query, please. Yeah. It's working fine. Now close and apply and you should be good. Okay. Stop sharing, please. Now I'm sharing my screen, every one of you. Okay. So everyone go to home and close and apply. So this is where the Power Query is completed. Okay. Now the next most important thing that we are going to cover is the DEX formulas. Okay. The DEX formulas is the most important thing. Samson, unfortunately, I'm not able to help you because a lot of time the issues are coming from your side, and I'll lag behind on the course. Okay, so uh, apologies to you that I'm not able to help you, but at the same time, I need to complete the course too. Okay, so every one of you, now let's move ahead and try to understand what is the DAX. Okay, so the language is called the DAX. Okay, hold on for 1 second. Please, everyone, read this slide. Please, everyone, read this slide. Divya, we are just back. Okay, we are just back. So you have not lost anything. We have not lost anything. We were on the dinner break, so you have just left, just back. Every one of you, what is the data analysis expression? Data analysis expression is the language of Power BI. We need not to mug up what is the DAX. Uh, we will we will get to know how the DAX is written. Okay, so but just try to understand a couple of things. You have to use the DAX where you can use the DAX to create the calculated column, to create the calculated measure, to create the calculated tables and perform the time-based calculations. Now, one thing I want to put a lot of emphasis on is how to use the DAX. Okay. Now I'll move to next slide. Allow me 15 seconds, please. I will explain you what is a calculated column and what is a measure. You might be thinking Pranam is going fast, but the other two slides were not that relevant. This will be covered in this slide only. Okay. Now, guys, when you write the DAX or when you write the formula, there are two things that you write formula for majorly. Okay. Either you want to create a column or you want to create a measure. Okay. Either I want to create a column or what I want to do is to create a measure. Now you might be understanding, you might not be understanding what's a calculated column or a measure. So what is a calculated column? A calculated column adds a new column to our data, while the measure is used for aggregation. It will not be clear with the definitions only. So let's go and go to the Excel once again. Okay. Now, every one of you, I'm creating one Excel. So there are 5 products with us. Okay. Just think of it. There are 5 products with us. The unit price of those products is 10, 20, 30, 40, 50. Okay. Now, discount percentage is 10, 20, 30, 40, and 50%. Okay, this is the discount percentage. Actually, I should write 0.1, 0.2, 0.3, 0.4, and 0.5. Okay, hold on for 1 second, please. Now, a question to every one of you in the class. If I want to know the total discount, how I would calculate? I want to know total discount. So what is the total discount given on these columns, on these products? So is it 10 rupee, $10? Is it $20? How it is done? Tell me. Change. Okay, so the average discount is this, okay, and unit price is this. If I say this multiplied by this, is it a fair? अरे भाई, if I say 150 into 0.3, is this the fair total discount? Now, the second way to do it is this into this and then sum this up, okay? This into this and sum of these five. Is this or is this the right? 55 is the correct number. So everyone, are you aligned that 55 is the correct number? I want the answer from everyone. Everyone, are you aligned that 55 is the correct number? Yes. Now, this is absolutely what we call a calculated column. So, a calculated column works row by row. Okay. What happens? It works individually, row by row, and then it will calculate the value. But what happens with a measure? What happens with a measure? It will work at a aggregated level. So it will not be calculated at the row level. It will be aggregated level. So there is one catch. Now, if this is calculated at the row by row level, then what will happen, guys? It will create a column in our data. Okay, it will create a column in our data. Since every row is computed 1, 4, 9, 16, 25. You see, every row the value is computed, but measure will never create a column. Okay, measure will never create a column. Why? Because it is just sum. It is just aggregation, one value. Correct? It is one value. But these are multiple values. Now, are you clear with the calculated column and the measure? Are you clear with the calculated column and the measures, every one of you? What is the calculated column and what the measure? I'll take that as a yes. Now, what is the scenario where you will use what? The calculated column will always be used when you want to do the calculation row by row. Row by row, if you need to perform the calculation, just like we did, we will create the calculated column. We will create a measure when we need a consolidated value. So if I ask you, what is the average discount offered? What is the average discount offered? How you will calculate that? Can you tell me how would you calculate the average discount? Every one of you? Everyone, I'm expecting the answer from you. I want to calculate the average of discount. Average discount that is offered. Perfect. So everyone, you gave the answer that average of discount. So this average of discount is a single value. That is why it will not create a new column. Okay. Now let us understand what is row context and the filter context in some time. Okay. So allow me 15 seconds. Now I would request you guys to please go ahead in the workbook. Please everyone go ahead in the workbook. Now please open a new page from the bottom. Please open the new page from the bottom. Here, new page. Okay. Now, what I want you is there is one visual that is called a slicer. So please go ahead and create a slicer. Please click here on the slicer, everyone. Please click here on the slicer. Now, in the slicer, search for category. Where you are going to search? You are going to search in this data pane. Okay, this is called a data pane. So here, search for category. Category, you will pull the category from which table? Orders table. So everyone, your window should look like this once the slicer is created. Okay. Once the slicer is created, your window should look like this. Let me know if this is done. Everyone, is this done? Now, what I want is, please create a card visual. Please create a card visual here. Please create a card visual. Which is a card visual where 1, 2, 3 is written. This is the value 1, 2, 3 is written now. Please click here. Now, what you are going to do? Search for sales. Search for sales. Where the sales will be coming from? Again, the orders table. Again, the orders table. Will ask me many slicers are there. I don't understood that point. Please repeat the slicer part. Okay, I'll again repeat. How to create a slicer? There is, let me first increase the size a little bit. Okay. There is the icon here. See, there is one icon, funnel type, correct? Funnel type icon. So you click on this funnel type icon, then your borders will be highlighted. What you are going to search for? Category. Category, click on the category here. In the orders table, click the category. Click the category. Is everyone with me? Is everyone with me? Selvarani, what is the error that you are getting? After that, create a card visual. So what is this card? Card is 1, 2, 3. Click here and then drag the sales. So let me see what error Selvarani you are getting. Supported set of relationships. So you might be using okay, you might be using the wrong data. You might be using the wrong data, might be using the tables from the data from the multiple tables, okay. So don't use the data from the multiple table, only use from the orders table, Silver. Please only use the orders table. Okay, so how to create a card? Card is this 1, 2, 3 visual. Okay, you see 1, 2, 3. Click here, click here, okay, and the same method will be repeated for every visual. The moment you will click, the boundary will appear. You will search for the relevant field. It is sales for us. Okay. So sales, what we have to do? We have to pull from sales. We have to pull from which? Orders table. Okay. Please pull from orders table. No, it can have multiple table velocity, but provided the relationship is there between these two tables. Okay. If there are no relationship, it will give the error. Everything I'll take gradually. Now, I would like to do one thing. Please click here, any of the value, any one value, please click and see if your slicer is working or not. See if the slicer is working or not. Run the card visual will work, or please click any visual, not a problem. Any visual, that's not a problem. Just try if the slicer is interacting with your visual. I just wanted to take into that. Just wanted to explain that only. Now, don't do anything on your screen. Okay. What is a filter context? What do we mean by a filter context? Think what the visual or calculate function tells DAX to look at. When it applies in measures, visual filter, and calculate. Okay. So this is very important. What a filter context is meaning. Filter context is the set of filters applied to data when a measure is evaluated. Okay. So again, go back to your screen. Again, go back to your screen. Anuja and Himanshu, it should be able to work. Okay. Uh, I'll help you in some seconds. Just try to understand the concept first, and I'll help you out in some seconds. So, every one of you, please click on the card. Please click on the card. The moment you click on the card, it is showing you sum of sales, correct? It is showing you what? Sum of sales. So, what is this? This is a measure, correct? Is everyone aligned? This is a measure. Is everyone aligned? This is a measure. Do anyone have any doubt that this is a calculated column? Do anyone have any doubt that this is a calculated column? No, it is not a calculated column. Why? Because we have calculated it at the aggregated level. Correct? So, what do we mean by a filter context? Filter context is a set of filters that is applied to what? First thing, it is applied to measures. Second thing, it is applied to calculate function. I will take one by one. First thing, it is applied to measure. Second thing, it is applied to calculate function. And how it is applied? It is applied with the help of slicers. It is applied with the help of slicers. Okay. And any other visual filter. Any other visual filter. So just understand this. Don't try to replicate this. You took an example of category equal to slicer, category equal to office supply, and your value comes. Now, if I create one more, filter of region, I will drag region from orders table in this page, okay, in this page level filter, and I will select central. I'm just showing it to you, okay. So what is filter context? Now I will summarize it in one line. Filter context is the set of filters that will be applied to measure or the calculate function by the help of external filters. It might be the category, it might be the slicer, or it might be any other external filter applied on page. So, is the filter context clear? Is the filter context clear? Everyone, I'm more than happy to explain again and again and again this part. Okay. Now I will explain once again. So understand this properly again. You see, this is what? Sum of sales. So how Power BI will be writing it? Calculate sum of sales. So Power BI is calculating it using this. Okay. So what is this? It is a measure. It is a measure. Till now everyone is clear? Till now everyone is clear? Okay. Now what I want is I want to calculate the sales, but only for my filtered results. What I want to calculate this part, calculate sum of sales only. But how I want to do it is for the filtered values. So I applied the slicer here. Office supply is the value selected. Now, how this office supply is passed to that measure is called the filter context. So, filter context is nothing but the set of filter applied to the measure. Applied to what? A measure by the external filters. Okay, be it a slicer or be it any other filters on the page. Is it clear now? Filters and slicers are different thing. Okay, they work same, Vilasini, but slicers are little bit more flexible. Okay, I'll let you know how. Once we will clear the like discuss on the formula, na, you will get to know why. Now, what I want to explain is calculate function. Everyone, this topic might take 10 minutes, might take 20 minutes, or might take 30 minutes. It's the most important function in Power BI. Okay, most important function in Power BI. If you master this, it is very, very important. So, what is a calculate function? Calculate function is used to create a measure. So here you see sum of sales is written, correct? Similarly, if I create the profit, here, sum of profit, okay, 8.8K. So what is this? Sum of profit. Now, calculate function is either we can explicitly use explicitly used, or it is internally used by Power BI. Okay. So look at this value 160.03K. Okay. Now this value is not selected. Imagine this value and this filter is not selected. So what is happening in that case? The Power BI is internally writing a expression. Power BI internally writing a expression by itself for this. I am marking this as 1. What Power BI will be writing? Calculate sum of what column? Sales. Calculate sum of sales. Is it clear now? Just this part. What is a calculate function right now? Now, yeah, I'll explain once again, not a problem. So now Power BI does what? Whenever it create a measure, guys, the measure is creating here. Correct? The sum of sales we know. This is sum of sales, it is written. So generally this formula is applied, sum sales. Now what Power BI does is it applies the calculate function by default internally. Okay. So how Power BI will be evaluating it is calculate sum of sales. Okay. Now, what if I select the category furniture? Category furniture. So what Power BI will be doing? It will be calculating the sum of sales only. Correct? The formula remains same. But what happened? What happened is a new filter come into place. What happened? A new filter come into place. What is the filter? Category is equal to what? Furniture. Are you guys trying to understand? Category is equal to furniture. So how this formula will be evaluated? Power BI will go calculate the sum of sales. But sum of sales for what? Only for the category furniture. So if you have to read the formula like this, calculate my sum of sales only for the category furniture. Is it clear? Power BI is internally doing it till now. Correct? So again, I am repeating one more thing. Tell me how the Power BI will be evaluating the, I want every one of you to give me the formula. How the Power BI will be evaluating the sum of profit. How the Power BI will be evaluating the sum of profit. Okay. So Sheetal, if I apply the filter of category equal to furniture, how the Power BI will be evaluating sum of profit? I want the answer from every one of you. Write me the complete formula. I mean, just give me the idea how it will be evaluating via our formulas. Perfect. So now you guys are understanding this. So every one of you, let's try to create the calculated column and a measure one by one. Till now, Power BI is doing it for us. Okay. But prior to that, these append tables are creating a lot of problem for me. Correct? these append tables. So can you right click on them and delete, or do one thing? Don't delete. Do one thing. Please everyone go to transform data. Please everyone go to transform data. Everyone, please go to transform data. Right click on this append one. Uncheck enable load. Okay. Continue. Right click on append 2, uncheck enable load, continue. Similarly, do for append 3 and merge. Similarly, do for append 3 and merge in the Power Query layer. Right click on these in the Power Transform, or sorry, Power Query, and then enable load. Uncheck the enable load. Mohit, once more about what? Okay, so you just have to right click and uncheck this enable load. So what do we mean by unchecking this enable load? It will remain in the definition, correct? But these tables will not be appearing in the front end. Okay, it will be there in the definition, but front end it will not be there. I hope everyone is able to do. Right click on this, right click on append one. There is an option of enable load, correct? If you right click on this, there is an option of enable load. There is a right button next to it. Just uncheck this, okay? That's okay. That's okay. Manish, that's totally fine. We want to lose the data in the front end right now. And close and apply, close and apply. Okay, meanwhile, you guys are doing it. Himanshu, please share the screen once. And Himanshu, and there was one more person. Anuja was there, if I'm not wrong. Himanshu, please share a screen. Yeah, so the card visual. Okay, so no, not this one, not this one. There is simple 1, 2, 3. Okay, so please click on simple 1, 2, 3. Yes, so you have used the category field there. Okay, if you use the category field, that is a text value. So what you have to use is sum of sales. So please drag sales there. Himanshu, please drag sales there. Search for sales. Search for sales. Only search. If you type sales, now it will appear. Yeah, that's the best way to do it. And check this. Check this button. Check this button, please. It is not working because furniture is already there. Remove the category from the fields, please. There is a fields well, na? There is a fields well. Yeah, please. Now, please drag the sales here. Click on the sales. Yep. Now, click outside. Click outside. Now, create the slicer. You have to go outside the visual. Okay. Then only a new visual will be created. No, not this one. Not this one. Not this one. Only the funnel one. Funnel one. Above that. Above that. Not this one. Above that. In the, yeah, this one. Simple slicer for now. In that simple slicer, click that slicer and drag the category. That should be it. Okay. Now you can continue. Please stop sharing. Anuja, please. Show me from which table you are. See, I said only one table could be used. Now click on the category. Please click on the category one now. See, you are bringing the sales from the orders table. Okay. Now please go to the category slicer. Go to category slicer once. No, slicer, please. Yeah, click here. Which table you are bringing it from? Orders 3, correct? You see towards the right, you are bringing it from orders 3 table. So uncheck this, please. Uncheck this and check the category from above table. And now click. So it has to be from the same table, or the relationship should be there between the two tables. Okay. Now please stop sharing. Yeah. So Mohit, please close and apply. Yeah, please close and apply. Everyone, I am sharing my screen. Now what we need to do is, we need to close and apply. Okay. Once you close and apply, you will see only 3 tables are there. Can you see this, please? Yes. So now we are not much bothered. Okay. So we were going to write the measures and a calculated column. So right click on the order table, every one of you. Right click on the order table. Now create a new column. Create a new column. Please create a new column. Now everyone, please hold on for 1 second. Make it a discount. Okay, make the name of the column discount. So what I am doing right now, I'll explain you one thing. So whenever you create a new column or a new measure, the left hand side of equal to is always the name of the column or measure. Okay, name. And the right hand side of it is definition. Right hand side of it is what? Definition. Okay. So it is very easy to write. Let me tell you how. Left hand side of it, you have to type it. Okay. Right hand side of it, you have to type. Left hand side of it, you have to type it. Now go to the right hand side. Go to the right hand side. What we need to do is, we need to create the total discount. Total discount is what? My discount column into my quantity. My discount column into my quantity. Did you guys get it? So what I need to do? Multiply the discount by quantity. I'll get the total discount. I'm just creating a random formula. Okay. So how to do it? You click here. Click here. You start typing discount. Correct? You start typing discount. Now discount come. You hover over it and click OK. You just click this. Then use the multiply symbol. What you have to multiply with? Quantity. So you start writing quantity. The orders quantity pop up. Then you can click on this. So our formula is completed. I'll hit enter. Discount column is already there. So choose a different name. Okay, we will choose a different name, not a problem. We will make it a discount total discount. Okay. So I'll hit enter. Now, everyone, are you able to write this formula? Yeah, sorry, Vilasni, I missed your message. Right click on the append. Okay, right click on the append. Enable load, uncheck that. Okay. Similarly, for append 2, append 3, enable, load, uncheck, and close and apply. Rahmani, I'll help you in some seconds. Can you please follow me in this? In slicers, I'll help you. Only slicers you need the help with? Rahmani, only slicers you need the help with? Okay, so every one of you, are you done with this formula? Hit enter. Hit enter. Now, tell me one thing. A question to every one of you. Will a new column be created in our data or not? Will a new column be created in our data or not? Okay, so everyone is saying yes. Now, where we can see this, everyone, we can see this in the table view. We can see this in the table view. You see now, here, mostly values are 0 because the discount is 0. Wherever the discount has some value, scroll down. Scroll down. If you see, I will sort descending. How to sort descending, guys? Okay. Now, this is a classic example where you need to see your data. Your data will be visible where? Table view, correct? You remember this? I told you in the table view, your data will be visible. Now, I can't see the value in total discount. Everything is 0. I need to verify if my formula is working fine, correct? How do I verify? Just go to the total discount, drop down, and see the values are there, correct? That means our formula is working, correct? Is it working for every one of you? Is it working for every one of you? Any doubts? Rahmani, calculate slicers. Orders is not getting populated automatically at the left side of the formula. No, left side it will not populate. Right side it will populate, Kavita. Right hand side of the formula is it will be populated. Anuja, formula is showing error. I'm just pasting the formula. Kavita, for you also pasting the formula. Left hand side, yeah. Data tables are not removed after unclick to enable load. You have to close and apply. Lastly, you have to close and apply, then only it will work. Can you please hit close and apply? Okay, just wait for some seconds and I'll help you out. Every one of you, are you able to create this total discount? Now, a quick check. Can you please click on total? Can you please search for total discount on the right hand side? Can every one of you please search for the total discount on the right hand side? Rahmani, I am assuming that you are following these. You are not stuck there, okay? I'm assuming you are following this. I will solve your next doubt, but it will require significant time, so that's why I'm not taking right now. But I am hope you are able to follow me. I'm hoping that. Okay, so everyone, can you do one thing? Search for total discount and click here. Click for the total discount. It will by default create a visual. Now convert that into a card. How to convert? Just simply click on 1, 2, 3. Okay, click on this visual, click here, the card. It will auto convert this. The value will be somewhat like this. Is everyone with me? Is everyone with me till now? In measure, Kavita, I just told you the formula. It is not the measure. It is a calculated column. The formula I have given to you. Okay. Bhageshri, sorry, can't help you right now. Uh, okay. So everyone now we will be understanding what are the different type of filters and the slicers. Okay. What are the different type of filters and the slicers? Okay. Let me solve the doubt first. Can you repeat what we did in table view with discount column? Nothing, Anuja. Just check whether the column is working or not. Okay. Nothing there. No changes were there. Vilasni, what help do you need in discount? Showing zero, but total discount here should not be zero. If you create a card of total discount, it will not be zero. What is the error that is showing to you, Mohit? Can you please share the screenshot with me? Kavita, are you creating a new measure or a new column? If you are creating a new measure, it will give error. If you are creating a new column, it will not give error. Okay, so that is why you might be creating a measure. Create a column. Yeah, Satyajit, I'll do that. Kavita, can you please? Yeah, Vilasni, that's the place where you need to add. Kavita, can you right click and create a new column? Mohit, can you please share the error with me? Mohit, can you please share the error with me? Okay, no problem. So guys, now let us try to explore the different type of filters. Okay, what are the different type of filters in Power BI? The first type of filter that is there in Power BI is, Mohit, just give me a couple of minutes. I'll help you out. Okay, I'll help you out in some second, in some minutes. So, what are the different type of filters that are there in the Okay, I think so. I should stop now. Now let us give the screen share permissions. So screen share one by one. Mohit will ask me, anyone else? Screen share one by one. Yeah. Mohit, just go to the screen, go to the dashboard once. Yeah. Order discount. Show me the formula. Yeah. So what is happening? What is happening? Everyone, it is a good lesson for you. See, in Mohit's formula, the error is where? It's in orders. You see the red line there? Mohit, you see the red line there? Remove this, please. Remove this. So Power BI, guys, automatically shows you where the error is. Hit enter, please. So if you look at that message, it will help you out. Okay. So Mohit, hopefully it will be resolved for you now. Now, Kavita, please go ahead and share your screen. Anytime, Mohit. Yeah. So there are two ways to create a column. Right click on the orders table, please, Kavita. Right click on order table, please. New column. New column. Okay. Just type the formula that I have sent to you, or if you want to learn total discount, yeah, total discount type equal to, now it will come, okay, orders discount into quantity. Search for quantity. No, don't type orders, guys. You have to type the column name. Every time you have to type the column name, it will automatically come. Okay, hit enter, hit enter, and it will work. The total discount already named, so please name it total discount too. Not a problem. This name already exists, that's why it was causing the problem, and it should work now. Okay. Now, who else want to share the screen? I think so, no one. So let me share the screen now. Now we want to discuss the different DAX function. Okay. So I will show you, sorry, first we will discuss the slicer, filters, different filters, and then the slicers. So everyone, do you notice this area? Okay, click here, click on any of the visual, click on any of the visual. Can you notice this area here? Filter on this visual, filter on this page, and filter on all pages. Now let us try to explore this one by one. Click on any visual, click on any visual, do one thing, search for region, search for region. Now, if you search for region, drag the region from orders table in this area, filters on this visual, filters on this visual. You see add data fields here, add data fields here, and click any value. Be it central, east, west, south. I am clicking on central. Do this, then I'll explain what is this. So I hope everyone is able to do it now. So what is this, guys? It is called a visual level filter. What it is called? Visual level filter. So if you want to limit your specific visual, so if I only want to limit my visual, this, then I will use a visual level filter. Correct? If I only want to limit a specific visual, then there is called a page level filter. Page level filter. For example, you want this page, you want this complete report page only for the West region. So what you are going to do? Click on region and do filters on this page. Then select West. So what will happen? The complete dashboard will be for the region what? West. Try this, please. Try this. The two filters, page level and the, not a problem, Vilasni. It might be because of slicers. Okay. So Vilasni, if the value is different, it might be of the slicers. No problem. Try understanding concept right now only. Okay. Vilasni, just give me 2 to 5 minutes. Okay. Uh, try creating first the visual level filter and then the page level filter. After I'm done with this concept, I'll give you the screen share, right? Okay. So everyone, are you done with the page level filter and the visual level filter? Now, the last thing that I want to do is the report level filter. What is this? A report level filter. Report level filter is what? That is applied across all the pages. That is applied across all the pages. Okay. Now, everyone, please go ahead and create a filter of segment. Please filter segment. Search for segment. Please search for segment and do the filter of segment equal to consumer. Segment equal to consumer on the report. Okay, segment into equal to consumer on the report. I hope you are able to create all the three filters. Okay. Now, very important, guys. Very, very important. Please remove the page level filter. Please remove the report level filter. My bad. Please remove the report level filter. How to remove it? If you hover over it, there is a cross button. What is this? Cross button. Then if you click that, it will remove. Now you click on this visual and just okay, don't do anything. Just remove the page level filters. Just remove the page level filters. Now, do you guys have any doubt in the visual level filters, the page level filters, and the report level filters? Hmm. Yeah, sure. I can show one more example when to use the report level filter. So, for example, I'm just picking a very small example. There is a profit field in our data. Okay, there is a profit field in our data. If I want my complete report to only show the profit greater than zero records, okay? If I want my complete report to show only the profit greater than zero, then let me know, then the filters on this pages will be the functionality, okay? I will use the profit, and I will create a filter. Okay, advanced filtering is greater than zero. Okay, apply. Is greater than zero and apply. Now, this is the use case of report level filter. Is it clear? Lastly, now I wanted one more thing to explain. There are basic filter and the advanced filtering. So, every one of you, please go to your page level filter and show the drop down. Please click on the drop down. Now look at the drop down here. Look at the drop down here. So there are two types of filtering. One is the basic filtering. One is the basic filtering, and second is the advanced filtering. Okay. So what do we mean by basic filtering and what do we mean by advanced filtering? So if you see drop down basic and advanced, basic is generally what? Basic is the checkbox only. Okay. Basic is the checkbox only. Now in the advanced filtering here, you can define the criteria. You can define what? Criteria. Now, let me do one thing. Let me do one thing. Please delete this slicer from here. Please delete this slicer from here. And please delete these visual also. Just make sure only 2 visuals are there. How to delete it? Click here and apply the delete button. Click here and apply the delete button. Yes, I will explain you in some second lastly. Now I will type 2 scenario. Please show profit only when sales is positive. Okay. Or there is one more criteria. Show only the orders placed in month of January. Okay. So there are the two options. Okay. So let's solve them one by one. Please show profit only when sales is positive. Now what I want is go to the profit visual. Go to the profit visual, please. Here, what I want is please show profit only when sales is positive. So we are going to put a filter on which column? Sales. And it will be what? Filter on the visual level, correct? Filter on the visual level. So you are going to search what? You are going to search sales. Drag the sales here. Drag the sales here. Now go to advanced filtering. Go to advanced filtering. Is greater than 0. Is greater than 0. If you apply this, there is nothing going to happen because every value is greater than 0. Are you guys with me till now? Till now, please let me know if you are with me. Okay. So you have dragged the sales filter here, correct? I will show again. Drag the sales filter here. Okay. What it is giving us? It is giving us a filter type. Okay. I select in the filter type advanced filtering. Let it be. Show values, show item when the values is less than. There are multiple options here, correct? Is less than equal to, is greater than equal to. So what our condition is? Only show the profit when the sales is greater than 0, correct? I only want to show them. So what I will select is greater than. Sales is the filter, is greater than 0, is greater than 0. Apply this. Is it clear now, everyone? I hope yes. Everyone, are you able to create this filter? At least yes, no. Yeah, no impact, not a problem. Now I will change the condition. Please show the profit only when sales is greater than 100. Can you do this? Can you do this for me and tell me the number? Everyone, do this and tell me the number on the chat window. Do this and tell me the number on the chat window. I want a response from everyone. 253.05. 253.05. Why it might be? Why it might be? Because there is a page level filter. I'll remove that. Okay. And the I filter, yeah, I remove all the filter from the page. Now I go to this. Now I go to this. So the value might come different for everyone. So please remove all the page level filters and the report level filters. This should be clear. This part and this part should be clear. Now let us try to do this. I clicked on this visual. I clicked on this visual. I typed the value 100 and applied the filter. 253.05K is the right value. Everyone able to do it? Yes. Now you see it was a integer column. It was a integer column. Okay. Now let's try to create a advanced filter on the category column. Okay. Category. Search for category and on the same visual drag the category. Please drag the category on the same visual. Use the advanced filtering. Use the advanced filtering. Now, I assume everyone is with me. I want you guys to explore these options. Okay. Since we are creating a filter on the what type of field? Text field. Okay. This is what our text field. That's why it contains the different option. Is empty, is not empty, is blank, does not start with, contain. So anything that can be possible for a string, it's there. Okay. So let's suppose I want furniture. I typed furniture. Okay. I typed furniture and apply the filter. Please apply the filter. Yes. So every one of you, I type contains furniture. Okay. When condition to be for category not blank, 15.92. 15.92, 1.32, 1.3. So, Selva, your value are not correct. Do one thing. Click somewhere outside, please, and remove any filter on this page and filter on all pages. Your value will match. Okay. Everyone, are you getting 15.92? Every one of you? Yes. Okay. Now, interesting is the next thing. Okay. So do one thing, everyone. Please remove this category filter. Remove this category filter, please. Remove this category filter. The third type of filter is top N. Okay. There is top N filter. Till now, what we were getting? Advanced, basic. What is top N? So what I want is, guys, I want top 5. I want top 5 subcategory. I want top 5 subcategory profit. Subcategory profit. On the basis of what top 5? Top 5 sales. Okay. So sales. Let's try to do it. Our scenario is what? I want the profit of top 5 subcategories. Top 5 subcategories on the basis of sales. So if there are a subcategory A, B, C, D, E, F, okay, sale is 20, 30, 40, 50, 60, 70. These are the sales. If I want top 3 subcategory on the basis of sales, then the answer should be D, E, and F, okay, because these are top 3 sales. Now let's try to do it dynamically. Now, please drag the filter of what column? Segment column. Segment where? In the visual level filter. So drag the segment. Please drag segment here. Sorry, my bad. Not the segment, subcategory. Sorry, my bad. Segment has only 3 values. Only subcategory. Please drag the subcategory. Every one of you, please drag the subcategory. And in the subcategory, please select the top n. Please select the top n. In the top n, what we wanted is top 5. What we wanted is top 5. So what you will write here? Top 5. So I will just go and type 5 here. This is the file, so you can refer to the file that I'm sharing right now. The person who has messaged that they don't have the file, Divya. Divya, you can open the yesterday's file also, correct? You can open the yesterday's file too. Now everyone, okay, not a problem. So you open this file. You should be able to do this. Even if you miss the last 1 hour of session, that is fine, not a problem. You can open the one that you are working. Okay. So everyone, we will be creating what? A new measure. Okay. Right click on the orders, new measure. Please create a new measure. Now on the left hand side, you will give that measure a name. So what I want is total revenue. What I want is total revenue. Now total revenue will be what? Sum of which column? Sum of sales column. The moment you type sales, it will appear. Okay. And you have to close the bracket. Everyone, please notice one thing. You see there is a red mark here. There is a red mark here. Red means that there is something problematic with the formula. Okay. So if you open a bracket, you have to close the bracket. Okay. So the moment I close the bracket, it turned into blue symbol. Correct? So this is the formula that we have created, and hit OK. Hit OK. And please show this total sales to me. Total revenue to me. The total revenue should be roughly around, it will take some second. The total revenue should be roughly around 2 million, 2.3 million. Okay. Please see if you are getting the same number. Okay. So it is now everyone, I apologize, but I will not share the formula for the simple formulas. For the complex formula, I will share, will ask me. Why I don't want to share? I want hit and trial. Okay. So if you are facing any difficulty, suppose you are facing any difficulty, then I want the hit and trial, the order sales, the order sales. Kavita, might be your region is selected the US. Okay, it's the US region. That's why. Are you based out of US? Okay, not a problem. If it is in yeah, if it is in dollar also, that's not a problem. I'll let you know. Okay, I'll let you know. Not a problem. Silva, we have not covered much of the topic, so please just open the workbook that was previously created. Okay. Now, everyone, what I want you to do next is I want the average of profit. I want average of profit. Divya, please clear the page level filters and the report level filters. Might be that is the reason. Okay. If there are the page level and the report level filters, that's the reason. So every one of you, you are going to create the average profit. So that is the formula, average of profit. Please try writing the formula by yourself. I will guide you in 2 minutes. Okay. Now, Samson, please share your screen quickly. If you are stuck, I'll be able to help you for the next 2 minutes only. I will show you how to write the different formula. Okay. So let's try the average of profit. What I want to do is average profit. So Samson, that's not a problem. Okay. Right now, do one thing. You will create another measure. Okay. Another measure will be created by us. So you see there is one button here. Correct? One button here, new measure. Okay. Either you can right click here on the orders, right click on the orders and create a new measure. Or what you can do is, or you can do what? You select the orders, you select the order and create a new measure from here. The moment you will select a table from here, on the top ribbon, it will show you new column, new measure, new table, etc., etc. Okay. So please click the new measure. Please click the new measure. Now you guys write the measure like this: average discount. On the left hand side, that's the name of the formula. On the right hand side, what will be? It will be the formula. So start typing average. The moment you type AVER, average will pop up. Hit the tab button. Hit the tab button. The formula will automatically open. Okay. So average of which column? Average of profit column. The moment I type profit, it will automatically pop up. You hit the tab button, then close the bracket. If you are opening a bracket, you have to close a bracket. Hit enter. Okay. Now show me the average discount. It will be where? In the data pane. So please show me average of discount. It will be roughly around 28.66. It's around 28.66. Samson, are you able to create this one? Now everyone else, are you able to create this? Kavita, your number was 17.09. Is your number 28.66 now? Okay. So everyone, you focus here. So what are the different type of DAX function? Okay. So these are the different type of DAX functions. These are aggregate functions, the counting functions, the logical functions, the information functions, the text functions, the date functions, and the filter functions. Okay. So what do we mean by aggregation? I am just drawing a simple table for you. Okay. I will give you the example one by one. Okay. So let's suppose we have the item and sales. Okay. We have two things, item and sales. So A, B, C, and D. These are the four items. Sale is 10, 10, 10, and again 10. So what do we mean by aggregation? Aggregation means the operation that will be running on a complete table. Either it will be sum, either it will be count, or minimum, or maximum. So the function that will calculate the minimum value, maximum value, average, or sum, something of that sort is called the aggregation. Aggregation function will always give you what? A single value. So you will relate from this. So if I ask you what is the total sales, you will say 40 is the total sales, Pranav. If I ask you what is the average of sales, you will say 10. If I ask you what is the maximum of sales, you will say 10. So what you are saying? You are telling me the single value only. So aggregation function take the multiple values and returns us a single value. Okay. Now the second type of function is a counting function. So counting function, as the name suggests, they will count. Okay. Counting function will do what? They will count. They will count what? whatever column we will be giving them. So if I say count of item, they will return me 4. Okay. If I say count distinct of item, they will return me 4 only, because there are 4 distinct items A, B, C, and D. Are you guys clear about the aggregation function and the counting function? We will cover in detail also. Yeah, this PPT is already present. This PPT is already present, Kavita. So if you download the session material, you will get this PPT. Now, let's talk about the logical function. So if I say, what is the sales of product A and B? Okay, what is the combined sales of product A and B? You will say 20. Okay, you will say 20. How it is calculated? How 20 is calculated? 20 is calculated product A sales plus product B sales plus product B sales. So that means logical. We consider both A and B, value here to calculate the sales. So logical means we will apply a condition, and condition, or condition, if condition, something of that sort is applied. Now let us go a little bit in detail. I don't want to waste much of the time here. You will understand this one by one. Now I have explained you one aggregation function, sum and average. I want you guys to please read this slide. Please read this slide and ask me any doubt. Please read this slide and ask me the doubt, please. What is sum x? Okay. Now any function, guys, there are multiple functions like sum x, okay, average x. There are multiple x functions here. So let's try to do these one example. Okay, everyone, create a new measure. You know by now how to create a new measure, guys. Okay, so create a new measure, everyone. Now name this measure sum x sales. Okay, name this measure sum x sale. What is the definition of this sum x sale? Write sum and you will find a formula sum x. So please navigate using the up and down keys. So if you use the up and down keys, it will work. So I will select this sum x, and in the sum x, you will see, I will just hold on for 1 second, please. I want to show you the definition. So sum x is what? Sum x will return you the hold on for 1 second. Sum x profit. Now I will show you what exactly it is doing. Don't try to type it as of now. Please don't try to type it as of now. So how it will work? You will see here sum x has 2 things as the input. This is the first thing as the input. You will enter a comma, and this is the second thing as the input. The first part is the table. Okay. And second part is the expression. Second part is what? Expression. So let me tell you how this is evaluating. What sum x is doing? Sum x is saying, please do sum of the expression of the expression inside this table. So what it is saying, please do sum of the values returned from this expression inside the table. So I will tell you how it is evaluating practically. For example, in your orders table, if you go to your orders table, I'll go to my order table, I'll show you. In my order table, what I have is, I have the sales and I have the discount. Okay. What I have sales, I have discount. So what is the overall sales? Overall sales is whatever the sales I did after applying discount. Okay. After applying discount, whatever sales I did is my sales. Okay. So how I will apply the discount? This into 1 minus discount value. Okay. 1 minus discount value. As of now, are you guys clear how we will be doing it? How the discounted sales will be calculated? Are you guys clear? I want the response from every one of you. If there is any doubt, do let me know. Vilasni, I'll come to your doubt. Now, okay. So everyone of you, what we want to do is my use cases. What is my use case? I want to show the discounted sales. My discounted sales is what? At the row by row level, I have to multiply the sales by the 1 minus discount, correct? So if I do this, then I will get the discounted sales. Then I will get what? A discounted sales. If I do the sum of the discounted sales, then I will get a total discounted sales. So for example, the first row sales came 60. The second row sales came 300. Third row, so on, so on, so on. And if we do the sum of this, that's the overall discounted sales. Is it clear now? Let's see. Divya, we will do that. Now, please go here. And I will just give you the formula. So your value should be somewhere around this. What I did is I mistakenly did what? Into discount. It should be into 1 minus discount. Now, everyone, please type this formula in your chat, in your measures, and let me know. How do you calculate if you don't want to calculate all? I will, okay. So guys, the name of these X function is iterator function. What are these function called? Iterator function. What are these iterator function? Iterator function evaluates the expression that we have written row by row. So they will go in the table, do this expression row by row, and once this part is done, they will perform the outer function. So they will then do the sum of whatever returned by the inside operation. Am I making sense to everyone? Ramani, am I making sense to you now? Are you guys getting the same result like me? Vilasni, if you are getting it in graphs now, not a problem. Click on that and turn it into a card. So if you click on a visual and click on the card here, it will turn into a card. You have to click the visual and then click here. How do I eliminate the decimal? It is simple, guys. So click here on the sum x sales in the data shelf. Click here, please. Click here. Now you see there are decimal places option here at the top, where you will see the decimal places option here at the top. Look at it, please. Look at it. Now please make it 2 decimal place. For those it is not working, make it 2 decimal place. So it will be converted into 2 decimal place. Now these are the aggregation functions. Let me see if there are any doubts. Work. Okay. Perfect. Now let's move to next slide. What are the different functions? These are the logical functions. So what do we mean by logical function? Logical function will test a condition. So what do we mean by AND condition? If the country is USA and the medal is gold, if both the conditions satisfy, then only the result is there. If both the conditions satisfy, then only the result will be there. So just read this slide. I will help you in one condition. I'll help you writing one condition. Please read this slide. So everyone, you read this condition. Now, let me create one scenario. Everyone go to the table view. By now, you know what is the table view. So what I want to do is, I want the California. What I want is California paper sales. What I want is California paper sales. So my state is what? California. My subcategory is what? Paper. So I want the state equal to California and subcategory equal to paper. You guys get it? So how I am going to write it? How I am going to write it? I will create a new measure. What I will do? I will create a new measure. So please create a new measure. Samson, I apologize. I cannot give you the share permission again and again. So, everyone, please write the formula California paper sales. Okay. So how we are going to do it? We are going to calculate the sum of sales. Okay. We are going to do what? Sum of sales. Correct? Just this. So you understand now we cannot place a condition here. We cannot place a condition here. It will not allow us. So tell me a formula which will allow us to write a condition. Please tell me the formula which will allow us to write a condition. Let me know. Sum if will also work. Sum if will also work. But the best formula will be calculate. So what do we mean by calculate? Remember, I told you the calculate function will help us to do the expression in the modified context. I will help you in just some seconds. So in a modified context, it will help us to do a calculation. So everyone do it along with me. Please do it along with me. You go here at this position before sum. Please go at this position before sum. Start typing calculate. So this came, the calculate function came here. So write this calculate. Write this calculate. Now, what the calculate function requires? Okay, the calculate function requires two things. The first thing is expression. What is the first thing? It requires expression. The second thing is it requires is the filters. Okay, so what we provided? We told Power BI that we need to perform the sales, sum of sales. But at what condition? But at what condition? My state should be California. State should be California. And subcategory is equal to paper. Subcategory is equal to paper. So you start typing it. State, state. So state will pop up. Equal to in the single apostrophe, okay, sorry, in the double apostrophe, California. Please write this with me. Please write this with me. Now we wrote the first condition. So we will wrap it inside AND function. So what you will do? You will go after the comma, type AND. Type AND. If anyone is lagging behind, let me know, everyone, till this point of time, if you are able to follow. Are you guys able to follow? Okay, if anyone has the problem, let me know. Now, in the AND condition, we gave the first condition. What was our second condition? Subcategory equal to paper. Okay, so you will do comma. So whenever there are multiple conditions, guys, whenever there is anything changing, it will always change with comma. So you see, from expression, we switch to the AND function. So it changed with comma. Now inside the AND function only, we have the first condition here, California. We will do the second condition, subcategory. So you see, subcategory equal to what? Equal to paper. Okay, you will close the bracket, again close the bracket. Hit enter, and the process remains the same. You will show the California sales. You will show me the California sales. I'll help you in some seconds. Lastly, just allow me 1 second if that formula is working. Yeah, that's working absolutely well. So state is not getting listed. Maybe you have not applied the comma. So try doing this. Maybe you have not applied the comma. So it happens with if you are not applying the comma. Are you guys able to understand this or not? Perfect. Perfect. So Kavita, don't worry about it. Formatting is okay. Formatting is fine if it is not working right now. We can make the settings visual specific. So I'll let you know about it. Okay. I guess everyone is able to follow. Now let me give you a problem statement. Allow me 10 seconds, please. Okay. So now do one thing. Please create total profit for state equal to California, or subcategory equal to paper. You have to use the or condition this time. Please do this. Every one of you, please do this. Total revenue is showing as dot dot. Okay. So for every one of you, Vilasni, I'll help you in some seconds, please. Please create a total profit states California or subcategory paper. So Vilasni, please share a screen. Please share a screen quickly. Yeah. So show me. Yeah. So it is coming dot dot dot. Click here. So you have applied a filter of sales greater than 100. Can you remove that filter, please? Filter on this page. Filter on this page. Remove the page level filter, please. Down, 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 down. Remove this. Remove this filter. Up, up, up. Sales filter, na, Baba. There is a gray filter. Yeah, remove this filter. Clear this. Now, yeah, show me the total revenue. Yeah, click on the bar chart. Okay, click on some different visual. Click on some different visual. Any different visual? Not this one. Can you click on the table? So the fifth row, third icon. Fifth row, third icon. Yeah, yep. So till now, do one thing. Do one thing, Vilasni. Your card visual is not working properly. Okay. So this is the advanced card. The 1, 2, 3 that you are looking for now, that is the advanced card. So your visuals are coming properly. Okay. But sorry, your numbers are calculating properly, but not able to show in the card visuals. So that is the problem. Okay. Convert everything into the, it was working. It worked. Go back again. Please go back again. Then again click on 1, 2, 3. Click on 1, 2, 3, please. In the 1, 2, 3, in the 1, 2, 3, in the value section, please drop the, no, Baba, go, the total revenue, na, click on total revenue. Click on total revenue, please. Yes. Now click 1, 2, 3. Click 1, 2, 3. There is total value section here. Okay. In the value. Why it is not working? Can you increase the width of this visual anyhow? Can you increase the width of this visual? It is working. Okay, it is working. So it is not working because it's multiple dot places. Okay, so how to remove this? I told you, click on the measure, go to total revenue, please. Not here, in the search pane, in the search area, go to total revenue. In the search, go to total revenue. Click here. In the top panel, no, click here, only just click. Kavita, the subcategory was paper. Now convert into the where the auto is written, na, right to. Hit enter. Now stop sharing, it will work. Anuja, do you want to share the screen now? Yes, the formula error occurred during parsing invalid token line 1 offset 40. Okay, hold on for 1 second, please. Calculate the sum of ordered sales and equal to California, comma, ordered subcategory equal to paper. State. Can you please enlarge the formula a little bit? Can you please do plus plus here? Control plus plus. Control plus plus. Yeah. Do control plus plus. Yes. Okay. So it is orders state. You are closing the bracket here. Some orders sales and okay. Do one thing. The and part, remove it, please, for once. Remove it for once. Completely remove the and part. Just copy paste it somewhere. Just copy it and remove this for now. Okay. Now, in place of one, in place of first one, write state equal to California. State, yeah, state equal to California. No, not like that. Not like that. Remove this. Remove this. You have to select the column. Just clear the equal to also. Clear the equal to also. Yeah. Select the column equal to California. Outside the bracket. Outside the bracket. Now I am sharing the formula with you. You will use this formula. Okay. You will now get the syntax. You have to you have to wrap it within the braces. Okay. You have to wrap this. Okay. So copy paste this formula once. Yeah, control A, yeah, just copy paste this. Hit enter. It should work now. Okay, can you stop sharing now, please? Now, everyone else, the next type of function is the information functions. I request you to please read this slide for 30 seconds, please. We will not be doing any practical on this one. Okay, on this one, we will not be doing any practical. I will explain you theoretically. So what do we mean by information function? Okay, so I am thinking about one column. Okay, so think about a column that is a product column. Okay, the column name is product, and the product is ABC for the first row. For the second row, it is blank. Third row, XYZ. Okay, the third row, XYZ. So what does is blank function do? Is blank function will help us to check if the value is blank. So if I use the is blank function, it will help me to understand if my value is blank or not. The second function is number function. Is number function will help us understand if my value is number inside a column. Similar to this, the third function is text. Is text will help us understand if the value is text inside a function. So they will just provide us the informations. Okay, they will provide us information only. If my value is blank, if my value is number, if my value is text. So not use too much. They are just used a little bit here and there. Uh, Okay, Kavita, if the time permits towards the end, I'll show you these functions. Don't worry about it. Okay, don't worry about it. I'll share the screen and will show you these functions, and they will automatically be covered. They will automatically be covered when we'll be talking about other functions. Okay. Now, these are other important functions, the text functions. The other important functions are called text functions. So please give this slide a read for next 1 minute. And Davya, I'll give you a screen sharing permissions in next 15-20 minutes. Hope so your issue is not a blocker, correct? I'm hoping the issue is not a blocker. Now, everyone, please read this slide. So what are the text functions? Text functions work on a text field and used to return the subpart of a string, used to replace something, used to concatenate the two strings. So I'm just showing you one formula. Okay. So for example, the value is California. Okay. For example, I have the field that contains the value California. Now, what I want it is, I want to show this in the uppercase. Okay. I want to show it uppercase. California. Okay. Like this. So which function I will use? I will use the upper function. Upper function will convert everything to the uppercase. Similarly, if I want to show everything in the lower case, I will use the lower functions. Now, the concatenate function will be used if I want to concatenate the two string. For example, if there is a value California and in the state and the subcategory is paper, if I want to show them together, I will use the concatenate function. So just theoretically understand this right now. We will do the practical of this right now. Just first theoretically understand this and let me know if there is any doubt. Okay, so lastly, a good question here. Not every text function is written. Okay, so just a sample of the text functions are written here. Otherwise, there are 20 plus text function: lower, upper, mid, replace, concatenate, fixed, and replace column. So there are n number of functions that are there in text. Not every function is written here. Okay. Now, everyone, we are going to do one scenario. Okay. So concatenate the state and subcategory. Concatenate the state and subcategory only if the state is not blank. Okay. What is my scenario? Concatenate the subcategory and the state only if the state is not blank. So first try to do it by yourself, then I'll help you out. Okay. Try understanding it by yourself for the next 2 or 3 minutes. Okay. I am helping Divya meanwhile. So what is the scenario? You have to concatenate state and subcategory only if state is not blank. Okay. So, Divya, please share your screen. Divya, please share your screen. Okay. Now, let me know what the issue is. Okay. Is this formula not working for you? So why it is not working? Go again to the formula, please. Go again to the formula. See, how you have written California, you have written all in the lower cases. So the value is case sensitive, correct? The value is case sensitive. So you have to write it like that. Enter here, please. And try showing it now. Is it working now? Show me again, please. Show me again. Can't be the case. Okay, so do one thing. Go back again to the report view. You are doing one thing wrong. You don't have to go in the table view again and again. Go to the report view. Search there California paper sales in the search window. In the search window, yeah, California paper sales. Yeah. Now show me the yeah. Show click it. it will pop up. Yeah, it is working fine. It is working fine. So what you are doing, Divya, you are showing it in a single visual. Okay. So you are showing it against the sum of sales, which is a very large value. That is why the other bar is very small. Okay. That is why it is not showing properly. Now stop sharing, please. You have shown the multiple bars now, so it is not working properly there. Now I will solve the other problem. Okay. So what I gave you? I gave you show me the concatenation of uh, the state and the subcategory. So guys, tell me what it will be. It will be a calculated column or it will be a measure. Tell me, it will be a calculated column or a measure. I want to represent a text value, okay, and it will be concatenation of two values only. Everyone, tell me please. Yes. So the answer is calculated column. I'll go to orders, then create a column. How to create a new column? You can right click or you can click here in the orders. You can click here on the orders and there is a new column section here. Okay. So please click on new column. Now I will start writing the expression. Okay. So let's name it concatenated. Concatenated. What I want to do is concatenate. So you write concatenate. It is asking you what you want to concatenate. I want to concatenate state, okay, and subcategory. Okay, state and subcategory. But when I want to concatenate, only if my state is not blank. Okay. So what you will do in front of state column, you will write is not, sorry, is blank. You write is blank and close the bracket. Close the bracket. Hit enter. Is it working fine for you? Now check this, please. Check this. What I want to show is concatenate. So I show concatenated here. See if the values are coming like this. Do anyone else have any doubt here? Does anyone have any doubt in the concatenate function? Okay, too many argument issue. You might have given, yeah, you might have given many arguments. Okay, so please see here. Yes, so please see here. There are two values. The first part of the formula, the second part of the formula. Both part of the formula are separated by comma only. Okay, they are separated by comma only. Now, is it done for everyone? Let me know, please. Perfect, Manoj, the formula is correct. Just allow me 15 seconds, every one of you. Allow me 15, 20 seconds, please. I'm thinking if I'm not yes, it will hide, but it will always be there in the data pane, will ask me. So that is why you always use the search window. There is a search window towards the right top. You use that. That's the best way to find it. Okay, so very important stuff, guys. This is very important. The calculate and the filter. Okay, calculate, I told you what is calculate. Now, the next thing that I want to show you is the filter function. So what is a filter function? Filter function is a very important function that will return us a table. Okay. Now, listen to my words carefully. Till now, what was happening, guys? Any function that you were using was returning you what? It was only returning you value, correct? The value might be 10, 20, or a concatenated column, something like that. It was only returning you the value. But what's the beauty of a filter function? The filter function will return you a table. Okay. Filter function will return you a table. Now let us try to do one thing. Okay. Go and calculate with me one by one. Create a new measure. Create a new measure. You click on orders, please create a new measure. Now you will write California paper sales 2. Okay. The context remains same. What we need to do is show the California sales only for the subcategory paper. Okay. Show the California sales only for the subcategory paper. The first part will remain same. Calculate sum of sales, comma. It will remain same. So please do till now. Till this point, please everyone do. Now, allow me 10 seconds, please. Let me first test it myself. Please allow me 1 minute. State equal to, okay, California. Now, please do it with me. How this is working. Everyone, listen to me how this is working. So what I did, I wanted to calculate the sum of sales. But how I wanted this time is I will use the filter function. Filter function will return us a table. It will return us a table. And how it works? It works on a table. It works on a table and apply the filters on top of that table and then return a result. So let me frame an example for you guys. I am assuming there are 10 rows. Okay, there are 10 rows. The state is there. Okay, state is there and the subcategory is there. Okay, so there are 1, 2, 3, 10 state, 10. Okay, there are 10 values here in the subcategory. Okay, so only for the two rows, the the state was California. Okay, and the subcategory was paper, only for the two rows. So what this filter function is doing, it will be taking this complete table, apply the filters, and whatever the filter result is, it will return us that table. Is it clear till now? Till now it is clear. Now what is happening? What is happening? On top of that returned table, the calculated sales is then computed. Correct? So the expression is evaluated in the modified context. When I say modified context, everyone, I'm repeating it third time. When I say modified context, the second part of the calculate function is the modified context. Okay. Then starting table was this, but then I placed some filters. My final table is this. So this is my final context table. Okay. I hope you are able to write this formula. If not, I am sharing it with you now. Try analyzing this formula, guys. Okay. So, Rahmani, what is happening? Calculate, we know. Till now, calculate we are doing. Calculate evaluates this expression. Okay. This expression is evaluated. We are interested in how this second part is done. So the filter function will take input. Okay, this is my input part. So it will take input as a table. Input is a table. The output of the filter is also a table. Okay, the input output both are table. Now, what is changing in between? What is changing in between input and output? Some filter conditions are applied. Some filter condition is applied. And that filter condition is what? Whatever we have specified here. So we have specified my California and paper should be returned. So it will take the complete order table and return a table that only has the California and paper records. Okay. Remani, is it clear now? Yeah, the answer will same. The answer will remain same because the like our problem statement is same, correct? Manoj? Allow me a minute, please. So anyone has any doubt? Does anyone have any doubt? Let me know, please. Yeah, sure, sure. Let me explain this. So, okay, there are a couple of questions that are there on the screen. Let me address all of them. Okay. So, the second part of the formula, Rahmani, California sales. Okay. The second part of the formula is you are taking input as a table. Okay. This P1 is the input. Now you will do certain operation. The name of the formula is filter. That means you will apply the filter on the input table. Okay. So I applied what filters? My state equal to California and subcategory equal to paper. I applied these filters. So after the application of these filter, whatever result is returned, it will be our final table. Okay, it will be our final table. So filter function returns a table only. I hope I'm able to make sense. Can you explain the difference between the two formulas? So, Knight, the formula is same. Okay, the only difference is the first formula is not creating a intermediate table. Okay, the first formula is only directly working on which table? Sale orders table. It is not creating any intermediate table. Now, what our second formula is doing? The second formula is creating a intermediate table. Okay, with the help of filter. My orders of sale is computed in the modified filtered result. Okay, the table that is returned from this filter. Is it clear now? Okay, now how do I set the decimal to two decimal instead of changing every time? So unfortunately, there is no way to do that. It has to be done on the field by field basis, Satraji. Okay. And there was same question from one more lady that you have to change on the formula by formula basis. So I have to click here. I have to click here and I have to change it. So why this functionality is not given? So guys, why this functionality is not given? Sometime what happens is you have to set your one thing to two decimal places. For example, discount percentage. The other thing you want to show without rounded. For example, sales 100K. So if I set everything to two decimal places, everything will come to two decimal place. So that's why not hard coded. You have to do it on the case by case basis. Any other questions are welcome, please. Now, the next thing that I want to explain is calculated table. So what is a calculated table? Sometime what happens, guys, you need to calculate a table for the DAX to evaluate. Okay, you might not be understanding it right now why it will be used, but sometimes you want to calculate the table from your data set. Okay, so I'll let you know how to create it. Click on orders and create a new table. Where it is? It is on the side of it. This new measure, new column, new table. Please click on new table. So what do we mean by a calculated table? What do we mean by a calculated table? A calculated table is the table that is returned as as a result of some functions. Okay. So I will give the furniture sales. Okay. Furniture table. For example, my use case is I want to return what I want to do. I want to create a separate table for furniture. I will explain, Kavita. Hold on for 1 second. I want to create a separate table for furniture. So how I can do it? I will show it in some seconds. I will name the table as the furniture table. So Kavita, how it will be created? If you click on orders now, if you click on orders, there will be a section of new table here on the top. New table. You click here on the new table. So furniture table, you will write calculated table. You will write calculate table. So calculate table is a function that will return you table. That will return you what? A table. Okay. Now, what it will do? Again, it will act like a filter function only. It will act like a filter function only. It will take some input table and return some output table. Okay. After applying some criteria. After the criteria is applied, then the result will be there. So what I want only furniture table. So I have to pass what I will take as input. Okay. So what I will take as input, I will take orders table as input. So where you will be giving the input? Always the first argument. So orders, please type orders here, comma, orders, comma. What it is asking me? It is asking me filter one. Now I will say category is equal to furniture, furniture, and then close the bracket. Please type this formula with me. Now hit enter. Now hit enter. Okay, so it's not working for me. It will work for you because I have already created this table with the same name. I am writing 2, furniture table 2. Now, as a result of this, you will see a new table created, furniture table 2. Now, one thing, everything will remain same. The structure of the table will remain same as it is. Correct? Where you can test it? You can test it here. You can test it here in the table view. Go to furniture table 2, please. Go to furniture table 2, please. Now, look at the category. Look at the category drop down, please. Look at the category drop down. It should only be furniture. Please see if that is the furniture only. Can everyone validate? Perfect. So now you guys are somewhat aware of the DAX. I have shown you many functions of DAX. Now, allow me 5 minutes, please. I'll see if there is anything that is missed or not. Hold on for 1 minute. Okay. So everyone, can you please answer me the question number 2 and don't look at the answers, please. Answer me question number 2. This one. Manoj, I'll help you in 5 minutes. You might be creating a new measure. It is new table. Manoj, you are creating a new measure. Please create a new table. Everyone question this one question. Please tell me. The answer is B. Okay. No, sorry. The answer is C, everyone of you. Modifies the filter context for an expression. Everyone, very important thing this is. I'm again emphasizing a lot on this because you are going to work a lot on this. So whenever you write a calculate now, you write an expression here. Okay. You write expression. Then you gave a condition. Okay. For context. You write a condition here that modifies the filter context. That means it gives you the modified table, modified filtered table. Correct or not? So it is C. Now give me the answer of D. Give me the answer of D. It is the multiple choice. Okay, it is the multiple choice. So please give me the answer of question D. The multiple choice question is there. Please give me the answer. Everyone, please give me the answer. It is multiple choice. So there are two answers. I'm giving you a hint. There are two answers. Look at it, please, everyone, carefully. I'm testing your Dex knowledge, and you can fairly assume these kind of questions will be asked a lot. In the PL 300, these kind of questions will come a lot. Okay, so let us explore the options. The option number one. So it is saying you want to calculate sales for a specific product category regardless of filters. So when you are saying specific product category, that means filtered product category. So the answer A is correct. The answer B, you are not studied all function till now. So not covered. The answer C is correct because it is giving me the filter, furniture filter. Now let's go to D. Remove filter. It is the function that removes the filters. I'll let you know what are these functions in some seconds. Okay. So the answer is A and C. What are the answer? The answers are A and C. Okay. So guys, I'll be sharing I'll be sharing this PPT with you. So please note down the the slide number 19 you have to do by yourself. Okay. Please do slide number 19 by yourself. Okay. Once I'll finish with the today's session, then you will do it. The next topic that we are going to cover are the different type of filter function. So first of all, let us understand what are the filter function. Filter function will help us. The first thing is to return the subset of a table or a column. Okay. So what filter function can help us to do? There is one table. Okay. They can help us to return a filtered table. Okay. Like we did in the filter function. Sorry, man. Like we did in the filter function. Now, the second thing that we can use is they are used to apply the conditional logic inside measures or the calculated column. Okay. So remember when we did the calculate function, we just did the calculate function at 20 minutes back. In that calculate function, we use the filter function here at the second part of that calculation. So what filter function help us to do? Filter function help us to return a subset of a table. That's the first thing. Second thing is it helps us to apply the conditional logic inside the measure. So what calculate function does? It creates a measure. So we will use the filter function to modify the filter context and to use the conditional logic. It will be cleared once we will be doing much more with the functions. Okay. So we have covered one function, that is filter. Now let us cover more filter functions. First of all, everyone, I'll request you to go on the report view and create a new page. Please create a new page. Please create a new page. Now, once the new page is created, go to the search panel. Go to search panel here. In the search panel, use the category. Okay. The category should be from orders table, should be from orders table only. Okay. Then click outside and use subcategory. Use subcategory. It should be from orders table only. So you should have the visuals like this.
So the module 1 will be about the introduction to SQL and database basics. So what is SQL is our first question, and why is it important? So today, SQL in simple terms, or let's expand as structured query language, is the standard language used to store, manage and retrieve data from relational databases. In very simple terms, SQL acts as a communication layer between humans and databases. Instead of manually browsing data through files or spreadsheets, SQL allows us to ask precise questions to the large data systems and receive accurate answers almost instantly. You can think of SQL as the grammar of data, because just like grammar helps us form meaningful sentences, SQL helps us form meaningful data queries. So through SQL, we instruct databases to perform critical operations such as searching for specific information, updating existing records, inserting new data into the entries, deleting or removing outdated data, and organizing information using tables, views, and schemas. Without SQL, interacting with structured data at a scale would be slow, manual, and completely error-prone sometimes. Now, why is it important? SQL turns raw data storage into an intelligent, queryable system that businesses completely rely on. Now, you might be wondering why SQL still dominates in 2026 despite hundreds of new technologies and tools and frameworks emerging every single year. So the answer is SQL continues to dominate the data ecosystem in 2026 and in future, because this is not by accident. Because SQL solves a fundamental problem: reliable access to structured business data, universal adoption. Every major organization, whether it's Google, Amazon, Meta, banks, hospitals, or e-commerce platforms, they rely on SQL-powered databases at their core. Even modern cloud-native systems ultimately store their most critical data in relational databases using SQL, and they also query that data using SQL. Next is standardized language. SQL allows ANSI standards, which means once you learn SQL, the same knowledge applies to MySQL, PostgreSQL, SQL Server, Oracle, Snowflake, BigQuery, Redshift, and many others. This portability makes SQL a career-safe skill that remains relevant across tools and companies. Next is essential for analytics and AI pipelines. In analytics and AI workflows, SQL is often the very first step. Before any dashboard, machine learning model, or AI system is built, SQL is used to extract clean, structured, and reliable data. In many ways, SQL is the foundation layer for data-driven intelligence. After that, we have high performance with massive data. Modern SQL engines are highly optimized and can process millions or even billions of rows of data in just mere seconds. Features like indexing, query optimization, and parallel execution make SQL extremely efficient for large-scale data operations. Now, the next question is, where do you see SQL in real life? Although users rarely see SQL directly, it silently powers many everyday systems we interact with. Whether you book a flight, withdraw some cash from ATM, place an online order, or check your bank statement, SQL queries are running behind the scenes. SQL also supports food delivery applications, telecom recharge history, hospital records, and customer support systems. Each of these systems rely on fast, accurate retrieval of structured data, which SQL excels at. A useful real-life analogy is to think of SQL as a remote control for business data. Successful learners who master SQL gain the ability to instantly switch to exact channel of information they need, whether it's sales data, customer retention, or customer records, or transactional history, without delay or dependency on others. So the next one is types of databases. So we have two types: relational databases, or RDBMS, and non-relational ones. Let's get started with RDBMS. A relational database stores data in tables made up of rows and columns, similar to Excel spreadsheets, but with far more structure, rules, and reliability. Each table represents a specific entity, and relationships between tables are clearly defined. Relational databases enforce consistency through constraints and relationships, ensuring that data remains accurate and reliable even as systems scale. They follow ACID, or popularly known as ACID properties, which guarantee transaction safety, making them ideal for business critical operations. Since relational databases are SQL based, they allow precise querying and strong validation and predictable behavior. Most popular examples include MySQL, PostgreSQL, SQL Server, Oracle, and MariaDB, all of which are widely used in enterprise systems. Now let's discuss the second type, which is non-relational databases, or simply known as NoSQL. Non-relational databases, commonly known as NoSQL databases, store data in formats designed for flexibility, scalability, and speed rather than strict structure. Instead of fixed tables, they often use JSON documents, key value pairs, columns, or graphs. These databases are designed to handle large volumes of semi-structured or unstructured data and are commonly used in microservices, IoT platforms, real-time applications, and distributed systems. Some of the popular examples include MongoDB for document storage, Redis for key value access, Cassandra for column-based storage, and Neo4j for graph-based relationships. NoSQL systems trade strict consistency for flexibility and scalability in many use cases. Now, in the next stage, let's discuss the basic fundamental differences between relational and non-relational database systems. So, relational versus non-relational analytical comparison. Relational databases focus on structured data, predefined schemas, and strong consistency. They are ideal for transactional systems, reporting, and business logic where accuracy is critical. SQL serves as a powerful and standardized query language in this ecosystem. Non-relational databases, on the other hand, prioritize flexibility, horizontal scaling, and high-speed access. They allow schema changes without downtime and are better suited for rapidly evolving data models. A strong analogy is to think of RDBMS as a well-organized library where every book has a catalog number and fixed location. NoSQL is more like a creative studio where items can be placed freely based on immediate needs without any rigid structure. So, what is RDBMS? A relational database management system is specialized software designed to store structured data and manage relationships between different data entities. It acts as an engine that processes SQL commands and ensures data remains consistent and secure. An RDBMS is responsible for enforcing rules, managing user access, and handling backups, recovering from failures, and even ensuring that multiple users can work with the same data simultaneously without any conflicts. In short, the RDBMS is the backbone that makes SQL reliable, scalable, and safe for enterprise use. Tables represent real-world entities such as customers, products, or orders. Each table focuses on a single concept, keeping data organized and easy to manage. Next is columns. Columns define the attributes of an entity such as name, email, or city. Each column has a specific data type and rule set that governs what value it can store. Rows. Rows represent individual records within the table. Each row captures a complete instance of an entity, such as a single customer or transaction. Next is the primary key. Primary key uniquely identifies each row in a table, ensuring no duplicates exist and enabling efficient data retrieval. Foreign keys create relationships between tables by linking related records, helping maintain consistency across the database. Next is indexes. Indexes function like a book index, allowing the database to locate data quickly without scanning every row. Followed by that, we have constraints. Constraints enforce data quality rules such as not null, unique, and check. These rules help preventing invalid data entry entering into the system. Now, the next stage is why RDBMS is the industry standard. RDBMS systems are highly reliable and trusted for business operations that cannot afford data errors. They enforce data integrity, support normalization, and handle complex transaction workflows efficiently. Because of these strengths, companies use RDBMS platforms for mission-critical applications like billing systems, HRMS, ERP solutions, inventory management, and logistic platforms. When accuracy, consistency, and reliability matter, RDBMS remains the preferred choice. Now comes the next stage, where we will learn the installation and setting up SQL environment. So now we have come to a stage where we will install MySQL into the system. Now it's really simple. All you need to do is just type down MySQL Workbench on your browser, and then you'll be redirected to this particular page. Use the first link, MySQL Workbench, or you can also go with the download option. And here you have the download now option, right? So you can click on this and your installation file or the setup file will be downloaded for you. And you just have to run that particular file. It's a simple installation procedure. But if you have any queries, don't worry. I'll also drop a link to this particular tutorial on how to install and run MySQL Workbench. For now, we have already installed MySQL. So let me run that. So this is my database, which is SLP database. So you can see on the right hand corner of my screen, we have an option that says the position of all the prompts and all the sections of this particular workbench. So I'll go with the first option where I can see all the databases I have and the tables I have, right? So right now we are in the table that we earlier created for interview questions and answers. So this will be down the line. So let's go to any of the databases. I would like to go with this particular one, sample dataset. So I'll be using the SLP database. So we can test our SQL database in this way. You can start by selecting any of the databases. Don't worry, in the upcoming section or at the upcoming module, I'll explain you how to load the data, how to create table, how to insert the values into your table, and all those fundamental things. So first, for the beginning section, to test our SQL installation, we'll do this. So before you get into anything, you just need to select the database where you have the data. So you can do that by simple command which says use the database name. This is the font. So let's say use and database name. And you need to have a semicolon, right? So you can also see why I'm using specific format. I'm using, let me expand my screen. I'm using all caps for the keywords. In SQL, we have keywords and also the user-defined words, right? So the keywords are something which carry a functionality. So here, if you see, we have a select, from, where, not in, right? These are keywords. They have specific functionality. And whatever the things you see in a black color, which have case sensitivity in lowercase or sentence case, those are the ones which I define. So tomorrow, if my query gets a little more complex, so down the line, we will be learning subqueries and advanced querying functions, where we should be at a stage where we should identify our own code. If you follow or some mixed kind of way to write your queries, then you might fall into a confusion understanding what is what. Is it a keyword, or is it a word that I define, or is it the name of the column, or anything, the name of a table which I define? So to avoid such confusions, we will follow this standard. If ever there is a keyword, just keep it in all caps. And if ever there is a column name or a table name, then you can keep it in mixed case or low case as per your requirements. So product ID, this particular name is a column name, so that I identify it as a column name, I'm using mixed case there. So it has a caps thing, and then the all small letters in that way. So basically, you need to select a database name and explain MySQL Workbench that I'm going to dive into this particular database, which is SLP. And you can see I have complete access here. So if I expand this particular section, you can see SQL gave me a green to go, and then I can also check what are the tables present in my database. So for that, you will be using show tables, control enter, and these are the tables which I have: bonus, book collection, book order, clone, consolidated, student information, employee details, etc. So now, if I want to understand employee details, what I'll do is copy this row, copy field, and then I'll simply write down a select statement, right? We will also understand what exactly does select from, and every aspect, every syntax of the statements in the upcoming module. For now, we are just testing the condition of the installation that we have done. So for that, so I'll be writing down select. So you can see When I type, you can see some auto suggestions, but don't take any auto suggestions. Follow a strict format for yourself. So select star, which means all the columns. So maybe I'll be having 5 columns, 6 columns in this particular data set or data table. When I indicate star, automatically MySQL Workbench will understand that user wants to query or extract all the columns from the table. If I dedicatedly provide, let's try that as well. So from, and remember the field that we copied, just pasted and remove the single quotes. And at the end, yeah, without semicolon, your query will run. But to follow a strict syntax, we need to enter semicolon. Now, let's hit enter to find out the entries in our data set. So we have 5 columns. You can see we have employee ID, employee name, age, department, and salary. So now, let's say I just want the employee name and their department. In that case, what I can do is quickly copy this and paste it somewhere here. And instead of star, I will write the dedicated column name, EMP name, comma. If your intention is to extract specific columns, then you need to specify them and separate them using a comma. Now I want employee name and department, so I'll write EMP name column, comma, separated, both are separated by comma, and department, right? So let me run this and I'll have, okay, there was some error. Copy field name and I'll paste it here. Yeah, I think that was a small spelling mistake, not to worry. Enter. There you go. So we have John Doe and all the other employees, Jane Smith and Michael Johnson, and their specific departments. Now let us understand something a little more detailed. Let's say the user wants to extract specific employees from IT department. How do we do that? We do that by adding a where clause. So these are clauses, don't worry. We're just testing it out. In the upcoming module, we will be going deep diving into each and every part of this. So where our department is IT. So since this is a character data type, it will be inside quotes. So IT, semicolon. Remove the semicolon and everything is good to go. Enter. And we will have the details of all the employees who are in IT department. So this is how a basic query on a MySQL Workbench works. Now we have a briefing on the understandability and working functionalities of the MySQL Workbench. Proceeding ahead, we have the choice of SQL engine for learning purposes. So MySQL and PostgreSQL both are excellent choices. MySQL is known for simplicity and ease of use, making it ideal for beginners and web applications. On the other hand, PostgreSQL offers more advanced features and widely used in analytics and data engineering roles. Both databases are open sources, stable and production ready, making them perfect environments for learning SQL fundamentals. Now we have common installation issues and fixes. Beginners often face issues like port conflicts, authentication mismatches, or missing environment values. So these will be the common issues that you might be facing during the installation process. Don't worry, we will be linking the complete installation and setup video in the description box below. You can go through that and it will have all the mistakes and all the possibilities of creating mistakes and all the permutations and combinations of the problems that you might be facing in real-time installation. It's a completely detailed tutorial, so it might take a lot of time of this particular session. So for that purposes, we have created a dedicated tutorial for installation. So we will be linking that. Now, why these issues come? Because you might be having Jupyter Notebook or any other platform that deals with databases like MySQL as well. So you might have to dedicatedly create a port for their access. So if there is a port conflict or any kind of authentication mismatch, you might face these. So you have that all covered in that session. Understanding these errors early prevents frustration and builds troubleshooting confidence. Addressing problems such as 3306, which is a port number conflict, or PG admin setup, which is for PostgreSQL failures, helps learners become self-sufficient and comfortable with database tools. Now let's go through best practices for beginners. So some of the best practices are, you should learn always to create a dedicated practice database to avoid accidental data loss. Using meaningful table name and column names improve readability and long-term understanding. Backing up data before experiments and maintaining a personal SQL notes file helps reinforce learning and builds good habits from the start. And that brings us to the end of module 1, and next will be the module 2. So now we have entered module number 2. So this module number 2 gives us a brief introduction to the basic commands in SQL. So this is all about how to create a table, how to insert data into a table, and then when you start querying, how do you query, right? For a basic example, you have select. So select in SQL means you're trying to explain the SQL workbench that you want to select something from a table that you just created. So there might be many number of tables. For this sample execution, we're going to create 5 tables, and you must specify which table are you focusing on, right? So for that, you might have to give SQL table name along with the select statement. And then what do you want to select? You want to select a specific column or all the columns available. So there are again specific ways to select the columns again. If you want any particular column from the table, you need to specify the column name. Or if you want to extract all the tables, then you don't have to write all the column names. You just write an asterisk, and then all the values will be extracted for you. And if you want to filter out, let's say there is a condition where you want to filter out all the employee details where department is equals to HR, then you will go ahead with one filter query, which is where, right? That particular where is a clause in SQL. So this can help you understand how simple SQL is. It's just a verbal language. You talk to your database and you'll get the queries. It's as simple as that, right? This is what makes SQL so exciting, so resilient, so reliable, and so relevant to the current IT standards and industry standards wherever data is related to it. So now without further delay, let's start by creating a simple table, right? So now you can see on my screen, we might have to use the database first. I have already created a database on the name interview, and this particular database will be used by us in upcoming modules, maybe 2 or 3 times for interview questions and answers and joins. And for now, we are just working on the basic terms of creating and filtering data and extracting data insights. So I'll be using this particular dataset. And if you want to create a new dataset, it's really simple. You go to File, and here you create a new model. And then you add the names to your model and all those things. Or you can also go ahead with this particular option. Create a new schema. And then you name your schema as sample SEHEMA test now. And then you can choose a default location and all those default things for yourself, and then apply. And then you create a schema if you want, apply, and finish. For now, I don't want to create this one, so I'll just close it. And once you create the schema, everything is straightforward, like we are going ahead with now. So once you create a database, you need to remember the database schema name. So now I've created this particular interview schema. So to begin with adding any of the tables or adding any of the data entries, I need to specify the database I'm using. So you can see on the left-hand side, we have a lot of data schemas. We have car dealership, credit card data, interview, sample stop, right? This is the one sample schema test that we recently created, right? You can drop this schema, drop now. So we have removed it. That's the way you delete a schema if you want. Okay, let's take it as a learning step in case if in future if you wanted to delete any schema. So now I want to get the access to interview schema, or the one which I created already. So how do I get access to it? Again, SQL is really simple. You just need to write down use schema name, which is interview. Done. Semicolon. Now SQL understands, yeah, user wants me to use this particular schema on the name interview. So let me expand this so that you can see it better. I hope the code is visible clearer. So now you can select the entire query and use this particular flash logo to execute, or the best way I use is hold Control and press enter. That is the best way, or a shortcut to select the database. Now comes the next step, where you want to create a database. So again, let me tell you this. So we have linked this particular code document in the description box below. You can open up the code document and follow along with us so that you have a better learning experience. And I've also saved this particular code documentation on a notepad for quick access. But before going with the quick access, let us manually type the table names and enter the data or the insert commands so that we have a decent understanding. Let's go back. So the first table that we will be creating is departments. Now you can see this particular double code, right? If you have programming background, then you might have something called naming conventions or tagging or quoting, right? It will not be executed in real time, but it will act as a note or a sticky note that you leave on your code so any of your fellow developer understands what's happening here. So I'm using these double hyphens here as a quote so that my fellow developer will understand that I'm creating a data table which is named as department. So the simple command for this is create. So you want to create something, so you just write create. What do you want to create? I want to create a table, right? So you can see that whenever we write something, we are using, or I'm using, a separate naming convention, right? So here you can see I used uppercase for the keyword use. So anything which is getting highlighted as in a blue color is a keyword. A keyword has a dedicated meaning and it cannot be used for normal purposes. It can be used only for SQL purposes only to make SQL understand what is your step or what is your intention. So use uppercase for all the keywords and use mixed case or sentence case or lowercase preferably for your names, right? For the table names, for the column names, for the row entries or anything which is from your end. Basically anything which you are giving, the users which you are giving to SQL should be in lowercase so that you can differentiate. For now, we are just trying to write 2 or 3 lines of code, 2 or 3 lines of query. That is easily understandable. But in future, you will be writing subqueries, you will be writing joins and a lot of more complicated queries where at least you'll be writing 10 to 12 lines of code. In that particular scenario, you must be capable to understand which is a keyword and which is a user-defined word or a name or a column name, right? So a metadata basically. So that's the naming convention you should be following. So understand what's the difference between a keyword and what's actually the name that you have given to your column name or a table name, which is basically user-defined. So you can take it in programming terms, which is user-defined, which is internal implicit design, right? Implicit function. So I want to create a table. So write create table. And what's the table name? So my table name is departments. So this is my table name. So what do I have inside my table is my next question. So inside my table, I want to have a couple of columns. Let's say 2 columns, department name and department ID. So for that, I need to write down dpt ID and data type is integer. I want to provide integer data type for it. So basically, before we continue, let me tell you something. So whenever you want to add columns, you need to add column name. Okay, let me comment this. Column name along with its data type. So this is a set. So whenever you try to enter a column name, you should follow this particular approach where SQL understands this is it's a combination. It's an entity which is made of 2 things, name of the column and what's its data type, right? So this is the naming convention that you should be following. So I want department ID as the first column and the next column is department name, right? So for this particular department name, I want to go ahead with varchar, and varchar is also another data type. And for that data type, you can allocate number of locations to save that particular department name. So for a basic request, I think I'd like to go with 50 character spaces, and that should be good enough for writing my department names. And then you can close the command and write a semicolon to end the query. So your query will run without a semicolon, But for safer programming practices, consider it as a protocol so that you or any other developer who is reading your commands will understand that it is the position where this particular query ends. So use a semicolon for that. This is pretty good, but remember, we might have to work on joins in the future modules. So joins is nothing different from the VLOOKUPs or the relationships or the data modules that you have seen on Power BI, Excel, etc. Basically, you're combining 2 or 3 different tables together. Let's say you are ordering something from your online websites, and for getting that particular product to your location, you're providing your address, phone number, and all the details, right? So in a similar way, when you want to access data from a different table, you might have to establish connection between them. So to establish a connection between the 2 tables, you might want something called as a primary key and a foreign key. So primary key and a foreign key act as phone numbers or an address location, or basically something which establishes a relationship between them. So now this particular thing you need to understand. A primary table in one table is the one which connects with the same primary key in another table, but in the other table it is termed as a foreign key. In my table, department ID would be the primary key. It will be unique and it will not be null, and this particular department ID can also be another table. It can also be unique, it can also be not null, and it will not be empty, but in that particular table it will be termed as foreign key. The same primary key in a different table is termed as foreign key, but the same primary key in the dedicated table is termed as a primary key. So now I want to term my department ID as the primary key in my table. For that, you just need to write one more sentence here, not even a sentence, one more word. You just need to specify primary key, and that's done. So primary key and done. Now what happens is SQL will understand you want to create a table and the table name is departments, and you have one department ID column, 2 department name column, and the data type for department ID is integer and the data type for department name is varchar, and you have provided 50 spaces or 50 data spaces or addresses for you naming your department name, right? And out of which department ID is the primary key. So these are the details that you have given to your SQL workbench, and you should be ready to create a new table. So now let's head back to the notepad where we had created the code. This is the one. So create table departments ID is equals to int primary key, department name is varchar, 50 locations, and semicolon. So only difference is there are some indentations done. So what is an indentation? Just like any other programming, you also provide dedicated spaces, new lines, so that the fellow developer understands where is what. So this is the indentation we have followed here. We are creating a new table, departments, and the first column is department ID. It is an integer data type and it's considered as the primary key. The next column is department name. Its data type is varchar, which is a character data type. We have provided 50 spaces, and then end of the command. Right? Now comes the insert command. Now, again, similar to table creation, inserting data into a table is also simple and easy. So all you need to do is specify the operation that you want to do. It is insert. I want to insert data, but into which table? So I want to insert into table which is departments that we recently created. You can simply copy and paste the departments table name here. And what are the department columns you have? So I have 2 columns there. I'll take department ID and department name. And now these are the values I want to insert. What are the values? So again, comma separated values. The first is ID, so you don't have to write any quotes, but the second one is varchar, so character data types must be specified in single quotes. So this is the first entry, comma separated values. The second one is number 2, comma, single quotes, and what's the next one? Maybe engineering. and again a comma separate, and third team could be finance, separate by comma. Fourth team can be marketing. So I don't have any further rows here, so what I can do is I can close this particular indentation and write a semicolon to explain the end of this particular query. So now similarly you can just execute this and add the values. So let's head back to the notepad. So here you go. So this is a similar approach what we have mentioned here on my MySQL workbench. You can follow this indentation so that you are clearer, and you can just simply run the query. I'll use Control Enter, and these values are entered into your table. Now I want to extract what are the values that I have entered into my table, or I want to just cross verify if I have entered all the values or if the values that I have given are properly inserted or not. So for that you want to select. So as we discussed, there are multiple ways to extract data. You can just specify the column names from which table. The table is departments, or you can specify dedicated column names. Let's say I want to only extract the department name or department ID. You can also do that. Or another approach for the same code is this one. You don't have to specifically mention the column names. You can just write down an asterisk and it will still execute the same. So let's try all these 4 commands. You have your data here, and the same works for this one as well. Now let's say I want to select only a dedicated column. So these are your department IDs and dedicated department names. This is your department name. And now if we drill down further, let's say I want to extract the details for only HR team. So this is where the where clause comes into the picture. So extract or select department name where. So this is basic fundamental queries that I'm really writing right now, so that you understand how it actually works in the background. So you understand the workflow of it. So where department ID is equals to, let's say, let's run this, department ID 4. So 4 is marketing. So department ID is equals to 4. So what happens is SQL selects the department name column altogether. The entire department column is selected. First, it will go to the departments table itself. It has 2 columns. One is department ID and a department name. You can see it right here, right? So this particular entire table is selected by SQL, and then it reads what are the columns I need to select. So we are dedicatedly specifying just one column, which is department name. This particular column will be selected in the second phase. The third phase is where it applies the filter for department ID. Now again it goes to department ID and it checks individual department numbers. So it will go for the department ID where it matches with number 4, and then adjacent to it is marketing, right? This is what we are trying to extract. SQL has understood this and it will give us the marketing team name. So this is how the query works in the background. Now that we have a basic understanding of how the fundamental keywords in SQL, which are select, from, where, filtering things, right? Basically how to create a table, how to insert values inside a table, and how to query them. Now we will proceed and add a few more tables onto our MySQL workbench so that we can get continued with further queries like some aggregate functions like average, sum, etc. So let's not waste much time. Let's go back to the query window where we have all the table details and copy them and simply write them. So let me copy the entire 3, 4, 5 tables and paste it on the SQL workbench here. I'll minimize this a little so that we have a better view. There you go. So this is our second table, which is employees table. Now, before we create the table, let me explain you few things. So we have about 5 tables. One is departments, second is employees, third one is users, fourth one is orders, and fifth one is sales. In the terms of data analytics, in the terms of business analytics, we deem these tables as 2 parts. The first one is fact tables and the second one is dimension tables. So what are fact tables and dimension tables? We will deep dive into these in the next upcoming modules. So basically, it's nothing but relationships between the tables. So there will be one table which is related to all other tables in the database, right? So in this particular scenario, the employees table is a fact table, and employee is the one which works in your company. Let's say you have an online store and you have a list of employees, and these employees are the ones which receive orders from the users, and they fetch your inventory, pack that order and send it to the users, right? So employee table is the fact table which is related to the orders table, which is related to the users table, which is related to the inventory table, which is related to the department table, right? It connects to all the tables. And on the other hand, the dimension tables, these are related to your fact table based on one foreign key, right? You will be having employee ID, right? This particular employee ID will be the primary key of your data table, and somewhere or the other, the employee table will dedicatedly have a department value, department ID, right? It will have the order values, the order ID, it will have the sales ID, right? All these entries will be in the fact table, and all these entries will be the primary keys of all the dimension values, right? The dimension tables. These values will connect to the fact tables. So it will be a little confusing now, but when we enter into the data modeling module, there you will have a clearer understanding. For now, let's understand one thing. You just have different types of tables. One is fact table, one is dimension table. Fact table is really important because fact table acts as the mother of all the other tables, and all the other tables are connected to fact table. If you delete the fact table, then there is no way you're going to perform the analytics in future, right? It is like the root. Just understand that basic thing. Now let's continue with table creation. So now let's head back to table number 2, which is our fact table here, or let me tag it as the fact table for reference. Now the same pattern again. We want to create a table. So create command, table command, provide a name to your table, which is employee. And here we have 1, 2, 3, 4, 5, 6 columns. We have employee ID, we have employee name, we have salary, we have department ID, on which date was he or she hired, and the department ID, right? So here we are dedicatedly specifying that department ID is a foreign key which relates this particular fact table to the departments table, and we are referencing this, right? So references is the keyword which helps SQL identify that you are trying to connect this particular employee data with the department data, right? So we have about 5 columns here: employee ID, name, salary, department ID, and hire date. And if you are trying to get this connected with another dimension table, then this particular command where it says we are trying to use department ID as a foreign key, which happens to be the primary key of a dimension table, which is the table name, departments, and in that particular table name, the column name is department ID. It is named as department ID. So please go to the departments table, refer to the department ID column, and then match the entries of department ID from employees table to the department table. So this is how it works. Now let's click the flash logo, or I'll go with my shortcut Control Enter, and we have successfully created the employees table. And similar to the previous approach, you need to specify the keyword insert. I want to perform an insert operation, and I want to insert these elements into is another keyword, and you need to provide the table name, which is employee. And now what are the columns I have in my table? I have employee ID, I have employee name, I have salary, I have department ID, and hire date. So based on the column names, I need to specify the data entries as well. So you cannot mix and match. You are specifically providing the order in which the entry should be happening. So the order is: first comes the employee ID, second comes the employee name, third comes the salary, fourth comes department ID, and 5th is the higher data. In the same fashion, your entries should also be matched. So first, the employee ID is 1, the name is Alice, the salary is 90,000, department ID is 2, so she belongs to department whose ID is 2, right? If we go back to department here and execute this, so we will be having engineering in the department ID 2. So Alice belongs to engineering department, and then comes the hire date, which is this one, right? So you need to specify the data type. So here I have specifically provided the data type as date for hire date. In the same fashion, rest of the employees, employee ID 2, 3, 4, 5, 6, 7, and 8, 9, and 10 are added, right? And deliberately we're also adding some null values here. So you'll understand why we are adding null values, because in future we will be performing some join operations in the upcoming modules where we will try to filter out the employees whose department is not yet allocated. We are considering these employees are new or fresh hires, so they are on bench period and they are not aligned or assigned to any projects as of now. So they are having their department ID as null. So we'll be performing such operations. For now, just try to, here I think I've marked it, no department, right? So for now, just try to create a table and add data. So now your fundamental job to do is you need to understand how to create a new schema, which I've explained before. Go to the schema table here, create new schema, and write a name to your schema, and then apply it to create a new schema, which happens to be a dimension table, and this will be related to the fact table, which is our employees table, right? And here I'll be having user ID, email of the user, and at what time was the account created at timestamp, right? Now control enter, and we have created this particular users table. And similarly, we will insert the data into users table. So we will be following the same pattern. So we will be inserting into users table, and these are my values. Let me indent it. So proper indentation will help you understand how your tables are organized. So you can follow this. It might take a little time, but in future it will definitely save a lot of your time entering or making mistakes, right? So this is a good practice or best practice. Now I have about 10 users in my database. And then this is the end of the query. So here you can see I've also tagged as duplicate email entry. So this will be another learning experience for us, where we will try to find out duplicate email entries in our database. Now hit Control Enter. I think we selected employees data table. We were supposed to select users data table. Yeah. Okay, we were supposed to create the data table first. Okay, we have successfully entered the elements into the users table. Now comes our fourth table, which is orders table. Similarly, we have order ID, customer ID, and order date. Control Enter, and we have created the orders table. Let's quickly add all the data into the orders table. You can also follow the same indentation, or if in case if you want to have a particular specific format of indentation, you can also follow that. We have the last table, which is sales table, and similarly, let's enter all the data into sales table. Now let's check all the entries or all the tables. The process is simple, like we discussed. Select star from employees. There you go. So these are the employees and their details. And similarly, you can just quickly copy and paste this command and rename this to departments and run a query, and you have all the employees or department details. Similarly, you can copy paste, and then you can use the name of sales, orders, and users. And I'll also have orders, and also I'll have sales. So these are the user details that we have entered, and these are the timestamps when a user account was created. and these are the order details. So these are the orders placed on what detail, on what date, and who was the customer and who was the order ID, and all the details of that. And sales data table, what was the sales ID, on what date was the sale made, and what's the amount they paid, right? So these are the details that we needed. Now let's take a step further and try to extract some details from this particular data set that we have just created. So I'd like to close it here. So far this is the creation and insert process. Let's comment it. Now let's proceed further, and this would be the querying stage. Now let's try the filtering process. So let's consider we want to filter the details of employees who are earning let's say 90,000 or more. So how do you extract it? Let's take a moment. So far we have a basic understanding of how to insert data, how to select queries, right? And we also went through a sample where statement where we extracted the marketing ID, right? So the department name where marketing or department ID was equals to 2, right? So following the same approach, can you devise a quick query? Yes, I think you already have a rough template on your mind, but it's okay if you don't have it. So let's get started with it. So as we discussed before, SQL is really simple. All you need to do is just explain SQL in very simple terms. I want to select. Select what I want to select. I want to select employee name, or I want to select everything from employee, where from employee. Let me copy the employee name to save time. This is the table name. From employees, where salary is greater than a rough number 90,000. So before that, let's run this query and see. We have Alice, we have Bob, we have David, we have Eve, we have Heidi, and we have, yeah. So there are a few employees who are drawing salary greater than 90,000. Let's say it as greater than or equal to 90,000. So we must be getting a couple of entries here. So let's quickly run the command, control enter, and there you go. So we have about 1, 2, 3, 4, 5 employees, Bob, Alice, David, Eve, and Heidi, who are withdrawing salary which is greater than or equal to 90,000. So this is one of the good filtering examples. Now let's go with a few other queries or filtering queries. So we have HR, we have employees, we have users, we have sales, we have orders. So let's say I want to extract employees who were recruited after February of 2025. So for that, we can use the same query. We can quickly copy and paste it here from employees where join date, right? So I'll execute the select query once again. So I'll copy this particular field name and paste it here is greater than or equal to March. We don't have a March, but we can take the September. We can copy this particular field and paste it here. There you go. So any employee who is hired after September 2025 should be highlighted. Enter, and there you go. We have about a couple of employees who were recruited after this particular date. Or you can also find out less than who are the employees who were recruited before this particular date. There you go. So only David was the one who was, maybe this can be considered as David is one of the senior most employees in this particular organization. Now let's proceed further and try the next type of query, which is the sorting data. Now I want to sort the employees table. Let's say now I want to identify employees in terms of salary. Who is the employee who is drawing highest salary and who is the employee who is drawing the least salary? I want to order them in decreasing order. So it's really simple. You can use the same query here. Select star from employees and order by salary DESC. So we have two keywords, DESC and ACSC. So ACSC is ascending order, BESC is descending order. So you just need to run this query and we will have salaries of the employees who have highest salary numbers. So we have Bob, David, Heidi, followed by that we have Eve, Alice, etc. And Ivan is the person, maybe he's a fresher, so he's drawing the least intern level salary or the beginner level salary, which is 50,000. And similarly, you can follow another thing here. You might be assuming, can I give two columns here? Yes, you can give two columns. Order by DEPT. So let's go with department ID. So this even works for character data types as well. Department ID ascending and salary descending. So you need to separate this by a simple comma and there you go. Enter. Now what happens is you can organize the department ID in increasing order and organize salary from descending order. So it's just executed for the reason to understand if this particular order by sorting command executes for one or more columns or not. So the reality is it works for one or more columns. So that's the basic understanding. Now we need to understand one more thing, which is filtering out with limits. Let's say I want to find out only one entry which has the highest salary. So in that particular case, what I can do is I can make use of limit command, which limits the number of rows output by one or two, number of a number, dedicated number. If I just want one entry, I'll have just one entry. In case I want to have top 3 employees, I can provide top 3 as limit 3 and you'll have top 3 rows executed right here for you. So this is where we come across the limit function. And apart from limit, you also have another function which is called as distinct. So the name speaks for itself, unique entries in the row. So for example, let's say I want to find out, let me use the same query, select star from employees and I'll replace star with distinct department IDs. Copy field name. So what it does is, for understanding what it does, we need to copy this statement and paste it once again, semicolon. Now what's happening is, when you enter this particular query, you have multiple departments. Let's say department number 2, engineering department, is repeated multiple times. But now I don't want to extract all the employee details. I want to just know how many number of unique departments are present in this particular employees table. So in that particular scenario, I need to provide a semicolon to follow the principles or best practices. So here you see we have about, okay, I think for distinct function we might not need semi double quotes. Okay, I think I made a mistake in keyword. Yeah, there you go. We have 1, 2, 3, 4 distinct department IDs and one null. So that is from the employer to which we did not assign any team yet. So that's one thing. And now if we continue ahead, we have aggregate functions, which are basically the average, sum, count, minimum, max, and a few other basic aggregate functions that you use on a daily basis. So for basic aggregate functions, I'll just quickly copy and paste the comments here so that we save time and spend that time for understanding how the query is performing. So here we have the first function, which is counting the number of employees. So basically we'll start with the first aggregate function, which is trying to calculate the total number of count of total employees in this particular data set. So we are using the count function, and here you can provide a dedicated column name, or you can also provide the star logo, which basically calculates the entire rows here. So just enter. Then you have about 10 employees here. Now the next aggregate function is we will be trying to find out the average salary of an employee from a specific department, which is engineering. So for that, let me expand this again. So for that, first we will be calling the columns from this particular table, which is employees table. And since we are also dealing with a specific department, which is engineering, we need to perform a join operation where we will combine both employees and department tables together based on one keyword or one column, which is department ID. So department ID will be a primary key for department table, and department ID will be a foreign key for employees table. So based on this foreign key, meaning the employees table will be able to get joined or connected with the department table based on this particular department column, department ID column. Now, so our statement is simple. We are selecting average of salary, and we are aliasing it as average engineering salary from the table employees, and we are joining the employees table with the departments table on one common column, which is department ID. Department ID is equals to employees.department ID. So departments is the name of the table and employees is the name of the table. So in this particular table, I'm referring this particular column, and I'm trying to connect to this particular column in the next table where department name is equals to engineering. Now let's execute this particular query. There you go. So on an average basis, the salary of any employee working in engineering department is 1,08,750. So this is the average salary of any employee who is working in engineering department. Could be more or could be less based on the designation. If he's an intern or a beginner, then the salary might be less. If he's a supervisor or in a senior position, the salary might be more. It's basically an average of both. Now, the next aggregate function that we will be dealing with is the maximum and minimum. So for finding out minimum number, you can use a function in SQL, which is called min. And for maximum, we can use a function called max in SQL. So it's as simple as that. Minimum of salary as minimum salary, maximum of salary as max salary from employees table. So let's quickly execute this query. There you go. So we found out the minimum salary of any employee in the entire company is 50,000, and the maximum salary in the entire company is 1,20,000. Next comes the last aggregate function in this particular domain, which is count function. So we will be selecting a department ID, and we will be counting the total number of employees per department, and we will also name it as employee count from the table employees, and we will be grouping it by department ID. Let's enter. There you go. So we have one employee who has no department assigned, maybe he's an intern, and department ID 1 has 2 employees, department ID 2 has 4 employees, department ID 3 has 1 employee, and department ID 4 has 2 employees in it. And with that, we have come to an end of this module, and we have understood the basic functionalities on how to create a table, how to insert a table, how to select or extract data entries from a table, how to filter data using where clause and having clause, and we also learned grouping, aggregate functions, basically all the fundamentals to proceed with the upcoming modules. And with that, we transition to the next module. So now we enter module number 3, which is about understanding SQL data types and operators. This particular module will help you set the stage for all the basics. In this module, we will be diving into something absolutely fundamental, something every single SQL developer, data analyst, and database engineer uses every single day: data types and operators. Now, I know what you're thinking. Data types? Operators? Isn't that basic stuff? Yes, it is basic. But it is also the reason behind almost 70% of SQL mistakes that beginners make. Wrong data type breaks queries, slows down performance, and causes corrupted results, and even sometimes crash the entire production system. I've seen senior developers accidentally storing dates as text and then wonder why the database can't sort December properly. So in today's chapter, it's not just theory, it's how not to break your job interview or your database. Let's dive into this section. The first step is understanding SQL data types. Before we even start to write a single query, SQL forces us to follow this one golden rule. Every piece of data must have a type. Why? Think of a database as a massive warehouse. Data types are the labels on the boxes. Without labels, the warehouse becomes chaos. With accurate labels, everything is fast, searchable, optimized. SQL databases rely heavily on the data types for storage, indexing, comparison, sorting, and performance tuning. Imagine a library where books have no categories. SQL without data types feels exactly like that. Now let's break them down. First one, numeric data types. We have integer, or it is also specified as int, which is used for whole numbers. Great for IDs, counts, quantities. For example, age can be stored as integer. Product ID can also be stored as integer. Quantity, the number of items ordered. Now it's a small story type. In one of my early projects, someone stored product prices as int field. So the price was $99.5 or 99.5 rupees. So the total became 99, ignoring the 50, right? Or the decimal value. Now, what happened because of it? We lost precision and the entire billing report was off by lakhs. Lessons learned? Use the right data type. Now, the right data type was numeric type or a decimal one. So this is the superstar for financial data. P is equals to precision, total of digits, and S is equals to scale, which is digits after decimal. Now, for a simple example, consider this one. Decimal 10, 2, up to 10 digits and 2 digits after decimal. The maximum value is 99 millions dot 99 decimal values, or one decimal value less than 100 million. Now, real world use case. Salaries, prices, taxes, rates, weight, percentages, etc. Next comes the float or double data type. It is used when you need very large or very small numbers, but some precision may be lost. Think scientific data sensors, machine learning scores. But don't use float for many unless you want rounding problems or angry accountants calling you. Now the next data type is character data types. We have char function n for fixed length string. Always use the full allocated space. Let's consider country codes where you have some country codes for that. For India, you have IN for US, you have US, and you can also have gender, which we have M and F. For example, country code, character data type, 2 values. And the second one is workchar, and it is one of the most commonly used ones. It stores variable length data, and some of the use cases to consider as names, emails, city names, product descriptions, etc. A small story again. Once I saw a table with workchar and the limit was 5,000 for storing the first names. First names alone. Imagine allocating 5,000 characters for storing just a 3-letter word like Max or Raj. Now, what are the lessons learned here? Proper sizing matters for performance. If you store 5,000 characters for just 3 letters, your space is wasted. And this might affect your performance. Now, the next data type is text. Text is used for large bodies of text. Blogs, descriptions, comments are a few examples. But avoid text whenever a reasonable workchar works in place of text. It cannot be indexed efficiently. That's the problem. Now, the next one is date and time data types. SQL is amazing at working with time-based data, but only when the data is stored correctly. For example, dates are stored only in year, month, and date types. You can see on my screen, we have YY, YY, MM, and DD as the format. This type of formatting is perfect for birth dates, join dates, attendance logs, and a lot more. Next is time, and time stores only time. And after that, we have date along with time function. This can be represented as date time together or also known as time stamp. This stores date along with the time. Now some of the use cases: timestamps, log entries, attendance tracking, transactions. A mistake I've seen too often is people store date time as workchar, right? a data type change completely. And then sorting goes like 2024 1 1 or 2023 12 1, 2024 1 10. Completely messed up, right? Now, this can be solved. You just have to change the data type, and also we'll go through some examples in the real-time use case where these type of issues are addressed. Moving ahead, we have the Boolean data types. So the name stands for itself. It is either true or false. Some of the examples is active, is verified, is published. Never store Booleans as workout. You might be wondering, why cannot we use workout? It's just simple yes or no. Reason, if you use workout, it wastes space and breaks the filtering logic. That's the main problem. Proceeding ahead, we have the next data type, which is binary, and miscellaneous data types, which is blob. This particular data type is used for storing images, PDFs, videos, JSON files, and they store semi-structured data. Modern SQL feature. JSON is a lifesaver when you need flexibility without completely switching to NoSQL. Now let's go to the next section where it will help us to learn the arithmetic operators and other functionalities. Operators help us calculate, compare, and manipulate data. Let's start with the easy ones. The first one is arithmetic operators. Just like math operator, operator meaning example, addition salary plus bonus, subtraction price, discount, multiplication, quantify, and division, modulus, etc. Now let's go through a simple example query. So you can see it on my screen. Select product name, sales, quantity into rate as new sales from Excel data. Now the real-time analogy. Operators like these are calculator inside SQL. Instead of exporting data into SQL, SQL helps you compute right inside the database. Now let's also go through a real-world scenario. Imagine a store wants to compute total revenue, discounts, tax calculations, profits instead of running separate scripts. A single SQL query can handle all of these arithmetic operations. Now, let's dive into section 3, logical operators. Logical operators help SQL make decisions like, should this row be included? Does it match with condition? Is it true or false? Followed by that, we have AND operator. All conditions must be true. For example, where salary is greater than 50,000 and department is engineering. You can see that query right on my screen. Followed by AND, we have OR operator. Any of one condition should be true, where city is equals to Mumbai or city is equals to Delhi. So this selects all the entries from the cities of Mumbai and Delhi. You can see a sample query on my screen. Followed by that, we have NOT operator. This exactly reverses the condition, where not country is equals to India, and this particular query is on my screen. So you can see any other data apart from India. Logical operators like filters on YouTube, language is equals to English, duration less than 10 minutes, category is equals to technology. SQL just filters rows instead of videos. Now we land into section 4. So this particular one is based on between, in, and like operators. Sometimes we have another one as well, which is called I like, which is the opposite of like. These are the operators you will use every single day. Now another one is between operator. So this is used for ranges. For example, columns between value 1 and 2. For example, you can see it on my screen. Select everything from Excel data where row ID is between 10 to 20 or 10 and 20. Now, what this query does is it will eliminate any rows before 10 and it will eliminate any rows after 20. Only the rows between 10 and 20 are executed and shown to you. Now, a friendly tip. Between is inclusive. It includes both the boundaries, which means 10 and 20 are included. They are not excluded. Now let's dive into the next one, which is in operator. Instead of writing many OR conditions, you can just write one in condition and write the set of cities. For example, you might want 3 or 4 cities. So what you can do is, where city is in and the function, inside that function, you can write the city names. For example, Mumbai, Delhi, Hyderabad, Bangalore, and many more, right? Whenever a city name matches with the elements present inside the in function, that particular row entity will be selected and displayed for you, or filtered and displayed for you. Now, followed by that, we have like operator and pattern matching. So you'll have a modulus sign or wildcard, which represents any number of characters. And the example is right on my screen, where name is equals to or name like modulus A and ends with a where name like modulus sign an modulus sign, so contains an as a wildcard. So any name which has an and included in it and it might have anything in front of it, it might have anything in the right hand side of it or the end of it. So whichever text has AN inside it, all those text values will be extracted and displayed for you. Now in the section 5, we will have a small practical story or a real world analogy. To make this chapter sticky to your memory, let's run through a few stories. The first one, date disaster. An HR system stored join date as varchar. So sorting by join date gave Jan 10, Jan 2, Jan 25, Jan 5. Why? String sorting treats 10 as smaller than 2. Solution, convert varchar to date to fix everything instantly. Moral, always pick the right data type. Let's also go through story number 2. The like operator that saved a scale. An e-commerce company needed to find all products with Pro in their name. iPhone Pro, MacBook Pro, GoPro. One more simple query where product name like modulus sign Pro modulus sign. It can have anything before Pro, it can have anything right hand side of or the end of the Pro. So basically any text which has Pro included in it will be displayed. So what's the result? Marketing team recovered thousands of lost sales because these products were mistagged. Now comes the section 6 where we will have some demos. Here are some fully explained queries for learning purposes. So we will be diving into MySQL Workbench and start executing commands. So now we are on MySQL Workbench for running all the examples that we discussed previously. So my data is in sample database. So we will be using the use database keyword. Let me expand the screen. And the name of the database is sample. So we are in a sample database right now. And we have to show the tables that we have. Again, the keyword. You can see that MySQL Workbench is showing us some recommendations, but we don't want any recommendations. We should go with what we have. Now, apart from that, we want to see what's inside this particular table. So, yeah, Superstore. So we were supposed to go into Superstore, not a problem. So this is our database name and show tables. We have checkpoint data, we have complex post view, and this is the Excel data we need to work with. So now let's type a command, select star or everything from Excel data so that we have an information on all the rows and columns that we have to deal with in this particular execution. So we have row ID, order ID, date, shipment date, customer ID, and everything that we need to know. So now we will execute some sample queries to understand the functionality. So let me write down the demos that we want to execute. So the first demo is about finding employees earning between 50,000 to 100,000. Right, this is the first query. Let's leave a little space and also write down demo 2. And what's about the demo 2? We need to search city names. So these are the examples that we discussed before on the go, right? So containing PUR. So it can be Nagpur or any city which has the letter PUR in it. So it took an auto recommendation, or instead of PUR, you can also have anything like DEL, right? So now let's go with the third demo, which is show products with price calculation. And demo 4 will be about list users from specific cities. Demo 5 will be about employees not in HR department. Or we can also make some changes to this based on the dataset that we are working with. So we can go ahead with the segment here. We have segment in, we have which are not in segments of consumer, or anything apart from consumer and home office. In specific segment, let's go with the consumer. And lastly, demo 6, which is about items with exactly matching some words, like let's say OUR, or let's say instead of exactly matching, we can consider this as text matching. So we have a template or a skeleton of what demos are we trying to execute here. Now let's start with queries. Now I want to find out any employee or any of the products. So we have number of pricing, right? So we should go with sales here. So let's identify sales which are more than 3,500. So between 3,500 to 4,000, or sales, find sales between. So this is a requirement. So what we will write is a simple select statement. We will select everything or select a specific product name. So we will go with the product name. So what I'll do is I'll simply copy this field name. I'll paste it over here, comma. I want sales column as well from Excel data. Where sales is between 35 and 4,000. Now we have the list of products that are having this range of sales. So we have about 5 or 6 entries which have the sales in between 3,500 INR or dollars to 4,000 INR or dollars. And now let's go into the demonstration 2, where we wanted to find out city names containing PUR. So if we go back to our Excel data set, we had a column which had the address, right? So we had cities like Leeds and a few other things, Paris, Parla, and all those things. So I want to find out any city name which has some given text. For example, if you go with Munich, so we have MUNICH, right? And we have Naples here. So APL or APL. So any state or any city which has Hamburg, etc., right? So any state which has AMB, I want to extract it, right? So let's write down a query for that. Select city from Excel data where city like, since we're using a keyword, let's have like, and since this is a text related data, we need to encode in between single quotes, and we want Hamburg, right? So AMB and anything after AMB, semicolon, enter. So now we have any city which has AMB included in it displayed here. We had Cambridge, we had Hamburg, and all those city names which has AMB included in the text. Now let's go with the demo 2. We wanted to show the price calculations. So we have, let's execute this one more time. So we already have sales data, right? So if we go back here, let me scroll it. So if we go back here, we have the rate of every single product and the number of quantity. So the rate for single unit was $24.4 or rupees, and multiplied by 3 times, you have 79.2 as the final price, right? And Now I want to calculate that once again. Let's say we didn't have that sales tag or sales column. If we wanted to calculate it, how would you do that? That's the problem, right? So we can do this by the following application of the formula. So what you can do is write down, select. What we want is product name. So I'll just copy paste this particular field name here instead to avoid any kind of errors.
Comma.
We also have sales, right? So let's keep sales,
Comma.
we have quantity star. Let me copy that. Quantity into price. We have rate here, so we'll copy this rate name, paste it here, and we'll alias this as new sales from Excel data, semicolon, enter. So now we have all the product names and the sales and new sales. Remember the one which we discussed, decimal points? So we did not, kind of constraint to, minimize the number of decimal points. So it gave the full potential of decimal points here. So we could, include a new column with mathematical or arithmetic calculations to go ahead with. Now the next demonstration was about including all the details about a specific segment. So list users or list products. So what we can do is again a simple select statement, star from Excel data,
Where
segment in. So we want the following. So we have segment as corporate, we have consumer, right? So I want, let's say, corporate and consumer, comma, consumer. So since these are text-based data, so we need to include single quotes as well. And a semicolon to close the data. And there you go. So we have also, you can choose to include only a specific segment, but overall we have filtered the data to include only corporate and consumer related data set. Now, if we go into fifth, so data of the not in segment, so all you need to do is a simple change. So you can copy this and paste it over here as it is, and simply replace in with not in, and there you go. Now you'll get all the data which is not from the section of corporate and consumer. Run that, yeah, there you go. Okay, so there was a small error mistake, corporate, and we could also include corporate, separate by comma. There you go. Now let's execute this command. And now we only have a home and office depot related data segment. So that's how you can filter. And the last one is nothing but text matching. So where we wanted to find out the products which have this particular, naming convention. So it's similar to this one which we executed before. Select city names which have this following text matching. So instead of AMG, you can go ahead with any of the other city names like MIL or ILA. So you'll have any of the cities which have ILA in that. This is the list of the cities. And now with that, let's close this particular section with pro tips and best practices. So let's wrap it up with some practical wisdom. First, never store dates as vocab. This is the #1 beginner's mistake. Use decimal for money, not float. Float introduces rounding errors. Third one, keep vocab length realistic. Avoid vocab 5000 unless necessary. Next one is use in for clearer queries instead of many ors. Fifth one is like with leading wildcard, and it is slow. Avoid it in large tables. Sixth one is Boolean fields, make filtering faster and cleaner. Seventh one is use int for IDs fields, not worker. Eighth one is understand indexes before using like frequently. And the final summary. In this chapter, you learned why data types matter more than most people think, how numeric, character, datetime, Boolean, and advanced types work, how arithmetic and logical operators really behave, how between in like help simplify filtering, real stories that highlight how crucial good data modeling is. Now let's also go through some professional best practices you can use immediately. With this foundation, you are now ready to write cleaner queries, avoid common mistakes, and handle real-world SQL tasks confidently. In the next chapter, we will start leveling up with constraints and advanced filtering logic, which is where SQL begins to feel powerful. Stay tuned and keep practicing. Module 4, Safe Deletion Practices and Best Practices for Data Entry in SQL. Before we talk about writing advanced queries, joins, or analytics dashboards, there's one uncomfortable truth every SQL professional must understand. The most dangerous SQL queries are not the complex ones. They're the simple queries executed without thinking. And among all SQL commands, there's one command that has probably caused more panic, data loss, and late-night emergency calls than any other. And that command is delete. In this chapter, we are going to slow down and talk about something that separates beginner from a professional. It basically depends on how you delete data safely, responsibly, and confidently, and how you insert and maintain clean, reliable data from day one. Because in real world, SQL is not about writing queries that work. It's about writing queries that don't break business. So the part 1, why delete statements are the most dangerous ones. So let's start with a very honest question. Why is delete such a scary command? The answer, delete is permanent. Delete does not ask for confirmation. Delete executes immediately. Delete can affect millions of rows within mere seconds. There is no undo button in SQL for delete option. Once data is deleted, reports break, dashboards go blank, finance numbers change, trust is lost. And most importantly, you are accountable. That's why companies don't fear complex joins. They fear one command, that is careless delete statements. Now, with that, we enter into part 2, the most common delete mistakes that a beginner makes. So let me share you the most common and most dangerous mistakes beginners often make. Let's look at a sample on my screen. For your information, we are not manipulating this database as of now, because we will be using these tables for our next module, and if we run these commands and delete or truncate the data, then we might lose it and we might have to recreate again. So let's not do that. Let's have a sample query on my screen, and that should be good enough for you to understand what's the flow. So here's the query. Delete from employees. We are deleting from the employees table. That's it. No where clause, no filter, no condition. This query means delete every single record from the employees table. In a production system, this could mean all employees' records are gone, payroll reports destroyed, compliance violations, audit failures, and here's the scary part. SQL will happily execute this query. It won't warn you, it won't ask you, it will just do it. This is why experienced SQL professionals treat delete like handling a loaded weapon. And with that, we transition to the part 3, safe deletion principles. So the first one, always preview before delete. The golden rule of safe deletion is simple. If you cannot select it safely, you should never delete it. Before deleting anything, always run a select query using the exact same where condition. Step number 1, preview the data. Let's take a look at the simple query on my screen. Select star from table, that is employees table, where department is null. This should show you employees without a department. Now ask yourself, does this data look correct? Are these the records I truly want to remove? Is this count reasonable? Only when you're 100% confident, Move to the delete option and delete those records. Now comes the step number 2. Convert select into delete. Let's look at the sample query right on my screen. Delete from employees where department ID is equals to null or is null. Same condition, same logic, no surprises. This single habit can prevent 90% of data deletion disasters. Now with that, we transition to part number 4, safe deletion principle number 2. Use transactions. This is professional level practice. In professional environments, delete is rarely executed alone. It is wrapped inside a transaction process. A transaction allows you to preview changes, validate row count, roll back if something looks wrong. For an example, safe deletion using transaction. Let's take a look at this sample code on my screen. Start transaction, semicolon, delete from orders where order date is less than 2025, 1st of January. Now, select row count method and then roll back. What's happening here? SQL prepares the deletion. You check how many number of rows would be affected. If the number looks wrong, you can directly cancel it. When you're confident, then you can commit. This is how real companies delete data. If you mention transactions during your interviews, it instantly signals production level experience. With that, we make a transition to part number 5 of this module. Safe deletion principle number 3. Delete with primary keys when possible. So what do you mean by primary key based deletion? Never delete data using weak conditions if a primary key is already available. So what could be the dangerous part? Let's look at a sample code on my screen. The code will be delete from users where email is equals to alice@example.com, right? Now, how would this be dangerous? Let's say you have orders data and Alice is your company's employee. Alice might have made thousands of sales and she might have entered the same email ID, which is alice@example.com. When you run this query, those thousands of orders records will be vanished in a mere second. Let's say you wanted to just delete the order for a specific number, let's say order 123, and instead of order 123, thousands of all other records based on alice@example.com will be deleted. So now let's understand why this is risky. So in technical terms or SQL terms, email may not be unique. Remember the unique keys that we discussed? You might delete multiple records unintentionally. Now what's the safe process to escape this? Let's look at the sample code on my screen. Delete from users where user ID is equals to 4, right? Or order ID is equals to 4. Now this will be the safest step. It will only eliminate the records of that particular primary key. Now let's go with primary key. Primary keys are unique, they are predictable, they reduce accidental data loss. Professionals think in keys, not names. Now with that, let's make a transition to part number 6 of this module. Safe deletion principle 4. Soft delete. This is again an industry standard. In many real systems, data is never permanently deleted. Instead, companies use something called soft delete. So what is soft delete? Instead of removing the record, you mark it as inactive, you preserve history, you avoid compliance issues. Example, add a status column. Let's look at the sample on my screen. Alter table users, add column, is underscore deleted, boolean default false. So what's happening here? You're trying to make some changes to the table users and you're trying to add a new column which is termed as is deleted. And you're adding a new boolean value which is by default false. So in case if you're trying to delete something, then you will refer to this particular default false value, and anything if you want to hide or delete or filter, you can just use that command and filter out those rows. That's what is happening here, and that's called the soft delete option. Now the soft delete query. Let's look at the sample on my screen. Update users, set is deleted is equals to true where user ID is equals to 4. Now the next one, fetch only active records. So for that, let's look at a sample on my screen. Select star from users where is deleted is equals to false. Now why companies love soft delete? It is audit friendly, reversible, safer, analytics friendly. If you say soft delete strategy in interviews, it shows maturity. Now let's make a transition to part number 7, delete versus truncate. It's an important distinction. Many beginners confuse delete and truncate. So let's discuss this once. Let's start with delete. Delete can use where. It can be rolled back when used with transactions. It triggers logs. It's slower but safer. While truncate, on the other hand, deletes everything. It cannot use where clause. It cannot be rolled back. It's extremely fast and extremely dangerous. So let's have this rule of thumb. If you don't fully understand truncate, don't use it. With that, let's make a transition to part number 8 of this module, which is about best practices for data entry. It's the foundation of trusted analytics. Now, let's shift gears. Safe deletion protects your data. Good data entry prevents problems before they even exist. Bad data is more dangerous than missing data. So, the best practices. Number 1, always define data types correctly. Every column should reflect real-world meaning. Let's go for an example for bad design. Salary, worker 50. So you know this is a character data type and it doesn't make any sense. The correct way, salary is integer or salary float. Why this matters? Sorting works correctly, aggregations are accurate, performance improves, data validation becomes automatic. SQL data types are your first line of defense. Now, the second best practice, use constraints, not trust. Never trust users, applications, or APIs to send clean data. Use constraints. So the first one, primary key. Primary key is employee ID in our case. A foreign key, department ID, which can reference department ID from the other table. And for safe side, you can also keep another constraint which says not null. So whenever a null value is being trying to insert, it will not take it. It will definitely throw an error. Next one is name, worker 50, and it can also be not null. Unique value, which is email, worker 100, and it should be unique. And another few benefits of using constraints, it prevents duplicates, maintains relationships, stops bad data early. Good SQL developers design defensively. And with that, the next best practice, that is number 3, handle null values intentionally. Null is not bad. Unplanned null is bad. Ask these questions. Is null allowed? What does null mean in business terms? Should there be a default value? For example, department ID data type is int and null, meaning employee may not belong to any department. This is acceptable only if business allows it. Clarity beats assumptions. Now with that, the next best practice, number 4, insert only verified data. Before inserting data, validate the formats, check references, confirm business logic. Let's look at a sample on my screen. Insert into employees, employee ID, name, salary, department ID, hire date. Select 11, Kevin, 80,000, 2, 25, 12, 10. Where exists, select 1 from departments where department ID is equals to 2. This is a sample query on my screen. This ensures 2 things. Department exists and referential integrity remains intact. Now the best practice number 5, standardized data formats. Inconsistent data kills analytics. Bad HR, human resources are a good example for that. Now, good version of it. Single standardized value. Solution, use lookup tables, enforce values via foreign keys. Avoid free text whenever possible. Now, clean data is equals to reliable insights. Now, with that, we have best practice number 6, log changes for critical tables. In real systems, every insert, every update, every delete is logged. Why? Because audits, debugging, compliance, accountability. This is why data engineering and SQL governance matters. Now, you might be wondering why this chapter matters. Let's look at the summary. Let's close this with something important. Anyone can write SQL query. Anyone can join tables, but only responsible SQL professionals delete data safely, protect data integrity, design clean schemas, think long term. Companies don't trust databases to beginners. They trust them to people who respect data. If you master safe deletion and data entry best practices, you are no longer just learning SQL. You are learning how real systems survive. In the next module, we will move into joins and relationships using the same database to answer real business questions. Real-world data never lives in a single table. In real companies, employee names are in one table, department names are in another, orders are stored separately, revenue lives somewhere else. If you know how to query one table at a time, you don't know SQL. You know toy SQL. The moment SQL becomes powerful is when you learn joins. Because joins are how HR teams combine employees with different teams, finance teams combine orders with revenue, product teams combine users and behavior, analysts answer business questions, not just technical ones. This chapter is where SQL stops being syntax and starts becoming decision making. Why joins exist is your next question. Let's take a step back and understand why joins even exist. When databases are designed properly, data is normalized, redundancy is avoided, each table has a single responsibility. For example, employees table. Employees table only stores employee details. Department table stores only department names and other details related to department alone. We don't repeat department names inside employees. So, why is this done is your next question again. It is done for few reasons. One is data consistency, easier updates, better performance. But this creates a challenge. If data is split across tables, how do we see the full picture? Right? That's your question now. That's where joins come into the picture. A join tells SQL, combine rows from two or more tables based on a relationship. And that relationship is usually a primary key in one table, a foreign key from another. In our database, departments.department ID is the primary key from department and department ID from employees is the foreign key for employees data table. This is not accidental. This is an intentional design. What's the business analogy behind it? It's very important for learners. Think of joins like VLOOKUPs on steroids. But unlike Excel, joins scale to millions of rows. Joins preserve data integrity. Joins power dashboards, reports, and even AI systems. If select is asking a question, join is asking a smarter question. Now, let's go to MySQL Workbench to execute some of the queries on joins to understand them even more. So now we have discussed the theory part of module 5. Now we will be proceeding into the demo part. Here we are going to slow down things a little bit because joins are not about memorizing syntax. They're about understanding how rows from different tables come together and work together. Most SQL learners struggle with joins because they imagine tables merging physically, data being copied. That's not what happens. A join is a logical operation, not a physical one. So in this session, we will visualize tables row by row. We will see which row survives, which rows disappear, and why that is happening. By the end of this module, inner join will feel more obvious. Left and right join will stop being so confusing and full outer join will finally make some sense. And you will understand joins well enough to explain them to someone else. That's a real goal. Now, let's start with first query, employees with department names. Let's have a look on the query on my screen. So you can see, let me minimize this output window. So you can see we are starting with the demos of module 5 from here. To get access to the data table inside this particular database, we will be executing use interview, which is the schema name. And now we are on the first type of demonstration here, first query. So what is the first type of join are we executing? So the first join we are executing will be an inner join. But before we understand what exactly or technicality of this particular join, let's understand the problem that we are solving. So we have an employees table. We have another table, which is departments table. And we already know what are the columns. We have an employee table and department table. So now what is our end output for this particular query, or what's the business question? Employees store only department ID, not the department name. So the business question here is, show me employees along with their department names. This is a classic relational problem. So let's deal with this in a step-by-step way. Step 1, understanding the join condition. So the join condition here is specifically mentioned. Department ID from employee table with department ID from the department table. This line defines how rows are matched. It tells the database, take department ID from the employees, match it with the department ID of the departments table. Only rows where this condition is true will be joined. Remember, this condition is not filtering after the join. It is defining the join itself. That distinction is critical. Now, let's go into the step number 2. What inner join really means. Inner join means only keep the rows where the match exists on both sides. So, employee with a valid department is kept and employee with null department will be removed. So, remember the employee with no department in the employees table? So, that particular employee will not be considered here. Department with no employees will also be ignored. So we might be having certain departments in the department table with no employees. So that will also be ignored. Think of it as give me only the confirmed relationships, not any vague relationships. Row by row visualization. Imagine looping through employees. Alice is equals to department ID is equals to number 2. And engineering exists is equals to keep. Bob from department ID 2, which is engineering exists, so keep it. Charlie from department ID number 1 is from HR and it exists, so keep it. And lastly, Frank, the department ID is equals to null and no matches found, so that will be deleted. Frank completely disappears from the end result. That's how inner join behaves. Now, let's select the entire query and execute. So as we discussed, there are 2 different ways to execute. So let's go with the shortcut Control Enter to execute the command, or you can also go with this flash logo here. So you can have the output table right here. So the department or employee ID, employee name, his salary, and department name. Second one is Ivan from employee ID 9, salary and department name, which is HR, and so on. We have about a couple of entries here. So overall, where the department is not null and employee is not null, those particular specific columns have a relationship established successfully, and those will be combined or joined together, and we have an end output here. We can also name this as, instead of specific name, ID, salary, department, you can also keep star, where all the columns of both tables will be displayed all together. Let's try that for a homework. Now, from an interviewer's perspective, interview insight, if someone asks you, why is Frank's missing? Your answer should be, because we applied inner join. Inner join only returns rows where the join condition succeeds on both the tables. That shows clarity. Now let's move to the next query. So let me scroll down my query. And here we will be implementing left join. All employees without departments. So let's have a look at the query on my screen. So this is the one which we will be executing for left join. Key mindset that you should be having in your mind is, what exactly is left join? The left join means the left table is mandatory. The right table is optional. Whatever happens, every row from the employees must appear, even if there is no matching from the department table, which happens to be the second table. What changes did you find here compared to inner join? It is only one thing. Rows without a match are not removed here. Instead, missing columns become null. Let's have a visual walkthrough. Let's focus back on Frank again, where Frank did not have any department ID. It was basically null. So no department match, but left join always says keep him anyway. That's the main core difference between the left join and inner join. So now let's see the result. So before executing the query, let's find out how it may look like. So employee ID is equals to Frank's ID, name is equals to Frank, and salary is Frank's salary, and department will be null. It is intentional, null. It's not a bad data. Now, let's execute the query and see the output. So let me select the entire query and hit enter, and there you go. So we have Alice, Bob, Charlie, David, Eve, and here you can see we already have employee ID 6, Frank, Frank's salary, and Frank's department name is null, right? So even if the matches are not accurate, right, in terms of accuracy, even if there is no actual match between both the tables, but whatever the data we have in the left table, which is employees table, everything will be present. That's the major difference between inner join and left join. Now, even if this kind of data is existing, why companies or why professionals prefer left join is your question. Left join is used often when you want to complete coverage, when you want to detect missing relationships, you want to preserve the main data set. When you have these kind of intentions in your mind while executing query, then left join is the most preferable one. So what are the kind of examples you must be thinking when you are dealing with left joins? So all users, if they are never ordered, all products, even if they are not sold, all employees, if they are not even assigned to a dedicated group like Frank here, right? So these are the scenarios where you are forced to use left join. Now a quick interview tip, a powerful phrase. Left join preserves the left table cardinality. That's senior level language. Now let's go into the next query. So the next query will be based on right join. So let me highlight my query first. And now let's understand the technicality. So this particular query is based on all departments, even if no employees. Let's take a look at the query on my screen. So conceptual identity to the left join. Right join is just the left join from an opposite direction. Previously, we focused solely on the left table. Now we will solely focus on the right table. Now departments are very mandatory. Employees are optional. In the previous one, employees were mandatory and departments were optional. Now this is the opposite side. What row survives will be your question. Departments with employees and matched rows will appear, and also departments with no employees will also appear. But anyways, employees without departments is a little bit irrelevant here, but for the concern of understanding, let's keep it that way. Now let's execute the query to understand the output. Now there you go, we have all the departments and their employees together. We have HR and the name of employee is Charlie. We have Ivan from HR, and we have Alice, Bob and David from engineering, Heidi, Eve from finance, Grace from marketing and Judy from marketing. Now let's understand one more thing. Why right join is rarely used? Most developers prefer left join, reorder table instead of using right join. So this query could be written as from departments D, left join, employees E, right? This is also a perfect logic. Same logic actually, more readable. Now for that, let's have a small teaching insight. Right join is important to understand, but not commonly used in production code. Now let's dive into the fourth query, which is about a simulated full outer join. So why simulated, you ask? Because there is nothing called full outer join, but we can still have a simulation of it by including the union in our code. So you can see I have highlighted the code and we have a union command here where we will combine both the tables together. So now why are we doing this? Some databases do not support full outer join, or learners want to understand how it works internally. So for that, we have a query highlighted right on my screen. We'll simulate it. But before that, what full outer join means conceptually? Give me everything, right? This particular data extractions include matched rows, left only rows and right only rows. Basically what we are trying to do is we are combining inner join, left join and right join, basically extracting whatever is present inside both the tables. Nothing is lost. And now you might be having a question. Why did we use union here? Left join keeps all the employees from left, right join keeps all the employees from right, basically employees and departments. And what is the purpose of union is union combines both and removes any duplicates present in both the tables. So what's the result? Full coverage from both sides. Now let's execute this query and see the output. So there you go, we have all the names of the employees and their specific departments, similar to the previous query. So we have Frank without department name and all the other employees with their dedicated department names right here. Now what's the important learning moment? This query teaches join logic, set operations, result set thinking. This is advanced understanding, not beginner syntax. Now let's move with a few example queries. So first one, I want to identify orders with user email, and we could go with an inner join here. So let me select the entire query. Now let's understand the flow of this particular query. So take a look on my query at my screen. Business story orders store, and we have customer ID, not customer email. User store, and we have email, not every other details on that, right? Now we want to join to enrich the order data. Why inner join? Because inner join makes sense here. An order must belong to a user. So orders without users is invalid. Inner join enforces data integrity logically. So before we move further, let's execute this command and see the output. So we have order ID, email ID and order date as per our requirement. Now, what's the real world relevance? This is how dashboards, invoices, analytics queries are built. Almost every real system uses this pattern. Now, let's go with the next query where we will try to find out revenue per order date. And we will be using an aggregate function here. So let's take a look at the query on my screen. So shift in thinking. We are no longer looking at rows. We are looking at groups of data. Group by in my query changes everything. how group by works conceptually, and everything else. Now, let's look at the database steps. First, we will scan all the rows, then group by order table, plus we will also be applying an aggregate function for the group, and then we will return one row per group. So, let's quickly execute this query and see the output. There you go. We have order date, total number of transactions, and total revenue all in one shot here. So why count and sum work here? Because count of number of rows per date, and sum adds revenue per date. This is basically time series analysis, and it is extremely common. Now a quick interview insight for you. Group by reduces number of rows, join expands number of rows. Remember that contrast. Now we have query number 7, which is about employees with highest salaries, and here we will be using two things. First is a join function, and next is a filter function. Now let's take a look on the query. So here we have employees with highest salaries, and this is my query. So what we are basically trying to do is we are combining both the tables, which is employee table and departments table, and our concern is to find out any employee whose salary is more than 90,000. So that's the overall observation on this particular question or business question. So what's the execution order? Coming to execution order, one of the most important and commonly asked question in SQL interviews is the execution order of the commands. So far, we have seen through all the basic fundamentals of SQL commands, right? The keywords basically select, join, and all those things. So let's consider this as a homework. Let us know in the comment section below what is the execution order of all these keywords in SQL. Now, for a quick clue, let's see the flow of execution for this particular query. So what happens is, first, join is the one which activates. It joins both the tables. Then, where comes into the picture? It filters the rows. And then comes selects, which formats the output. And this order matters. Let's quickly execute this query and see the output. So there you go. We have Bob, David, Eve, Heidi, who have salaries greater than 90,000, and their dedicated departments are engineering, finance. So these three employees are from engineering department, and we already discussed this, right? Engineering department is the one which is paying highest number of salaries. So we have three from engineering itself, and the next one is finance. Now, why, where is executing after join? This is your question, right? We are filtering employees, not departments. If we filtered earlier, we might lose the relationship context. Now, let's have a quick practical takeaway. Join defines relationships, where defines conditions. Never confuse with both of these. Now we have the query number 8, where we will find out departments with no employees at all. Now, let's take a quick look on the query on my screen. So this is my query. I want to select the department name from departments B, and I want to apply left join, and I'm joining this with employees on the category of department ID, and where employee ID is null. This is a classic interview query, and it tests deep join understanding. What's happening is, in a step-by-step way, left join keeps all the entries from the departments table, where employee ID is equals to null, and it keeps only rows where no employee is matched. So the result, let's execute this to find the result. So there you go. Departments with 0 employees. Why inner join can't solve this? Inner join removes non-matching entries. Left join plus null, check, reveals them. This is powerful logic. Now we move into the 9th query, customers with multiple orders. So let's take a quick look on the query. Now this is a multi-layer query, and it combines a lot of things. For example, join, group by, and having. This is real world SQL. Why having is used instead of where could be one question in your mind, because where filters rows and having filters groups. This you need to understand. This is one golden rule which you always need to keep in your mind. Now let's discuss the execution logic. Join users and orders. Join is used to combine users and orders. Group by to group or categorize email. Count is used to count the number of orders per user. And lastly, having keeps only the users with order numbers greater than 2. Now, let's execute this query. So we have the output here. We have Alice and Bob with total orders 4 each. That's the output. Now, what's the business meaning? This query finds out the loyal customers, high engagement users, retention targets. Exactly what analytics teams do on a daily basis. Now this is a final wrap up for joins. If you understand this module deeply, joins are no longer scary. Nulls make sense. Aggregations feel logical. Interview questions become more predictable. You didn't just learn the syntax, you learned how databases combine data, how SQL thinks, how real systems are queried. That's professional level SQL. And with that, we make a transition to the next module. Now, repeat. Now we have reached to the module number 6, which is about grouping and aggregating data in SQL. So here we will be dealing with group by, having aggregation functions, and filtering group results. Now, let's have a quick introduction to this. Why this chapter or this module matters the most. Up until now, everything we have done in SQL has focused on individual rows. We used to select rows, filter rows, sorted rows, and we used to join some rows. But here's the reality of how SQL is used in the real world. Businesses almost never ask that, show me every row in the table. Instead, they ask, how many employees do we have per department? What is the average salary? Which days generate the highest revenue? Who are most active customers or the most loyal customers? These are summary questions. And the moment SQL moves from showing rows to answering summary questions, you made a huge transition. We enter the world of group by and aggregation. So far, you had a basic introduction to these functions. This chapter is where SQL stops being data relevant and starts becoming data analysis. If joins helped us connect data, group by helps us understand patterns inside the data. Now let's go with the part 1. What group by actually does. Let's build the intuition first. SQL looks at each row independently, but when you use group by, SQL changes how it thinks. Instead of processing row by row, SQL tries to process in a different way. It tries to group rows that share the same value, applies calculations to each group, returns one row per group. So you are no longer working at row level, you're working at a group level. Think of group by as a machine that takes many rows, bundles them into logical buckets, and produces summarized information. This is the foundation of reports, dashboards, KPIs, analytics, and business intelligence. Now let's go to the part 2. First, group by, simple and clear. This could be our first query here. Now let's go through the sample query on my screen. So here we have department ID and we're trying to count the number of employees per department, and we will be aliasing it as total employees. And we are selecting this data from employees and we are trying to group it by department ID. Now, what we want to know is the question. So it is basic and simple. We want to know how many employees are there per each department. Instead of listing employees one by one, we try to group them, and once we group them, we will try to count them and then execute the query. So let's execute this query and see the output. So basically we have 5 departments here. One department is not assigned, so that particular one is based on Frank that we earlier executed. So let's take a pause and understand what SQL is doing here. It is scanning the employees table, grouping rows by department ID, counts the total number of employees inside each group. Every department becomes one row in the result. Now, one important observation that you need to have here is employees with null department form a separate group altogether. This is real world behavior. Missing data doesn't disappear. Now let's make a transition to part 3, where we try to group by with join, making output business friendly. IDs are useful for databases, but people don't think in IDs. They think in names. So let's improve this query by using a join function. So let's quickly go to Workbench and see the code on my screen. So previously we had no names to the department, right? Now to make it more sensible, we are trying to combine employees table with the departments table, because departments table has the name of the department, right? The null 1, 2, 3, 4 doesn't make sense. So it could make a lot sense when we had an actual department name. So for this, let's execute this particular query, and you already know how the left join works and on what basis did this particular employee table establish a join with employees table, right? So here we have department ID from employees table, and here we have department ID from departments table. Based on the match and the type of join that we are using is left join, what it does is it keeps all the entries from the left table, which is the department or employees table, and the matching elements from the right table, which is a departments table, right? So employees is the left and departments is the right. Now we will be grouping by department name. So let's execute this query, and there you go. We have HR, engineering, finance, and the null department, and the total number of employees working in each department. Now we join employees with departments. We grouped by department name. We made the output more readable for leadership. This is how SQL is used in HR reports, management dashboards, workforce planning, and a lot more. Now, one very important learning from this part is joins usually happen before group by. Now, let's make a transition to part 4, which is slightly tricky group by, and we will be using multiple columns here. Now, let's raise the difficulty slightly. Suppose the business asks you this: how many employees were hired per department per day? This means we group on more than one column. So let's execute the code right on my screen. So if I scroll down, here we have another slightly tricky query. So here we are trying to select the department ID, hire date, and we are counting the number of employees based on the column employee ID, and we are aliasing it as hire count, and we are extracting this data from employees table. And here we are grouping by multiple elements. One is department ID and another is hire date. You might be wondering, will this work? Group by was designed to take multiple entries here, so this totally works. Now let's execute this query and see the output. So we have a department ID and hire date. So based on these dates, we have the total number of recruits that we had on that particular date. Now what's happening here? SQL creates groups using both columns together. Each unique combination becomes one group. This increases the number of results per row. The key rule to emphasize clearly is any column in select that is not aggregated must appear in group by. This rule appears frequently in interviews. Now, let's move to the next part of this module, which is about aggregation functions. So it's a quick deep dive. Now that group by makes sense, let's talk about aggregation functions. These are functions that operate on groups, not individual rows. Now we have a few of them. So let's get started with count function. It is basically used for measuring volume. Let's start with count. You can see a sample query on my screen. So let's go to the workbench once. So here what are we trying to do is we're trying to count the total number of employees from the employees table, right? And we will be aliasing it as the total employees. What this basically does is it counts all the rows. Now with grouping, back to my screen. So let's execute this and we have about total employees. Now about grouping, we have the query right on my screen here. So what we're basically trying to do is we are basically trying to group the total number of employees per each department. So we are adding the department ID and counting the number of employees in there. So let's execute this query. There you go. So count of column ignores all the nulls. Count of star counts total number of rows regardless of how many entries we have. Count answers questions like how many, how frequent, how active. Now with that, we have the next aggregate function, which is a sum function measuring total value. Sum is used for totals. Let's see a code. So here we have select sum of salary as total salary from employees table. Let's execute this and we have about 8,70,000. Now let's make it a little more meaningful. Explain the business context, budget allocation, cost control, department-wise spending, right? These will be the business level questions. If you categorize by departments, then you will have a clear answer on the budget allocated for each department. Next aggregate function is based on average, typically measuring some values such as average salary per department. So let's execute the code. So we also have another query on sum. So let's execute this as well. So once executed, you will have, this is the amount of salary or budget allocated to each department. Now let's go with the average function again as discussed. So here we want to find out the average salary allocated per employee in each department, which is similar to the previous query. So let's execute this and we will have the answer. So the average salary allocated per each department is, for HR we have 60,000, for engineering we have 1,08,750, for finance we have 95,000, and for marketing 80,000. So this is the average salary which we have allocated for each and every department. Now the next aggregate functions are minimum and maximum, and it is finding the extremes. So let's go for an example, and the business use cases are salary bands, compensation gaps, identifying anomalies, and a lot more. So here we have the department name. So minimum salary as lowest salary per department, maximum salary is the highest salary per department, and we're extracting this from employees table. And since we need the department name, we are joining this with departments table D, and based on the column department ID, and we are grouping by department name. So let's quickly execute this query, and there we have the lowest and highest salaries of each department: HR, engineering, finance, and marketing. So the lowest salary in HR is 50, highest is 70, engineering is 90, and 12 or 1,20,000, and 95,000 for finance, and 95 is the highest as well. Marketing, we have 75 as the low and 85 as the highest. Now let's make a transition to the part 6 of this module, aggregations with dates, transaction data. Now let's switch tables and think like analysts, like orders per day. Now let's go through the query here. So this is one query that highlights the number of orders per day. Let's execute this. So we have about so many orders, and a few dates are where we had multiple orders, and we also have few dates where we have about a single order per day. And let's go through the next query that we had, which is revenue per day. So this particular query is based on revenue per day. Let's execute this, and we have 25.6 as the highest revenue which we earned, which is December 6th, 2025. So this is how daily KPIs are built. These queries sit behind dashboards. Time-based aggregation is extremely common. Now with that, let's make a transition to part 7 of this module, which is about having clause, filtering groups, and it is really critical. Now we address one of the most misunderstood concepts of SQL, where filters rows, having filters groups. You cannot use aggregation functions inside where. I guess this is the second time I'm repeating this because this is really important, and most of the times we confuse with this. This is why having exists, and basic having examples are the following: departments with more than 2 employees. And for executing this command, let's take a quick look on the screen. So here we have the query. Select department ID, count the total number of employees as department's employee count from employees table, and group by department ID, having count of employees greater than 2. So let's execute this, and we have that one particular department where we have about 4 employees. I think it is engineering department. Now let's also discuss the execution order once again, so that you have a quick understanding of how the execution order really works in SQL, and it could be helpful for your homework that we had in our previous model. Group by runs first, aggregation happens next, having filters the result, and having with join. And for this, let's go with an example. Right here, we will be combining both having with join. So here we are trying to have this particular business question: which departments are highest paying? So here we have a department name, average salary, and employee, and we are trying to find out the employees with paycheck more than the average paycheck of every employee. So engineering and finance are those two teams which are paying more than the average salary. So we have our final answer. So those two departments which are having the highest salary, right? Tricky, having multiple conditions. So is our next repeat. Now moving next is another tricky question, and this particular one is based on having multiple conditions. So let's go back to the MySQL workbench and have a look at the query. So multiple conditions is right here: having count more than 2, and the average salary should be more than 80,000, right? So let's execute this query. The only difference is we are trying to have the average salary should be more than 80. So engineering team is the one which has employee count as 4, and average salary is 1,08,750. So having can use multiple aggregations. This is advanced interview level question from SQL, so you can make a note of it. Now moving further, we have part 8 of this module, filtering grouped results, where we have where along with having together. This is where learners truly level up. Now let's have a small business requirement. Show average salary per department for employees hired after November 2025, but only include departments where the average salary is above 85,000. So let's take a quick look on the code. So this is the code that we will be executing. So we have put the hire date, which is November 1st, 2025. We're trying to group by department, and the same query condition, which is salary should be more than 85,000. So let's quickly execute this query. So we have 2 departments in that way, engineering and finance, where we recruited employees after November 2025, and the salary is above 85,000. Now let's look at the execution order. From executes first, then join, followed by that we have where, then group by will be executed, followed by that we have having clause, then we will select, and lastly we will order by. This is core analytical SQL thinking. Now, let's move to the part 9 of this module, which is a capstone query, and this could be real dashboard logic. Let's end this with a realistic analysis query. Back to the workbench. So here we have the query. So here what we are trying to do is we are trying to group by order date, and we should be having some amount greater than 800, and total revenue should be in descending order. We are trying to find out those particular columns, which is order date, count total sales, sum of total revenue, and average order. So let's execute this query, and we have the output over here. Now let's understand this. Multiple aggregations are done together. Filtering is done using having clause. We have sorted the results, and this query could power a business dashboard. Now let's also discuss some of the common mistakes that learners should be warned about. Now let's discuss some of the common mistakes that learners make and we should be alert about. So the first one is about forgetting group by columns using where instead of having, mixing row level and group level logic, ignoring null behavior, aggregating without the business context. Now, why this chapter was a turning point? At this stage, learners cross an important milestone. If you have understood group by, aggregation functions, having clause, where clause, filtering group data, then you're no longer just querying data, you're analyzing data. This is the skill that powers dashboards, drives decisions, gets tested in interviews, separates beginners from professionals. In the next chapter, we will build on this foundation with advanced analytics concepts, including window functions and ranking. Now we enter the module 7, which is about subqueries and nested queries in SQL. So it could be single row, multi-row, correlated subqueries, plus usage in select, from, and where. Now let's have a quick introduction to why subqueries matter so much. So far in SQL, we've been answering direct questions. Some questions like, show me the roll number of employees, show me departments, show me total revenue per day. But real business questions are rarely simple. Businesses ask questions like employees who can earn more than the company's average, departments with higher than average salaries, customers who place more orders than most of the other users, sales days that outperform the overall trend. Notice something important. These questions depend on the result of another query. And that's exactly why subqueries exist. A subquery allows one SQL query to depend upon the result of another SQL query. This chapter is where SQL becomes logical and layered, not just procedural. Now, part 1 of this particular module, what exactly is a subquery? So, let's define it. Subquery is a query inside another query. It runs first, produces a result, and that result is used by another outer query. Think of subqueries as asking a question, using the answer to ask a better question. In interviews, this is often described as SQL inside SQL. Simple visual example can be understood in this way. Inner query calculates something, and outer query uses that calculation to provide some better answer. SQL reads subqueries inside out, not top to bottom. This mental shift is really critical. Now, let's go through some examples. So this brings us to part 2, single row subqueries. What is a single row subquery, you ask? A single row subquery returns exactly one value used with operations like equals to, greater than, less than, greater than or equals to, less than or equals to. Let's take an example on my screen. So employees earning more than the average salary. So let's find the average salary first. Let's look at the code on my screen. So here we are trying to find out the average salary of the overall employees table. So the average salary is 87,000. Now instead of hard coding this value, we will nest it, right? So here we want to find out the employee ID, name of the employee, and salary from employees table, where salary is more than the average salary. So here we are ingesting this particular subquery that we recently executed, right? So this happens to be the single line subquery that we are discussing as of now. So this particular single line subquery will be ingested inside the outer query. So this happens to be the inner query, and this happens to be the outer query. Now let's run this. There you go. So we have about 1, 2, 3, 4, 5 employees who earn more than the average salary of other employees. So let's take a pause and understand what's happening here. Inner query calculates company's average salary. Outer query performs and filters employees above the average salary range. Important business interpretation to understand here. Who are our top earners compared to the organization? This is a classic interview question. Now, let's take another example. employees earning more than the maximum salary in a specific department, let's say HR. Now, let's take an example on my screen. So here we have a subquery which is select maximum salary from employees where department ID is equals to 1. So the department ID 1 is none other than the HR department. So we are encapsulating this particular inner subquery onto the outer subquery, which is trying to select the name, salary from the employees table, right? And where salary is greater than a number which is the result of this particular subquery, which is the maximum salary of employees. Now, let's execute this query. Control Enter, and there you go. Now, let's take a pause and understand how is this working. The inner query returns the maximum value of salary from HR department, and the outer query compares every employee against it. This shows targeted comparison logic. Now, let's make a transition to part 3 where we will have multi-row subqueries. So, what is a multi-row subquery? A multi-row subquery returns more than one row. It is most commonly used with operators like in, any, all. So for this, to understand in a better way, let's take an example. And the example question is, employees in departments with average salary greater than 90,000. So first, let's identify all the departments. For that, let's take a look on my screen. So let me quickly write a small query. Star from departments. So we have 1, 2, 3, 4 departments: engineering, HR, finance, and marketing. Now we need to execute this particular subquery where we are trying to find out department ID and employees and department having salary more than 90,000. Now let's execute this. So we have department IDs 2 and 3 where they have greater higher salary or the average salary. Now we need to use this particular query inside another external query. So this is the outer query, this particular section, and this was the subquery that we just executed. Now we need to encapsulate this particular subquery inside the outer query, and now let's execute this. So we have the name of the employee, their salary, and their department ID. So as discussed in the first subquery, these are the employee or department IDs and their relevant employees. Now let's understand this clearly. Inner query returns multiple department IDs and outer query filters employees belonging to those departments. Now the business question answered here is, which employees work in higher paying departments? So that's what the answer we gave. Now let's take another example. So the example 2 is, we want to find out customers who placed more orders than the average. Now let's execute this particular query. So there you go. These are the customer and their IDs 1 and 2, and they have placed orders 3 and 4. These are the most loyal customers. Now let's understand the working of this particular code segment. Customers who placed more orders than average. Now let's understand this carefully. Inner subquery calculates order counts per customer. Next level calculates average order count. Outer query filters high activity customers. This is advanced analytical SQL, not beginner stuff. Now let's make a transition to part 4, which is about correlated subqueries and most important concept. Now, what is a correlated subquery? A correlated subquery depends on the outer query and it executes once per row and cannot run independently. Think of it as, for each row, run a subquery that depends on that particular row. This is where SQL starts to feel like programming. For that, let's take an example. So this is the particular example we are going to execute. The question here was, employees earning more than their department's average. Now let's understand this particular example. Outer query processes each employee. Inner query recalculates average salary for that particular employee's department. Now the comparison happens row by row. Now the business interpretation. Who are the top performers inside each department? This is one of the most frequently asked SQL interview questions. Now let's consider another example. Orders that occurred after customer's first order. For that, let's take a quick look on the code on my screen. So here it is. We are using two different queries, the outer query and the inner query. So the inner query is where we selected minimum orders and customer ID is equals to customer ID from orders table. and we are joining, or we are applying self join here, basically combining the orders table with itself. Now let's execute this query. There you go. Now let's understand this. For each order, we find the customer's first order. We keep only the later orders. This helps to analyze repeated behavior. Now, what is used here? We use this in retention analysis, funnel tracking, behavioral analytics. Now with that, let's make a transition to part 5. Part 5 is about subqueries in where clause. So it is a basic recap plus best use. This is the most common place where subqueries are used. Let's take an example. So here the business query is sales on high revenue days. Let's understand this. Inner query identifies high revenue days. Outer query fetches detailed sale rows. This pattern is used constantly in analytics. Now let's execute this query. So there you go. We have the answer. So we have two different entries, sale ID 8 and 9, and the amount was 400, 50 and 600. Now let's make a transition to part 6 of this module. So part 6 is about subqueries in SQL clause and will have calculated columns. Subqueries can act like dynamic columns. So let's take an example. So this is our example here. Let's execute this. So we have the output. We have name of the employee, salary, company's average salary, and difference from average. Now let's understand what did we execute here. Salary compared to company's average. The inner query runs once, adds context to every row, makes reports more meaningful. Now it's great for dashboards and exports. So here what we did is we find out the salary of the employee and company's average and what's the difference, right? The difference amount that they are earning more than the average salary. Now this drives us to part number 7 of this module, which is about subqueries in from clause, or also known as the derived tables. Subqueries from act like temporary tables. For example, department-wise salary summary. Let's take a look at the example on my screen. So this is the code that we will be executing, and here we have the output. Now let's understand what is the logic that we implemented here. The inner query creates a derived table, outer query filters it, and this improves readability for complex logic. This is a stepping stone to CTEs and window functions. Now let's move to part 8. So part 8 is about when to use subqueries versus joins. Now one important discussion. Now with that, we make a transition to module 8, which is about the difference, right? When to use subqueries and when to use joins. Use subqueries when logic is layered. Aggregation is needed first. Readability improves. And when to use joins? Joins are used when data relationships are direct, performance matters most, data volume is really large, and professionals choose clarity and performance. Now let's also go through some of the common mistakes to warn learners about. So using equals to instead of in, expecting multi-row subqueries to return one value, forgetting correlation logic, overusing subqueries where joins are better, and the last one, ignoring performance implications. Now why this chapter was a milestone? If joins taught SQL how tables relate, subqueries teach SQL how logics relate. Once you understand single row subqueries, multi-row subqueries, correlated subqueries, subqueries in SQL, from and where clauses, you can answer almost any analytical question in SQL. This chapter is a bridge from intermediate SQL to advanced SQL to interviews to real production analytics. In the next chapter, we will take this logic and supercharge it using window functions and ranking, which solve many problems more efficiently. Now we transition into module 8, which is about data modeling and relationships. So primary keys, foreign keys, relationships, ER diagrams, and normalization are the topics discussed in this particular module. Now let's have a quick introduction. Why this module defines your SQL maturity. Before we begin this chapter, I want you to pause for a moment. Up to this point in the course, you've been learning how to talk to a database, how to select data, how to filter it, how to join tables, how to aggregate results. That's important. Okay, this chapter answers a deeper question. Why does a database look the way it does in the first place? This chapter is not about writing queries. This chapter is about thinking like a database designer. And here's a reality check that most tutorials won't tell you. In real world, SQL queries are easy to learn. Poor data modeling destroys companies. Most production bugs are data design bugs. Most analytical errors come from bad relationships. If data modeling is weak, joins become confusing, data becomes inconsistent, reports contradict each other, performance drops, and most importantly, trust in data disappears. This is why senior designers, architects, and analytical leaders care deeply about data modeling. This chapter will help you understand how professional systems are designed, read any database schema with confidence, answer system design interview questions, avoid beginner level modeling mistakes, build databases that scale logically, not just technically. Think of this chapter as the architecture class of SQL. Now, let's start with part 1. What is data modeling? Now, thinking before coding is nothing but data modeling. Let's start with the foundation. So, what do you mean by data modeling? Data modeling is the process of identifying entities, defining their attributes, establishing relationships, enforcing rules and constraints. In plain language, data modeling is deciding how information is structured, stored, and connected before data even exists. A good data model answers what are core subjects of this system, what information belongs to each object, how do objects relate to each other, what rules should never be broken. Now let's go through a real world analogy to understand this better. Imagine you're designing a hospital data system. You don't start by randomly creating tables. First, you think. You think about patient's data table, doctor's data table, appointments table, departments table, prescriptions table, bills table. Then you start asking questions. Can a patient have multiple doctors? Can a doctor treat multiple patients? Does an appointment exist without a patient? This type of thinking is nothing but data modeling. SQL syntax comes later in the picture. Why data modeling comes first is because of some reasons. First, many beginners jump directly into creating tables. Start inserting data, worry about queries later. Now, let's discuss this in terms of professionals. Professionals design the data model first, validate relationships next, anticipate growth in the future, and prevent any type of inconsistency. Data modeling is about future-proofing your dataset. Now, this makes our transition to the part 2 of this module, primary keys, the primary identity of any data. Let's talk about the most fundamental concept in relational databases. What is a primary key, you ask? A primary key is a combination or a column of columns that uniquely identifies each row in a table. Every record must have one identity, one unambiguous reference. In simple terms, a primary key answers one question. How do I uniquely point to this exact row? Now, why primary keys exist? This is one particular and critical insight. Imagine a table without a primary key. You have two customers with the same name, same city, and same phone number as well. Now you ask yourself, which row do I update? Which one do I delete? Which one does a specific order belong to? Now your answer. Without a primary key, data becomes unreliable. That's the answer. That's why we do have a primary key. It's like an identity for your data entry. Let's understand through a real world analogy. For example, government identity. Your name can change, your address can change, your phone number can change. But the passport number, the Aadhaar number, social security number, which will not change. This uniquely identifies you. That's exactly what a primary key does for a row. Now, let's discuss the characteristics of a strong primary key. A good primary key should be unique, no duplicates ever, it should not be null, its identity cannot be missing. Third one is it should be stable, should not change over time. And next one is it should be minimal, prefer single column keys. Now, let's understand one difference between natural keys and surrogate keys is very important. Natural key comes from business data. Example, email, username, PAN number, etc. Now, what are the problems here? So the problems are this can change, this can be duplicated, it can be tied to business rules. Now, let's understand the surrogate key. Surrogate keys are artificially generated ones. For example, auto increment ID. What are the benefits of using surrogate? They are simple, stable, and efficient for joins. Most modern systems use surrogate keys to enforce uniqueness separately. Now, a quick interview tip. Should email be a primary key? A most mature answer is email can be unique, but emails can change. Better as a unique constraint, not as a primary key. Now, we make transition to the part 3 of this module, foreign keys which are connecting the data world. Now comes the concept that makes SQL relational. So what is a foreign key? Foreign key is a column in one table that references the primary key of another table. In simple terms, a foreign key relates a relationship between tables. Why foreign keys exist? Now the next question is, why foreign keys exist? Instead of duplicating data, department name, customer details, product information, we store it once, reference it everywhere. This ensures consistency, reduced storage, cleaner updates. Now let's understand through a real world analogy. Booking a flight. A ticket references to passenger ID, flight ID. The ticket does not store passenger name repeatedly, aircraft details repeatedly. Foreign keys keep systems normalized and scalable. Now let's go through referential integrity, a non-negotiable rule. Foreign keys enforce you cannot reference a record that doesn't exist. You cannot delete a parent if children depend on it. This protects the database from orphan records, broken relationships, logical corruption. The next one is on delete and on update. These are business decisions. When a parent row changes, should child rows get deleted? Should they get updated? Should the action be blocked? Now to understand this, consider these examples. Deleting a customer with orders, usually it is restricted. Deleting a draft record, cascade is allowed. These are domain decisions, not just SQL syntax. Now let's make a transition to part 4 of this module, relationship types, how data connects. Understanding relationships is the heart of modeling. We have a wide variety of relationship types. Let's start with one-to-one relationship. One record in table A maps to another record in table B. For example, user data table to profile data table, employee data table to ID card data table, person data table to passport data table. Now the next question is, when should you use one-to-one relationship? It is rarely but intentionally used when sensitive data needs separation, optional data exists, performance optimization is required. Now let's consider an example. Authentication data separated from user profile. Now the next type of relationship is one to many or one to n. This kind of relationship is most common. One record in table A maps to many records in table B. Examples, customer table to orders table, department table to employees table, user table to post table. This is the default relationship in relational databases. What's the implementation rule? The foreign key always sits on the many side. This rule alone clears 70% of beginner confusion. The next one is many-to-many relationship or M is to N relationship. Many records in table A relate to many records in table B. Some of the examples are students table to courses table, products table to orders table, movies table to actors table. Now, junction table concept. Relational databases resolve M to N using a third-party table, two foreign keys, optional extra attributes. This table often stores timestamps, quantities, status, grades, etc. With that, we make a transition to part 5, which is about ER diagrams. It is basically about thinking visually. An ER diagram is a visual blueprint of a database. It shows tables, columns, primary keys, foreign keys, and relationships. Now, why ER diagrams matter in the real world? Before code, architects use or draw ER diagrams. Teams review them. Business rules are validated. ER diagrams prevent rework, confusion, costly redesigns. How interviewers use ER diagrams could be a question. So they want to see logical thinking, relationship clarity, normalization awareness. You don't need fancy symbols. Clarity matters more. With that, we make a transition to part 6 of this module, normalization, which is about keeping the data clean. Now with that, we make a transition to part 6 of this module, which is about normalization and keeping the data clean. Now, let's talk about one of the most misunderstood topics. What is normalization? Normalization is organizing data to minimize redundancy and dependency. In simple words, avoid duplicate data, avoid inconsistent updates, protect data integrity. Now, why normalization exists? Without normalization, same data stored in multiple places, updates miss same rows, reports contradict each other, and the data trust collapses. Now we have a few different types of normalizations. So the first one is 1F or the first normal. It is about atomic values and no repeating groups. Now a bad format will be phone 1, phone 2, and phone 3. And a good separate flow table is the best example for this. Now we have this second normal form, which is 2NF, and the rules are: in 1NF, no partial dependency, and it applies mainly to composite primary keys. Now we have the third normal form, which is also known as the 3NF, and the rules are: in 2NF, no transitive dependency, meaning non-key attributes depend only on the primary key. Now let's understand the difference between normalization versus denormalization, which is a real-world trade-off. OLTP systems, highly normalized, write consistency matters. Analytics systems, often denormalized, read performance matters. And professionals choose intentionally, not blindly. And with that, we make a transition to part 7 of this module, which is about real-world case study on e-commerce modeling. Let's design a simple e-commerce system verbally. So we have the following entities. We will be having users, products, orders, order items, and payments. Now let's discuss the relationships. Users are connected to orders in 1 to n, and orders are connected to order items, which is also 1 to n. And the last one is product to order items, which is also 1 to n. No direct order to product, which is m to n, resolved via order items. This is real world modeling in action. Now let's make a transition to part 8, which is about common beginner mistakes. Let's quickly cover some mistakes professionals avoid. So some of the mistakes are using names as primary keys, storing repeated values, missing foreign keys, over-normalizing early, ignoring future growth. Avoid these mistakes and you already think like a pro. Now we enter the part 9 of this module, which is about interview mindset and how to answer design questions. Interviewers want thought process, trade-off awareness, business understanding. Always explain why you choose a structure, why you rejected alternatives, how it scales. Now, a simple summary. Why this chapter changes everything. This chapter transforms how you see databases. You no longer memorize syntax, fear joins, or guess relationships. You now understand structure, design confidently, think long term. This is the difference between a SQL user and a data professional. So now we have entered module 9, which is about indexing and performance tuning. This module will help us understand why indexes matter, creating and using indexes, and query optimization tips. Now, let's have a quick introduction. Why performance is a career skill. Before we talk about indexes, let me tell you something very important. Most SQL learners stop at select, where, join, group by commands. But professionals are judged on performance. In real companies, no one praises a query that works. They praise a query that works fast. They praise a query that works at a scale. And here's the truth. Performance problems don't show up in small datasets. They show up in production. This chapter is all about why some queries are fast, why others slow down as data grows, and how databases search data internally, how indexes change the game completely. If you understand this module, you'll write scalable queries, you'll pass performance-based interviews, you'll avoid production outages, you'll sound like someone with real experience. This is not about memorization. This is about how databases link. Now the part 1 of this module. Why indexes matter, how databases find data. So let's start with a simple question. How does a database find data? Imagine a table with 10 rows. It could be fast. And if you have 10,000 rows, maybe your query is manageable. 10 million rows, already you might be thinking your query could be slower. And in case if you had a billion rows, it's a complete disaster. So without indexes, this could become a reality. Now, without an index, the database performs a full table scan, meaning it checks every row one by one until it finds what you asked for. That's like searching for a name in a phone book without an index, reading every page from start to the end. Now, a real-world analogy. Book index versus page-by-page reading. Think of a textbook. If you want to find out a normalization topic, you don't have to read every page. You go through the index, find the page number, jump directly, and that's exactly what a database index does. Now, what is an index? An index is a separate data structure that stores column values in sorted order without pointers to the actual rows. In simple terms, an index is a shortcut for finding data quickly. Why indexes improve performance is your question, right? Indexes reduce disk input-output operations, CPU usage, query execution time. It is especially for where conditions, join conditions, order by conditions, or clauses and group by clauses. Now, important reality check indexes. They speed up reads, slow down writes, every insert, update, delete commands must also update indexes. So indexes are not free. This is why indexing is a design decision, not a default action. Now, with that, we make a transition to the part 2 of this module, which is about how indexes work internally. Now, you don't need to be a database engineer, but you must understand the intuition. Most databases use B tree or B plus tree structures. Conceptually, data is stored in sorted blocks. Each block points to a child block. Searches are logarithmic, not linear. This means searching 1 million rows is almost equal to a few steps. Searching 1 billion rows is also still manageable. Without indexes, search time grows linearly, performance collapses at a scale. Now, let's understand the difference between clustered and non-clustered index. First, clustered index. It defines physical order of data. Table can have only one and it is often a primary key. Now, non-clustered index. It separates structure. Multiple clustered indexes are allowed. Points back to table rows. You don't need to memorize this just now. You just understand. Some indexes control how data is stored. Others act as lookup maps. And with that, we make a transition to part 3 of this module, which is about creating and using indexes. Now, let's talk about practical usage. Basic index creation. Indexes are created on columns that are frequently searched, frequently joined, frequently filtered. Now, some of the examples are like user ID, order ID, email address, and other foreign keys. When should you create an index could be your next question. You should create indexes when table size is large, queries use where on that column, and joins happen frequently, and sorting is very common. And the next topic is about selectivity, which is a key performance concept. High selectivity column has many unique values. For example, email, user ID, and low selectivity are few unique values. For example, gender, status, active or inactive. Now, indexes work best on high selectivity columns. Composite indexes sometimes queries filter on multiple columns as well. For example, a department ID is equals to 2 and salary is greater than 90,000. A composite index on department ID and salary can significantly improve performance, but order matters. Department ID comma salary is not equals to salary comma department ID. Indexes follow left to right rules. Indexes and joins, very important part. Indexes on primary keys, foreign keys make join operations faster, more predictable. This is why foreign keys are often indexed. Now, we make a transition to part 4. Query optimization is not magic. It's about reducing work, reducing data scanned, helping the optimizer. Now, the rule 1. Avoid select star. Select star fetches unnecessary columns, increases input-output operations, slows network transfer. Always select only required columns. Rule number 2. Filter early. Use where conditions as early as possible. Filtering early reduces rows, improves joins, and improves aggregations. Now comes rule number 3. Index where and join columns. If a column appears often in where, join, order by, it's a candidate for indexing. Rule 4. Avoid functions on indexed columns. Now let's go through an example which is bad, where year of order date function is equals to 2025. Now let's also go through a good example, where order date is between 2025 1st of January and 2025 December 31st. Functions can prevent index usage. Now the rule number 5. Use explain. Most databases provide explain and explain analyze. These show query plan, index usage, and scan type. Professionals always check execution plan before optimizing blindly. Now comes the part 5 of this module, which is about common performance anti-patterns. Let's talk about mistakes that kill performance. First anti-pattern, over-indexing. Too many indexes, slow inserts, slow updates, and increases storage. Indexes should be intentional, justified, and reviewed. Second anti-pattern is indexing everything. Not every column needs an index. Indexing low selectivity columns rarely helps and often hurts. Now, third anti-pattern, ignoring data growth. A query that works today may fail at a scale or may time out later. Always ask, what happens when this table has 1 million rows or 100 million rows, right? Now, the fourth anti-pattern is blind optimization. Never optimize without measuring, without understanding the plan. Premature optimization is often dangerous. Now comes the part 6 of this module, which is about real world scenarios. Now the first scenario, slow dashboard query. millions of orders, filter by date range, group by customer. Now the solution for this problem: index on order date, composite index if needed, and avoid select star. Now the second scenario: slow join query. Orders joined with customers, foreign key is not. Now the quick fix for this problem is index foreign key, reduce join columns, and check execution plan. Now comes the scenario number third, which is about reporting versus transaction systems. OLTP, normalized index for writes plus reads. Analytics, denormalized index for reads, sometimes materialized views. Now comes the part 7, which is about interview perspective, how to talk about performance. Interviewers don't expect perfect tuning, deep engine internals. They expect awareness, trade-off thinking, real-world mindset. Good answers mention indexes, execution plans, data volume, and query patterns. Now, some of the bad answers that you should avoid are add indexes everywhere, use faster hardware. A little summary of this module. Why this module makes you professional. Anyone can write SQL that works, but a very few can write SQL that scales, performs, survives growth. This module moves you from beginner level SQL thinking to production ready SQL thinking. From here on, you won't fear slow queries. You will reason about performance, you will design smarter schemas, and you will earn trust in real teams. And with that, we make a transition to the next module. Now we enter module number 10, which is about views, functions, and stored procedures. Up until now, we've been writing queries directly on tables using select, join, and group by, subqueries, and even some window functions. That's great for learning SQL fundamentals. But in real-world organizations, analysts and applications do not write raw queries every time. Instead, SQL logic is abstracted, reused, and secured using database objects. This is where views, functions, and stored procedures come into the picture. Think of it like software development. Views are reusable layers, functions are calculation utilities, stored procedures are like back-end APIs running inside the database. Mastering these concepts separates someone who knows SQL from someone who works with SQL in production systems. Now, SQL views. What is a view? A SQL view is a virtual table created with a select query. It doesn't store any data by itself, but it stores the logic. Whenever you query a view, SQL runs the underlying select query. It fetches fresh data from the base tables. So remember, tables store data and views store business logic. Why views exist in real systems is the question you ask. There are 4 main reasons companies use views. First one, simplification. Analysts don't want to write complex joins every time. So the next reason is consistency. Everyone should calculate metrics in same way. The third reason, security. Views hide sensitive columns from certain users. The fourth and most important reason is maintainability. Change logic in one place and it updates everyone. And those were the 4 reasons why views really matter in real-world data analytics. Now, let's go through some examples. View example number 1, right on my screen, which is about employee details view. Right, we are creating a view on the employee details. Now, let's imagine you are an HR and you want employee details along with department names without writing joins repeatedly. Now, for that, let's create a view. So here, we are creating a view using the word or the keyword create and the keyword view. And this is the customized name that you are providing to your view, VW employee details. And inside this view, you will have this particular query where you are selecting employee ID, employee name, employee salary, hire date, and you're also using department, right? So here you can see the D letter. So this means you are using a different data table, which is department's data table, and from employees. And you're joining that particular department's table based on the foreign key department ID and the keyword, the primary key in department table, which is department ID, right? This is the query. And this is totally a join, and this is your view. Now, let's execute this so that your view is successfully created. So I have executed this query previously. So here you can see VW employees details already exist, right? If you want to extract the details from this particular view, all you need to do is select star from view, which is this one, and you'll have view here, right? Let's have a quick understanding. So when you execute this particular query, you create a reusable virtual table. You'll have a left join here, which ensures that employees without departments are still visible. For example, contractors or new hires. The Frank, which we have in our table, he doesn't have a department here, right? In our previous section, we have discussed about that intentional missing of department for Frank. And this view hides the complexity of joins. Now, so we have already used the view to extract the details, right? Now the key point, SQL executes the join behind the scenes. The user sees clean results. This is exactly how dashboards and BI tools work. Let's go through another example in view, which is department salary summaries. And what's the business question here? The business question is, what is the average and total salary per department? Now, let's go through the query. So here we have the second view, which says department salary summary. And we are creating this particular view using create and view keywords. And here we have department name, counting the total number of employees in each department. And we are aliasing this as employee count, and average aggregate function, and we are aliasing it as average salary. Sum aggregate function as the total salary alias from departments team. Left shown the employees on department ID from departments table with a department ID from employees table and grouped by department name. We already created this view. Let's say if we try to execute this, we'll get an error which says view department salary summary already exists. Now, how do we use it? So you can just use the same select function. You can copy and paste it here and replace this particular view employee details with this particular view name, salary department, and enter to use this view. And there you go. So we have the department name, employee count, average salary, and the total salary, right? Now we enter a state where we should understand why views matter. So views matter when you're creating monthly reports, leadership dashboards, financial analysis. Without views, you would write the same query multiple times, risking inconsistent results and creating a maintenance headache. Now, a quick interview insight. Now, if someone asks you to explain what is a view, then you should not answer use store data. As we discussed in the beginning section, views never store any data, but they store only the logic. So the correct question would be, views store query logic. They abstract the complexity and keep the data dynamic. Now we transition to the next part, which is the SQL functions. Now let's understand what exactly is a function. A SQL function is a reusable block of logic that accepts input, returns a single value. It can be reused inside a select, where, order by condition, and you can think of it like an Excel formula that works directly on your data table. Why functions matter? Functions avoid repeating case statements in multiple queries, centralize business rules, improve readability, reduce errors. Now, let's also go through some examples. Now, the first example is salary category. Now, what is the business need here? The business need is we can classify employees as high, medium, or low salaries, right? Now, let's go through the query. So here we have the delimiter, and we are creating a function which is function salary category, which returns worker type of data 20 and deterministic begin here. So declare category, and the categories are high for employees having greater than 1 lakh salary, medium for employees having greater than or equal to 70,000 salary, and the other category is set to low. Now this function is already created. Now how to use the function? Now we are using the function here, select name, salary, and the function name as salary band from employees. Now let's quickly hit enter, and we have all the details right here. Now we have the second example for function, which is experience calculation. Now before that, let's see how the output works. So basically this particular query returns worker type of output, and deterministic, which is same output, always returns the same output, and helps the optimizer if or else if function, and encodes the business rules using the function. Now this approach keeps your queries clean, readable, and maintainable. Now as we discussed, the second function, which is experience calculation. What this does is it basically calculates how many years of experience does each employee have. Now where is this being used? So for that, let's go to the workbench, So we have already created this particular function, which is function experience in here. Now we have deterministic returns int type of data type, and we will use this particular function here and execute the query. So Alice, I think this particular industry was created recently, so none of the employees have crossed 1 year of experience. So that's great, not a big deal. Now we enter the next part, which is about stored procedures. And before that, let's understand the difference between function and a view. When comparing views and functions, there are few points to note. First, their purpose. A view is designed to be reusable query. It encapsulates the logic of one or more tables so that anyone can access it without writing or rewriting joins and aggregation. A function, on the other hand, is reusable calculation. It is meant to perform specific logic or transformations on data. Second, what they return. A view returns a result set, essentially behaving like a virtual table that you can query just like a regular table. A function, on the other hand, returns a single value which can be used directly in calculations or conditions. Finally, where they are used. Views are referenced in the from clause of a query, just like any other table. Functions, on the other hand, are used in select statements, where conditions, or even order by clauses whenever a value needs to be computed. In short, think of views as query containers and functions as calculation helpers that make your SQL cleaner and more reusable. Now, a quick interview insight. A good explanation is functions encapsulate calculations while views encapsulate data relationships. Now we enter into the stored procedures. Now, what is a stored procedure? A stored procedure is a named set of SQL statements stored in the database. It can accept parameters, execute multiple queries, return result sets, enforce business workflows. Think of it as a backend logic running inside the database. Now, why stored procedures exist? They reduce application database traffic, improve performance, improve security, standardize business logic, and a lot more. Now, let's go through an example. Now, the example is about employees by department. And what's the business requirement? They return all employees for a given department. For that, let's go through a sample query on my screen. So here's a procedure that we recently created, and the procedure name is SP get employees by department. Now, it's already created and we cannot create this procedure once again. So let's simply call it. So there you go. So all the employees from engineering department are being called here. Now, why it matters? Applications call the procedure. Users never see the underlying tables. Logic is centralized. And now let's go through the next example on procedures, which is department salary summary. Now let's go through the procedure name, which is department salary summary. And since this is already created, we can just call it and execute it. So this is what we have. So we have engineering, HR, finance, marketing, and their employee count, average salary, and the total salary. Proceeding ahead, we have another example in procedures, which is in and out parameters. So here we have in and out parameters. So we are providing customer ID, and out will be the order count. Now this particular procedure is created. Now we can call this particular procedure and then select the total orders. And here we have the output, which is a total of 4 orders. Now, what was the business use case? They return total orders from a dedicated customer. Now calling it will give you the results. Now let's have a quick understanding between the stored procedures versus the function. When we compare functions and stored procedures, there are 3 differences to keep in mind. First, what they return. A function always returns a single value, making it perfect for calculations or deriving a specific result. A stored procedure, on the other hand, can return full result sets and even use out parameters, which makes it ideal for handling workflows or multiple operations at once. Second one, how they are being used. Functions can be called directly inside a select statement, so you can embed them in queries whenever you need a calculated value. Stored procedures, on the other hand, cannot be used inside a select. They are executed independently. Finally, their primary use case differs. Functions are primarily used for calculations like categorizing salaries or computing experience. Stored procedures, on the other hand, are better suited for workflows like fetching all employees for a department, updating multiple tables, or encapsulating business logic. In short, think of functions as a calculation tool and stored procedures as a workflow engine inside the database. Now, a final summary. Views improve readability and consistency. Functions improve reusability of logic. Store procedures improve performance and control. Mastering these concepts prepare you for data analyst job roles, business analyst interviews working with production level databases, and backend and business intelligence systems. Now this finishes the module 10, and with that we transition to the next module. Now we have entered module 11, which is about transactions and error handling in SQL. Before we talk about SQL transactions, error handling, or even asset properties, let's take a moment to understand why this chapter matters so much. Until now, we've been writing SQL queries that read data, filter rows, and analyze information. But in real systems, SQL is not just about reading data. SQL is also responsible for changing data, and once data changes, the consequences become serious. In production systems, a single SQL mistake can lead to incorrect salaries being paid, orders being duplicated, money being deducted twice, customer records becoming inconsistent, or the worst case, complete data corruption. This is where transactions come into play. Think of transactions as the safety net of SQL. They ensure that when multiple changes happen together, they either all succeed or nothing happens at all. This chapter will help you understand what SQL transactions really are and how databases protect data integrity, why asset properties are critical in enterprise systems, and how databases deal with errors gracefully. This is one of those chapters that separates beginners from professionals. Interviewers love this topic. Architects expect you to understand it, and production systems depend on it every single day. What is a transaction is our first question in this chapter. At a very simple level, a transaction in SQL represents a group of database operations that are treated as one single logical unit of work. Instead of executing each SQL statement independently and immediately making its changes permanent, the database deliberately groups multiple statements together and evaluates them as a whole. In practical terms, a database makes a promise. That promise is simple but powerful. It says either every change inside this group must succeed together, or none of the changes should be applied at all. There is no middle ground and no partial success. To understand why this concept exists, let's step outside the world of databases for a moment and think about real-world scenarios that almost everyone can relate to. Imagine you're transferring money from one bank account to another. This process always involves at least two steps. First one, money is deducted from account A. Second, the same amount of money is added to account B. These two steps are logically connected. One step cannot exist without the other. Now pause and ask an uncomfortable but important question. What happens if the system crashes after the money is deducted from account A, but before it is added to account B? From a user's perspective, that situation is completely unacceptable. Money has vanished without reaching its destination. Trust in the system is broken. Databases face the exact same challenges. In SQL, real-world operations rarely involve a single statement. A business process might require updating one table, inserting records into another table, and deleting rows from a third table. Each of these statements may succeed individually, but from a business perspective, they are not independent. They are a part of a single operation. If one of these steps fail, allowing the others to remain would leave the database in an inconsistent and unreliable state. That is why these actions must behave like one combined operation, not three separate ones. This logical grouping of multiple SQL statements into one indivisible unit is what we call a transaction. Now, why transactions are needed is your next question. Without transactions, databases would behave like a collection of isolated commands that execute independently without awareness of each other. While this might sound simple, it quickly becomes dangerous in real systems. Imagine a database that executes every SQL statement immediately and permanently without any ability to reverse or group changes. In such system, failures would create chaos. Partial updates would become common. Data mismatches would appear across tables. Relationships defined through foreign keys would break silently. Reports and analytics would start showing numbers that do not align with reality. Let's take a very common example from an e-commerce system. An order is created in the orders table. Payment processing begins. The payment fails due to a network issue or insufficient balance. However, the inventory system has already reduced the stock count for that product. Now the database shows an order that was never paid for or inventory that no longer exists. This is not a rare edge case. It is exactly the kind of scenario that happens in real systems every day if the transactions are not used correctly. Without transactions, SQL would simply execute each statement in sequence and move on, completely unaware that something went wrong midway. The database would not automatically understand that these operations were connected logically. Transactions introduce control and intent into this process. They allow us to clearly tell the database when to start tracking changes, when to confirm and permanently save those changes, and when to cancel everything and revert back to the original state as if nothing ever happened. This level of control is not optional in modern systems. It is essential. Banking platforms rely on transactions to protect financial accuracy. E-commerce systems use them to ensure orders, payments, and inventory always remain in sync. ERP systems depend on transactions to maintain consistency across complex business workflows. Payroll systems cannot afford partial salary updates. Analytics pipelines and data warehouses rely on transactions to ensure reporting data is trustworthy and complete. In short, transactions exist because real systems fail, networks break, users make mistakes, and databases must be prepared for all of it without compromising data integrity. Now, we land into the next part, which is begin, commit, and rollback. It is the core of SQL transactions. Now that we understand what a transaction is and why transactions are necessary, it is time to focus on the three most important commands that make transactions actually work in SQL. These commands form the backbone of transactional control in every major database system used in the industry today. Those three commands are begin, commit, and rollback. You will encounter them in MySQL, PostgreSQL, SQL Server, Oracle, and almost every enterprise-grade relational database. While syntax variations may exist, the underlying concepts are universal. If you understand these three commands deeply, you understand how databases protect data from mistakes, failures, and unexpected crashes. Let's take them one by one and truly understand what each command does, not just at a syntax level, but at a conceptual level. Now, let's start with begin, or also known as a start transaction. The begin statement marks the starting point of any transaction. Conceptually, begin tells the database something very specific and very important. It tells the database, from this moment onward, do not permanently save any changes yet. Before begin is executed, every SQL statement typically operates in what is known as auto commit mode. That means each individual statement is immediately finalized and written permanently to the database. Once executed, there is no easy way to undo it. Begin changes this behavior. When you execute begin, the database switches into a controlled state. From this point forward, every insert, update, or delete statement is tracked internally by the database engine. The changes are applied in memory or in temporary structures, but they are not yet committed to the permanent storage. This distinction is extremely important. At this stage, the database remembers what has changed. The original data is preserved internally. Other users do not see the changes. The system is effectively waiting for your final decision. A very helpful way to think about begin is, imagine opening a draft document. You start editing the document, but nothing is published yet. You can add text, remove sections, or rewrite entire paragraphs. But until you click save or publish, the changes are private. Begin creates the same draft-like environment for database operations. This is why begin is often described as the moment when the database starts recording intent rather than finalizing the action. Now, visibility of changes after begin. One subtle but critical aspect of begin is visibility. Once a transaction has started, the changes made inside that transaction are usually not visible to other users or sessions. This means you may update a salary inside transaction. Imagine multiple analysts running reports while data is half updated. Without isolation, reports would show unpredictable results. Begin creates a protected workspace where changes can be reviewed, validated, and finalized safely. Now let's dive into commit. Once you have executed all the necessary SQL statements inside a transaction and you are confident that everything is correct, you use the commit command. Commit tells the database that everything that has happened since begin is correct. Make it permanent. This is the point of no return. When commit is executed, the database takes all the track changes and writes them permanently into the disk. At this moment, the transaction ends. The database is updated. Other users can now see the changes. The old data is replaced by the new data. From a conceptual perspective, commit is equivalent to clicking save or publish. Until this moment, everything was reversible. After this moment, the changes become a part of the official database history. It is very important to understand that there is no undo after you use commit. Once the database confirms a commit, the transaction is complete. If a mistake is discovered later, it must be corrected with a new SQL statement, not by reversing the commit itself. This is why commit should only be executed when all statements have run successfully, all constraints are satisfied, the data makes logical sense, the business rule has been fully applied. Professional developers and database administrators treat commit with respect because it represents finality. Now we have durability and commit. Another important idea connected to commit is durability. When a database confirms a commit, it ensures that the changes are safely returned to persistent storage. Even if the server crashes immediately after, the committed data will still exist when the database restarts. This guarantee is one of the reasons relational databases are trusted for critical systems. Commit is not just a logical confirmation. It is a promise that the data will survive failures. Now we have rollback. While commit represents success, rollback represents recovery. Rollback tells the database something went wrong. Cancel everything that happened since begin. This could be due to a constraint violation, a failed business rule, an unexpected error, a manual decision by the user, or even a system failure handled gracefully. When rollback is executed, the database discards all track changes from the current transaction. Every insert, update, or delete is undone, and the database returns to its exact previous stable state. It is as if the transaction never happened. This behavior is what makes transactions so powerful. Instead of leaving behind partial updates or corrupted data, the database cleans up everything and restores order automatically. This is why rollback is often called the panic button of SQL transactions. When something feels wrong, rollback ensures safety. Now we deal with rollback and data integrity. Rollback protects data integrity in situations where partial success would be dangerous. Consider again the banking example. Money deducted from one account, errors occur before adding money to another account. Rollback ensures that the deduction never truly happened. The system goes back to a consistent state where balances still make sense. Without rollback, errors would permanently damage data trust. Mental model for transactions. A very effective way to remember how these commands work together is to use a simple mental model. Think of it like this. Begin means start recording changes. Commit means accept and save changes. Rollback means forget all changes. And this mental model is powerful because it works across databases, tools, and even interview discussions. Whether you're working with MySQL, PostgreSQL, SQL Server, Oracle, or any other enterprise database, the behavior remains conceptually the same. The syntax may differ slightly, but the intention never changes. Transaction lifecycle is our next concept. Every transaction follows a clear and predictable lifecycle, even though the most users never see it happening. The lifecycle begins when a transaction starts. This may happen explicitly using begin or implicitly when auto commit is disabled. At this point, the database prepares itself to track changes rather than finalizing them. Next, SQL statements execute one by one. Insert, add rows, update, modifies values, and delete, removes records. Each change is carefully tracked internally by the database engine. During this phase, the database maintains enough information to undo everything if required. This is where transaction logs and internal buffers come into the play. Although those mechanisms usually remain hidden from the users, after all statements are executed, the transaction reaches a decision point. One of the two outcomes must occur. If everything is correct, commit is executed. The database permanently saves the changes and ends the transaction. If something goes wrong, rollback is executed. The database discards all the changes and returns to the previous stage. What is crucial here is that there is no third option. A transaction can never end in half-completed state. The database guarantees that it will either fully succeed or fully fail. This all-or-nothing behavior is what makes transactions more reliable. Why this lifecycle matters? Although this lifecycle is invisible to most users, it is absolutely critical behind the scenes. Every time you place an order, receive a salary, update customer information, generate financial reports, you are relying on this lifecycle to behave correctly. Understanding this flow not only helps you write safer SQL, but also helps you think like a system designer. It teaches you to anticipate failure, plan recovery, and respect data integrity. Now, with that, we make a transition to the asset property. Now, a quick introduction to asset properties and error handling in SQL. Now that we have built a strong understanding of transactions and we clearly know how begin, commit, and rollback work together, it's time we move into one of the most important theoretical foundations of SQL and database systems as a whole. This section is not just theory for the sake of theory. It explains why databases are trusted, why transactions work reliably, and why SQL systems can safely power critical business operations across the world. Every reliable transaction database follows a set of guarantees known as ACID or asset properties. Asset is not a buzzword. It is not any academic concept that exists only in textbooks. Asset is the reason why banks do not lose money, airlines do not double book seats, and enterprise can run large-scale systems with confidence. The word asset is an acronym, and each letter represents a functional fundamental property that a transaction must satisfy. A stands for atomicity, C stands for consistency, I stands for isolation, and D stands for durability. If you truly understand these four properties, you understand why databases are considered reliable systems rather than simple storage tools. Let's explore each one of them carefully, one at a time. First one is atomicity, all or nothing. Atomicity is often the earliest asset property to understand conceptually, but it is also one of the most powerful. Atomicity means that a transaction is treated as a single indivisible unit of work. In simple terms, a transaction must either complete entirely or not happen at all. There is no such thing as partial success. When a transaction contains multiple steps, the database does not allow some of them to succeed while others fail. Either all steps are applied successfully or every single change is undone. Imagine a transaction that contains 10 SQL statements. According to atomicity, the database guarantees one of the two outcomes. Either all 10 statements succeed or none of them are applied. There is no scenario where 5 succeed and 5 fail. This guarantee becomes especially important when systems fail unexpectedly. Consider what happens if a transaction is executing and the system crashes during the ninth step. From the user's perspective, this crash is unpredictable and unavoidable. However, the database still guarantees safety. It detects that the transaction did not complete fully and automatically rolls back all the changes made by that transaction. This is atomicity in action. Atomicity prevents half-written records from entering the database. It prevents partial updates that could break reports, analytics, or business workflows. It ensures that relationships between tables remain intact and logical. Without atomicity, databases would be extremely fragile systems. Every unexpected shutdown or error could leave the data in a corrupted or unusable state. Atomicity is one of the primary reasons databases are trusted in financial systems, healthcare platforms, airline booking engines, and other mission-critical applications. When money, lives, or legal obligations are involved, almost correct is not acceptable. Atomicity ensures correctness or nothing at all. Now, the next one, C for consistency. From one valid state to another, while atomicity focuses on all or nothing, consistency focuses on correctness. Consistency means that a transaction must move the database from one valid state to another valid state. A valid state is defined by the rules of the database and the rules of the business. These rules include technical constraints such as primary keys, foreign keys, unique constraints, and not null conditions. They also include business rules such as salary limits, account balances, or workflow conditions. For example, if a table requires that every employee must have a unique employee ID, consistency ensures that a transaction cannot insert duplicate IDs. If an order must reference a valid customer, consistency ensures that orders cannot exist without customers. When a transaction violates any of these rules, the database does not allow it to succeed. Instead, the transaction fails and is rolled back. Consistency ensures that invalid data never enters the system. It guarantees that every committed transaction leaves the database in a state that makes sense according to the defined rules. It's important to understand that consistency does not mean the database automatically knows what is right for your business. Instead, it enforces the rules that you, as a designer or developer, define. Once those rules are defined, consistency becomes the database's responsibility. This is why well-designed schemas matter. The stronger your constraints and rules, the stronger the consistency guarantees your database can provide. Consistency is what allows analytical teams to trust reports, auditors trust financial records, and engineers to trust system behavior. Now we have the next one, I for isolation, protection in a multi-user world. Modern databases are multi-user systems by design. At any given moment, hundreds or even thousands of transactions may be executing at the same time. Isolation answers a very important question. What happens when multiple transactions interact with the same data simultaneously? Isolation means that transactions should not interfere with each other in a way that causes incorrect or unpredictable results. In simple terms, isolation ensures that one user's incomplete transaction does not affect another user's transaction. Imagine one transaction is updating employee salaries, but it has not yet committed. At the same time, another user is running a report that calculates average salaries. Without isolation, the report might see half-updated data, leading to incorrect results. Isolation prevents such scenarios. It ensures that uncommitted changes are not visible to other transactions. Dirty reads are avoided, data remains predictable and stable. Different databases implement isolation at different levels, allowing trade-offs between performance and strictness. These are known as isolation levels. While the strictness may vary, the core principle remains unchanged. Isolation exists to ensure that concurrency does not break correctness. Without isolation, databases would become chaotic under load. Reports would fluctuate unpredictably, updates would conflict, and debugging would become nearly impossible. Isolation is the silent guardian that allows multiple users to safely share the same database. Now comes the last one, D for durability. Once committed, always committed. Durability is the final asset property and it focuses on permanence. Durability means that once a transaction is committed, it will remain committed, even in the face of system failures. Once commit is executed successfully, the database guarantees that the data is safely stored. Even if the power goes out, the server crashes or the database restarts, the committed data will not be lost. This guarantee is achieved through internal mechanisms such as transaction logs, write-ahead logging, and persistent storage strategies. Before a transaction is considered committed, the database ensures that enough information has been written to disk to recover the changes if necessary. Durability is the reason databases can recover safely after crashes. When a database restarts, it replays committed transactions and discards incomplete ones. Without durability, a database crash could result in data loss, broken trust, and catastrophic failures. Durability transforms databases from temporary data stores into reliable systems of record. Why ACID matters in real systems. At this point, it should be clear that ACID properties are not abstract ideas meant only for exams or interviews. They are the foundation upon which real systems are built. Banks rely on ACID to ensure financial accuracy. Airlines rely on ACID to manage reservations without conflicts. E-commerce platforms rely on ACID to synchronize orders, payments, and inventory. Enterprises rely on ACID to run payroll, compliance systems, and analytics pipelines. When interviewers ask about ACID properties, they are not testing memorization. They are testing whether you understand why databases can be trusted or not. A candidate who understands ACID demonstrates system-level thinking, not just SQL syntax knowledge. Now we make a transition into error handling in SQL transactions. Now let's move on from guarantee to reality. In the real world, errors are inevitable. Networks fail, constraints are violated, input is incorrect, applications contain bugs, systems crash unexpectedly, and the key question is not whether errors will happen. The key question is how databases handle these errors without compromising data integrity. The transactional system's error handling is deeply connected to ACID properties. When an error occurs inside a transaction, the database does not panic or partially commit changes. Instead, it ensures safety. Errors typically trigger rollbacks. This means the database cancels all changes made by the transaction and returns to a stable state. Some databases automatically roll back when a fatal error occurs. Others require explicit rollback commands regardless of the implementation. The principle remains the same. Errors must never leave the database in an inconsistent state. This principle is non-negotiable in reliable systems. Now, the conceptual workflow of error handling. The conceptual workflow of error handling in transaction is simple and elegant. First, a transaction begins. Next, the SQL statements execute one by one. The database continuously monitors for errors. If an error occurs at any point, the transaction is rolled back. If all statements succeed, the transaction is committed. This flow is deeply embedded into enterprise systems, even if the developers are not consciously aware of it. It is this flow that allows databases to gracefully handle failures instead of amplifying it. This is why this chapter is career critical, and this chapter may feel theoretical, but it is one of the most practical chapters in SQL. Understanding transactions, ACID properties, and error handling improves system design thinking. It prepares you for production environments. It helps you answer senior level interview questions with confidence. It builds credibility as a data professional. Many people know how to write SQL queries. A very few truly understand how databases behave under failure, load, or concurrency. This chapter closes that gap. Now let's summarize everything that we have covered so far. Transactions group multiple SQL operations into a single logical unit of work. Begin starts tracking changes. Commit saves changes permanently. Rollback cancels all changes. ACID properties guarantee reliability. Error handling protects data integrity. Transactions form the backbone of enterprise systems. If SQL were a building, transaction could be its foundation. Without them, everything collapses. And that brings us to the end of this chapter. And now we transition to the next one. Let's imagine you just joined a company as a data analyst or a business analyst, and your manager gives you one of these CSV file and say, we sell products across multiple regions. We run marketing campaigns. We generate traffic, leads, and orders. And I want you to find the insights that can drive revenue and reduce losses. That's exactly what this project is all about. In this module, we will build a complete SQL sales analytics project using real-world sales data. We will move step by step, just like the actual analytics role does. By the end of this project, you will know how to analyze sales data performance using SQL, how to convert raw data into business insights, how to write interview-ready SQL queries, how to explain your analysis like a professional data analyst. Now, before we get started with data understanding and everything, let me show you a quick way to understand how to import data. So this particular data is from an Excel workbook, just as we discussed. So it can be either an Excel workbook or it can be an Excel CSV file. So this is my data. So we'll be having order ID, order date, delivery date, order status, and all those things. So if you observe closely, on each and every column ID, I have not left any spaces. You can either go with an underscore or don't leave any space, because in real world data analysis, if you're having spaces in between the column header names, then you might face issues while writing the queries. So for safe side, just understand one thing: no spaces in between the column header names. Okay. And then make sure you save this as .csv, because in SQL Workbook, we import data in the form of .csv files. So that's one major thing. Now let me show you my data location. So we have data in the download section. Here we have the file. So if you save the same file in the form of .csv, this is how it's going to look like. There you go. And also you need to remember the files, the date files should be saved in the form of date, and the specific format should be year, month, and date, right? So let me go through the workbook and check if my data is according to my request. So here we have the data already. Let me also show you how to load it, not a worry. So there you go, we have the data in form of year, month, and date. So this is how you basically have the date files. So what I'm basically telling you is, before you load the data onto SQL Workbook, when you have the opportunity to work on it on Excel, then why don't you use it, right? So most of the times, before you load the data, on any of the platforms, it can be a MySQL Workbench, or it can be a data visualization tools like Tableau, Power BI. Make sure you clean the data and data is ready for analysis, right? So we've already gone through how to, change the data type of the column, how to change some elements, how to replace filter, and all those things, right? So based on that analysis, or based on that approach, you might have to work on the data cleaning first. And once you're satisfied with it, you can close and load the data. So now back to MySQL Workbench. So this is the location. And now if you come back to the MySQL Workbench, now here you can see the databases. You can select any of the schemas. So this is my schema. So here what I'll do is, I'll go for an option which says data import or visit, right? From here, I have already given my location, or else if your location is in a different location, then you can just browse and go to the location and then just select the file, and here you go to the next option, and here you have the next, right? So you already have the table. So in case if you don't want to delete the table and import a new one, you can just cancel it. But in case if you want, you are exploring, don't worry, this particular data set will also be provided to you in the description box below. And if you want to just load the data, you can just proceed with it, and I'll use the existing. So I don't want to delete the data table. So this is how you basically load the data table. And in case if you want a little bit more clarity, I'll also drop a tutorial link in the description box below, which will explain you how to load data from Excel files. So that's the approach. Just right click, and here you go to the table data import wizard and just select the location where you have it, and then load the data. That's basically it. And once you are loaded the data, what you can do is select the database. I'll just use interview database, and then here show tables. So these are the tables you have, and this is our dataset, which is sales data, and you have an overview. And once you load this data, you might be having a few errors on the column names, sometimes, very rarely, 1 out of 100 cases. So I had an issue due to some spacing issue on the name. So I quickly changed this, but let me expand this. Yeah, I quickly expanded or selected the column name. What I did is I just copied the field name and pasted over here. So this was the initial field name, and I changed it to my requirement, which is order ID. And once you do it, the column header name from this got changed to the expected name, which is order ID. And now we start with the business analysis and questions and queries, right? So this is how you quickly load the data to the MySQL Workbench platform, and then you start with the business queries. So this was a basic understanding of how to load the data and understand what's present in our data. Now, let's proceed to deep dive into the data set. So now comes the data understanding. Before writing even a single SQL query, the first thing an analyst does is understand the data. Our dataset contains the following key information. We have order level data, which includes order ID, order date, and delivery date, order status, such as it is delivered or cancelled. We also have customer information, which includes customer ID, first name, and the last name, which state or region he or she belongs to. Then comes the product and sales metrics, which includes product name, product category, product subcategory, the quantity of the product sold, cost to the company to make it, and the revenue details which we made out. And also we can have the profit column, and finally the marketing funnel metrics, which include the traffic number on the website or the store's site, and the total number of leads we had, total number of orders we received, and all those things. This tells us something very important. This is not just sales data. This is sales plus marketing plus operations data all combined together, right? So we have the sales data, which has product price, cost of the company, revenue, and all those details. And we also have marketing data, which is about leads, revenue, and traffic, and all those orders, and the product data as well. So this is a combination of all three of the data sets together. And most of the times what happens is these three different data tables will be stored in three different data modules altogether. So we also have data modeling part in this particular full course. So you can go through that once again to get a full detail on this particular aspect, right? So most of the times the data will be stored in different tables so that we maintain a schema of data sets. Most importantly, we follow the star schema, and all the other tables are related to one another through a foreign key, right? Using foreign key, we can combine different tables to the fact table. So here the fact table will be the orders data table or the CS data table, and product data, marketing data, and all those things will be the dimension tables. But now to eliminate the confusion and keep the project more simplistic, we have combined all this together in one single data table, and we have it in one table here itself. So this means we can analyze revenue, profitability, conversion funnel, regional performance, product performance, order cancellation, and all those aspects in one single go. That's exactly what companies expect from SQL analysts today. Now, the project problem statement. Let's clearly define our project goal. So the problem statement is analyze sales, performance, profitability, and marketing efficiency across different regions, products, and customers to identify revenue drivers and business bottlenecks using SQL. It is simple, clear, and business focused. Now, let's get started with the questions and their answers. So the first question. So I have already added the questions here to save time, and also the queries, and you can have this code documentation readily available for you in the description box below. So to follow up with me, make sure you copy the dataset and the queries document with you, and be ready with your SQL workbench so that I will explain you on the go what's happening here, and you can also follow along with me and run the query with me and get the output. And if you're getting anything different, or if you are facing any difficulty, please feel free to drop them in the comment section below, and we will address that as soon as possible. Now, the first question is, what is the total revenue, total cost, and total profit? Let's understand this a little bit more detail before we start with the solution approach.
In this video, I will show you some of the categories of operations that are possible in Python. So let's start off. So the first category of operations are arithmetic operations. And as you can see in this table, there are different types such as addition, subtraction, multiplication. So let's go over them one by one. So a simple addition operation would be like 5 plus 6, giving me the value 11. I can do 5 minus 3, that's subtraction. Similarly, I can do a multiplication using 5, say 5 into 2. There's division where I use the backslash. So say I did division of 8 divided by 2. Now you might encounter another type of division, which is called the floor division, where we use a double backslash. And what this does is it returns us the largest whole number that is lesser than the result of our division. So the difference between the float division and the normal floored and the floor division, or the single and the double backslash, is this. Say I did 9 divided by 2 using a single backslash. It should give me, as you can see, 4.5, right? So this is the actual value. Now let's see what happens when I do 9 double backslash 2. It will give me 4, which is the largest number lesser than or equal to 4.5. That is also a whole number. So this is what we call floor division essentially. Finally, we also have, if we want to raise something to the power or something. So if I want to do say 6 raised to the power 3, so I would use double asterisks, and this is how I would do it. It will give me 216, as you can see. If I wanted remainder between the division between two different numbers, I will use the percentage sign. So if I wanted the remainder of the division between 7 and 3, this is how I would do it. I get the answer 1, as you can see. So the next category of operations are logical operations. The first one is the logical AND operation, where we use the operator AND. Alright, so let's see what we mean by this. I am creating, so as we know, the AND operation returns the value true if both the operands are true. So let's actually do this for an example. Let's give this variable the value true and this the value false. Actually, it should be done like this, true, false. So now think of it like 1 and 0. So 1 and 0 is obviously 0, right? So if I did A and B, I should get the answer false or 0, because I'm doing true and false. So it's like doing 1 and 0. So if you see this, I should get the answer false. So if I change this to true as well, now if I do this, I will get the answer true, as you can see. The next logical operation is the OR operation, where, logical OR is if either of the operands are true, then we should get the answer to our OR operation as true as well. So in this case, obviously, if I did OR over here, it will naturally give us true. If I change this to false, it should again give us true, and it will only give us false if both are false, as you can see here. Now it's false. The next operation is the logical NOT. It's done by using the NOT operator. So in this case, the value that we get is true if the operand is false. So let's take A. As we know, A is false over here. So if I did not A, I should get the answer true. But if I change this to true, now if I do not A, I should get false, as you can see. So this was the logical operations. Let's move on to the next set of operations, that is comparison operations. So there are a bunch of them. Let's go over them one by one. If I want to check if two operands are equal, so if I did X is say equal to 2 and now Y is equal to 3. If I want to check if they are equal, I will use the double equals to sign. And if they are equal, I will get the value true. If they aren't, I'll get value false. As you can see, since X is 2 and Y is 3. As you can see, X and Y are not the same, so there's false. They are not equal. If I change this also to 2, now I will get the answer 2. The next comparison is the not equal to, or where we use the exclamation sign. So over here, the result of this is true if X and Y are not actually the same. So I should get false over here, as you can see. But if I change this to say 5, now I will get true because X is not equal to Y in this case. The next one is greater than. So if I did X greater than Y, as we can see 2 is not greater than 5, I will get false over here. Similarly, there's a lesser than. If I did X lesser than Y, I should get true over here, as you can see. Well, there's also a greater than or equal to and lesser than or equal to. We simply add the equal to sign here. So let's see. Now if I say X is lesser than or equal to 3, I should get true because X is 2. And if I put 2 here, I should also get true. But what if I put 1 here? Since X is equal to 2 and 2 is not lesser than or equal to 1, this is a false statement. And I can do the same thing with like this, using the greater than equal to. Now it's true because 2 is actually greater than equal to 1. And so this was comparison operations. The next set of operations that we can do in Python are assignment operations. We've already seen a whole bunch. We've already been assigning values to variables. We've been doing assignments throughout already. but let's go over them and see some of the assignment operations. So as we already know, the equal to operation is assigning everything that is on the, or the value on the right hand side of the equal to sign to what is on the left. So if I did a is equal to 5 plus 6, it will assign the value 5 plus 6 or 11 to a. Let's check what's in a. As you can see, it is 11. There is a plus equal to sign, and what this does is, so for example, if I did say a, now since a is 11, let's create another variable called b and call this 5. Alright, so now if I did a plus equal to b, what this will do is it will add b to a and then store it in a. So let's see what this does. Once I do this, now let's check what's in a. It should be 5 plus 11, as you can see, 16. So this a plus, so this plus equal to sign is essentially the same as doing a is equal to a plus b. It's essentially the same thing. They're both the same. There's a similar thing for this, the negative or subtraction as well. Minus equal to. So now that a is 16 and b is still 5, of course, if I did minus equal to b, now I'm subtracting the value 5 from 16. So I should get a is equal to 11 again, as you can see here. And this is the equivalent of doing a minus b. A is equal to a minus b, I mean, as you can see. So the next similar like assignment operation, let's create a is equal to say 6 in this case, and say b is equal to, I will say 2. Alright. Now if I do a star equal to b, what this does is it multiplies b to a and then assigns it back to a. So if I see what's in a now, it should be 12, as you can see here. Similarly, there is similar thing for subtraction as well. So if I did a is equal to 6 and b is equal to 2, if I did for division. So if I did a division symbol and the equal to sign, and then if I give b, what it will do is it will divide a by b, or 6 by 2, and it will assign that back to a. So my value in a should be 3, as you can see here, 3.0. Obviously, this is a single backslash, so this is a float division. The resultant of a single backslash is always a float. I can do the same thing with a double backslash. So let's see if I did a is equal to 7 now, and then b is equal to 3. Now if I did a double backslash equal to b, now it will do the same division, but it will do a float function. So it should give me 2 in this case. If I did the same thing with a single backslash, just to show you the difference between single backslash and double backslash division, in this case it will give me the value around 2.3 or something, a float basically, 2.33, as you can see here. Then there is the modulus. You can use the modulus sign as well with this assignment. Say a is equal to say 5 now, b is equal to 2. Now if I do a percentage symbol equal to 2, I mean b, it should give me, it will assign the, it will take the modulus in both sides and then assign it to the left hand operand. Now let's see what's in a. As you can see, it did a divided by 2. The modulus symbol is basically the remainder of the division between two objects. So in this case, it will divide a by b and then give me the remainder and then put that remainder back in a. And as you can see, that the remainder of 5 divided by 2 is 1, and we get that over here. Similarly, we can also do exponential. So if I have a is equal to say 5, b is equal to 2, and I want to raise a by, if I want to raise the value of a by the value of b and then store that back in a, this is how I would do it. So it should be 5 to the power 2, which is 25, as you can see here. So this is assignment operations. So finally, we move on to two special sets of operators. One is the identity set, identity operators, and the other is the membership operators. Let's look at the identity operators. So when we talk about identity operators, what we mean is the is and the is not operator. So what the is operator does is it checks whether two operands have the same location in the memory, essentially. This does not mean that it does not check for whether two objects have the same value, and this is very important. So let's look at this. If a is equal to 1001 and b is equal to 1000 plus 1, alright? If I did a is equal to 2, this is an equality check. Are they the same values? True. Now if I say a is b, let's see what happens. As you can see, it's false. This is because this object and this object are not the same, and this is what the is operation does. We can confirm this by checking the ID of a. The ID of a gives us some value like this, and the ID of b gives us as you can see, a different value. So the two objects are not located in the same place in the memory, as we have seen using the id function, and that is what we check through the is operator. And the is not is essentially just the opposite of that. So that is the identity operator. Now the membership operator is used for checking whether something is present in a sequence or not. So let's create a sequence. I will create a list to show in this example. My list is 1, 2, and 3. Basically simple list with 3 integer objects, 1, 2, and 3. I will check whether, now say 2 in A. So is 2 in A? If it is, it will give me true, as you can see. Is 5 in A? It should give me false because 5 is not in A. And the not in operator is just the opposite of that. It checks the other condition essentially. So this is the membership operators in Python. In this video, we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmic functions, power functions, and even trigonometric functions that we can do using this math module and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, the standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. You know the value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22/7. So how do we access this pi constant? Is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say we have the radius of a circle 3, it can be in any units, 3 meters or whatever you want, and you want to find out its say circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with a radius 3, all I would have to do is use the formula 2 pi r. And to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle's circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant from the math module, it will also return you a float number. And to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, so let's see what happens when we call the math function math constant infinity. So this is how we do it, and as you can see, it will return us this. It might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this INF data type, which is the equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus inf. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I will take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf, and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be a smaller sign symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. It actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf or the infinity constant in Python, it will still give us the same value, the same data type of inf or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus INF, as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical constant. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error, then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, like how to call it, this is how you actually do it, math.nan, and it will give you a data type called nan. Also, much like the infinity constant, let's see what's the type of this constant. Again, might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like it's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the math module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation, there's permutations, there's combinations. You can find the greatest common divisor or the GCD, and the LCM or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation. The factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this, math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values, or it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass math.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2, that is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil, as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the largest, it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12. The smallest integer that is greater than minus 12.3. And this should give you 12, minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component. So only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I give it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It shall give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this, as you know. So in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So what this mathematically, what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's this very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, are GCD and LCM. As we know, GCD is the greatest common divisor, LCM is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in to Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if you say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, this is how you do it. And if I had to do same 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number or e to the power 3. So this was the exponential function. And let's look at an example. So we will look at the example of rate of decay, and we will use the this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of -693 times t, t for time, divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is, the details are not important. So this will, I'm using the math.exponential function over here, as you can see. And for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element. And in 10 years, this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of, again, functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So a basic log function would be written like this: math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2, and this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log2. What this will do is, again, I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the math? The square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, we move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know, 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this. And for arctan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles, but on hyperbolas. Again, the details you don't have to know the details. You just should know that if you wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine sin h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h, and if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sin h, and similarly for cos, it would be cos a cos h. In this video, we will learn about conditional statements, and we will learn about how do we create these control structures where we have these conditional statements. We will learn about the keywords that we use in Python to create a conditional statement block, the if keyword, the elif keyword, and the else keyword. We will also learn about indentation and its importance in Python. So let's get started. So the basic syntax, if you will, for a if statement in Python consists of the keyword if followed by an expression. As you can see from this pictorial, there's an if statement, there is a expression, there is this block of code which, if you can actually see, is slightly indented to the rest of the code, and then we have the rest of our code after that. So what we're looking at is this. So this is our if statement block. Now let's break this down. So what is this expression that we're speaking of? An expression in this context is a Boolean expression which evaluates to a true or false statement. So when we are speaking about the if statement, we have an expression, and if this expression evaluates to true, then we execute everything below the if statement. Otherwise, we skip that portion. As you can see, if this statement is true, we execute this statement or these statement blocks. Otherwise, if it's false, we move on to the next statement block or the beginning of a new statement. So let's look at an example to further understand this. Let's take this if statement over here. As you can see, in this if statement, I have this expression 50 greater than 30. So what Python is going to do now is it's going to check whether 50 is greater than 30, and it's going to check it in a Boolean context. If this is true, then we can move on to the next portion, which is this. But if it is false, then we will skip this. So let's see what happens over here. So since we know that 50 is indeed greater than 30, this is a true expression, we move on to this block of code, which is saying that print 50 is indeed a larger number than 30. So let's see if this actually gets printed. So as you can see, we get this, the result, which is, this is a true statement, and we get our print statement getting executed. What if we gave a false expression over here? So let's look at what happens if I gave a false expression. Now I'm checking if 50 is lesser than 30, which is a false statement. So if it's a false statement, we do not move on to this portion of our if statement block, and we directly skip. So if I have to execute this, you will see nothing gets executed. And in fact, my print statement is just not executed because we never entered this, because our expression over here was indeed false. So yeah, this is how a basic if statement block looks like in Python, and this is how how we move on to how we check for the truthfulness or the falseness of a particular expression in the if statement. So moving on, let's move on to the topic of indentation in Python. So as you can see, this if statement is an example of a control structure. So without defining what a control structure is in detail, control structures consists of these conditionals or loops or iterations, if you will. So all of these control structures involve heavy indentation. So what does an indentation mean? Well, what if I gave you an example? Say I gave you some variable called age, and I wrote 20 over here. Now if I gave you an if statement saying if age is greater than 10, now it's very important to note that when I'm defining an if statement, I need this colon, otherwise this if statement is not defined. So this colon is important anyways. So now I'm checking this expression if age is greater than 10. Now what is this? What happens if age is greater than 10? Now what if I want Python to do something only if age is greater than 10? Well, how do I tell Python that there is a piece of code or a section of code that I want executed only if this condition is met? Well, this is where indentation comes into play. So if I want this line, this person is an adult. Again, this is some random line where I'm assuming age is pertaining to this adult, alright, or this person. So if I have this variable age where I write this number 20, which denotes the age of some person, and I'm doing a check if age is greater than 10. Actually, let's be specific here. Well, the adult age for most people is 18 in most countries. So let's see if age is greater than 18. Now, if I'm doing this check, I want to print this statement only if this person's age is above 18. So how do I tell Python that I only want this statement to be executed only during this, if this condition is met? Well, this is where indentation comes into play. As you can see, exactly as you can see, this portion of the code is slightly indented compared to the if statement. So when this condition is met, then only do we move on to this. If this condition is not met, we move on to whatever the next section of code will be, like whatever code that we have after this if statement. So let's see. So since this condition is actually met, as you can see, this print statement is actually executed. So this is the importance of indentation. Now we will see as we learn more about if statements and else statements and elif statements, how indentation plays a key role in defining what we want as an output when a certain condition is met. Alright, so for now it's very important to understand that this is how indentation is used in Python. In other languages we might use, we probably don't use indentation. In fact, popular language, the C language, does not use indentation at all. But some languages, and Python is probably the trademark language for indentation in programming. So you might say that, so different people have different opinions on indentation. The general consensus is that indentation helps make the code look very presentable and very readable, and this actually is one of the facets of Python programming, is the indentation and the easy readability of it. Anyways, moving on. So what if we have multiple conditions in our code, or in our if statement block that we want to see? So let's create this list, or let's actually just copy this example that I have written over here. As you can see, what I am doing in this piece of code is I have a list X where I have this integer 50, I have two strings, cat and apple. Now I want to check a bunch of things. So I want to check if 60 is an X, and I also want to check if the string cat is an X, and I want a final sort of, like, if none of these conditions are met, I want something to happen. So how do we do that? Well, we start off our if statement block with the standard if keyword. Alright. Now if we have one more condition that we want met, then we can use the elif, which is kind of a short form for else if. So we use the elif keyword. So what Python reads is it checks this condition, then it will check this condition. And then finally we have this else keyword, and else is a keyword used in our block to tell Python that if none of our earlier expressions have been true, then do what is in the that is within the else keyword, that is indented within the else keyword. So again, we don't pass an expression for else, because else is we only reach this else statement in case all of the earlier conditions have not been met or have come to be false and not true. So let's look at this particular code example. So we have a list of 50, cat and apple, and my first expression that I'm checking is 60 in X. So this is how we check actually. So if 60 and X should be read as is 60 in the list X. So is this 60 in the list X? Well, actually no, we don't have the object 60. So this part is not executed. We move on to the next condition. Is the string cat in X? Well, actually it is. The string cat is indeed in X. So we move on to this statement block, which is within the condition that is met, which is print cat is in list X. And you will see that none of the other statement blocks will be executed because we have met our condition over here. So if I execute this, as you can see that the print statement cat is in list X is what is actually executed. And we do not execute this obviously because it is false, and we do not even check, or we do not even move on to this statement because, well, we have a condition met over here. So it's one thing that is important to note is that we can use as many elif statements to check for as many conditions that we want to check for, but it's very important that we only use, and if we are using, that we only use one else statement and only at the end of our block. Okay, so moving on. Now I'm going to show you a very neat example about how Python actually does its these condition checkings. So it's very important to note that once a condition is met, none of the other conditions are even checked for. So we do not even consider the next statements, and we directly leave this if statement block. So let's look at this example over here. Now in this example that I have over here is where I've stored the string cat in X. Now I have three conditions that I'm checking. I'm checking is 50 greater than 60. I am checking if the value of X is indeed cat, and I'm checking some random expression 1 divided by 0. This is not even a check. This is literally just checking if 1 divided by 0 is true or false. And as we know, we cannot divide anything by 0. So let's see what happens when I execute this statement. Now typically if I wrote 1 divided by 0, Python will throw me an error because 1 cannot be divided by 0. That is an erroneous statement. So let's see what happens when I do this actually. As you can see, I have a statement being printed, but I have no error even though I gave an erroneous statement in 1 divided by 0. Well, now you might ask, why is that so? Well, it's simply because I have actually never reached this condition. I have not even, Python has not bothered looking at this, because if you actually see, there is a condition previous to this over here which is met and which is true. So we move on to this block, we execute this block, and we forget about the rest of the code. So we don't actually get to this erroneous statement, which is an interesting thing and which is an example that I have shown to show you that once a condition is met in an if statement block, we do not look at any of the further conditions that are being checked. Okay, so finally I have one small topic that I would like to share with you is the conditional expressions, or the Python's ternary operator. Now this is slightly different to the if statement that we have talked about up until now, in the sense that it is not a control structure. So what this actually is more of an operator that defines some expression. So let's see what I am trying to say over here. So as you can see over here, highlighted is the syntax for what I'm trying to talk about, this ternary operator. So let's look at this example and let's see what I'm trying to do over here. So I have this variable age, alright, and this age is 26. Now X, now just read this statement. X is equal to adult if age is greater than 18, else child. Now I could have done an elaborate control structure with an if statement, then an indentation within that if statement. And then I could have written else and then another indentation, and I would have written another statement over there. But instead of that, I have used this operator to assign a particular value to the variable X. And this, what value I'm assigning to X depends on if this condition is true or false. So as you can see, the condition says is age 18, greater than 18. So if this is true, then I assign this particular string. If it is false, then I go on to the else statement and I assign this. So since age 26 is greater than 18, I should assign the string adult to X. And as you can see, if I execute this and check what is an X, you can see adult is indeed an X. So this is a very neat, a very readable, and a very it's probably a more it's a better looking way to perform simple else simple if and else statements, where you don't want to create a whole if else statement control structure block. So yeah, this was the ternary operator. Finally, we make a short note on the pass statement in Python. So the pass statement, or the pass keyword, is a place where is a placeholder of sorts. So what if I had an if statement and I'm writing a piece of code, but I don't know what to do with this if statement. So if a statement is correct, if a statement is true, but I don't know what to do if this statement was true, how do I tell Python, well, let's just keep it a hold for now, and I might put something into this block later in the future? Well, I would use the pass statement. So if I had this, say this some condition again, if I'm checking age is greater than 18, but I don't know what to do with this, I would just simply use this pass statement. And this basically does nothing. It's like a way to create a placeholder where maybe in the future I might write some sort of say a print statement or some sort of a different function or something else within this indentation. So, but in the meantime, like currently I don't have anything to place over here, so I just leave it with a pass statement. So this is a way where you can use a pass statement in if and else statements or if and else control structures. In this video, I will introduce you to the concept of iterations in Python, And we will be speaking in specific about the indefinite iteration in Python, otherwise known as the while loop. So let's look at what an iteration means. An iteration is executing the same block of code over and over, potentially many times. A programming structure that implements an iteration is called a loop. Now in programming, we have two types of iterations, definite and indefinite iterations. And in this example, we will be speaking about indefinite iterations. Indefinite iterations in Python is the while loop, where we use the while keyword to define an indefinite iteration. So let's look at the basic syntax. As you can see, this is the basic syntax where we have the while keyword followed by an expression and again the colon, and below that is something indented. Again, we encounter indentations just like in if-else statements, a set of statements where what happens here is, following the while keyword, we have this expression where this expression is evaluated in a Boolean context. Again, we check if this expression evaluates true or false. And if it is true, we execute all the statements or the statement block that is indented below this while statement. This is another example of control structure, much like if and else statement blocks, where we use a lot of indentation. So let's look at a basic example now of while loop. So let's copy this example and let's see what this does. So I have a variable n where I am assigning it a value 0. This is called an initializing process, and it's very important to note that most while loops consist of an expression which contains a variable, a control variable, which is usually initialized prior to starting the loop, and then this control variable is typically modified somewhere within the main loop body. So in this case, my control variable is n, and I am initializing it by assigning it the value 0. So let's move into the loop now. So the loop has this while keyword, as you can see, followed by an expression n lesser than or equal to 5. Now what this is an expression which is going to check if it's true or false. Is n lesser than or equal to 5? And as long as this expression is true, we will continue doing whatever is indented below this while statement. And what is below this while statement is a print statement, first of all, which says value of n is, and it basically prints the value of n in that particular iteration. And as you can see, this compound assignment where we add the value of n by 1 and we assign it back to n. So what this is, let's see what this does actually. Let's execute this and see what this does. Important to note, the value of n again is initialized at 0. So this while loop will keep going on until the value of n remains lesser than or equal to 5. So as you can see, I have the execution of this particular block of code or this while loop where I get the multiple different iterations of this print statement that you can see here. The first iteration, it says value of n is 0. Then it says value of n is 1. What I'm doing is I'm writing the value of n multiple times. And each time the value of n is written over here based on what iteration it is. So what is happening actually is that initially the value of n is 0 and I print the statement value of n is 0. Now I add the value of what is in n by 1. So now what is the value of n? So again we do this check. So after this first iteration, we come back, like once this whole block of code is executed, we again come back to this expression and we again check if this statement is true. So now that the value of n is actually 1, this statement is still true. So again we execute this, and that you can see over here, value of n is 1. Now again we add the value of n by 1, and again we go back here once this block is executed and we check if this statement is true again. And as you can see, the value of n when it's 2 is still making sure that this expression is true. And this keeps happening until the value of n is greater than 5. So once the value of n becomes 6, this condition is no longer met, and finally we do not execute this statement because this expression evaluates to false, and we do not do this anymore, and we finally leave our while loop. So let's check what the value of n is just to confirm this. As you can see, the value of n is indeed 6, and that is why we have left this while loop over here. So this is an example of a basic while loop where we check for this an expression. If it evaluates to true, we evaluate everything within it. Once this is done, we go back and we evaluate this expression again. If it is again true, we again go back and do whatever is indented within it. And we keep doing this until the expression gives us false. And interestingly, we don't necessarily have to define these control variables always. We can actually use iterables, and we will learn about iterables actually in a future video. But we can use iterables, and an example of an iterable is the list. So let's look at this list and let's look at this whole block. Alright, so I created this list A, which contains 5 objects, 1, 2, 3, 4, and 5, all integer objects. And I have another variable x, where I store the integer 1. Now, this while statement, now it might look confusing. Now, it says while A. Now, what is A? Well, A is not your typical expression where you're making sure if some condition is being met or not. But this, the way you read this is while A exists. So in the context of a list, as long as A, which is a list, contains objects within it, A is true. If it does not have any objects within it, A is false. So while A, basically what it means is while A has objects within it. And if it does have objects within it, or as long as it does, we continue executing whatever is indented within this while statement. And this while statement is a print statement. Again, we we have this value x where we're doing we're printing this is iteration number, and we pass x. So the first iteration will obviously pass x is equal to 1, and then we add x by 1, and then the second iteration should pass this is iteration number 2, and then so on. And finally, we have another statement within this block called the pop statement, where we're popping the elements of A. Now, as if you would have seen the video on lists, the pop statement removes the rightmost value from a list. So if I do a.pop, initially it will remove 5 from this list, and I will have the rest of them. Again, if I do pop, it will remove 4 from this list, and then you will have the rest of these. So let's actually see. We'll actually check what's left in this list each time we do this pop statement. So I'll also print the list A during each iteration, and let's see what happens over here. As you can see, what is happening out here is while A has elements, we are going to continue doing this while statement, whatever is within it. So in the first iteration, obviously we have all of it, and it is iteration number 1. And as you can see, the list contains everything. Then I pop it. Then iteration number 2, it again has elements, but it has lost its rightmost element. And this keeps on happening until the list finally has no elements left. And once the list has no elements left, this expression while A evaluates to false, and we do not execute this anymore, and we leave the while loop. And again, let's check what is in A. A should have no elements. As you can see, it's an empty list. When I checked what's in A, it's an empty list, and that is why while A returned me a false, and we did not print any further. So this is an example of using a while statement using lists. And of course, the next topic would be discussing nested while loops. And this is a broad topic. What I mean by this is that when I'm saying nested while loops, I'm actually talking about nested control structures. So we can have while loops within while loops. Not only that, we can have if and else statements within while loops. We can have while loops within if and else statements, and we can have if and else statements within if and else statements. So if you think of all of these loops, and we will even speak about for loops in another video. For loops again are a type of control structure. So all of these are control structures. While loops are control structures. For loops are control structures. If and else statements are control structures. All of these are control structures, and nesting can happen within them, and it does not matter which is the parent of the nest and then the child of the nest. You can have a while loop within an if and else statement. You can have for loops within a while loop. All of this is valid in Python, and it's one of the great features of Python that is very flexible in this way. So let's look at an example where I have a while loop within another while loop. So I'm copying this piece of code where I have this list 1, 2, 3, 4, 5, and another list first and second. Now my first while loop, I print what is popped from A. So I take A, then I pop the 0th index. So basically from the left hand side, and I print what is that. Alright. And then I have another while loop where I have this list B, and I'm doing the same thing. But this while loop is within the first while loop, and let's see what happens out here. So as you can see, my first iteration of this parent while loop causes me to pop what is the first element, which is 1. Then I do these while loops, and this is completely executed, and only then do I go back to this first one, and then I come back and do all of this again. Then I go back to this one, and then I come back and do all of this again. And that's why you can see this repetition. So I have this first iteration, and then I do the second while loop. Then I have the second iteration, and then I do the second while loop, and I keep doing this. And this is an example of a nested while loop. Okay, so our next topic in this video would be break and continue statements. Now, break and continue statements are ways to abruptly end iterations in a particular loop. You can use break and continue statements not only in while loops, but you can use it also in for loops. So let's look at how we use it in while loops. And let's look at what we mean by break and continue statements first of all. Well, the break statement terminates the loop entirely. So once the break statement is found, the complete while loop that we are using is completely terminated. And the continue statement, on the other hand, terminates only the current loop iteration, and it goes back to the beginning or the expression, and it checks whether the expression or the controlling expression is again reevaluated, and it is checked whether the loop will execute again or terminate. This pictorial that you can see here actually emphasizes, or it shows the difference between break and continue. So I have this while loop and I have an expression. Alright, I have a bunch of statements and I have a break command over here and I have a continue command over here. So if I encounter the break command, it will not execute any of this. In fact, it will not execute this while statement at all, and it will move on to the next piece of code that we have. But a continue statement, if a continuous statement is encountered in a while loop, will not completely break away, but it will not execute the rest of the statements in that iteration, only these two, but it will go back here, it will check this expression again, and again we will do this all over again. So this is this small difference between the break and continue statements, but both are used to abruptly end an iteration in a loop. So let's look at an example of how we use the break statement. So I will use this example where I have initialized some controlling variable n to 0. My first loop will check whether n is less than or equal to 5. If this is true, then I will print this statement. Then what I'm doing over here is I am incrementing it by 1. Now in my earlier example using the similar example, I had no, this part was not there. So what you got was, I was printing the value of n. So it was printing as value of n is 0 and then 1 and then 2 and then 3, 4 and 5. But over here I've included I've nested an if statement, and within that I put a break statement. And this if statement is checking if n is equal to 2. So once n is 2, I move on to this and I do the break statement. So let's see what happens now. As you can see, so when I've executed this, I don't get the whole value of n is 0 and then 1 and then 2, 3, 4, 5. I stop at 1, and that is because once n is equal to 2, I actually do not execute this while loop again. I do not go back and execute print value of n is 2 now. In fact, I break from this whole while loop, and my while loop terminates right then and there. And that's why you only get these two iterations, value of n is 0 and then value of n is 1. Okay, so now I'm going to show you a neat example of what happens, or what is the difference between a break and a continue statement. Okay. So let's go back to our initial example where we're printing this value of n is 0, 1, 2, 3, 4 and so on. But I've added one more statement where I print hello at each iteration. So let's see what happens when I do this. As you can see, it will print hello after each of whatever I was doing already. Now let's introduce our break statement first of all. So when I do break, well, let's go back to this if statement. If we check this condition, then we break. Let's see what happens now. As you can see, something interesting has happened where we have this first iteration completely being executed, but the second iteration kind of stops where there's no hello, and that is because we have broken from this while loop before the second iteration's hello was printed. Let's see the difference between a break and continue now. So now I have this continue statement instead of a break. Let's see what happens here. As you can see, it seems familiar to our first example where we did not have any break or continue. But there is a small difference that I want you to catch, and that is very important about this continue statement. So as you can see, the first iteration has value of n is 0 and then hello. Then value of n is 1, but there is no hello. And this is because once this condition is actually met, we do not move on to this statement, but we go back to this expression and we evaluate this expression. And then once we evaluate this expression again and it's found to be correct, we do everything the same again where we print hello. But except for that one step where this if statement was met and we did continue, and this following statement was not executed. And that happens only for one iteration, and that is when n is equal to 2. And as you can see, that is what happens over here. In one of the iterations, we miss a hello, and that is the difference of the continue statement between, that is the difference of the continue statement with the break statement. This video will be an extension to that topic where we will be looking at 3 examples where we are using while loops along with other stuff like say if and else statements. So our first example will be where we calculate the factorial of a number. In this example, as you can see here, we are first going to ask the user to enter a particular number for us. Now this number is supposed to be an integer. Once we have this integer, we store it to a variable called number. Now we have this, you can say this variable called FAC which stores 1, and we will see how we are using it later. Now we know that the factorial of 0 is 1. That's how it's just defined. So we have an if statement checking whether our entered number is 0, and if it is 0, we say that the result is 1 or the factorial is 1. However, if we enter a number that is greater than 0, we must calculate the factorial for this number, and that is what we are going to do in this else statement block over here. Now in this else statement block, we have a while loop. In this while loop, the condition is checking while number is greater than or equal to 1. So as long as this condition is true, everything within that while loop will be executed. So as long as number is greater than or equal to 1, we are going to execute these 2 lines. Now what do these 2 lines do? Let us see. So the first line takes the variable FAC where we had the number 1 stored, and we are going to store FAC times number into it, number being the number that we have inputted. So in case, for example, we entered 8, then what this line will do is 1 into 8, and it will store that back into FAC. Now once that is done, we move on to the next line where we are decrementing the number variable by 1. So if we have stored 8 or we have entered 8 into our input, it will become 7. Now as we know, 7 is still greater than or equal to 1, so this condition is still being met. And then we do this process again where we are going to multiply FAC. This time FAC stores the value 8, and we multiply it times the new number, which is 7 now. So we do 8 into 7, and then again we decrement this. Also once we do 8 into 7, we store it back into FAC. And we keep doing this where we keep multiplying 8 times 7, and then we decrement the number variable by 1, and then we check this condition again. So what ends up happening is we are going to keep doing 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. And once we are at 1, again when we do this decrement operation, the number variable will store the value 0, and then this condition will no longer be met. So number will be 0 and this condition will be false, and we can move out of this while loop. And then finally we store the result into a variable called result, which stores the result of 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is of course if we did enter 8 when we were asked to give an input. So let's see this in real time once we execute this. So I'm executing this. The first thing it asks me is to enter a number. So let's say I enter my number 8, as I was speaking about 8. Alright, now that I have entered 8, as you can see, the result that it gives me is factorial of 8 is 40320, which is correct, and you can check this for yourself where it will show you 8 times 7 or 8 factorial is basically this number. Okay, so now in our next example, we will be looking at how we can generate Fibonacci numbers. For this example, we will be using bunch of if and else if statements along with a while loop. So let's look at this piece of code where we are actually doing this. So as you can see, the first part of the code is basically an input statement asking us how many Fibonacci numbers we would like to generate, and then the user would be asked to give an input which is stored as an int into a variable count. Now in this if-else statement, the first if statement checks whether what we have entered is 0, in which case we just store an empty array in the variable called fib. Next, if our entered integer is 1, we just store the value 1 in this array called fib. If our entered number is 2, we store 1 and 1 in the array fib. All of these are different sets of Fibonacci sequences. This obviously an empty array shows that, well, there is no numbers to be generated in this sequence. If we have 1, we just print the first number of the Fibonacci sequence, which is 1 itself. If it is 2, we print the first 2 numbers, which is 1 and 1. Now, the actual calculations happen when we say we want a Fibonacci sequence for more than 2 numbers. Now in that case, we move on to this block. In this statement block, we initialize the fib variable with the first 2 Fibonacci numbers 1 and 1, and we store in this array. Now we are going to do a while loop within this, and in this while loop we're going to keep executing this statement block as long as this condition is met or this condition is true. And what this condition is it's checking this variable I, which we have initialized as 1 over here, and we're going to check whether that is lesser than count minus 1, count being the number that we have been asked to input. If the statement is true, and as long as the statement is true, we will be executing this statement block, which is basically us appending this expression into the array fib. Now what this expression is basically, it's going to keep adding each subsequent numbers, and we're going to store each subsequent numbers back into the array fib. So in this case, if you see, what the first step will do is it will take the value at the first position of the array fib, and it will add it to the value at the 0th position of the array fib. And both of these values, since they are 1 and 1, when we add them, we get 2, and we append that to fib. So now our fib will look like 1, 1, 2. Then we increment this by 1, and what we do is we do the same process again. So in the next step, what we would do is we would do 2 plus 1. So we would get 3. Now this would keep going on until this condition is met, or basically until the numbers that we actually want to generate in our sequence. So let's execute this, and let's see an example of what happens. So it asks me how many Fibonacci numbers I would like to generate, and I will say I want the first, let's say 6 Fibonacci numbers. So I execute this. As you can see, this gives me the first 6 numbers in the sequence, which is 1 and 1, and then 2, which is basically 1 plus 1, and then 3, which is 1 plus 2, and then 5, which is 2 plus 3, 8, which is 3 plus 5. So if we wanted more numbers, we would just enter over here. Like say if we wanted the first 10 numbers, it would give us the first 10 numbers in the sequence, as you can see here. Now in our next example, what we are going to do is we're going to write a program which takes 2 digits that represent the dimensions of an array. For example, if we want a 3 by 3 array, we will enter 3, 3, and we are going to generate a 2-dimensional array in which each of the elements of the array are basically the row times the column position of that particular element. And what I mean by this is, say we have a position I, j on the array. The value of the element at that position would be I times j. So for example, if I'm looking at something at the 3rd row and the 5th column, or say the 3rd row and the 3rd column, for example, the value of the element would be 3 times 3. And if I'm looking at something at the 2nd row and the 4th column, I am going to do 2 times 4. So let's see how we can do this using code. So if you look to the right over here, I have a piece of code where I'm going to where it asks me to input 2 numbers, 2 integers, to represent the dimensions of my my sample array. Now once we have done this, we are going to store these dimensions in the inputs in a variable called input string. So obviously when we enter say 5, 5, that will be stored as an int in this particular string or this variable. What we want is, we want 5, say we entered 5, 5, we want 5 as a separate integer and the other 5 as another separate integer. And that is what we do in this particular statement, where we're going to split up our input string based on the comma separator, and we're going to store the first part of that string into the 0th position of dimensions, which is an array, and the next dimension in the first position in this particular array. Now we're going to store the number of rows as row number, and that is the 0th position of this array, and we're going to store the number of columns as the first position of dimensions, or whatever we've mentioned in the input. So now we have this our results array called multi-list, which is basically what our final array is going to look like, and we're going to store into multi-list. And in this example, we will be using for loops to do this, or to create this particular array. So as you can see here, our first, we have initialized our multi-list saying that we're going to have only zeros in our sample array. So initially, once we have initialized this array, all multi-list will contain is a, say for example, we have inputted a 5 by 5 array. It will have basically a 5 by 5 array with all elements as 0. And that's what this line does. Once we have done this, we are going to move on to the for loop portion where we are actually going to create our array that we want. So as you can see, our first for loop is going to say for row in range row number. So obviously range will generate an iterator which can be iterated over, and since it says range row number and say the number of rows that we entered were 5, what it's going to do is it's going to create an iterator containing the value 0, 1, 2, 3 and 4. So for row and range, it will basically row will take the value 0, 1, 2, 3 and 4. And a similar thing is going to happen in this nested for loop, which is within this, where we're going to again create an iterator using this range function and for the column number. Once we have this, we're going to do the simple process of multiplying the value of the element based on its position. So if it's at the position 3, 4, we're going to store the value 3 times 4 into that particular position of the array. And we're going to do this for every position, which is what happens in these two for loops. We're going to first go by each row, and then within that we're going to check each column, and we're going to perform these calculations. And finally we print our result. So let's look at an example. Now I'm going to say I want a 3 by, let's say a 2 by 4 matrix. So let's see what the results will be when I give this as, so what I'm saying is I want 2 rows and 4 columns. Now as you can see here, it might not be very clear to you right now, but what you can see here is this is the first row and this is the second row, and each row contains 4 columns. So this is my final array that I get. So what you can see here is this is the 0th position, and or you can say this is the first row, first column, first row, second column. And since Python is 0 based, so this is actually the 0th row and this is the first row. So as you can see, this value basically is 0 times 1. This value is 0 times 2, 0 times 3, 0 times 4. And over here it is 1 times 0, 1 times 1, 1 times 2, 1 times 3. So similarly, if I did, for example, a 5 by 5 matrix, what you will get is 5 rows now, 5 rows and 5 columns. And for example, like this particular value is 1, 2, 3, or 0, 1, 2, 3. So 0, 1, 2, 3 and the first column. So this is 3 times 1. If I took this value, this is like the 4th row, for example. 4th row times the 0, 1, 2, 3, third column. So this would be 4 times 3, which is 12. So, and each value of this has been generated in the similar process. So this is an example of how we can use for loops for a particular exercise that I have shown you right now. In this video, we will be covering the topic of definite iterations using for loops in Python. So starting off, we know that there are two types of iterations in programming, definite and indefinite. We have already covered indefinite iterations in the form of while loops. Definite iterations, on the other hand, are done using the keyword for, and the basic syntax or the standard syntax for a basic for loop in Python is as you can see over here. We have this for keyword, we have some variable, we have the in keyword, and we have this iterable, and we of course define this control structure with the colon, and then indented we have this statement block. So once this for loop has started, we execute all of these statements within the statement block as part of the for loop iteration. So yeah, let's to understand like how for loops work exactly, let's look at the concept or meaning behind what we call iterables and iterators. So think of it in a stepwise manner. Alright, so in Python we have different objects that can be used as iterables, and an iterable is basically some object that it's a collection of other objects. So think of your lists, think of dictionaries and sets. So all of these are essentially collections of objects. So once we have these collection of objects, we can create an iterator out of it. How do we do that? Is we use the iter function. So for example, if I passed this list A through the iter function and I store it in some variable iter underscore A, and I see what is iter underscore A, it is actually a list iterator at some random memory location which we don't really care about. Similarly, if I gave a tuple and I did the same thing, I will create a tuple iterator. And in the left, if you can see over here, I've done the exact same functions with sets and dictionaries as well. So I'm creating iterators out of these iterables, so as to speak. Now, what is an iterator? Well, an iterator is an object that yields values successively. So if my list contained 5 values or 5 objects, an iterator of this list will yield these values one after the other. And that is kind of how, or that is the basis for which we do, we create loops. Let's see what we exactly mean using this, using another function that we call the next function. So the next function keeps moving from object to object within an iterator. So since I've created this list iterator, let's just do it once again. So as you can see, I've created this list iterator iter_a. Now with this iter_a, what I'm going to do is I'm going to use this next function. What next function does is, starting from the leftmost object within this iterator, I will keep yielding, or I keep producing the values. So let's just see what happens when I do next when I do next for this particular variable. It gives me this object first. Now let's see what happens when I do it again. Now it gives me the object second. What if I did it again? It gives me third. Now if I kept doing this, it will keep giving me the different objects that were initially stored in A. That is first, and then second, third, fourth, and fifth, one after the other. So let's actually perform that. Now I get fourth, now I get fifth. Now a natural question is, now that I've exhausted all of these values, what will happen if I perform the next function again? Well, let's see what happens. I get an error, and this error is the stop iteration function error, which basically is telling me, look, you have exhausted all of the objects that were initially present in this list A, and you cannot keep doing the next function anymore. You cannot keep going further. So yeah, so this is what the next function does when it comes to the concept of iterators. Alright, so now we've learned two things. What is an iterator, and how do we create an iterator out of different collections of objects like a list or a tuple. And we've also learned how to use the next function. Now let's let's come back to our for loop that we started off this video with. So our for loop again, let's consider our for loop over here. As you can see, some for loop with the objects again 1, 2, 3, 4, and 5. Alright, this is a list. Now I'm going to do for x in A, print x. And let's try to see what happens when we do this. Okay, as you can see, when I have executed this, it gives me 1, 2, 3, 4, and 5. So first of all, let's look at this for loop. In this for loop, I define a new variable x, and then I say for x in A, print x. And what's happening? Well, in each iteration, I'm printing whatever the value of x is at present. So in the first iteration, it is the first object 1. In the second iteration, it is the second object 2. Then 3, 4, 5. And then finally, on its own, this for loop knows that, okay, now once I have exhausted all of the objects within my iterator, I can stop doing this for loop and I can move on with the rest of the code. Alright. So think of it like a 3-step process, a for loop in Python. The first step is it calls an iter function to obtain an iterator for whatever we pass over here, this iterable. Second step, it calls the next function repeatedly in each iteration. Alright, to keep getting the next item from the iterator. So it gets 1, then it calls next, then it gets 2, then it calls next, and it gets 3, and then 4, and then 5, and so on. And then finally the third step is the termination step, is when after we do the final next, where we get this error, as you can see, the stop iteration error or exception. Finally, this tells the for loop function or the for loop that, okay, we have reached the end of our definite iteration or the end of our definite for loop, and this is where we must terminate our loop and then continue with the rest of the code. Alright, so this is how a for loop works in Python. Now it's very important to note that whatever we have discussed when it came to while loops, such as nesting of while loops and nesting of other control structures, is also applicable in the case of for loops. So if I had a for loop within another for loop, that is perfectly fine. If I had a while within a for loop, that is perfectly fine. So all of these are valid statement blocks that we can do. And again, for loop is another control structure, and so we must follow the concept of indentation when it comes to writing our statement blocks within a for loop. Okay, so now I'm going to speak about, in specific, I'm going to speak about something called the range function. That is quite, you could say it's used in other areas of programming, but it's widely used in Python. I mean the for loop in Python. What I mean by this is that this range function is very important for the for loop, and we will see why. Okay, so let's look at one of the examples of using the range function. So what does the range function do is, if I give range 5, let's see what it does. It gives me range 0 to 5. What this basically tells me is that this will create an iterator that contains integers from 0 to 5. So it will contain the object 0, 1, 2, 3, 4, and 5. And we can use this as an iterator. So let's look at this. I have range 5. Let's store this in X. Okay. Now let's do a type just to see what happens when we do type X. It should give me the type of range, as you can see. And this is a type of an iterator in Python. Now let's see what happens when I do for I in X print I. Okay. Let's see what happens. As you can see, it prints the number 0, 1, 2, 3, 4. An important caveat when it comes to the range function is when we say range 5, it creates an iterator from 0 to 5, but it contains the objects 0, 1, 2, 3, and 4 only. It does not contain the object 5 itself. Okay, this is something that is very important too. So once again, I use this range function to create an iterator of 5 objects from 0 to 4, 0, 1, 2, 3, and 4. I use that in my for loop, and that is what you are seeing here. Now let's use this range function in the context of something else. For example, let's see. So I had my earlier list A, right? Look at my list A here. So you can see list A contains these 1, 2, 3, 4, 5 objects. Okay. Let's see what length of A is. Length of A is 5. Okay. Let's use the range function on top of the length of this list A. And this is like, I can't show you an example right now without any context, but this form of using a for loop is widely used in Python programming. You will use it so much in data science. You will use so much in machine learning and AI. I cannot tell you. This is a very important, like, sort of for loop expression. So you have for, let's say, I in range len A. Let's see what's going on here. First I do length of A. That gives me 5. Then I do range of 5. That creates an iterator between 0 and 4, right? When you do range 5, it gives you an iterator of 0, 1, 2, 3, and 4, as we saw earlier. And this is what we're doing over here. We have created an iterator out of the length of a list. Now when I do print I, it should give me again 1, 2, 3, 4. 0, 1, 2, 3, 4, of course. So as you can see here, it will give me 0, 1, 2, 3, 4. And this is a very neat way of using the range function on top of the length of a particular collection of objects. In this case, we're using the list A. This is something that you will use a lot. So I would recommend that you get used to this form of creating a for loop as well, using the range function. Also, of course, you can use break and continue statements as you have in the case of while loops. It works exactly the same in the case of for loops, wherein the break statement will abruptly stop the for loop completely and we will move on to the next piece of code, whereas the continue statement will break that particular iteration and then we will resume with the next iteration. So yeah, that was break and continue statements in for loops. Finally, I would like to show you something about how to use dictionaries as an iterator or as an iterable when it comes to for loops. So let's create our dictionary. Let's go. We have a dictionary already here. In fact, let's create this dictionary. Again, we'll store it in A. Okay. So I created this dictionary A. All right. So I have dictionary A. What I'm going to do is I'm going to pass it through the iter function, as you can see. And now I'm going to just, for the sake of showing you, I'll show you that it is actually an iterator of type of a specific dict key iterator type. All right. So now let's do something on this. So as you can see in the dictionary, I have the key first that has the value 1. I have the key second that has the value 2. I have the key third that has the value 3, and then fourth for 4, fifth for 5. Now, a good question would be, when I do iteration or when I do a for loop on top of this A, well, what is it going to pick up? Is it going to pick up first? Is it going to pick up the keys like these? Or is it going to pick up the values? Or is it going to go one by one? Key and then value and then key and the subsequent value. Let's see what actually happens. So let's do for I in iter underscore A print Hi, let's see what is the iterations happening upon using this. So as you can see, we're using the keys. So by default, when we do this, when we create an iterator out of a dictionary, we use only the keys as our iterator elements or iterator values. But of course, like if you wanted to use values, all you would have to do is pass a dot values over here. And if you remember from a dictionary video, this a dot values gives us a list of, or it gives us essentially a list of the values in our dictionary. So when we pass this to the iterator, iter function, and we create an iterator out of it, let's see what happens over here. Now let's see what is iter underscore a. You can actually see it's now the dict value iterator at a particular memory location. So it's not the dict key as we saw earlier, it's a dict value iterator. So now that we have this dictionary value iterator, now let's print what are our iterator elements. And as you can see, now we are printing values and not the keys. So this is how to, this is basically two different ways of iterating through a dictionary, one through keys and one through values. In this video, we will be doing a small exercise on if statements. Now in the previous video, you might have already seen some of the basic concepts surrounding if statements. However, in this video, just to drive home the point or the purpose of an if statement, we will be doing a small exercise. So let's first revise some of the concepts of an if statement. So a basic if statement can be something like this. We have a small condition where we're checking if a variable x is greater than 5 or not. And if it is greater than x, we print a statement over here. So if this condition is met, we print this statement. Else, we move to this statement block. Now our variable x has the value 5. Now since x is not greater than 5, what this will do is, it will check this statement, and since this will be false, we skip this statement block and move on to this statement. So as you can see here. Similarly, we can do something where we are checking multiple statements. We use the elif statement in such a case. So now in this block, we are checking in one of the conditions we're checking is if x is equal to 5 or if x is greater than 5. And then finally, if both of these conditions are not met, we say else and we print whatever, or we do whatever is in this particular statement block, which is a simple print statement. So as you can see, x is indeed equal to 5. So this is the block that will get executed, as you can see here. Now another example are nested if statements. So nested if-else statements are if-else statements within if-else statements. So let's look at an example. As you can see here, we have a string stored in a variable called orange quality, and the string is fresh. Now we have an integer, or a float in this case, 4.0, stored in orange price. Now our first statement is checking whether orange quality, the variable orange quality, is it equal to the string fresh. Now within that, if this statement or if this condition is met, we do another check where we're checking what is the price. Is it lesser than 5? If it is, we do this block. Else, we execute this block. Finally, if our initial statement or initial condition is not met, we move on to this else block. Now when I execute this, what should happen is I will enter this block because this is true. And finally, I will enter this block because this condition is also true. So I should have this printed. I will buy 5 dozens, as you can see here. Now let's move on to our main exercise for this video. So this was all just a revision. Now we're going to use some or all of these concepts in a sample project or a sample exercise for your further practice. So in this exercise, what we're going to do is we're going to request the user to enter a number between 1 and 20. And our code is going to check whether this number entered is an even number or an odd number. So as you can see, there are two sets of checks that we're going to do in this code. The first check is going to be whether the number that is entered is between 1 and 20 or not. And if it is not, we have to say it's an invalid number. But if it is entered between 1 and 20, we have to move on to the further checks, which is whether it is an even or an odd number. So let's see how we do that. So in this piece of code, what we start with is a print statement saying, please enter a number between 1 and 20. And then we add an input command. This input command will open a box where we can enter whatever number that we want to enter. Now we use this int keyword to make sure that whatever we have entered into the input box is stored as a int data type in the enter num variable. Once we do that, our first if statement is going to check whether the entered number is greater than or equal to 1 or lesser than equal to 20. And lesser than equal to 20. So both of these conditions have to be met. If this condition is true, then we have a valid input and this statement is printed that we have entered a valid number. And then we move on to the rest of the statement block within this if statement, which is another set of if and else if statements. If our number is not between 1 and 20, we move to this block, and this block prints that we have entered an invalid number. Now, once we have, say, entered a valid number, we move on to this block, this if else statement block. Now, what this block is checking is whether the entered number is an even number or not. Now, as we know, an even number is divisible by 2 and leaves the remainder 0 when divided by 2. So this is what this check is doing. If this check is true, that means our number is even and we get printed that our number is even. The other check or the other if statement is checking whether it's an odd number, and that means when we divide by 2, we should get the remainder 1, as you can see here, and we get printed your number is odd. So let's execute this and see what happens when we enter a number. Now it's asking me to enter a number. Let's say I enter 17. Now that I have entered 17, as you can see, it's a valid number that I have entered, and the code is telling me that my number is indeed odd. Let's look at some other. What if I entered something else here? Let's say if I enter 16 now, since it's an even number. As you can see, 16 is also a valid number as it's between 1 and 20, and my number is even, and the code checks for that. Let's see what happens when I enter an invalid number. Let's say 25. Now when I enter 25, as you can see, it says I have entered an invalid number. And in this case, what has happened is this condition itself is not met, and I have moved on to this statement block. So to give you a breakdown as to how our code has executed this, let me show you an example for the number, say 9. When I enter 9, the first check that happens, of course, is this check, whether it's a valid number or not. And since it is between 1 and 20, we move on to this block. And in this block is checking whether our number is divisible by 2 or not. And since it is not, it will leave a remainder 1, and we execute this block, which says our number is odd, as you can see here. In this video, we're going to learn about the topic called file handling. Now, file handling is basically needed because most of the times when we're handling large and different types of data in Python, or in general, we cannot store everything into a variable, and we will have to use files. Now, there are two types of files that we are going to deal with. They are binary and text files. So binary files are some of the files that most of the files that we commonly encounter, like document files, image files, video files, etc. Now, all binary files are encoded in a particular format, and they cannot be read by a normal text editor. And we would be needing certain specific softwares for specific files. Text files, on the other hand, do not have any specific encoding, and they can be opened in the normal text editor itself. And they are like XML, CSS, HTML files, and so on. Now, there are 4 main operations that we can do in Python on files. They are open, read, write, and close. There are certain other operations as well, though, like rename, delete. So some of the most basic operation that we can do is obviously creating and opening a file, and the syntax is as you can see here, where we use the open command, and we give a file name, and we give a mode, and we store that in a particular variable. Now, a mode is basically telling Python how to handle this opening. So we can have a read-only mode, which is done by this letter R, a write-only mode, which is done by letter W, and there are a bunch of other modes, such as read or write mode, which is done by R+, and we are going to see them as we encounter them. Now, it's important to note that what I just mentioned is for text files. If we are going to do, for binary files, we're going to do this file handling, then we would be using the letter B in front of whatever we were using in the case of text files. So if we were doing a read-only mode for opening a binary file, we would be using RB. And if we were doing read and write mode, read or write only mode, for a binary file, we would be using RB+. So basically just adding the B in the case of binary files. Let's look at a basic example. When we want to open a particular file, we are going to open, like in this example, I'm going to open some file called filehandling.txt in a read and write mode, read or write mode, and I'm going to store it in FO. So this is as simple as it gets. Similarly, if I wanted to do it for a binary file, since I'm using a binary file, I will use the letter B as well in the mode. And that's how you do it here. Now let's look at different ways in which we can read from a file. And there are 3 commands that we can use. We can use the read command followed by an optional number of characters. We can use the read line command followed by an optional number of characters, and the read lines command. So this optional number of characters is denoted by n over here, and basically it's telling us how many characters we want to print. So let's look at a simple example of where I'm going to print something called, so I'm going to take this and I'm going to do a print on top of this. So I've done first, I've opened it and I've stored it in my file, and then I'm going to do a method or a function called read, and I'm going to say, like in this example, just read the whole thing. So as you can see, my file that I have opened has all of these lines. This is like the whole file basically. But now what if I wanted to open only the first 5 characters of this file, which is basically this? Well, in that case, let's open this once again. Now let's do the same read command, except we will give the character number, which is 5. As you can see, it's only printed 5. Now let's do a print read command and try to read the whole thing again. And you will notice something very interesting. Now when I do the read command, you can see it's kind of picked up from where we left off from our previous command. And that is the nature of how Python handles files. So if I wanted to again take the cursor back in such an example, I will have to open this again, and then I use this read command once again to get back to where I started from, as you can see here. Now another command that we can use is the read line command. So let's once again open this over here, and now we're going to use the read line command over here. So what read line command is going to do is going to, each time we use this command, it's going to go one by one and read each particular line from this file. So in first case, it will take artificial intelligence, then data science, big data, and so on. So as you can see, if I execute this, it first takes artificial intelligence. Now if I did this command again, it will say data science. Next time if I do it, it should say big data, as you can see here. Okay. So this is the read line command. Now within the read line command also we can enter characters, and that will tell us basically that we want these number of characters from the next line. So if I want the first 6 characters of the next line, I will say 6, I will enter 6 here, and it will give me the first 6 characters of this particular line, which is the next line that is to come, as you can see here. Now another way in which we can print whatever is there in our file line by line is by using a for loop. So again, I'm going to open this file, I'm going to store it here. Now I'm going to use a for loop saying that, well, for line in my file. And what this does is basically at each iteration, it's going to take each line and store it in this variable that we enter over here, which is called line itself. And we're going to print that. At the end of the loop, what we'll have is all of the lines have been printed one by one. And another thing that we can do right now is, say we want to read a particular line. Say I wanted you to read the 5th line of my file. I can use this technique where I just say, okay, I'm going to store 5 in this variable called line number, and I have this another variable called current line, which I'm going to initialize with 1. And what I'm going to do is I'm going to do the same loop where I'm going to say for line in my line, but I'm going to add a condition saying that only if current line, when it's equal to line number, am I going to print the line, and then I'm going to break out of this whole thing. And at the end of each loop, I'm going to say current line is going to be incremented by 1 until basically these 2 variables are equal. So when I do this, I get my result, which is machine learning, which is the 5th line of whatever file I had. Now we're going to move on to the topic of image file handling. So we saw how we handled and we saw certain operations around text files. And text files are obviously something that we're going to use a lot. But we are also going to be using files such as images a lot. And let's look at certain examples and certain use cases around image file handling. So my first step is going to be importing a bunch of modules and packages. Now the details of these modules and these packages are not important as of right now because they will be covered in a future video. But just keep a note of some of these packages such as let's say NumPy and the image package. So once I've done this, let's move on to my example. So what I'm going to do is I'm going to store certain file locations in 2 variables. So it's basically 2 strings. I've attached the this prefix R to say that this is a read-only sort of a prefix. So the next topic that we're going to be handling is image file handling. Now we have already seen many examples pertaining to text files. So text files are obviously something that we're going to be using a lot. But image file handling is something very important as well, and we're going to see certain operations that we can do around image file handling. So starting off, I'm going to import a bunch of packages and modules. What these packages exactly are and what these modules exactly are right now not that important to you right now, but it's something that will be covered in a future or in future videos. It's important to just keep note of what these are, such as NumPy and image. So once I've done that, what I'm going to store is I'm going to store two particular file locations in two variables, location 1 and location 2, and I've prefixed them with R just to say that these are raw strings. So once I've done that, I'm going to use the image from the image package. I'm going to say open, and I'm going to say open from this particular location and this particular location, and I'm going to store these images in IM1 and IM2 over here, very similar to a normal text file opening. Now once we've done this, we can access certain properties of this image using, say, format, which tells us the format of the file. It identifies the source of an image, and if the image is not read from a file, it is set to none. We can also see the size of the file using the size attribute, and we can see the mode, which basically defines the number and names of the bands in the image and also contains the pixel type and depth. Certain common modes are like L for luminescence, RGB for true color images, and CMYK for pre-press images. So let's look at them. So when I access this, you can see my first file is of JPEG of this size and an RGB format image. And my second image is another JPEG, slightly bigger image, and again RGB. Now we can also, of course, display these images, and to do that, we can use the PLT. Again, PLT is supposed to stand for matplotlib.pyplot. It's a particular package that, again, you don't need to know the details of right now, but this is how we would do this. So I'm going to use a bunch of commands and methods such as figure and subplot and then IMShow. So once I have done this, as you can see, both of my images, with this being IM1, this being IM2, have been produced on the screen, as you can see. I can also use display, this display function followed by the name of the file, and this will simply display my image, as you can see here. Now I can obviously save a particular image using the save function, which is as simple as just doing this. So I'm going to save the image as im_save.jpg over here. Now if I wanted to crop an image, I can do that as well. So I stored the dimensions that I want cropped in the form of a tuple, as you can see here, and I'm going to pass that tuple to the crop function, and I'm going to apply that on top of IM1, and I'm going to store that to region. Once I've done that, as you can see, so basically what I've done is I've cropped this image based on whatever I've passed here, and I've stored it into region. And now if I wanted to see what was actually in that crop, I can just do the IMShow function, and I'm going to pass the particular cropped image, which is denoted by region, as you can see here. And you can see my cropped image is basically a left portion of this whole image has been cropped out, and I have produced it over here. Now I can also use the copy function. It's a simple basically copy. You use the copy function, and it copies an image onto another variable that you have assigned. And when I use the IMShow function, I'm going to show you the copied image, which is basically the same. Now we can do the transpose operation as well. So let's see what we have done here. So in this transpose operation, so in this basically I've done a bunch of operations such as rotating by 90 degrees, rotating by 180, rotating by 270. And finally, once I've done with all of these multiple operations, I'm going to show you the final output, which is basically a certain transposed image like this, which is basically the result of whatever I have done before this. So this is it for this video on file handling. I have shown you two slightly more comprehensive examples on text files and even certain examples on image files. However, we can use file handling in different libraries pertaining to file handling for audio files and even for stuff like PDF files. And this is just only the beginning, and I'm sure you will encounter a lot of different use cases, different examples as you continue learning Python programming. This video is going to be the first of a part of a series on object-oriented programming. So to start off with, let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I gave you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user-defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I passed, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. repr is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user-defined method. User-defined methods are so methods that we define, and these are like tasks that we define on our own. So in my user-defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also, the function of the self keyword is basically telling Python that, any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional. We don't really need it, but basically the first attribute of any method is basically what is the instance that the method is invoked upon. So if I say self, I'm telling this particular function that, okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1, and this is invoked by the print function. The print basically invokes the dunder str function, which does all of this. Now in the next line, we say print c1.getArea. So this is going to print the value of what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance, our radius is 2.1. So the getArea function should do pi times 2.1 squared. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, anytime that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1.getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1.radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a dunder method which followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods, and this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now instance, the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, well, it's something different now. So if you see, each instance basically has a different memory location in our memory, and each instance this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the @class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called myClass. I'm going to use this @class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of is called the string name my class with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class, my class in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like @class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called my instance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method. which is declared using the addStatic method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say dot hello. It should basically print hello world. That's all. In this video, we will continue that discussion on OOP with inheritance. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods. And the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization where we are supposed to enter a value for a radius that gets stored in self.radius. Now we also have a description string, which basically is a dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter the name that you want, and you enter the name of the superclass that you want the subclass to be a subclass of in parentheses right after the name. Now next, if you move on to the dunder initialization, the initialization is very familiar, except now we have another attribute for height, which has a default value of 1, just like the radius. So this basically means that we have an option of entering two different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like, this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use the print function. And finally we get on to a new method that we have defined only for the cylinder class called getVolume. Now if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method. And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3. And I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print isInstance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that well, this is what this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is just simple single inheritance. And in this example, you can see I have a class called country where I have a method that I have defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called show state, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with 2 methods defined called method 1 and method 2. In method 1, we can pass 2 attributes, SN, SNO, or I think this is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically 2 attributes we can pass that are probably descriptors for a student. And in the next method, you have basically 2 print statements which says student number, and then they will print the student number, and it will also print the student name. Next we have a class called marks. This is also so these 2 classes are basically what our super classes are going to be, and we're going to derive a third class from these 2. So this second class is a class called marks, and we have 2 methods again. One method is called set marks, which has the option of putting in 2 attributes, M1 and M2, both representative of the 2 marks, and we store them in self.mark1, self.mark2. The second method is put marks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called result, which derives from 2 classes, marks and student, as you can see here. In my parentheses, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have 2 methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and then I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I have created an instance of this derived class called result. I'm storing it in R. Then I'm going to access method 1, which is obviously a method from the first superclass called student. And I'm going to store, okay, so his name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do our set marks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first two subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2. And then finally, we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I had written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined two methods called set stud and put stud, or you can call it set student and put student. In my first method, I have two options of adding two attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called set marks, where I'm going to again get the option of adding two integers for M1 and M2, which is going to represent mark 1 and mark 2. And finally, I have put marks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and put total. Calc will calculate the total as we had seen earlier, and put total will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do basically, we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2. And finally, we're going to display the total marks. So let's execute this. And if you see, it's basically the similar operation that we did earlier. But the only difference is, in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance. Whereas in this example, the result class derives from marks, and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately, we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1, where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1. And I'm going to say, after that, I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3. And this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3, and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2 I mean, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3, so I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is a display method. It will display the values of x and y, and since I've done this twice from 2 different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much, that this is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the third class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called setStudent. Again, 2 attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called putStudent. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called setMarks, where we can pass 2 attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a putMarks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. And what it does is it has 2 methods, get practical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for put practical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you see, notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark p1. And we have a put total method, which is basically going to print us the total. So now we're going to create an instance of this result. And through this instance of result, we're going to first invoke the parent class method called setStudent, which is the second level parent, basically the student class setStudent method. So we're going to setStudent here. We're going to say 60 is the student ID and name is Ash. Then we have setMarks, which is again the second level parent, which is a student class, where we set the marks. Finally, we access this get practical. Now, if you notice, get practical is part of the practical superclass. So in this, we store the third subject of the practical marks 100. Then we calculate the total and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. In this video, we will continue our discussion on object-oriented programming with the topic of polymorphism. Now, the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example where we're able to use the plus operator for different operations is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now for example, what I'm going to show you here is an example where I have a method called sum. Now by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two digits, two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called an instance called OD for the class overload demo, and I have what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now if you see here, I have not passed a third argument. So what this method is going to do is it's going to take the value of C as 0 by default. So it's basically going to do 7 plus 8, and it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give three arguments, 7, 8 and 9. So now C will be replaced by 9 instead of 0, and then I'm going to get the sum of 7, 8 and 9. So in this is not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute C have a default value of 0, I have induced some form of polymorphism through method overloading. Now the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define. The initializer is two attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we're going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to so it's also going to have an initializer, and this constructor will basically what this initializer will have is it'll have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called ID in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store two attributes x and y in self.x and y, and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also want it to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator or the special method to provide functionality for the plus operator in Python is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we're going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point and I have the same initializer when I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method. And similarly, we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffix with 2 underscores, and they're also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point. I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator where I'm going to basically allow the this asterisk operator to multiply two objects from, like, for example 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance P1, 12, and I'm going to multiply it with the attribute 5 from instance P2 whenever I say P1 times P2 or P1 asterisk P2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object1.name, and it will say earns more than object2.name if in case object1 is indeed greater than object2. So when I execute this, you can see here, my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object1 is not greater than object2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. In this video, we will be taking a brief introduction into what is a function. So a function in Python is a group of related statements that performs a specific task or tasks. Now, functions help break our program into smaller and modular pieces of code. And it's very good and very convenient to use functions to make our code organized and manageable, especially as our overall program grows larger. It also helps us to avoid repetition and makes the code reusable. So let's look at the basic way of defining a function. So this is a basic function that I'm calling fun_name. Alright. Now the rest of the function, or whatever the task is going to be performed by this function, will be written over here with an indent, of course, as a standard when it comes to Python. So I'm going to define this one something in double quotes. So don't worry about what this is right now. This is a doc string. Don't worry about what this means, and I'll explain it to you just in a short bit. Alright. Now the rest of the statement, the rest of it will obviously be what this function will do. Let's include a simple print statement. Alright. Let's done here. And let's call this. So of course, now once you define the statement function, to call the function, you just have to use its name like this. This is how you call a function. So as you can see, when I call this function, it should print the statement hello. Now let's look at some of the like what happened over here. So we've used the keyword def to define a function. We give it a unique name, which makes it with which we uniquely identify this function. And also, once we've done this, we can give this function a particular header. It's called a doc string. So what this doc string is basically something that we include in triple quotes over here, just after the def keyword. And this is like a brief. We can use this to give a brief give brief information into what our function is doing. So we can say this is this function performs addition, this performs subtraction, or whatever, like some basic information as to what our function does. So we can use a doc string for that. Of course, this is an optional thing. This does not have to be, we don't have to include this as well. Alright. But for the sake of this, let's just keep it here. After that, of course, rest of the function will contain whatever task we want to do with it, and that will be indented. Finally, we can also include a return keyword. And what the return keyword does is, at any point you find the return keyword in a function, you immediately leave the function and you go back to where this function was called. Okay. So now let's see. Now there's also one more important component of defining a function, and that's parameter. Now if you've noticed over here, within these parentheses, I did not include anything. This is like an empty parenthesis, opening and closing. What if I said if I included some a and b over here? So what this means is, whenever I call this function, I need to pass two parameters, a and b. These can be like strings or numbers or whatever. But now it becomes almost mandatory that I pass these two things for my function to work. So let's define a function where I'm going to add a and b. So instead of this print statement, let's do this. I create a variable c, and in that I'm storing a plus b. Alright. And then I return c. So you can use a return, and you can return certain like variables along with the return statement. So I'm saying not only return from this function, but also give an output or return an output called c, which is the addition of a and b. Now how do we use this? Well, now instead of just calling the function like this, I'm going to include parameters. So I'm saying pass 2 and 3 to function name, where 2 will take the place of A and 3 will take the place of B. Alright, what will happen now is addition will take place and we will get returned the result. So let's see what happens now. As you can see, 2 plus 3, and I got the addition of 2 plus 3, and it returned me 5. So yeah, this was like a basic usage of a function and parameters. So of course, we can, if you want to know like what the docstring of a particular function does or says, you can use this statement. So let's say it's very important to like just keep a note in your while you're going through this or while you're learning that whenever we use some sort of a function which has double underscore, right? This is like a built-in command provided by Python within the Python library itself. So these are like built-in commands to check certain details. So I want to check what is the docstring, and this is how I do it. So let's do print. Let's print what is the docstring over here. This is a docstring. So this is basically what I wrote over here. I can change this to this, like this does addition, for example. All right. Now this will say this does addition when I execute this line. So this is the way to check what is a docstring. Anyways, so now that you have seen a basic function or two basic functions that I defined for you and how we use them, what a parameter is, let's look at another concept that we call scope and lifetime of variables. So scope of a variable is the portion of the program where the variable is recognized. All right. Now a parameter and a variable that are defined inside a function are not visible from outside the function. This is a very key thing. So if we define something within the function, we can only use it within this function, and we cannot use it once the function has already been executed, so as to speak. These variables and these parameters have what we call as local scope, since they are only recognized within a particular function. Now the lifetime of a variable is the period throughout which the variable exists in the memory itself. And it's very important to note that lifetime of variables that are defined inside a function are as long as the function executes. Once we return from a function, whatever we have defined within it are destroyed. So when we use a function, it will not remember the values of a variable from a previous iteration of a function call. So let's try to understand this example or this concept using certain examples. So out here I have defined a function where I'm going to create a variable my underscore var, my variable, and I am going to store the value 10 in this, and then I'm going to print. So whenever I call this function, I will always create this variable, I will store 10, and I will print the value of this. Alright. Now what I'm going to do is, I'm not only going to create this my var inside this function, I'm also going to create a variable outside. So you see there, now you might be confused as to, okay, how is the behavior going to be? Because outside the function, I have created my var with a value 20, but inside the function, I will always define my var as 10. Okay. Now I'm going to print. So what I'm going to first do is, I'm going to execute this function that I created initially, where I store the value of 10 in my var, and then I'm going to print the value of my var that was present outside the function. Let's see what happens. You can see two different things happening. So when I execute this function, it prints the value inside the function as 10. But when I print the next line, which says, okay, now get the value of my var, it actually prints a value of 20. And this is a very key concept, because what's happening here is when I initially call my function, within this function, it creates a variable called my var, and it prints the value as 10. And the moment my function has been executed, it destroys this variable, and the variable which contained the value 10 is of course now destroyed, and all we have is the my var that contains 20 from the outside. And when we print that, we get its respective value as 20. So you can also think of it like this. The my var that is present inside this function is different to the my var that we create outside. So the scope of the my var within this function is local only to this function. And once the function is executed, that variable is destroyed. Alright. Now let's look at another case, or the other side of this case, where say we're dealing with variables that have a global scope. How do we deal with them? So let's create a variable called myvar. Alright. And I say I store 100 in this. Alright. Now if I define a function I've stored my var. Let's say I define a function, define underscore, say again, same name, where what I'm going to do in this is I am going to print the value of whatever is there in my var. Okay, so let's do print value of variable is value stored in variable is. Okay, that's my var. So let's see what happens when we do this. Let's call this function fun underscore name. See what happens here. So as you can see, the value, I stored a value 100 in my var and I've called it inside the function. And this is because since I've defined it outside, I can use it inside as well. Now what if I try to change the value of this variable inside the function though? So let's see. If I did this, and now if I try to print, let's see, is this allowed? No, it's not allowed. In fact, I get an error. It says local variable myvar reference before assignment. And without going too much into detail, what it's saying is that the variable inside over here is still local to this function. And I have not defined this myvar as a global variable. So I cannot make changes to it within this function right now. And to change that, I can use the global keyword. What if I did global over here? So if I did global, and now if I said, okay, global myvar, and I declare this variable as a global variable. Now if I do this, now if I do the same incrementation, now let's see what happens when I'm trying to do this. You see, I get the value 101. This is exactly what I wanted. And that is because I've defined my variable to be a global variable within this function. So I can, in fact, make changes to it within this function. So this is how we use the global keyword and global variable. Also, just to make a quick note, there are three types of functions. The three types of categories in which we can divide functions. First one being built-in functions. These are the ones that are built into the standard library of Python. The other is user-defined functions. That is the ones which we define ourselves. And the third type is called anonymous functions. They're also known as lambda functions, and this is something that we're going to cover in a separate video. Now let's talk about the arguments that we pass in Python. So there are four types of arguments that Python user-defined functions can take. First one being default, the other one is required, then there is keyword, and then there is variable number of arguments. So the default argument is when, say, if I defined a function where fun underscore name, and I'm saying a comma b, right? But what if the user has not, say I want a default value of a and b each time when I use this function. So in the case where if, say, I don't pass a value for a and b, like this will always be used. So I can just say a is equal to 2 by default and b is equal to 3 by default. And then within this function, I will say c is equal to a plus b and then return c. So I do this, and if I say fun underscore name, and in case I don't pass any arguments here, let's see what happens. By default, I get the answer 5 because by default a is 2 and b is 3. But this is not fixed and I can always change this by passing my own values here, 5 and 6, and in this case I should get 11, as you can see here. Now the next type is required arguments, and when we are defining a required argument, we just simply do not use the equal to sign for the parameters over here, and this basically it makes it so that now anytime we call this function, we have to pass something over here. So now if I try to pass like this, I won't get a I won't get a default value. Then that's because well, there is no default value and it needs an a and b. So I have to pass it a 3 and say 4. Now it should give me 7, as you can see. The next type of argument that we'll be talking about are the variable number of arguments. So let's look at an example here. So what I'm doing in this particular example is I'm defining a function called mySum, where I'm passing some parameter called myIntegers, and I'm doing something out here. And what this does is, it will take the values of a particular collection of objects, and that's called myIntegers. And each value, I'm going to keep adding it to each other, and I'm going to result a particular sum. I'm just going to result the sum of whatever is there. So in this case, what happens is I'm creating a list 1, 2, and 3, which contains 1, 2, and 3, and then I'm going to print the summation of whatever is there. So it should give me 6. Now, the problem in this case is that each time when I'm going to perform this function, I have to create a separate list where I'm going to store these objects. But what if I do not know what exactly I'm going to pass here? What if I don't know if it's going to be a list of objects or what is it going to be exactly? Well, in that case, I can use a variable number of arguments. So it's like a variable keyword argument. So what we use here is a specific way of passing keywords, and we do it like this. So I say define my underscore name, and I use an asterisk. Now I give it any name. This can be args, this can be integers, it doesn't really matter what this is. But this is the key, the asterisk here, and this tells us that whatever we pass here is now, we're supposed to create an iterable out of this, and then we can perform whatever task we want. So let's just, since I've already created one here, let's see how I'm going to use it in this case. So as you can see, I'm creating a particular variable argument function over here, and I'm doing the same task. I'm just going to keep performing I'm going to add whatever I pass over here. But now when I'm calling this function, I don't need to create a separate list as I did over here. I'm just passing all the numbers that I want to in the form of, like, it's pretty much like a tuple. So I'm just passing these numbers here, and what this function is going to do is going to create an iterable out of this, and then we're going to iterate over it. As you can see, that's happening over here. And I can keep, I can just keep like, so since I've done it for 1, 2, 3, and 7, the summation should be 13 in this case. I can add another number here just explicitly, just like this, and you can see the value will change. And that's because this is a variable, argument method of creating a function. Now the fourth type of function arguments is the variable keyword argument. So let's look at what is the keyword argument now. So I have defined a function here called the concatenate function, and let's see what I'm going to do with this. So in this, I have passed a keyword argument. I've said that, okay, this is going to be a keyword argument function, and what I'm going to do in this is I'm going to create a blank string, and what I'm going to do is I'm going to add or I'm going to concatenate certain strings that I'm going to pass to this function. So in this example, I have passed Python and is and cool and an exclamation mark, all separate strings, and what I'm going to do in this function is I'm going to join them together, and I'm going to create one whole string out of it. Let's see what's the result. Python is cool. So this is, so of course, like if I had to add something else, like Python is say cool, and say I just wanted to say hello and say one more string, I can add it just like this. I don't have to like define a fixed number of arguments. I can pass any number of arguments I want, and this works exactly the same as variable. In the only difference is instead of positional arguments, we're using keyword arguments over here. Hello, bye. Like this, it doesn't really make sense, but just to show you, as you can see. So this is how we use keyword arguments. In this video, we will be learning about exceptions. Exceptions are errors that are raised during the execution of a program. When an error occurs, Python generates this exception that can be handled, which avoids our program from crashing. Python has many built-in exceptions. However, we can create many user-defined errors or exceptions as well to catch whatever errors we're looking for in our program. So when an error occurs, Python interpreter raises an exception and stops the current process, and it passes it to a calling process until the exception is handled. And if this is not handled, the program will crash. Some of the built-in exceptions are like IO error, in the case when a file cannot be opened, or import error, Python cannot find the particular module being imported. And there are so many similar, exceptions that are built in Python for the appropriate cases. Now, before we move on and see how we raise these exceptions, let's look at the difference between an exception and a syntax error. So for that, I will be using an example where I will be dividing something by the number 0. Now, of course, this is not possible. So let's see how Python handles this particular problem. Well, it raises what we call a zero division error. And this is an exception that is built in Python whenever we try to divide something by 0. Now let's look at the difference between this exception and a syntax error. So this is the same statement, except I'm going to add this extra bracket, which does not make sense syntactically in this. Now if I try to execute this, as you can see, we get a different type of error known as the syntax error. And it says the unmatched closing bracket. So this is what a syntax error looks like an extra bracket or a comma that basically makes the line unreadable to the interpreter in the first place. So the interpreter doesn't even get to the point where it needs to figure out that there's something being divided by 0. It doesn't even get to that point because it finds this extra bracket and it cannot execute this line at all. So that is like the difference between an exception and a syntax error. Alright, now for our first case of how we raise or how we handle exceptions, let's look at the keyword raise. So for this example, what I will be doing is I'm going to take this variable x, alright, and I'm going to store a value 10. And what I'm going to do is I'm going to check for a condition. If x is greater than 5, then I'm going to raise this exception using the raise keyword like this. And in case this condition is met, if x is actually greater than 5, I want this particular message to play out in my exception. So let's see what happens when I execute this. As you can see, the exception is raised because x is indeed greater than 5, its value is 10, and the error message says as so that x should not exceed 5, the value of x was 10. So this is an example of how we can raise an exception. And as you can see, when a condition was met, the program comes to a halt and an exception was raised. Now let's look at another type of handling exception, where we use the assert statement. So when we use the raise command, we waited until an error occurred and our program crashed midway, right? What if we want to check if a condition is met? And if this condition is met, then the program can continue. But if the condition turns out to be false, then we want a particular error, namely the assertion error exception, to be thrown to us. So we can use the assert command in such a case. So in our example, we will be checking whether the system that we are working on is actually Linux or Windows 32. So let's see. First of all, let's import a library called sys. This is it's a library where we can access system information. One of the modules in that is one of the functions in that is the platform. It basically tells us what system are we working on. So we're working on a Win32 system. Okay. So let's use the assert keyword. All right. Now we're going to check if Linux is what we are working on, and in case it is not, then we want an error message, and this will be the error. The error will obviously be an assertion error because we are using the assert keyword. So this is how we use the assert statement. And if we execute this, as you can see, we get the assertion error because sys.platform contains Win32 and not Linux. And so we got this assertion error. So if we change this to check for Windows system, we won't have any error when we execute this, as you can see. So this is the example where we use the assert statement. Another way of handling exceptions is by using the try and except block. So this is probably one of the most common ways of handling exceptions in Python, where we use a try keyword and an except keyword. Now within the try keyword, as you can see here, we have a chunk of code which we're going to check. And if everything is fine in the try keyword, then this is perfect. So we don't need to move on to what we call the except part of the try and except block. But if say there was an error in the try block, then we move on to the except block, where we're going to run the part of the code in the case we find an error in the try block. So first we check the part of the code that is under the try block, and if there is an error, we move on to the except block and we run that part of the code over there. And in the except block, that is where we handle our whatever error that might get thrown our way in the try block. Okay, let's look at an example at how to use this technique. So I have a basic function out here. All right. It's defining a function called Linux interaction. What this is basically doing is that when I call this function, I want to do an assert check. I'm going to check if Linux is the system I'm working on, and if it is not, then I want this error to be thrown. Okay, and so yeah, let's see what happens in the case. And if this assert statement is actually passed, then we will move on to this statement. So you could look at it like this. If when I call this function, it will first check for this assert statement. In case something wrong happens and we get an assert error, then we do not move on to this line. So we only get this printed. But if this assert statement passes, then we move on to this line and we get print doing something. Okay, so let's see. Now I'm going to call this function out here. Let's see what happens here. As you can see, I get an assertion error because obviously this is a Windows system and not a Linux system, and I get this message. Okay, now let's see what happens when we use it in a try and except block. All right, so now I have a try block over here in which I am going to try this function, Linux underscore interaction. If in case I find an error, I immediately jump from the try block into the except block. Now you see the slight difference in how we handle this. Like what happens. So as you can see, when we use the function explicitly, we directly went to what we call an assertion error. But when we use a try and except block, we will not use the assertion error because we are leaving the try block immediately and we're going to go into the except block, where the only thing we're doing is printing the statement. As you can see, we are not on Linux, found some error. Okay. Now what if we wanted to catch the error within this function itself, which was the assertion error? And we can do that explicitly like this. So now what I'm doing is I'm going to try, alright, and it's going to catch an error in this, right? So now in the except block, I'm going to say the assertion error that we found in this function in the try block, we're going to use that in our except block. So as you can see, we're going to print that assertion error. It will basically print this statement: function can only run on Linux systems. As you can see here, function can only run on Linux systems. Function can only run on Linux systems. And the next part of the thing was the Linux interaction function was not executed. Okay, so this is something very important happening here. When we use this assert statement, the whole program is actually getting executed, right? But when we're using the try and except block, we are immediately jumping on, like the moment we catch an error, we are immediately jumping onto the except statement. And all the handling of the exception is done in the except block and not in the try block anymore. So we have to think of it like this, that the try block is only to check if a particular piece of code is does it have any errors or not, and in case it does, then all the handling that we do is in the except block of this particular statement. Now let's look at another example. In this example, I'm going to try opening a particular file. Now this file does not exist, so I will get a file not found error, and this is a built-in exception. And I'm going to catch that, and I'm going to print that error over here in the except block. Alright, so as you can see, file not found, and whatever error I have, I printed over here. Alright, so this is another a file not found error that we caught in our try block, and we're handling it in the except block. Now let's combine both of the examples where we use this Linux interaction and we also try to open a particular file, and we try to do both things in the try block. And since both of these contain errors, let's see what happens when we have multiple errors in a try block. So as you can see, in my try block, I'm not only doing this Linux interaction, I'm also trying to open a particular file that does not exist, obviously. So now you might think, will I get two exceptions? Well, let's see what happens when we try to execute this. So it's important to note that in our except, we have an except for catching a file not found error, and we also have an except for finding the assertion error that is part of this Linux interaction function. So since both of these are erroneous statements, they will throw exceptions. So now the question is, will we get both of these except blocks, or will we get both of these exceptions? Will we get only one of them? Will we get the first one? So let's see what happens. So as you can see, my error statement is very much like the assertion error that we had done as part of this Linux _ interaction function. Function can only run on Linux systems. The Linux function will not execute it. So as you can see, that is the one that has been caught, and for some reason the file not found error has not been caught. And this is because this is a very important feature of the try block. The moment we find the first error in our try block, we immediately leave and we do not execute any of the further statements, and we jump into the exceptions and we handle it using the except blocks. So the moment an error was found in this function, we did not execute this part of the statement and we directly jumped into the respective exception. That was the assertion error exception. So this is a key takeaway. So some of the other key takeaways when it comes to exceptions is a try clause is executed up until the point where the first exception is encountered. And in the except clause or the exception handler, we determine how the program responds to this exception. We can have multiple exceptions and we can differentiate how the program responds to each of these. And it's also very important to not use except clause on its own. It's very important not to use a bare except clause. Now finally, before we conclude this topic of exceptions, let's look at the else and the finally clause. So the else clause is used when we want to execute a particular piece of code in the case where we have no exceptions or no errors found. So let's look at this. Just like we had the Linux interaction function, I'm going to define a win underscore interaction. And this is going to check whether our system is Windows or not. In case it is not, then we get this error message. Alright. And in case it is a Windows system, we print this in the case of when we call this function. So let's again use our try and except statement. Only in this case, we will be using an extra else clause. So we first try this function. In case there's an error, we catch it as an assertion error and we print that error. But if there is no exception, then we move on to the else statement and we print this. So as you can see, our we have actually moved on to the else statement and we print this line executing the else clause. And that is because we have found no exceptions over here. So again, it's key to remember that the else clause is used whenever we want to execute a particular statement in the case where we do not find any exceptions in the try block. The finally clause is used when we want to execute something regardless of whether we have an error or an exception or not. So no matter if an exception happens, is raised, or if it's not raised, we want this finally block to always get executed. And let's look at let's look at an example of it being used. So I have this block where I'm doing a lot of things. The first thing that I'm doing is I'm going to check for this Linux interaction function, which is going to check, of course, whether it's a Linux system or not. This I'm doing the try block. Now, if I catch an error, that I want to handle it by simply printing the error over here. And in the event that there is no error, then I will move on to the else statement and I will try this particular block of my statement, which is again that where I'm trying to read a particular file that does not exist. And it's very important that you note that within the else block, I have another try and except block, and this is perfectly legal and it's perfectly valid in our program. We can do this. So think of it like this. I'm first trying this. If I have an error, then I do this and I don't execute this. But if I don't have an error, then I execute this whole statement, which contains its own try and except block. Alright. But regardless of whether I get an error here or not, I will always execute this portion of my statement or under the finally clause. So let's execute this. As you can see, of course, the error is raised in this try block. So we move on to the exception, and that is what is printed over here. And after the exception is done, we move on to the finally. We of course skip this else block because the exception was actually raised. So after that is done, we move on to the finally block where we print this particular statement. Well, that was it for an introduction into exceptions in Python. I hope you learned something from this. And of course, this is just the beginning. Exceptions are something that you would probably encounter a lot, especially when you're beginning. And it's something that you will learn to extensively work with. And that will also help you improve in your programming. In this video, we will be covering the topic of iterators. Now, an iterator in Python is an object that contains a countable number of values, or it's a larger object that contains a countable number of sub-objects. An iterator is an object that can be iterated upon, and what that means is we can traverse from each value and we can manipulate or perform certain functions or operations and tasks using each of the sub-objects or values within this larger collection called iterator. Now, when we're looking at it technically, an iterator is an object which implements the iterator protocol in Python, which consists of the methods iter and the method next. So to begin with, let's look at a simple iterator. We're going to see the example of a list where we're going to traverse through the objects of a list using the for loop. So we have objects 1, 2, 3, 4, and I'm going to print each of these values one by one, as you can see here. Similarly, we can also do the same thing for another iterable known as the string, where we can go character by character, again using the for loop, as you can see here. Another example of an iterable in Python is the dictionary. So let's say I have a dictionary where I have two values, two key value pairs. Key x, which contains the value 1, and key y, which corresponds to the value 2. Now, when I'm going to do a for loop through this, by default, I will be traversing through the keys x and y, as you can see over here. And of course, the other types of iterables in Python are like sets and tuples as well. Alright. Now let's look at what this iterating protocol is in Python. So first of all, we take an iterable. It's an object that contains, it's a collection of objects that contain sub-objects. And when we use the iter function, it creates an iterator out of it. So we can, one by one, we can traverse through each of the objects and we can manipulate each of the objects that is contained in this. And anytime we want to move to the next object, we use the next function. And when we have finally completed all of the, or we've manipulated or traversed through each of the sub-objects, we encounter the stop iteration exception, which tells us, okay, there are no more objects to be manipulated or iterated upon. So as an example, I will create a list where I will store the values, some simple values, integers 1, 2, 3, 4, 1, 3, 4, 5. Okay. I'm going to create an iterator out of this where I will use the iter function. And I'm going to say this is, let's say this is called my iter. Okay. And I'm going to use the iter function as I had mentioned, and I'm going to pass my list in this. Now if you see what is my iter, it should be a list iterator at a particular memory location. Now let's use the next function to keep going through whatever is there in this. So of course the first object should be 1, as you can see. Now when I look at the next, it should be 3, then I should get 4, and now I should get 5 as I use the next successively. Now since I've reached the last of my objects in this collection, now the next time I use this next function, I should get a stop iteration exception that is raised, as you can see here. So this is the basic iteration protocol in Python. Now you might have already gone through the for loop video, and in that I have spoken in quite a bit of detail as to how a for loop performs this this iterator protocol and how it creates an iterable object out of, say, a list or a tuple, and how it internally performs the next function, and it breaks out of the for loop once it encounters the stop iteration exception. So for loops are like, they're very, very similar to your standard iterator, and they use pretty much the same protocol for its functioning. Now let's do a basic comparison of what is a basic comparison between a generator and an iterator in Python. So in generator, we use a function. We define it using the def keyword, and we define it under one function to create a generator. Whereas in the case of iterators, we use two separate functions, the iter function and the next function. The generator makes use of the yield keyword, whereas the Python iterator does not. In generators, we save the states of the local variables each time we use the yield keyword, and we pause the loop temporarily. Whereas in iterators, we do not make use of any local variables. All we need is an iterable like a list to iterate upon. We may use any number of yield statements in generators, and we do not use yield statements in iterators. Generators are not memory efficient, whereas iterators are very memory efficient. So this is like basic comparison between generators and iterators. In this video, we will be covering the topic of modules in Python. Now, a module in Python, to put it simply, is basically a Python file that has functions and classes written into it and is saved with the .py extension to specify that it is indeed a Python file. A Python program can use one or more modules, and modules can have one or more functions. They basically help us organize our code, and instead of having one long Python file, we can have several files or several modules. Now, modular programming is the process of breaking a large event or task into smaller and more manageable subtasks, and we call these subtasks basically modules. Now, individual modules can be grouped together like building blocks to create a larger application. There are several advantages to modularizing code in a large application, and we will be going through them right now. So first of all, there is simplicity because instead of focusing on a big problem or big task, we can break down the problem into smaller portions or modules. Now, maintainability of code is much better through modules because they are designed to create these sort of boundaries or clear demarcations between different problem domains. There is reusability in the sense that once we create a module, we can use it in different parts of the code or even different applications itself. There is also scoping, and what this means is modules typically define a separate namespace, and this helps us avoid collisions between identifiers in different areas of a program. Functions, modules, and packages are basically all constructs in Python that promote code modularization. You might have already come across or gotten an intro into functions. In this video, we will be going through modules. And in another video, we will also cover the topic of packages. To import a module, we use the import keyword. And in this example, what I'm going to show you is a simple function or a simple operation of importing the OS module. This is short for operating system. And as the name suggests, we can perform system tasks through the functions and methods that are part of this OS module. So simply executing this statement will import this module onto our program for us to use. Now, if we wanted to see all the functions that are present in a module, what we have to do is use the dir function. So if we print the dir OS function, it will print us basically a directory of all the functions that are present in the OS module, as you can see here. All of these are basically names to different functions that are part of the OS module. Finally, moving on, another function commonly used with modules is the getCwd function. And what this does is it will give us the current working directory that we are working upon right now. So if I execute this, It will tell me what is the directory that I am currently working upon right now. As you can see, C notebook dir/temp. If we wanted to see all the files in a particular directory, what we can do is use the list dir function followed by giving a path. By default, if we do not enter a path inside the parenthesis, it will basically give us all the files in the current working directory, which in our case is temp. So if I were to execute this, it basically gives me a list of all the files that are presently there in the directory that I am currently working upon. Now a basic step is creating a Python module. The simplest way to create a Python module is basically creating a Python script with whatever functions and tasks that we want and methods that we want inside whatever module, and saving it with a .py extension. So in my example, what I'm going to do is I have already created a script in Notepad, and I've stored it with a .py extension that contains these 4 functions: add, subtract, product, and division. I've basically used this code and I've stored it in a .py script, and I'm going to be using this as my as a test module for this particular example. Now, how do we import a module? Now, once that I have created a script, in my example, it will be called mycalc.py, and we've stored it in our directory. To import the module, all we have to do is use the import statement. So if I had to import mycalc, all I have to do is say import my_calc, and now my calc has been imported. So we can use the import statement, or if we want to import something particular from my calc, we can do from my calc import. Now we can, whatever, like for example, if we wanted the add function, we can basically just say only add, or if we wanted add and subtract, we can say add and subtract, for example. So this is basically by using from, we can say that we want something from something, but only parts of it. We don't want everything. We can also use from mycalc import, and we can say asterisk to basically say import everything that exists in mycalc right now. So this is another way of importing something from a module. Now to access contents in a module, we have to use the dot operator, and I will show you how right now. So what I'm going to do is, in my example, I'm going to import mycalc as calc. So now since this is the original folder or the original module, but I'm going to give it a shorthand name so that I can easily use it in my code, and I don't have to type out my_calc every time. So now I'm going to import this as calc. So anytime I have to refer to a particular method or function inside this script or this module, I will just use this placeholder, this variable name. So now I have 2 variables, a and b, and I'm storing 20 and 30 in them. So my first what I'm going to do is basically 4 operations. I'm going to print the addition of a and b, and then the subtraction, multiplication, and the division of these 2 numbers. And each time to do this operation, I am going to use the add function that is present in the mycalc module. So to do that, I have already imported mycalc as calc. All I'm going to do now is invoke these functions using the dot operator that we are already familiar with. So I'm going to say calc.add, and then I'm going to pass these 2 arguments or these 2 variables to say that I want to add these 2. And similarly, I'm going to do it for subtraction, multiplication, and division. As you can see, these are the results of my tasks. Now, if I had to do a directory operation on the module calc, it will basically give me a bunch of inbuilt or dunder methods that are already a part of any Python script by default, such as built-ins. So if I execute this just to show you what happens when I use the dir function, it will basically give me all the functions that are part of this Python script. So these double underscores that you see are basically denoting magic methods or dunder methods, and these are like inbuilt methods as a part of the script. And if you see here, add, division, prod, and sub, these are the methods that we have defined earlier on in our script ourselves. Now to go slightly deeper or in more detail into what happens when we do a module search, let's actually look at what happens. So what happens is when, for example, we execute the statement import mycalc as calc, as we did over here. So the steps that actually take place are the interpreter executes the above statement, and it searches for this Python script in a list of directories assembled from these following sources that you see here. So it takes the directory from which the input script was run, or the current directory, if the interpreter is being run interactively, which is the case right now. Secondly, it will list all the directories contained in the Python path environment that you set up, that you can set up or you can change later on as well. And this format for Python path is OS dependent, of course, but it should mimic the path environment variable that we see in Windows systems. And then the other source or the other directories is basically an installation dependent list of categories configured at the time Python is installed. Now the resulting search path that is accessible in the Python variable system.path this is basically obtained from a module named sys. So if I imported this sys and I did sys.path, now these are all the directories that we are going to look for when we want to search for any particular module. So if I'm doing import mycalc or import os, it's not only going to look at the current directory that I am working on, it's also going to look at all of these directories that have been set up as you could say directories or paths in the system.path. In this video, we will be covering the topic of packages. Now, what if we developed a very large application in Python that contains many different modules, and we have so many different modules that have similar names and functionalities, and they're all kept in or dumped in the same location, that it becomes very difficult to track these modules? What if there was a way to organize and access these in a much simpler and more organized manner? Well, packages allow us to do just that. Packages are a hierarchical structuring of the module namespace using dot notation. And this is the same dot notation that we use when we want to access methods or functions that are part of other classes or modules. So let's look at certain examples to understand what we mean. So I have a directory called pkg. This can be basically treated as what we call a package. Now in our package, we have two modules, mod1.py and mod2.py. And what we're going to store in mod1 and mod2.py are the follows. So I'm going to define a function called foo, and I'm going to print this particular statement, mod1, and then I'm going to basically say foo. And then I'm going to say in class foo, I'm going to have an empty pass command. Similarly, I'm going to define a function called bar in mod2.py where I'm going to print this statement. So basically mod1.py has a simple function where I'm going to print this statement, and mod2.py has a simple function that I'm going to print this statement. And I'm going to store them in mod1 and mod2.py respectively. And these two modules I'm going to store in the directory pkg in my local folder. Now I've already done this, so we can already get to working with this. Now if I wanted to access these particular modules from the pkg folder, I can simply use the import command and use the dot notation. So I can say pkg.mod1. So this will import the mod1 module from pkg folder. Similarly, I can do the same thing for the mod2 module from the pkg folder in the same line. So now that it's been imported, just simply execute this, and this imports whatever we needed. Now, if we wanted to perform a function that was a part of mod1.py, we can just extend the dot notation and use the function as over here. As you can see, it performs this print command, whatever it was supposed to do. Similarly, I can invoke the function that was part of the mod2 module by extending the dot notation to it in the same way. Now, another way that I can invoke I can import a package is by directly importing the package itself by using import pkg and not accessing any of the specific modules within it. Now let's see what happens when we do this. So just for this example, what I'm going to do is I'm going to restart the kernel so that the pkg modules that were already imported get cleaned away. So we see what happens when we execute this on its own. Now if you see, I have imported this. Now let's see if I can access my mod1 and mod2. Now if you see here, it's throwing me an error. And this is because simply using the import command on a particular package only imports, you could say, the package namespace, but it does not actually import any of the modules and files that were part of this package. So if I wanted mod1 from this package, I would have to actually say import pkg.mod1 directly. And I cannot simply say import pkg, and Python will not import everything that is part of a package on its own. I have to specify it myself specifically. Now I'm going to create, and I'm going to show you another type of importing from a package using the star operator. So I have this package pkg once again. Now I'm going to store 4 different modules within this package: mod111.py, mod222.py, and I've already done this, so you don't need to bother about seeing me doing it right now, because I've already created these files. And what I've done is within mod111.py, I've written this statement and I've stored it in the Python script. Similarly, I've created another Python script called mod222.py, and I have basically written this in the code. And I've similarly done this for mod333.py, and I've done another for mod4.py. Now, once I have done this, I've stored these Python scripts into my package or pkg package. So now what I'm going to do is I'm going to execute this command. If you see this, from pkg.mod333 import star. So once I execute this, Now I'm going to say print directory, and print directory basically will tell me all the functions that exist in my current directory. If you see here, there's this baz function that was a part of mod 333 module. Now if I change this and if I imported mod 111 and if I did the same thing, you will see foo has now been added as a part of this directory. And these are all functions that were part of these different modules where I'm importing from. And that is what the star function does. What the star function will do is it will basically tell Python, okay, so the statement is saying from pkg.mod111. So it's saying that, okay, look into this directory or this package and find this module. And in this module, import everything that exists inside it up until this point. So this is another way of basically importing files or functions from a particular package and a particular specific module within that package. So yeah, this was a very brief video on packages in Python. The conclusion being that packages are basically an organized way of storing many different modules that we might have created in a very large application. And these modules can be accessed using the familiar dot notation that we have used in other examples such as methods when we were working with classes and objects. In this video, we will be taking an introduction into the concept of generators. So Python provides a generator, which is like a function where we can create our own iterator. In a generator function, we use the yield statement instead of the return statement that we use for standard functions. So let's look at a simple generator first of all. So out here, I have defined a generator called myGenerator, where I'm doing like there are three functions or three tasks that I'm doing. First one is when I'm printing the first item and I'm yielding a value 10. Then I'm printing second item yielding 20. Then I'm printing last item yielding 30. So let's see how do we use this. Now, since we know myGenerator is the function, it uses the yield keyword. Every time we use the next keyword, we will keep getting what is next in this function. So let's store the generator in mygen. So now we have stored the iterator in this function variable called gen or gen. Now let's see when we do next and we use gen, what happens. So the first task is performed, or the first iteration is performed, where we get this, the first yield command is done. Alright, let's see what happens when we do next again. Next gen. Now, as you can see, we get second item and we get 20. Let's do it for the next. Let's do it once more, since there is one more task. There's one more iterable inside. You can see this. Now, a valid question is what will happen if we do next gen again, since there is nothing after this. Well, let's see what happens. We should get an error. As you can see, stop iteration error. This is another built-in exception that happens when we have reached the last object of an iterable. So we get a stop iteration error. So now a key difference between a generator and a function is that when we execute a function, the moment we hit the return statement in a function, or when we execute a function, like whatever variables that were stored inside are lost and they're destroyed unless they were defined as global. And the function is completely done executing and we leave the function completely. Whereas when it comes to a generator, when we hit the yield function, we don't actually completely leave this function. So the first time the yield is found, we get 10, but the generator remembers its position inside this function. So the next time we use the next, we actually move on to the next iterable, and then we move on to the next iterable. So you can think of a generator as it sort of has memory, if that makes sense. It's a way to create iterables in Python or create iterators in Python. So to understand what the difference between the yield command and the return command does, let's take the same function. Alright. And let's put a return over here after this particular, the second yield. Okay. Let's do the same thing. We say gen is equal to my generator, and let's start doing next gen and seeing what's there. So the first yield will be standard, first item 10. The next one is again going to say second item and then 20. But now if you notice, there was a return I put over here. So technically when I did the second next, it's not only yielded 20, but it's also executed this return function or this return statement. So let's see what happens if I do next again. As you see, I have gotten the stop iteration seemingly earlier than I did before. And that's because I have used the return function and return statement. And what that's done is that if we've completely left this function, so as to speak, and there is nothing next, so as to speak. So we get the stop iteration. And that's the difference between yield and return. Now in the next example, I'm going to show you how we use a generator function in place of the for loop or for a for loop. So let's take this, what I have over here. And I have defined a function called getSequence up to x. And what this will do is basically, it will keep printing the printing numbers up until whatever we have entered in place of x over here. So if I said, say sequence is equal to, let's copy this, all right, and say I want sequentially, I want every number up until 10. Well, not including 10, of course, because Python starts with 0, right? So let's do this, and now let's see. So the first number will yield 0, and now if I did this again, it should give me 1, 2, and I can keep going until I will stop at the value 9, as you can see here. So 8, 9. Now I should get the stop iteration error because that we have reached the end of our iteration. So this is a way of using generator functions for loops. So another neat example where we're going to use a generator is in the case of Fibonacci numbers. So let's use it. Let's see how we can generate a Fibonacci series using generator. So I've defined a Fibonacci function called Fibonacci where I'm passing max. So max is basically the max value that I want, like up until where I want the sequence, right? So this is basically the code which will return me the subsequent values of my Fibonacci sequence. So let's pass this to fib and say I want all the Fibonacci numbers until 10. So I will pass 10 over here. Let's see what happens when we do next fib. Well, it should start with 0. Then when we do this again, we get 1. Then we do 0 plus 1. It should be 1. Next number should be 1 plus 1, which is 2. Then we should have 2 plus 1, 3. And then 3 plus 2, 5. Then 3 plus 5 should be 8. Now 8 plus 5 is 13. And since 13 is greater than what we passed for our max value here, now when we try this, we should get the stop iteration error, as you can see. In this video, we will be learning about the concept of list comprehension. Now, list comprehension it's a neat way of creating a new list based on values that are already there in an existing list. So you can think of it like creating a new list using a much shorter and cleaner syntax compared to what you might traditionally be thinking. So let's go through some examples, and through those examples, we will see how list comprehension makes creating these new lists much simpler and much easier for us. So in our first example, we will be creating a new list which will contain fruits that contain the letter A in their name. So we already have a list of fruits over here, as you can see. It has apple, it has banana, cherry, kiwi, and mango. Now we want to create a new list which has only the fruits that have the letter A inside them. So apple would be one of them, banana would be one of them, and mango would be one of them. So traditionally, if you look at this piece of code, this would do what we want to do, but this contains a few extra lines. But yeah, it does do what we want to do. Now what if there was a way of doing the same thing by just writing one simple line of code? And that exists, as you can see here. So I take the same list. Now this is where you need to follow. So now my new list is equal to, so I'm creating a list over here, as you can see. Now within this list you have this line. This is what we call a list comprehension. So as you can see, it says each fruit for each fruit in fruits if Now it's checking for the letter or the character A inside each fruit. And what this each fruit is, that we're checking each object in this list one by one. So first, in the first iteration, each fruit will contain the string apple. Then in the next iteration, it will contain banana. And in each iteration, we're going to check if it contains the character A. And if it does, then we store that each fruit in the new list, as you can see here. So if I execute this line, you see my result is the same. I have my whatever I wanted. And this was a much cleaner way of writing or creating this new list. Let's look at some other examples now. So my next example, what I'm going to do is I am going to iterate through a string. So I have a string. It can be anything. In this case, I am using a string called human. All right. So I have a string called human, right? Now I want to store each character of this string into a list that we call h_letters. So if I use the for loop, this is how we would do it. If I execute this, as you can see, the list contains h and then u, m, a, and then n. Now what if I wanted to do the same thing, but by using list comprehension? So what I would do is, let's create a list over here, h_letters, and so as we know, list comprehension will you just basically need one line. In this case, it will just be like this. Now this is my string. Now let's see, when I check what's in h letters, let's see what is the output. So as you can see, I have the output as what I needed. So this is a much cleaner way. Let's go through some more examples now. Now we can do more list comprehensions. We can even use, so we've already seen one case where we checked for the character A. We've seen a case where we went through, where we did a sort of a loop through a string. We can also use list comprehensions in conditionals. So let's look at an example where we use the list comprehension with an if statement. So what if I wanted to store, say, the first 10 even numbers? So this would this is an example that I'll be using. So in my list, I want to store the first 10 even numbers. So this would be a way to do it. So I have in range 20. So what this is going to do is x is going to take the value of 1, 2, 3, 4, and so on until 90. It'll actually take it from 0, 1, 2, 3, 4 until 19. So when we do range 20, we're creating an iterable where we're going to loop through or iterate through the values 0 to 19. So if I do this, and this, what this statement does is basically it checks if it's divisible by 2. So if this is equal to 0, that means we have an even number. And if this condition is met, that means we store the x into our number list. So let's see what happens when we execute this. This should contain 0, 2, 4, 6 until 18. So this is the first 10 even numbers, as you can see. So this is a neat way of using if statement. We can also use an if else statement. So what if I'm checking each, okay, so I'm going to create another list, and in this list I'm going to basically see if each of my numbers are either even or odd. The first, let's say 10 natural numbers. So let's write this statement down. So I want it to be even in case the I that I'm checking, I being every number between, like say the first 10 natural numbers, as I said. So let's check if it is divisible by 2. Well, if it is divisible by 2, of course it's going to be even, right? Else, we say that it is odd. And then we check for I in, say, the first, let's say the first 20. Okay. So now when we do this and we check what's in the list. So as you can see, the list contains like even, odd. It's basically saying the number 0 is even, then the number 1 is odd, then number 2 is even, and so on and so forth. So this is an example where we used the list comprehension with if-else statements. So another neat thing that we can do with list comprehensions is that we can use it along with functions. So let's look at this function. In this example, we have a function called double x, where we define this double x this double function to take an input, to take an argument x, and what we return is the square of the argument. So let's use this in our list comprehension. So what we do over here is that we're checking. What we're doing is for every x bit in range 10. So we're taking the value 0, 1, 2, 3 until 9, and we're passing it to this function double x, and we're going to get the square of them, and we're going to store that in a list, as you can see here. Let's call this list x. Let's just call this list, let's call it y. So now let's see what's in y, and we check. It should be 0, 1, 4, 9, and so on. So wait, let's check again. Does this square? No, this is actually 2 times. So let's make it square, as you can see. So you can see 0, 1, 4, 9 for the first 10 numbers, 10 natural numbers. Now what I've shown you is obviously list comprehension, but we can also do set and dictionary comprehensions. In fact, set comprehensions work exactly the same way as list comprehensions. The only difference is the set comprehensions will make sure that there are no duplicates inside the set. So you can't have like duplicate items, which you can in the case of list comprehensions. So let's just take a look at an example. So here in this example, what we're doing is we're going to check. So we have this string that we're storing in the variable text, and the string is something like life finds a way. So whatever this is. Now what we're going to do is we're going to iterate through this string character by character, and we're going to check if we're going to check for vowels essentially. So we're going to see if the character A, E, I, O, or U is present in the string, and if it is, we will pass it into our set. Now if you look, you will find there are multiple I's, right? And there are multiple A's as well. So if we did this through a list comprehension, each time that we find a vowel, it would be added to our list. But since this is a set, and sets do not allow duplicates, so you will only have one copy or one particular object for each of the vowels. So of course, now set comprehension is defined using curly braces, so let's keep that in mind. So now if I check what's in this, I will see A, E, I, and U. Even though there are multiple A's or multiple E's or I's and U's, since this is a set, we don't have duplicate copies of any of these. So this was just a small example for showing you set comprehensions. Similarly, we can do the same thing, this comprehension for dictionaries, and we call it dictionary comprehensions. The only thing that we have to worry about when it comes to dictionary comprehensions is that we have to define a key when it comes to this. So let's look at an example. In this, what we're doing is, again, dictionary comprehensions are also defined using curly braces, just like sets, except in this case, we will define a key, and that separates it from a set comprehension. So in this case, what we're doing is that I'm checking, I'm going through a list of numbers from 0 to 9, right? This is what the range 10 function does. And what I'm going to do is, I'm going to create a key, which is going to be like 0, 1, 2, 3. And the value of each key would be its square, as you can see here. I'm doing I times I, or just to make it a little more clearer, as you can see, I'm doing I square over here for every value from 0 to 9. So what I should get is like a dictionary where the first key is 0 and the value of that key should be 0 as well, because 0 square is 0. Then for 1 it will be 1, and then for 2, 4, and then 3, 9, 4, 16. So let's see what happens. As you can see here, this is the result that I wanted. So just to summarize, let's go through some key points to remember when it comes to list comprehensions. So it's obviously an elegant way to define and create lists based on existing lists. It's more compact and faster than normal functions and loops. But we should also keep in mind that we shouldn't write like very complicated list comprehensions, because the idea of a list comprehension is to be user-friendly. And also, it's important to note that every list comprehension can be written in the form of a loop, but every loop cannot be written in the form of a list comprehension. And that is probably a very key point to remember. In this video, we will be learning about the concept of regular expressions. Now, a regular expression is simply a sequence of characters that defines a search pattern. For example, if you see this example here, you can see a symbol called the caret followed by P and then 5 periods, then an N and a $sign. And what this regex pattern does is it's searching for a 7-letter string that starts with P, ends with N, and has 5 characters in between. Let's look at this example now. This is a regex pattern that is looking for a 5-character string that starts with A, ends with S, and has 3 characters in between. Now, if we had to match this with this string, with these strings as our test strings, the first one would not match because it's a 3-letter string and we're looking for a 5-character string. The second one would match because it's a 5-character string that ends with an S, starts with an A, and has 3 characters in between. This will not match because what our pattern would do is it would find the first S and it would find that the string itself starts with an A, and it would say, okay, there are only 2 characters between this first S and this A, and it would assume that this is actually just a 4-character string. To actually identify 2 consecutive S's, we would have to do something special, and what we would have to do is what we will see later on. So again, this is the same example. Since this is case insensitive, capital A is perfectly fine when we're searching for this, and it will also match. This is obviously 2 words, and it's not a 5-character string, so this will not be a match. Now, the regex pattern or the regular expression module in Python can be imported using this statement, import re. Now, once we've done this, we can actually use our regular expression tools and methods to do pattern recognition, character recognitions, and to identify different sequence of characters in our strings. Let's try to understand a bit more in depth about regular expressions now. So what you're seeing here is one variable called pattern which stores something that looks like a regex, and another variable that stores our test string called abis. Now what we're going to do is we're going to use the match method of this module re, and we're going to check whether this pattern or whatever we are trying to search using this regex is in fact, does it match with our test string. And what we're trying to look for is, if you see here, very similar to what I just showed you, a 5-character string that starts with A and ends with S. So if you see our test string, it indeed is a match, and when we use this this command, we should get a perfect match. So we should basically it should say that search is successful if I execute this, and this is what it does. Now if I change the test string to this now, you will see that now this is no longer what we're looking for, a 5-character string with A and starting with A and ending with S, and you will see that the search will be unsuccessful, as you can see here. Now let's try to understand what exactly do we mean by when we use these special symbols, like for example this caret or this dollar symbol. These are, by the way, known as meta characters, and now we're going to look into all the or most of the different meta characters that are used in regex. So to put it simply, meta characters are simply characters that are interpreted in a special way by the regex search engine. Now here's a list of meta characters. Let's go through them one by one. Now the square brackets. Square brackets simply specifies the set of characters that we wish to match. So we want to match some combination of A, B, and C. It can be 1A, 2A's, 3B's, 4C's. We are not looking at a specific pattern. We just want to know if A, B, and C exists in any form in our string. So if we used it on A, the string A simply, we would find one match because the letter A is found here. AC would match twice because we have A and C present here. In this string, Hey Jude, we will have no matches because A, B, and C, none of them are found here. And in this weird string, we will have actually 1, 2, 3, 4, and 5 matches. So we would have 5 matches for this this bigger string because we have 5 instances of A, B, or C. Now let's use re.match to actually search for this and to see if we have our particular whatever patterns that we're looking for. Now in this input string, this is just some example string. I'm going to test this. I'm going to match whether my pattern that any of A, B, and C, is it actually found in this. So let's see what happens when I use re.match for this. So the format, the syntax is simply the regex pattern and then comma whatever test string that we have. So let's see what object gets created when we try to do this. As you can see, it's none. even though you might be wondering, like I can see an A over here, I can see a C over here, re.match actually gives us the result none. Now, if I try to do it on this test string, which is slightly different, instead of the film Titanic was released in 1998, what I'm saying here is all film Titanic was released in 1998. Now let's see if the R match works or not. As you can see, it actually does return. When I execute this, it returns us an object called re.match object with a span 01. The span 01 is basically telling us that we have found a match between the 0th and the first character, which is basically this character A, which is what it has found. And it's saying that the match is indeed the character A from amongst these options. So what this is basically telling us, and what this means actually, is that the re.match method will only find matches if they occur at the start of the string being searched. Once there is a space in our bigger string, it will not search for whatever comes after it. So what happened in the first instance was, it was actually only searching for matches in this particular word in my largest string. And since it found no match, it basically gave us the result none, which was not the case in the second example because it found a match immediately in the first letter A. Now, if we want to actually check the whole thing, what we would be using is the re.search. As you can see here, the re.search method will actually check the whole string, and it will return us the first instance where it finds a match. Now let's see, this is a test string now, and we're searching again for we're searching for A, B, and C, any of these in our test string, but we're going to use re.search and not match. So now if you see, it returns us, when I execute this, it returns us a match object again, but this time it's saying the span of 9 and 10. Now the span of 9 and 10 actually exists over here. This is the 9th character and A itself is the 10th character over here. So what this basically is telling us, that the 10th character is where we found a match, which was the letter A, which was the first instance of either A or B or C in this whole string. And this is basically how re.search works. It will not only search the beginning of the string, but it will search the whole string and return us the first instance of wherever we find. Now, what if we wanted to find out all the instances wherever A, B, and C were found and not just the first instance? Well, in that case, we would be using the method findAll over here. So when we use findAll, it will actually return us each and every case where it found A, B, or C. And you might not, it won't tell you the exact position, but it will tell you like, so if I execute this, you can see it gives us a list with A, C, A, and A. And what this basically means is it was looking for the characters A or B or C, and it found A first, and hence this for the first item in the list. And then it found a C, and then it found two A's successively. So this is actually how findAll works, where it will actually find all of the instances of our regex pattern. Now that you've seen how the square brackets work and how the re.search and re.match and re.findAll methods work, now we're going to go through all the other meta characters that we saw above. So the period. Now a period matches any single character except the new line. New line is basically /n or a break. Now if you look at this picture, what it's going to do is this expression basically saying that do we have two characters, like sets of two characters in our string. So this is a single character string, and obviously a single character string is not a double character string. And this expression, this double dot, is basically asking us, do we have two characters present in our string? So if I had to match it with this A, it will obviously be a no match because A is one character. If we checked it with AC, it is a match because A and C are two characters. A, C, and D will also give us only one match because it will find A, C, and then it will leave D as a single character. But when we check A, C, D, and E, or this string in particular, it will find two matches because it will consider A and C as one of the matches and D and E as one of the matches. So below is basically what we're doing. Basically the same thing, we're just using re.search for each of these different examples. So if you see when I use findAll on A, C, D, E, and when I'm searching for a two character match, you will see that it will return me A, C, and D, E, as you can see here. And similarly for something like this, it will return me again, whatever like two character patterns it finds successively. So the next symbol, the next meta character is the caret symbol that you've seen earlier. And the caret symbol is basically used to check if a string starts with a certain character. So if you look at this picture, we have two expressions that we're going to check over here. One is checking if A is the beginning of a string, and the other one will check if A is the beginning of the string, but is it followed by B or not? So when we check this, what you can see is the first string will be a match because it's only the character A, and it will match here as well because this string starts with A, but it will not match here because this string starts with B. Now if I look at this particular expression, you can see that this is going to search for if the string starts with A and is followed by a B. So it will match in this case because it does start with A and is followed by a B, but it will not match in this case even though it starts with an A because it's not followed by a B. So out here is basically us using the re.search to basically find these patterns. The next symbol that we will come across is the dollar symbol. So the dollar symbol that you can see here is used to check if a string ends with a certain character, and we have already seen how this is used in one of the earlier examples. So this is going to check basically this expression will check if the string ends with A. So this string is basically the character A, so it will match. This also ends with A, so it will match. And this particular string does not end with A, so it will not match. And we are going to do that using the re.search over here. So as you can see, it finds a match in the first character itself here. In this case, it finds a match in the last character, but in CAB, there is no match, so it returns us a none. Another example is of the meta characters is star. So this is the symbol for star, and what the star basically is used is for checking if there are 0 or more occurrences of the pattern to the left of it. So now if you see here, what this will check for is there any form of M and A that occurs before N? And it's very important to note that the N has to follow the A in this case. So let's look at these examples and what will happen. So if I checked it with M and N, this is actually a match because N is followed by 0 occurrences of M and A, which is, it might seem a little weird, but it is technically the truth, because the star symbol doesn't check for the existence, it just checks for if N occurs, it must occur after an A, or the A should not be there itself in this particular string. So as you can see here, the N occurs after an M, and it's fine because there is no A. Now you will see when it will not work. So M, A and N is obviously fine. M triple A N is also fine because N follows an A and there's an M here. This, however, main will not match. Now why? Even though we have M and A and we have an N, you see the N is immediately followed by an I. N follows an I immediately, or the N is preceded by an I immediately. And this is a no match because the strict condition in the search is that N must precede an A if the A exists. Again, in women it will match because N follows an A over here. We're just going to use the re.search for these examples that we saw over here in terms of code using the re.search, as you can see here. Finally, we have the next meta character, which is the plus symbol. Yes. So the plus symbol matches one or more occurrences of the pattern left to it. Now this is very similar to what we saw earlier in terms of the star, except now in the plus, the key difference is we're looking for one or more occurrences instead of 0 or more occurrences that we were looking for in the case of star. So when we say one or more occurrences, now we need what is there to the left of the plus sign. A 0, no occurrence of it will not be allowed or will not cause a match. So let's see now what we're going to do here. We're going to use the same expression, except we're going to replace the star with the plus sign. So now what we're going to say is, okay, we need M and A, at least one occurrence followed by an N. All of these conditions have to be met. So again, if we took the first example, M and N, this time it will be a no match because there is no occurrence of an A over here for preceding the N. So it's a no match. M, A and N is a match because, well, this is perfectly fine. M triple A and N is also perfectly fine. But if you look at M, A, I and N, much like earlier, the N is preceded by an I and not an A. So there is no match. And again, woman is perfectly fine. And we basically execute the same thing through the search function in this piece of code. The next meta character is the question mark. The question mark symbol matches 0 or 1 occurrences of the pattern to the left of it. So let's see what this does. So now we saw the star which was 0 or more occurrences of the pattern to the left of it. We saw the plus, which is 1 or more occurrences of the pattern to the left of it. Now we will see the question mark, which is 0 or 1. Only 0 or only 1, and not 0 or more or 1 or more, which was the previous cases. Only 0 and 1 or 1 occurrences of the pattern to the left of it. Again, we're going to see the same expression, except we're going to replace the meta character with the question mark. So now let's see what happens when we match. So if you see here, m and n is a match because there is 0 occurrence of a and 1 occurrence of m preceding n. So this is fine. This is also fine because there is 1 occurrence of a and m and then it's followed by an n. This will not be fine because now we have 3 occurrences of a which is followed by an n. We're only looking for 0 or 1. This again, main will be a no match for the same reasons that we have already gone through, and woman will be a match again for the same reasons. And we do the same thing using the search function in this piece of code. The next meta character is the braces character. Now the braces character is interesting because what we're going to do is we're going to see if there are, the typical syntax for a braces is n brace followed by some integer n, comma integer m, and then close braces. So what this means is we're looking for at least n and at most m repetitions of the pattern left of the braces. Let's see through an example. If you see this expression, we're looking for at least 2 and at most 3 occurrences of the character a in our test strings. So let's see what happens in the first case. We have no matches in this case because this part of the string contains only one a, and even this part of the string only contains one a. We're looking for at least 2 and at most 3. This part will contain one match, the second example, because the second part of the string actually contains 2 a's for two repetitions of a's consecutively. But this in the third example, you can see both the strings actually contain matches, so we get 2 matches because, as you can see here, there's 2 a's here followed by 3 a's here. Now when we look at this particular string, let's look at what happens now. So what we're going to find is that this thing is perfectly fine. So we have 2 occurrences of a, but now we have 4 occurrences of a, but what the search engine is going to recognize is these first 3 a's, and it's going to see, okay, so there are 3 occurrences of a and I already have a match. It's not going to consider this 4th a in the search. It will just look at the first 3 and it say, okay, there are 3 a's and my match is fine. So again, there are 2 matches in this case. Again, we're going to use the search function initially, and you can see in each of the cases there is a match except for the first case, which is this case. Now let's see the find all option and see what happens when we do the same thing using find all. So when we use find all, it basically gives us each of the instances where the match has occurred in each of these lists. Now let's try to use a slightly more complicated example where we combine different meta characters and we create a more sophisticated expression that we want to search in our test strings. So if you look at this expression, what we're looking for is 0-9. Now a dash symbol is valid in Python using regex because what this basically tells it is that it's looking for either 0, 1, 2, 3, 4, so on until 9. Basically any of the digits. We're looking for any of the digits from 0 to 9, and we're going to check if at least 2 and at most 4 occurrences of digits, if they are there or not in our particular code. So let's see what are the matches that happens when we use it on test strings. So if you use it on this string, you can see it'll find one match. This particular part of the string where it says 1, 2, 3. So this is 3 occurrences of digits, so it's fine. Now when we look at this whole string, 12 and whatever this is, you will see this will not find a match here. This obviously will not because these are characters. But if you look at this part, it will find matches in terms of the first 4 and then 7 and 3, the next 2. 1 and 2 again, there are no matches because there's only single occurrences of digits. We're looking for at least 2 and at most 4. So if I use a find all, you will see like what all it will return. So for the first test string, what it's going to return me is, it's going to return me 1, 2 and 3 as you can see here. But now if you look at this test string, it's going to return me 12, it's going to return me 3, 4, 5 and 6, it's going to return me 3, 4, 1 and 2 but not 7 because we're looking for at least 2, and then it's going to return me 4, 5, 6 and 7 followed by 8 and 8 as you can see in this list over here. Now if we use curly braces with only one digit, it's basically telling the search engine that we want exactly so many repetitions of the preceding whatever expression that we have. So when we do this example, for example, we are basically saying that we want x followed by a dash, and the dash has to occur at least 3 times in our particular expression, and then it should be followed by an x again, which will not match in this case because there are only 2 dashes, and it will match in this case because there are exactly 3 dashes, and it will again not match in this case because there are 4 dashes. as you can see here, none followed by an object match followed by none. Next we move on to the alternation meta character. And as the word suggests, alternation is basically looking for some alternate form of A and B. So A should be followed by B, and basically this pattern has to keep going on. So in the first string over here, this pattern will not match. In the second string over here, we will have a match because we at least find an A, even though there is no B. But this is still considered a match because we did find an A at least. Over here we'll have 3 matches because we have A followed by a B followed by an A again. So if we did a regex expression for this, we would basically find these many matches for each of these examples. The next meta character is the group. Now a parenthesis is basically used to group subpatterns. So let's look at an example to understand what we mean. Now if you look at this complicated expression, what this means is that I want some form of x and z. The x and z have to occur together. But before that, what I want is some form of A following B following C. Some sort of alternation between A, B and C. So this part, as you can see here, is kept in a parenthesis because I want this whole condition to basically occur before I find an x and z. So let's look at what happens here. In the first case, we don't have a match because this parenthesis condition is not being met. X and z is preceded by a space, or basically the A and B is followed by a space. So if the space didn't occur, we would actually find a match, as you can see in the next example. Here you can see A and B occur. Basically this initial condition is met, followed by x and z. So there is one match. So it's fine for us. Now if you look at this slightly more trickier one, what you can see is we have 2 matches in this case. First an A followed by x and z, and then we have C, A and B. Now this is perfectly fine because we are looking for a B followed by an x and z. We're looking for either of these things. We're looking for some form of alternation of these things followed by an x and z. And we can get that over here. We get B followed by an x and z. So you'll get 2 matches in this case. Now let's go through the concept of grouping constructs. Now that you've seen many meta characters, you've seen how parenthesis works. Let's look at grouping constructs. So grouping constructs break up a regex in Python into sub-expressions or groups. And this serves 2 purposes. One is the grouping part, which basically says that a group represents a single syntactic entity. And any additional meta characters apply to the entire group as a unit. And then there's the capturing part, which basically tells us that some grouping constructs also capture the portion of the search string that matches the sub-expression in the group. And you can retrieve captured matches later through several different mechanisms. So let's look at basically what we mean by this example over here. So if you see this expression has a plus sign. So we're looking for, as you know, a plus looks for one or more occurrence. So this will basically check for one or more occurrence of the character R only, because there's no parenthesis as in this example. So this plus is next to an R, and it's going to check for basically whether one or more occurrence of R happens preceding B and A. But if we actually put B, A and R in a parenthesis followed by plus, it will actually check for the entire string BAR, and it will check one or more occurrences of BAR together. So if you look at these 2 examples, when we use this on these examples, you can see that these are fine, like these matches are fine. But if I used this parenthesis, then these would be the acceptable matches. And like BA triple R would not be a match if I use parenthesis, as you can see here. So this is how grouping constructs work and how parentheses work. So look at some other examples. So what this will do is FOO has to be optionally followed by BAR, and BAR must exist together. And this is because we have a question mark here. This question mark symbol tells us that there should be 0 or 1 occurrences. Similarly, this particular complicated expression is checking for one or more occurrences of whatever we saw earlier. Basically, this whole thing is followed by a plus. So we're looking for this whole sequence for one or more occurrences of it. COW is simply just COW. We're looking for this pattern. And this is going to check for 0 or 1 occurrence of COW because of the existence of the question mark preceded by the parenthesis.
Now, without further delay, let's get started with our Python exploratory data analysis. But before getting started with the demonstration, let's have a brief understanding of exactly what is exploratory analysis. Is this anything different from regular data analysis? Yeah, that's exactly what we're going to discuss. Now, types of data analysis. So basically, there are 2 different types of data analysis. initial data analysis and exploratory data analysis. Now, what is initial data analysis and what is exploratory data analysis? Let's understand a little briefing about these both. First, let's get started with initial data analysis. So what exactly do you mean by initial data analysis? So data can be in any form. It can be an Excel file, it can be a SQL file, it can be a PDF, it can be an XML, it can be even a website. Whatever it is data. If you have some information in this which can be used to extract some valuable information, then it is data. So initial data analysis is a process of inspecting the data and screening the data that takes place after data collection and before statistical analysis. So before you conduct any statistical formulas and analysis on the data and squeeze the data to extract some valuable insights, the process which you perform is called as initial data analysis. Like taking the data from the source, cleaning the data, transforming the data into a readable format, and using that readable data to build some basic charts. What exactly is happening with this particular company, brand, or anything. Let's say I give you some data from the company, then you get some insights of it. How many number of traffic you received, how many number of orders you received, what's the sale that you made in a specific month, specific quarter, or specific year, and what was the profit. So basic information which you convert from the data and create a dashboard, right? That is called as initial data analysis. So a step beyond initial data analysis is known as the exploratory data analysis. This is where you perform some statistics and probability and predict the future, right? So let's dive deep and learn what exactly is exploratory data analysis. So a simple definition for exploratory data analysis is as follows. Exploratory data analysis is a key step in data analysis process that helps you identify patterns, outliners, and relationships between variables before making assumptions. It is not like you just create a dashboard out of the initial data analysis and you can predict the future. No, it's not like that. You might have to you might have to go through some permutations and combinations. You might have to check the seasons. You might have to check the possibilities, right? During some particular seasons in the year, let's say it's Christmas, then you can expect some good sales. Let's say it's some festival, it's some special occasion, you can expect some good sales on the product, right? And maybe a part of the year, maybe a part of 10 years, a decade, right? In a certain period of time, there might be some reason due to which the sales of a certain product were high. So to make sure that your assumptions, to make sure that your projection of the sales is 100% accurate, or at least 90 to 95% accurate, then you might have to go through the exploratory data analysis, where you make use of statistics in your data analysis. Now, there are certain steps that you might have to follow while going through exploratory data analysis. So following are the steps. So first few steps might be slightly relevant to initial data analysis, like connecting data, cleaning it, transforming it, and loading it. After that, you will import certain libraries from Python. And after that, you read the data, what exactly you have in your data, the number of columns, the number of rows, and if there are any null values, if there are any entries which are invalid, you might have to check that, read that, and you might have to check for duplicate entries. It is possible that one entry might have been entered by two different people, right? There might be a duplication, so you might have to eliminate those duplications. You might have to check for some missing values. You might have to calculate the total number of missing values from the dataset and try to eliminate them from the calculation during your exploratory data analysis. Followed by that, you have to do some model engineering. Followed by that, you might have to do some feature engineering, creating features, and then you will get started with exploratory data analysis. And at the end, you will generate a projection or a prediction or give your assumption that this might happen in the future, and you might have to take action to avoid it, or you might have to take action to improvise it, right? So this is how the steps in exploratory data analysis take part. Now, let's proceed and start with our demo on Python's exploratory data analysis. And in this session, we will be using the use case that we discussed before, which happens to be the student's performance dataset. So in this particular dataset, we will be having some columns based on physical activity, the distance from home, parental education, the subjects, the marks they have scored in the previous exam, the marks that they have scored in the previous exam, and if they have any disabilities, if they are having any resources that they require to write the exams, right? So a few parameters, the important parameters that we will be discussing in this session, and followed by that we will project the future, that how they will improve in their exams, and if there is a problem and if there is a solution to that, then we can implement that solution and help students to gain better marks in their exam. So that's the overall use case for this demonstration. Now let's get started with our Jupyter notebook. Now we are on Jupyter notebook. Now let's get started. So I would like to have a title for my notebook. So I'll write an HTML code for that. So HTML code, and I have 3 apostrophes. And here I would like to write something in H1, so I want my title to be in H1. So style will be background color, color name will be dark blue. So let's proceed with the Simplilearn's background, which will be dark blue usually. And the color of text will be orange. And I also want to have the font. Let me give the font size as 30. And in the next line, I'd like to have border radius. I can give the border radius as 20 pixels. And padding to be 16 pixels. Text alignment, I'd like to keep it center. There you go. Let's close the H1. Now let's code the background color or border color. So B style. So what we can do is we can basically have this code here, and what we will do is we will reuse this particular code segment, because we will be having multiple HTML codes in this particular workbook, which will explain the results of the analysis that we are doing. So the way we just run the code, and after that we will be getting some visualizations, and I will be writing some textual content in HTML page, so that it will be easier for the people to understand what exactly is happening here, right? So the color will be light blue, and now comes the text. We will close this, and here we will write the text as Python exploratory data analysis, and we will break here the student performance. And here we will close the H1. And lastly, we will display this in HTML code. So basically we missed this library. So we will be importing from IPython display import HTML to display this particular code. So without this particular library, we cannot display any HTML codes in our notebook. So we will quickly run that, and we have a title over here. Now let's proceed with the next part. Now we will use some libraries like CatBoost and LightBGM. So for that we might have to install these libraries. So we will be using pip install here, pip install CatBoost, and control enter to run this particular code segment, or you can also use run, and it's installed. And after that we will also install LightBGM. Sorry, not BGM. So it's already installed. Now we will start importing the libraries that we need. So we will be needing NumPy, Pandas, Seaborn, Matplotlib, and we will also import another special library which is for ignoring warnings. So we will import warnings, and after that we will be importing that warnings from IPython display import clear output, and after that we will tell the Jupyter notebook to import if there are any warnings. So that code will be warning.filter warnings, and in the brackets we will write ignore. So the basic libraries which we will be needing are as follows: import NumPy as np. Let's quickly copy this and proceed, enter. And now we will be needing Pandas as pd, enter. And now we will be needing Seaborn SNS, and we will also use matplotlib.pyplot as plt, and after that we will import warnings from ipython.display import clear output warnings dot filter warnings ignore. Now we'll just quickly run this query, run, and now we will proceed with feature engineering. So you can use a hashtag to ignore that particular line from execution for Jupyter Notebook. And here we will be importing import re from sklearn.impute import simple imputer from sklearn.model selection import kfold. There you go. Now let's quickly run this query. There you go. Now we will proceed with modeling and model evaluation. Once we are done with this, then we will directly import the data into our notebook. So for modeling the data, we will again use a hash code so that this particular line will not execute, and import some libraries lit-gbm as lgb from lit-gbm library, import lgbm regressor from catboost, import catboost regressor. There you go. Let's quickly run this command. There you go. Now lastly, we have one more task before importing the data, that is model evaluation. Once that is done, we can proceed with importing the data. There you go. Let's quickly run it. And now, so far so good, we have done the basic library imports, and feature engineering is done, modeling is done, and model evaluation is also done. Now we can begin with importing the data. So let's also add the HTML code where we have done this importing. So here I will try to add another segment, and I will import the HTML code here which displays a similar HTML format which explains what exactly is happening here. Just a moment, I have the code ready. I'll just paste it here. There you go. Let's quickly run this so that we have a HTML code here, page here which explains what exactly is happening here. So we are importing libraries and also student data. Now let's import the student data. For that, let's write the query. So we are importing the data as data frame, and after that we will write pandas read csv, right? And here we will add the location of the file, right? So the file is located in my downloads section. So let's quickly copy that location and paste it here. So this is the location of my file. Let's quickly run it. So there might be some error. It's okay, we can resolve it. So in such scenarios, you don't have to worry. Either you can add an R, but even if that doesn't work, you might have to change. In this case, it worked, but in case if it doesn't work, what you can do is you can eliminate the R, and you can just change this from forward slash to backslash. This will also help. So this could be worth it. So this can also work. So these are the situations where you can use this. Now let's proceed with some more interesting facts. Let's try to understand what's going on with our data set, right? So what you can do is, now the data is stored in df variable as a data frame. So what you can do is read this particular data, df dot shape, so that you can understand what's happening with this data, right? So it can tell you that there are 6,607 rows and 20 columns. Now let's add another query part, and here you can try to see the head, right? What head means? Basically, head means the column headers. So what you can do is just write df dot head and run. Now you have the column headers and couple of sample columns, couple of sample rows. Now let's proceed with checking the duplicates and identifying the total number of duplicate entries in this particular data set. So you can write down df dot duplicated dot sum, and you will get the number of duplicates present in this particular file. So we have 0 duplicate entries. Now let's see if there are any null elements in this particular data frame. So df dot is null dot sum. So these are all functions. Control enter. There you go. So in the column teacher quality, there are 78 null entries, and in parental educational level there are 90 null entries, and distance from home there are 67 null entries. Now what we can do is from df shape we can add a new cell here, and we can write a HTML code so that the viewer can understand that we are trying to understand our data. So let's write a quick code for that. So let's not waste much time in just writing the HTML code. So I've got that HTML code written in a notepad already. So I'll just paste it over here, and let's quickly run it so that we have a HTML visibility here. So this was supposed to be the result, so we will add it here. So what we will do is quickly edit this particular content. We'll just quickly copy this code and paste it over here. Change the content from importing libraries to reading student data, and we will cut this code from here and we will paste it in here so that it will give us some information. Let's also run this particular code segment so that we have reading student data. There you go. Now the next part of this session will be about creating a target variable. So overall target of this particular data analysis is about exam score, right? So we can name our target variable as exam score, and let's understand the distribution of this particular exam score with the variables we have. Now let's write down plot dot figure size should be around 15,9 equals to, let's add a bracket here, 15,9, or let's keep it as 6. Now 9 would be a little bigger. Now enter. Now we'll use Seaborn library here, SNS dot count plot x is equals to data frame cleaned target. Okay, before cleaned target we might have to run a few more. Okay, we did not perform data cleaning so far, right? So let's proceed with data cleaning so far. So we found some empty entries, right, null entries, and we also found some. So here we have 299 rows which have missing values, so we will have to remove that. For that we might have to create a new column which has to be named as not assigned, right? df data frame not assigned, which is equals to df dot drop na. So we will be dropping the null values here. It's a function, and here let's print the values. Print df dot df underscore hyphen underscore na dot shape. So how many number of rows and columns we have, right? And after that, let's also try to eliminate the null values as well. Dot is null, so we don't have null values, but we have some illegal entries, maybe some. There you go. Now let's quickly run this query. So there you go. So the new data is about 678,20. So there is some, okay, we did some mistake here. So we are supposed to add it as null, null. Now quickly run this. So we should not get any errors this time. There you go, no errors. So far so good. Now let's describe the new data set. df na dot describe. So these are the new columns and the rows that we have, and we have mean, standard variation, standard deviation, minimum, maximum. So the scores are split into 25%, 50%, and 75%, which could be based on hours studied, which could be based on attendance, sleep hours, previous scores, tutoring sessions, everything. So minimum sleep hours, maximum sleep hours, 25% of that, 50% of that, 75% of that. So that is supposed to be the describe. Now what we will do is we have a target variable which is exam score, right? Now we will do some changes to it. We already know in an exam there will be a threshold value. It can be 25 marks per exam, it can be 50 marks per exam, and it can be 100 marks per exam, right? In our situation, let's consider the threshold value is 100 marks, right? If there is a situation where marks is entered in a wrong way, right? It can, if they wanted to add 11, but by mistake if they added another one, right, triple one, it's not a right entry, right? So we will try to eliminate those kind of data. So we will create a new data frame here, which is data frame cleaned is equals to data frame underscore not null. So we have eliminated the null values, df underscore na. Now we will add our target variable, which is exam score should be. So let's come out of this, and here we will add it as should be less than or equal to 100, but not more than 100. Let's use square brackets. Here we also, the format is square brackets actually. Now enter, and we will describe this particular data set. Instead of dfna, we will copy paste this here. Now let's run this. Okay, exam score is not identified. Let's quickly check the error and resolve it. Yeah, so we missed out to add colons here. It's okay, not a problem. So this was supposed to be how it is. Now let's run this, and we will have the answer over here. So we have the output. Now let's check the head of this particular cleaned data set. So we can make use of the same code here and paste it right here. And instead of describe, let's write head, so that we have the header of this particular data set. So we have our study and everything normal, and we will categorize the data, right? So we will make use of 3 columns: hours studied, attendance, and previous scores. And after that, we will also make use of other columns in this particular data set, which happens to be the parental involvement, access to resources, sleep hours, tutoring sessions, etc. And now our target will be the exam score that we created over here, right? This exam score will be our target. And using this particular exam score target, we will categorize the data, okay? We will categorize the data in terms of, let's say, first class, second class, and pass or something like that, right? So if a student is scoring below 64, and that is a separate category. If the student is scoring equals to or above 65, that is a different category. And if the student is scoring beyond 70, that's a different category. And before we proceed with that, let's try to add a HTML code before this particular data set so that we have an understanding of what exactly happened here. So I'll just quickly copy paste this particular code here. So we will run it, and now next we will check the data type, column separate and everything, and we will create data type category variables. Right, and now so far so good. Now we will create the categories. So num call equals to hours studied, comma, attendance. So let's quickly add the data. Previous exam scores. Just a minute, let's quickly add the columns. Let me take a while. So there you go, I've added the columns. So we are considering 3 different columns. Hours studied, attendance and previous scores. For num call and for cat call, we are considering the other columns apart from the first 3, and our target value is exam score. Let's quickly run this. There you go. And now we will try to build some visualizations, and before that let's try to add some data from in HTML. Let's try to create a what we can do is simply copy this particular HTML file here. We can take this and add it here so that we will understand what exactly is happening next. And in place of reading student data, we will write data visualization for student data, and we will keep the colors same, dark blue background, and the color for data visualization will be light blue and student data will be orange. Let's quickly run, and there we have it. Now our target variable is exam score, right? Now we will compare this particular target variable with 3 other parameters. So our parameters will be the following, as we discussed, creating the segregation in dataset, right? So first will be distribution of target variable with other parameters. So we will create another HTML file for that right here. Just a minute while I paste the code for HTML. Quickly run this. There you go. So distribution of target variable exam score against some parameters. Now we will write the plot for that. Plot.figure. So we are going to consider the size equals to 15,6. Fig size is equals to 15,6, the same one that we considered before, and we will be using cbon SNS dot count plot, open bracket, is the function, x is equals to df cleaned. Okay, what we can do is just quickly take the column name so that we don't create any mistakes here, and we will paste it over here instead of df. There you go, of target. So our target is exam score, comma, and we will use the palette as green, and the plot title will be distribution of target variable exam score. We can copy this. Okay, just a minute. Before that, plt dot title should be, let's use double quotes. Now copy this and paste it here. I think semicolons went off. Okay, not a problem. It's right here. Let's add a dot as a full stop, and the next line, if you need you can add the full stop, if not you can ignore. plt dot grid true, which equals to major, comma, axis is equals to y, comma, line style equals to, so I want lines to be hyphen hyphen, in this way I want the lines, and comma, line width, let's say 0.5 or 0.7, let's go with 0.7, line width equals to 0.9 mm. There you go. Now let's quickly run this query. There you go, done, and we have the first visualization. So here you can see there are some students which are scoring 58, 59, and you can see maximum number of students are already scoring good marks, which is under 65 and which is under 70 and above 65, and there is a good number of students which are also scoring above 65 as well, right? So sorry, 70 as well. So we have now less than or equal to 70, 71, and highest scorer in some situations there is also 100. If you can see, there is slight growth here. There are a few students, toppers maybe, which have already scored 100 as well. Now we have the list here. Now what we need to do is we need to segregate. That is part 1, which is less than or equal to 64, which falls under 65, and another category which falls in between 65 to 70 and above 70. So we need to categorize these three datas and segregate them as bottom 65, top which is above 70, and mid between 70 to 65, right? Now before that, if you want to add an HTML document segment here which explains about the distribution of target, you can also do that. It's already added here. Now let's continue. But in case if you want to add some data which explains that we are trying to segregate, you can also do that. I would like to do that. Let's quickly add that HTML code here. So what this particular code will do is it will tell the percentage of students which are scoring less than 65, number of percentage of students scoring in between 65 and 70, and the percent of students which are scoring beyond 70. Right, let's run this, and here we have the result. Bottom 21.81% scores under 64, while 24% scores over 70, and 50% are in between 65 to 69. Right, now let's continue with the segregation part of the data. So for segregation, we will create three different variables, A, B, C. So first, A is equals to length of df cleaned. So let's copy the column name, data frame name, length of df cleaned. Inside the square brackets, we'll again add df cleaned of target variable, which is exam score. Let's also add single quotes here, who are scoring in between or less than. Let's start with less than or equal to 64. We'll not consider 65, we'll consider 64, divided by len of df cleaned target variable exam score, single quotes, into 100, which will give us the percentage. Now similarly, let's just copy and paste this 3 more times for B and C. So here, instead of minus, I was supposed to add equals to, and another one. So here equals to, and instead of A, I will write B, and the last one is C. And instead of 64, we will add 70 here for top, and here we will make some changes. It should be greater than or equal to 65. So this is the third category, A, B, C, and then we will proceed with printing the files. So print the bottom for the first one, which is f of A is to dot to f, and we will add the percentage symbol over here, r under 64. Now we can copy paste the same here, and we can change the variables. So here we will be adding under over 70. Lastly, in between, the ones in between 65 and 70. There you go. Here we will change the values from A to B, and here A to C. There you go, and we can quickly run this query. So it's not 70, it was supposed to be 69. There you go. So we forgot to mention this particular one. Now let's run this. There you go. So we have 21% of people who are scoring under 64, 24% over 70, and 53% are in between average. So I think the school is focusing on improving this particular percentage, reducing this particular percentage, and increasing this particular percentage, and try to eliminate, if possible, this particular one which are under 64. So that is the overall motto, I guess. Now, so far so good. Let's now try to remove infinite values from HTML. Right, so before that, let's add this particular HTML code here, so which explains what we are trying to do. So we will first implement the code that prevents warning about infinite values during data visualization. And now let's add the code which will try to eliminate the infinite values. Let's copy this particular data frame cleaned data frame name here. Now df cleaned dot replace square brackets np dot info comma minus np dot info out of these square brackets dot np dot na non na values. We're trying to eliminate na values. In place of those values, you can write true. And after that, we will try to eliminate the null. So if it is null, dot sum, give me the total number of null values after this, right? So let's try to execute that. There you go. So all the null entries have been removed here. Now let's see the distribution of numerical values here. So before that, let's add the HTML code for that. So let's quickly run this. So distribution of numerical values. So we will be considering these three parameters. So if you go back, here you can see hours studied, attendance, and previous course. So we will be considering these three values or these three columns and check the distribution of these variables against the exam score. So is it making any kind of variation if the attendance is high? If the attendance is high, is the exam score high? And apart from that, we have if our studies is high, is the mark score is high, and if the previous scores are high, is there a chance to get better scores in this particular exam? So what we are trying to do is we are trying to see if there is any direct involvement of number of study hours and number of days attended and number of or the number of marks they received in their previous course, and we'll try to build a visualization on that front. So let's go and build that. So we'll try to write the code here. Figure axis equals to ELT dot subplots. So we will be having three different plots here since we're considering three different categories, and the fixed size should be equal to 12,4. There you go. Now access is equals to access dot rebel for idx comma call in enumerate call, and we will try to import the cbound library here. We will try to create histoplots here, histograms here, histoplot, so line style we will be selecting this one, and comma line width will be 0.7. There you go. Next will be access idx dot set title. So for this we will be setting the title as distribution of columns. So the columns will be the three ones: attendance, hours studied, and what was the third one that we considered? Previous course, right? So instead of mentioning them specifically, what we can do is we can just write columns here, COL, and close. There you go. And lastly, plt.height, and show the plot. There you go. Let's quickly run this query. Run, and now we will be having the visualizations here. So you can directly see the involvement of these three parameters here if they are trying to help. If the number of hours are increased, then you can see if there is a better improvement in scores. If the attendance is increased, if there is a betterment in scores, or if the previous scores are helping, then you can find it out how it is. There you go. Now we can write a result here in the form of HTML page, and if we run this, it will give you the result. The breaks or gaps in the hours studied variable may be due to the respondents answering appropriately. The variables attendance and previous scores, which exhibit a uniform distribution, have a normal impact on exam scores variable, which is a target variable. Now, let's proceed with another part of this session, which will be about the relationship between the numerical values and the target variables. Now, we will copy paste the same code and make some minute changes to it. So the only change that we did to it is we're trying to build a scatter plot. So we will be getting a scatter plot here. But before that, let's try to add another column here and try to add an HTML code which explains why we are doing it. There you go. A scatter plot. So basically these two are one and the same. Here we use some column graphs. So here we did the same using the scatter plot, which will help for a better understanding. Now we will try to build some correlations. So basically, a list is called correlation is created containing the names of the columns for which you want to calculate the correlation. So here in our situation, it is the df.corr, which is a data frame, and it is created by selecting only these columns for df clean data frame, effectively created a new data frame containing only the specified columns. Now the second one, which is the corr, which is a calculate correlation. So this method computes the correlation matrix for selected columns, which is in df.corr. The 1 indicates perfect positive correlation, -1 indicates the perfect negative correlation, and 0 indicates no correlation. And lastly, the setup of plot. This line sets up the figure size of the plot. In this particular situation, we are choosing 5 and 4. Right, now let's quickly try to execute this query and see the answer. And we will also add the HTML code for this so that we have a better understanding for this. So we will be adding that HTML box here, which will explain what exactly happened here. So this is our plot and this is the correlation. Now let's try to add that HTML code right here. So the result of this particular data visualization will be maintained here. So the hours studied and attendance shows a positive correlation with the target variable, which is exams hour. However, previous course appears to have no or little relationship with the target variable. Right, now let's continue with our next part of this session. So now we will try to identify the relationship between studies, hours, and attendance and extracurricular scores. Right, so we have other columns to consider, which is extracurricular activities. So there is a belief that extracurricular activities will also help students to study better. So we will find if there is a relation between the target variable and these extracurricular activities, attendance and study hours. Now let's quickly add the code here. Now let's quickly execute the code. Now we have the visualization which explains the relationship between the number of hours studied, extracurricular activities, etc. So here it is. And now let's add an HTML code which explains about this result. I think this particular code was supposed to be added here. So this is the resultant column here. Now here it explains about the influences that it performs. So the extracurricular activities, parental income, and extra things that influence the scores. And there you go. Now let us also consider other columns, right? The other parameters like resources are available or not, parental education, and other things which also might have influenced the exam scores of students. So for that, let's add an HTML code so that we have an HTML page here which explains what is the next procedure that we are following, right? Now let's add the query here. So here we are considering the other parameters like family income, peer influence, motivation level, gender, parental involvement, parental educational level, and extracurricular activities. And we are considering them against the target variable, which is exam score. And now let's execute this query. There you go. Now we have generated a graph which explains about this particular parameters against the target variable. And now let's add the HTML page here which explains about these results. Let's quickly run it, and there you go. So when certain factors affect Q1 and Q2 but not Q2, it can be understood that individual has overcome challenges through personal effort, right? So if government policies and corporate social contributors are focused on addressing these aspects, it seems that we could create a dynamic country with greater social mobility and open opportunities for all, right? So if extracurricular activities can outweigh the influence of other variables in academic performance, then we should foster that kind of an environment, right? So this is how you can extract some statistical analysis on this particular data set. Now let's quickly rename this Python EDA students performance, and you can quickly rename and save it.
Web scraping is a powerful technique that allows you to automatically extract data from website, turning the vast amount of information available online into something you can easily analyze and use. Whether you are gathering data for research, building a dataset for machine learning project, or just curious about how websites work behind the scenes, web scraping is an essential skill to have in your toolkit. On the other hand, Python is one of the most popular programming languages for web scraping, thanks to its simplicity and the wealth of libraries available. In this video, we will explore how to use Python to scrape data from websites, and we will dive into practical examples using Python libraries like request and Beautiful Soup to fetch and parse web content. But it's not just about the code. Web scraping comes with its own set of challenges and ethical considerations. We will talk about how to scrape responsibly, respecting the rules set by websites, and ensuring that your scraping activity don't negatively impact the sites you are collecting data from. So by the end of this video, you will have a solid understanding of how to start scraping data from the web using Python. Whether you are new to programming or looking to add web scraping to your skill set, this video will give you the knowledge and tools you need to get started. So let's jump in and see how Python can help you unlock the full potential of the web.
So here I am using this Google Colab for the web scraping. Okay, you can use your own like Jupyter Notebook, Visual Code Studio, anything. Okay, so here I will write web scraping using Python. Okay, then here first you have to install some libraries like request, and you have to install Beautiful Soup, and you have to install that pandas, because we will create one data frame and we will save it, then we will check our data. Okay, and you can install some basic Python libraries like NumPy and all that. Okay, so here first I will import request. Okay, then I will write from bs4 import Beautiful Soup. Okay, soup. Then I will write import pandas as bill. Fine. Then now what I will do, okay, let's see what is this request and all this. So request is an HTTP client library for the Python programming language. So request is one of the most downloaded Python libraries. Okay, it's like more like over 2000, not exactly 2000, sorry, 200 or 300 million monthly download. Okay, so what it does, it maps the HTTP protocol onto Python's object-oriented semantics. And here Beautiful Soup. So Beautiful Soup is a Python package for parsing the HTML and XML documents, including those with malformed markup. It creates a parse tree for documents that can be used to extract data from HTML, which is useful for web scraping. Let me run it. Here our second step will be define the URL and the headers. Okay, URL and the headers. So URL, okay, from where you want to extract your data. So I will write here Simplilearn, then this, Okay, let's open this PMP certification. Okay, let's got it. Yeah. So here I will write this and headers equals to. So these are the headers. Okay. So like in which device or you are working on, which browser you are working on. So these are for the headers. So now what I will do, I will send a GET request to the Simplilearn page. Okay, to this URL. For that, right, let me write this, sending GET request. Okay, here write response equals to requests dot get, then URL comma headers equals to headers. Okay, let me run it. Okay, working fine. So now let's check if the request is successful or not. For that, if response dot status code equals to 200, then so equals to to. Okay, then response dot content comma HTML dot parser. Okay, here I will write codes titles. Why? Because here I'm initializing the list to store our titles or whatever the things are. Okay, basically the data. Okay, why I'm writing course here? Because this is again course page, that's why, nothing else. Okay, here I will give the empty list. So now we will find all course titles based on the actual HTML structure. What is HTML structure? You have to go to the page, right click, then inspect. Okay, according to this HTML structure means what is the class name, what is the this PMP certification is which heading, H1 heading, H2 heading, which heading it is. Okay, so let's see which heading it is. Okay, this PMP certification training H1 heading. Okay, just remember H1 heading. So here I will write for course in so dot find or H1. Okay, then title equals to course text dot strip. Okay, then here I will write course titles dot append title. Okay, now what I will do, I will check if any data was extracted before it not. Okay, I will write if course titles. Here I will create a data frame, df equals to pd dot data frame. In this I will write course title. It will be our that column name. So I will write it course data. Okay, then course titles. Okay, then here I will write df dot to CSV, then just create Simplilearn.csv. Okay, so our data will be saved in this Simplilearn.csv. Okay, CSV. Fine. here what I will do, I will write index equals to false. Print data, and data is saved in CSV, Simplilearn.csv. Fine. So here I will write else print web page. Okay, write field to retrieve the web page. Okay, that's it. Let me run it. Okay, if response or status quo. Response object has no attribute. Status code. Okay. Okay, title. It is text. Some minor spelling mistakes are there. Okay, dear dot field. Sorry, my bad. Again. Okay, sorry. D will be capital, F will be capital. Yeah. So now you can see data is saved in Simplilearn.csv. So what I will do, I will write data equals to, everyone know how to read CSV in Python. Read underscore CSV. What was our file name? Simplilearn.csv. Okay, let me copy paste, run it, and then find data. Okay. PMP certification training data is fetched. Okay, here you can see H1 we gave, and that's why PMP certification training came. Let's take what's in H2. Okay, in H2 there is leading premier PMI partner, something is there. Okay, I will change here H1 to H2, then I will run it. Okay, fine. See, leading premier PMI. Okay, let me make it big. Yeah. So now you can see course data we mentioned. So if you will see, this H1 didn't come. Why? Because we have mentioned H2. That's why. So these all are the H2. Okay. So what is this? I don't know. Okay. This is a time series graph. This is Google Colab thing. Okay, so this is how you can literally retrieve your data from any website. Okay, just remember that some websites don't give you access to their, for their scraping, just like Amazon don't give. So you have to use at that time API, and this is not ethical also to use someone's data. Okay, without asking or whatever you guys. So as you can see, I'm using Jupyter Notebook for the Python. Okay, so here what I will do, I will go to new and the Python 3. Okay, so here first I will rename it to pandas for data analysis. Okay, then rename it. Okay, so already everyone know pandas is a Python library that provides extensive means for data analysis, right? Data scientists often work with data sorted in the table formats like .csv, .tsv or XLX. Okay, so pandas makes it very convenient to load, process and analyze such tabular data using SQL-like queries. Okay, so in conjunction with Matplotlib and Seaborn, pandas provide a wide range of opportunities for the visual analysis. Okay, you can make charts and all. Right. So the main data structure in pandas are implemented with series and data frame classes. So now let me import NumPy first. Okay, as NP. Then I will write import pandas as PD. Why I'm writing as NP and as PD? Because I don't want to write pandas and numpy again and again and again. So I gave the short form, you can say. Okay. So here I will write just PD dot set underscore option display dot precision. Okay, then I will write comma 2. Okay, where are it? Okay, fine. So we have imported pandas and this numpy library. So now what I will do, I will demonstrate the main method in action by analyzing a data set on the churn rate of telecom operator. I have like one data set named telecom churn, okay, operator clients data set. So now let's first import it. Okay, so I will write here df equals to, df means data frame, you can give any name. Okay, df pd, as you can see here, pd means pandas dot read underscore csv, then telecom churn dot csv. So you can find this data set from the description box. Okay, in the description box below, right? Then I will write here df dot head. What does this do, df dot head? It will show you, the first 5 lines using the head method of the data set. It will show you first 5 lines of the data set head. And if you will use tail instead of head, you can see the last 5 rows of data set. Okay, if I will write here df dot tail, you can see the last 5 rows of the data set. Fine. Yeah, so on our data set we have state, account length, area code, international plan, voicemail, this. Okay, and the churn rate is false. Fine. So now what I will do, I will recall that each row correspond to one client and instance, and the columns are the features of the instance. So now let's have a look at the data dimensionally, features, names, and the feature types. Okay, so how many columns and rows we have? Fine. So I will write here print df dot shape. Okay, so now we have 3333 rows and 20 columns in our table, in our data set. Okay, so now let's try printing on the column names using columns. Okay, so for that, what I will do, I will write here print. So these are all the functions used in pandas. Okay, then df dot columns. Okay, so now you can see here we have 20 columns right here, 20 columns. Okay, so here state is one column, account and 3 4, these are the all columns name, these columns name. Fine. So now let's use another function called info, which will give you some, it will give you some general information about the data frame. Okay, so here I will write print df dot info. Okay, so yes, so now you can see class is panda score frame data frame, then this much entries. Okay, 0 to this 3332. Okay, column name and the non-null values, non-null count is 0, and the data types you can see, this is object, this is int64 64 object, floating type. Okay, so there are 4-5 type of data sets here. Okay, bool is there, float is there, okay, int is there, and the memory usage you can see 498.1 plus KB. Okay, and then bool is 1, float 64 type is 8 columns, then int 64 8 columns, and object is 3, right? So here these bool, int 64, float 64, and object are the data types of features. Already I told you. So
we can see that one feature is logical. Okay, that bool one is logical. Where is the bool? Yes, this one. Churn rate is logical. Okay, logical means true, false, true, false. Okay, and the three features are of the object type. You can see this state. These are the object, and the 16 features are numeric. Okay, float is also numeric plus variable, right? So with this same method, we can easily see if there are the missing values. So here are, none, because each columns contain 3,333 observation. See, every column is same, and you can see null count is non-null. Okay, so here you can see we don't need any cleaning and that type of thing. Okay, so we can change the column type with the as type method. There is one more method. So let's apply this method to the churn feature to convert into int64. Got it? So for that, what I will do, I will write df, then I will write churn. Please note that no spelling mistake while writing the column names. Okay, equals to df churn. Okay, C is capital dot as type in 64. Fine. So now we have convert this bool to int64 now. Okay, so now what I will do, I will use one more method. Okay, let me run it first. Okay, it's no issues. Now what I will do, I will write here df dot describe. Yeah, so now, so the describe method shows basic statistical characteristics of each numeric feature, int64 and float64. Okay, count is there for the particular column, the mean, standard deviation, minimum value 25%, 50%, this is the max value. Okay, now you can see the churn 0 and 1 to 1. Okay, so, and the number of non-missing values, mean, standard deviation, range, medium, everything is here. Using describe, you can just find it. Okay, for every column it will give you. Okay, count, how much count, and mean of this particular account length and the area code, like this. So now, so in order to see the stat of non-numeric feature, so one has to explicitly indicate data types of interest in the include parameter. Okay, I will use the include parameter. So at first I will write df dot describe include equals to object comma bool. Okay, so now you can see the count is 333 and unique values are the 51, and the top is this and the frequency is this. Okay, so I am here seeing the stat of non-numeric features. Okay, like state, international plan, and the voice plan, like this. Fine. So for categorical data like type, object, and the Boolean type bool feature, we can use the value counts method. So now let's have a look for that also. So I will write df churn dot value counts. Okay, so this is some data, right? So now what I will do, so there are, okay, fine. So now what I will do here, I will normalize it. Churn dot value counts normalize equals to true. Okay, So we have 2850 users out of 3033 are loyal. Their churn value is 0. Okay. And to calculate fractions pass normalized is equals to true, I have did that to the value count function. Okay. So here you can see 0 and the 1 value counts. Right. So now let's go for the sorting data. So what is sorting? So a data frame can be sorted by the values of one of the variables like columns. So for example, we can sort this table by total day charges using ascending or in descending, right? So now I will do here df. Okay, first let me write here sorting. Okay, df dot sort values by equals to total day charge ascending equals to false dot head. Dot head means I want to see the top 5 rows. Okay, so now what I did, total day charge. Okay, total day charge I have sorted in this. Ascending equals to false means I have sorted into the descending order. Okay, and the top 5 rows are this. Okay, 59 is the maximum, 59.64. Fine. So now, like, we can also sort by multiple tables, so in one go. Okay, so let me do it. Df dot sort, same thing I have to write, values by equals to churn. Okay, this. Yeah, churn, comma, then again total day charge, comma, ascending equals to true, comma, false. Then I want to see, okay, let me write the same dot head. Okay, first I will show you this 11111. Okay, then let me change it. See, it's sorted now. Fine. So these are the top 5 as per these 2 columns, churn and the total data charge column. Okay, so now we will perform some indexing and retrieving data. So a data frame can be indexed in a few different ways. Like, to get a single column, you can use data frame name. Okay, and so now let's use this to answer a question about the column alone. So let's take one question like, what is the proportion of churned users in our data frame? Okay, proportion. Okay, df dot, we will do simply, we have to find the mean. I will write churn dot mean. That's it. Okay, so 14.5% is actually a quite bad for a company, such as a churn rate can make the company go bankrupt, right? So Boolean indexing with one column is also very convenient. So the syntax is, I will write here df, then again df churn equals to 1, then dot mean. Okay, so here what I am finding is what are the average values of numerical features for churn user. Okay, see, account length just ignore this warning. Okay, so account length is 102.66, area code is this, right? So now what I will do, I will find one more thing. So like, we will find how much time, like in average, Do churned users spend on the phone during daytime? Okay, df then churn equals to 1, then total day in minutes. We have this column, right? I hope so. We have this column, total day minutes. Okay, fine. Yeah, dot mean. Okay, so how much time an average churned user spend on the phone during daytime is 206. Okay, almost 207. Okay, so now let's take one more question, like what is the maximum length of international calls among loyal users? Okay, loyal user means where churn is 0, like who do not have the international plan. So here for that I will write df and df churn equals to 0. Here I will write and df, okay, I will, okay, international plan equals to no, because there is, see, you can see the international plan, no, yes, no, yes, no. Okay, no, then total international minutes. Okay, this, okay, for the confirmation let me copy it and paste. Okay, no issues. Dot maximum value. Yeah, so 18.9. okay, so 18.9 is the maximum length of international calls among loyal user, whereas churn is 0, who do not have the international plan. Okay, so indexing, data frame can be indexed by column name, I told you already, or the row name, or by the serial number, you can say, of a row. So there is one method, loc. Okay, method is used for the indexing by name, while iloc is another method for indexing by the number. Okay, first I will show you df dot, here I will write indexing, df dot loc comma state, then area code. Okay, so in this first case, we can say I gave the values of the rows with the index from 0 to 5, like inclusive, and the column labeled from the state to area code inclusive. Okay, so this is how you can perform indexing, okay, using by name. Okay, if you want indexing by the numbers, you have to use iloc instead of this loc. Iloc means location. Okay, don't get confused. 5 comma 0 to 3. Okay, see, you got the same almost, right? Yeah, this is 0 to 5, okay, and this is 0 to 3. 0 to 5 means 1 2 3 4 5, and 0 to 3 1 2 3. Fine. Yeah, so what if we need the first or the last line of the data frame? So we can also do that. So here simply you have to write simple thing, df -1, okay, That's it. See, this is the last line, -1, last line. Fine. So if you want to, apply something to all the columns, so there is one more function which is apply. So how to do is df dot apply np dot max. Okay, right? It gave me all the maximum values of the particular table. Sorry, particular column, not table. Okay. So this is how you can do this. So this apply method can also be used to apply a function to each row. I already told you. So to do this, you have to just specify the axis or the lambda function are the very convenient in such scenarios. Like for example, let me give you one example. df, then df state. Let's use the state. Okay. Then dot apply lambda state and state 0 equals to w, which is starting from w. Okay, then dot, I need only 5 rows, dot it. Okay, so the state is starting from w, here it is. Okay, top 5, right? So yes, so there is one more function, map method, which is used to replace the values in a column by passing a dictionary or the form, right? So map function d equals to no okay, it is false, then yes is true, right? Then df international plan equals to df international plan dot map d. Okay, df dot head. Fine. Okay, there is some international plan. Okay, p is small, that is why I was saying please write it carefully. Yeah. Okay, so this is the map function. Okay, so wherever there is no or yes, okay, so I have mapped it to the true false, right? Okay, see here you can see international plan, yes no yes no yes no. I have marked yes to false. And okay, why different? Because the series is different. Okay, here I have performed different thing. The numbers, just check the number. Okay, 0 1 2 3 4, right? df dot head. Let me write this. So now let's compare. Okay, why it's coming? Because I have already performed that thing. So we'll go to here, see no 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 yes yes. Now you can see here false 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 true true. So for no I gave false, and for the true, for the yes I gave true. Fine, this is the mapping. This is how you can do the mapping. Okay, so now let's do df equals to, same thing can be done using replace as well. There is one more function. Okay, let me give you the name, stack replace. Dot replace, then voicemail plan. Oh sorry, my bad.
plan D. Okay, fine. Now yes, then df dot. Okay, so what I took, voicemail plan, right? Same, see, true, true, false, false. Because here, if you will see, I have write D equals to this. Again, you have to write no to false and yes to true. Same I used here, D. No need to write again and again. Fine. So now let's see how to do grouping. Okay, so first the group by method divides the grouping columns by their values. Okay, first let me write this grouping. Okay, so here I will write columns to show equals to total day minutes, right, comma total if minutes, comma total night minutes. Okay, then df dot group by, then here I will write churn, then here I will write columns to show dot describe, percentile. Fine, where is it's empty. Fine, where there is error, df dot group by churn by can different describe got an unexpected keyword argument percentile. Okay, fine, it will be percentiles. Yeah, so this is how you can do the group by with a churn. Okay, so what I did, so let me explain the steps. So first, the group by method divides the grouping columns by their value. Okay, then they become a new index in the resulting data frame. Then column of interest are selected, column to show, this column to show. Okay, so if column to show is not included, all the non-group by classes will be included. Finally, one or several functions are applied to obtain the groups for selected columns. So here what I did, we group the data according to their values of the churn variable and display stat of 3 columns in each group. Right, these 3 columns in each group. Same, count means standard deviation minimum 50% max, count means this. Okay, so this is how you can do grouping. Fine. So if you want to summarize the table, okay, suppose we want to see how observation in our sample are distributed in the context or 2 variables, churn and international plan. So to do so, we can build the contingency tables using the cross tab method. I will show you. Okay, so here I will write summary table pd dot cross tab, then I will write here data frame df churn comma df international plan. Okay, so this is the true false, the summary. Okay, we have this much true false 0 from the international plan, and the 41 are this much. Okay, for one there are 346 and 137 true, right? So this is how you can perform the summary table, right? You can do for the more also. So now let's create the pivot table. Okay, so let's make the tables stack pivot
tables. Okay, pivot tables. Fine. So I will add df dot pivot table okay, then I will write here, sorry, yes, so here I will write total day calls, comma, I will take 3 column total eve calls, comma, then total night calls, comma, then area code. Okay, comma, then aggregate function equals to mean. Okay, I'm using mean. Fine. So this is pivot, you got the area code and the mean of particular this thing. Right. So data frame transformation. So let me explain you first this pivot table. Okay, before moving forward. So so now we can see the most of the users are loyal and do not additional services. Okay, international plan or the voicemail. So this will resemble pivot table to those familiar with Excel and non, of course. Okay, so here the values are the list of variables to calculate stat for, and the index, okay, a list of variables to group data by, okay, area code, okay, and the aggregate function is what stat we need to calculate for the groups, like we can use sum, mean, minimum, maximum, okay, something else. Okay, so here I have used the mean, right? So now let's predict the telecom churn. Okay, so now let's see how the churn rate is related to the international plan feature. So we will do this using cross tab contingency, already saw, and also through visual analysis with Seaborn. I've already told you with Matplotlib and the Seaborn, it pandas is crazy. Okay, so here I will write predicting telecom churn. Okay, so here I will write pd dot cross tab df churn, okay, C is capital, churn, comma, df international plan, comma, margin equals to true. Okay, okay, sorry, my bad, it's margins. Yeah, okay, we got the pivot table here using cost tab. So I will import here, import matplotlib for the charts, matplotlib dot pyplot as plt. Then I will import Seaborn. Import. Just remember to install all these libraries. Okay, you can use pip install Seaborn and pip install numpy, pip install pandas before using it. Seaborn as SNS. Then for the graphic retina, I will use config inline backend dot figure format pursue retina. Okay, then here I will write SNS dot count plot, where X equals to x-axis I'm giving, okay, international plan, comma, let's set the hue equals to churn, then comma data will be df. Okay, see, we have the counting of using international plan, and the hue is churn, okay, 0 and 1. Fine. So we can see that the international plan, the churn rate is much higher, which is an interesting observation. Perhaps the large and the poorly controlled expenses with international calls are very conflict. Okay, so now let's take a look to another important feature, which is customer service call. Let's also use to to make the summary table first. So for that, I will do here pd dot cross tab df churn comma df customer service calls comma margins equals to true. Okay, yes. So again, I have made the summary table for the customer service calls. So now what I will create SNS dot count plot x equals to customer service calls where hue is churn, then data equals to df churn. Yes. Okay, so this is how you can create the charts using pandas and the Seaborn. Fine. So therefore, predicting that the customer is not loyal, churn equals to 1 in the case of when the number of calls to the service center is greater than 3 and the international plan is added. Okay, so this is how you can do data analysis using pandas. Okay,
imagine you're building a powerful backend system that can seamlessly handle requests, process data, and serve responses, all while staying organized, scalable, and easy to maintain. Sounds exciting, right? That's exactly what we'll be doing in this tutorial. Now, in this tutorial, you won't just know how to build a REST API with Flask, but you'll also master structuring it the right way. So guys, watch this video till the end if you want to learn more about it. Now guys, before moving ahead, let us try to understand about REST API. So REST stands for Representation State Transfer Protocol. It is a kind of a web service that basically allows clients like web apps and mobile apps to interact with the server using HTTP methods. Now, you would be dealing with methods like get, post, put, delete. Now, if I talk about get method, guys, so get is all about retrieving a data, okay? And if you want to use post HTTP method, it means like we'll be creating any new data. Similarly, if you talk about put, then this given method updates the existing data. Suppose, for example, you have this data along with you, which you just recently entered using the form, and in which you entered your name, ID, and your given designation. Now, suppose I want to send a HTTP request where I want to change this data, the current designation, to something else. So, for the same purpose, you'll be using put as a given request. So, in this way, you could also do it, and definitely you will have one more option to delete it. So, delete is also one of the HTTP verbs, okay, basically HTTP method, which is going to delete the data from the given database. So guys, basically REST APIs are commonly used in web development, backend systems, and microservices. Now, we will outline our project. We'll be using a layered structure to create our given projects for this API tutorial. And we'll be using Python's backend framework, Flask, to do the same. So as you can see all over here, I have created this folder Python REST, under which you could see that I have these subfolders: controllers, models, repository, services, init.py, and app.py. Now, let's try to understand the role of each of the given folders. So, as you can see all over here that in this given folder, we have app.py, which is basically the main entry point. So this will be the entry point of our application. So this given file is going to initialize our Flask app. It is going to register the controllers, okay, whenever our server starts. Then we have the controller file, okay. So basically in this file, we are going to define our API endpoints with the help of those methods that we discussed, like get, post, put, and delete. And this given layer will be responsible for handling all the user requests, and it is going to send the appropriate response based on that. Then this given controller layer is going to call our business logic layer, okay, which is basically the service layer to process that given data. Think of this as a front desk of your API. It receives requests and directs them to the right department. If I talk about service file, then in this, we are going to implement the core logic of our application, which is going to call the repository layer, okay, to interact with the databases. And it is also going to validate and process data before sending it to the controller. This is where the actual decision making happens. It ensures that data flows correctly between controller and repository. Now, I hope you have got a brief idea about these files. So we have one left file, init.py. Now, this is a given file which is going to make each directory like controller, services, repositories, model act as like a Python package. So it is basically required for importing modules properly. Now, you could see this is a given folder structure, and I would recommend you to use this folder structure for basically, creating organized code, easier maintenance, scalability. And each component has a specific role. You can maintain it will be very kind of easier maintenance. You can modify one part without breaking, everything. And the scalability is also there. Easily you could add new features without cluttering the code. Now let us try to understand what is there in our models folder. So here we have file name item.py. This file is going to define how our items are structured in our application. So you can see all over here we have created a class item. This defines a class item that represents an item. And then you could see we have written def init self, item ID, name, description, and we have binded all these variables all over here. Just like that we do create a constructor in Java, and similarly we use this dot given field name to bind it, so that the particular thing could be what kind of behavior could be occupied in that object. So similarly, we could see that init is a constructor in Python, which basically initializes the item within it. So here we have item ID, which is a unique identifier. Then you have a name. For example, you could put name as laptop. Then you have description, where there is the description of the item. And finally, you have def to dict self. And then you are returning the ID, name, self.name, description, and self-description. So basically, this converts the object into dictionary or a JSON format. So it can be returned as an API response. So you would have got a brief idea of what we are exactly doing in our model class. Okay, so we are defining all the parameters that our given API will be returning, or what given data that will be adding to the post request. Now, after you have created your model, it's always a good activity to go to your services class. Okay. Now, before moving to the services, let us go all over here and try to understand. So you could see that we are using an instance of repository all over here. Now, what happens, guys? So basically, after creating your model, it's always a good practice that you should go to your repository, write a code in the repository. So let us try to understand our repository first, okay? And then after that, you create your business logic. So basically, all over here, you could see we are importing our models.item, importing the item all over here. Then we are creating a class called item repository. Okay, then you could see we are doing self.items, which is basically storing items in a memory, like a dictionary, so dictionary is acting as a database. Then we have put self.counter equals to 1, which is basically going to generate unique items IDs. Okay, and then you could see we have created def create self name description, and then we are using item string self.counter name description. So basically this given piece of code creates a new item object with auto incremental ID, and it adds to the dictionary with self.items. Okay. Now there's another method called def get all self, which basically returns all the items as a list of dictionaries. Okay, so that's one thing you should remember. Then what we have all over here in this piece of code, def get by id, self item id, item equals to self.items.get the given id, and then you are returning in the form of dictionary. If item is there, then return, otherwise do nothing. So basically it retrieves an item by its id and it returns none if the item doesn't exist. So you have got a brief idea regarding the get by id. Okay, now similarly for updating the given data, there is a def update function. Okay, so you could see it's written that def update self item id name description. If item id is present in the items, then what you have to do, you have to assign the given item with the proper id. Okay, you have to access this item, then you have to access it name and description and return in a form of dictionary. If present, then do it, otherwise return none. Similarly, there's a delete function that we have created and it returns self item.pop item id none if it's not none. So basically it is popping up, or it is deleting the item id present. Okay, if that item id matches the given item id present in the item, then it will be popped out. Now we have successfully created our item repository, and this given layer will be responsible for interacting with the database and do a bit of manipulation. Now let's move to our service layer, which will basically be using the instance of repository for all the business logic that needs to be implemented in our REST API will be done by services. So you could see we have this file name itemservices.py. Just right click on this. So guys, as you can see all over here, that when the request is coming from controller, it is directed to the services layer. Okay, then the services layer is using the item repository instance to interact with the database and do all the manipulation. So all your business logic, imagine like services file is acting as a middle layer between the controller and the repository. It is somewhere here in the hierarchy of communication. Now, if you could see our code, we are importing the repository from item repository. Then what we are doing is we are creating an instance of item repository so we can call all the database functions. Now, you could see in this line that we are doing the same thing. Now, in the next, we are creating a method def get all items, and we are using the instance of the repository and calling the method get all, okay, which we have created in the repository. Similarly, by get by id method, the same thing that we have done. For updating the item ID, we have done the same thing, and for deleting the item ID, we have also done the same thing. Now, the logic for these methods are built in the repository section. So whenever the controller, for example, let's go to our request ID. Suppose if the request goes to get the given item by ID, okay, as you can see in the controller layer, so /item ID, okay. So now it is going to go all over here, and the service method that's all over here, so it is present that get item by given ID, so it will be calling the service instance. Now if you go in the service class, guys, so in the service class you have this method def get item by ID. Now this method is going to call this given method which is present in our repository section. So def get by ID, and here is your logic written, which is basically interacting with the DB if you connect it to MySQL or MongoDB or anyone else. So all manipulation you could do is. So there are a lot of things you could do with the REST API. Now let us try to understand our controller layer once. Okay, so you could see all over here that in this given file we will be creating all the important HTTP request methods that are get, post, put, and delete. So basically this given layer will be handling all the given request which is coming to the endpoint. So our base endpoint is /item. Okay, so this is a given URL that is mentioned. So when your application is running on a given port, so you can use HTTP localhost /items/item/item ID. If you want to get that particular ID, you could post it or update it using the put request, and also you could delete the given item. Now let us try to understand the code present all over there in this file. So you could see initially what we are doing is we are importing our Flask module. Okay, so as you can see, so in Flask we are importing blueprint, request, and JSON file. Now blueprint allows for modular routing. You could use it for that purposes. Request basically reads the incoming data from the request. Now you have JSON file, which basically converts Python objects into JSON responses. So you can see all over here, we are importing item service to access the business logic. Now you can see item controller, blueprint, item controller, name, service equals to item service. Now what it is doing, guys, it basically creates a Flask blueprint, which is basically item controller, to handle all the requests which is coming to /item route. Okay, this creates an instance of item service to interact with the stored data. Now you could see all over here, we have the post request first, like creating the item. Okay, so you could see we have used this annotation item controller dot route. So route here we have to give the given route which is going, and you could mention the method, what kind of HTTP method you are using. So suppose here we are using the post method. Now basically you are creating the item, so you are requesting a data from the request.json. So we are using this given package from the Flask library. Then what you are doing is that this data, it is going to read the JSON file. Okay, then you could see it calls service.create item to create an item. Okay, and then it returns a new item with the status code 201. Okay, now similarly, if you go and see all over here in get/items, okay, so in the get all items request, what we are basically doing is we are trying to use the method get request. Okay, so which is going to return the resource. Suppose you added any data, like suppose let's say for example you added a product with name, ID. Okay, so when you are going to go at this URL get/items, so that given data will be returned. So basically it is going to call service.getAllItems to fetch all the items that you have added in your database. It is going to return the list of all the given items. Now every item added will have the particular item ID. Now if you want to access the individual items, then this given method will be called. So basically you are using the instance of service to call this method getItemById. Then you are returning the JSON file item, okay, in that format, the JSON format. Now you can see all over here, we have the update method all over here. So you can see we have the method mentioned name as put, and the given way to, actually update the data is, you have to access the given data by that ID. So in this case, we are basically accessing the user's data by the given user ID. So that's why we have used item/item ID. Similarly, for the controller, we have the same thing mentioned for delete. Deleted the given item with its item ID. Now, similarly, you could see we have put the method as delete, okay, and then it deletes the item if it exists. So you could see it is stored in the variable success, and this is calling the method from the service class, okay, which is present delete item by given ID. And finally, it is going to return a JSON data with message name as item deleted. If the given item is present, means if the operation is success, you return it. Otherwise, else return a error response. So basically with the message as, item not found. Basically 404 status code. So this is how our controller is designed in this project. You would have got a brief idea what, packages we are using from the Flask library. Okay. And how our given layers are actually working and interacting with each other. So there is a lot of dependency management going on in this REST API. Okay, so that's it, guys. So we have created all those things. So guys, you can leave init.py is empty right now because we are not doing the package level imports in this. So this code looks pretty much fine. This project structure looks good. Now, if you go to the app.py, our server will run on this given port, and this is our local host. Okay, so go to your terminal after this, guys. So click on terminal. So you can see we are in our required directory. Now type the name of your given file, okay, and try to run it up. So type Python, okay, and then type app.py, and let's see what is happening. So you could see our server is running on this port. Now I'll be using terminal, guys, to check how our, whether our get request or post request is working or not. So what you could do, guys, you can open PowerShell. Okay. Now, guys, as you can see all over here, we have put a post request in our terminal, and we're using PowerShell for the same. So you could see I have put the header as content type, and the file is application.json. And this is a body which I'm sending right now. Name, laptop, description, MacBook Pro. Okay. Now you could also see I also telling it to convert it into JSON with depth of 10, and then I'm invoking this URI to the REST API. So guys, now let us do the post request. Now guys, as you can see all over here, let's say we are giving the body something like this. Hash headers @ the content type is application.json, and here you could see the body is mentioned with the name, description. Okay, so this is a Dell Pro laptop, and finally I'm invoking it to the given URI, which is the method is post, and I'm attaching the headers and the body section that I've sent all over here to this given URL. Now just click onto it, and you could see our item with the ID 3 Dell Pro 16 laptop is created. So it means that our server is running great and everything is all good. Now guys, let us try to use a GET request and see whether our given items are added or not. So as you can see all over here, we have updated it to MacBook Pro 14 with M3 chip. And this is how you could do it. Now let me also show you how could you do the delete request. Suppose we want to delete this given ID. Now the same command that you have to invoke REST method with the given URI, you have to add the URI with the given item ID set with the ID 1, and I'm using the method delete. Now click on it and you could see message item deleted. Now let us try to use a get method. Okay, and we could see we don't have any items with the ID 1. So guys, this was a short tutorial on REST API using Flask and Python, where we were using the layered architecture of controller, model, repository, and a service.
Today we are talking about must-have Python AI projects and how to build them so that can really help you sharpen your skills and stand out in the growing field of artificial intelligence. So let's quickly see what is Python. Python is one of the most popular programming languages for AI because its simplicity and the powerful libraries it offers, like TensorFlow, Keras, and PyTorch. Building projects using Python is a great way to get started if you want to break into the AI industry. Whereas artificial intelligence is transforming industries like healthcare, finance, and even entertainment. Companies are now looking for experts who know how to apply AI to real-world problems. In this video, we will explore beginner level to advanced level projects. So these projects are designed to give you hands-on experience in building intelligent systems, analyzing data, and even automating tasks. So without any further ado, let's get started. So let's start with beginner level projects. So number one, we have fake news detection using machine learning. So in today's world, fake news is a major concern, causing misinformation to spread rapidly across social media and news platforms. Detecting fake news is crucial to maintaining the integrity of the information we consume. So these projects aim to build a machine learning model that can identify fake news articles by analyzing their textual content, by learning from existing datasets of real and fake news. The model will be able to classify articles into these two categories, thus assisting media outlets and social media platforms in reducing the spread of misinformation. This project is perfect introduction to natural language processing, NLP, as it involves text data manipulation, feature extraction, and supervised learning. It can also be adapted for real-time use on website or social media platforms to flag suspicious articles and provide more reliable information to users. So now let's see how to build this. In this, first step is data collection. Use dataset like LIAR or fake news net that can contain label, real, and fake news articles. You can find dataset from the Kaggle. The second step is pre-processing. Clean the text by removing stop words, punctuation, and special characters. Tokenize and stem words using NLTK or spacing. The third step is feature extraction. Use TF, IDF, or bag of words to convert the text into numerical data for machine learning models. The fourth step is model training. Train a classifier like logistic regression, naive Bayes, or random forest on the dataset. The fifth step is evaluation. Evaluate the model using accuracy, precision, recall, and F1 score metrics to determine how well it classifies fake and real news. Tools you can use is NLTK, Scikit-learn, and Pandas. Skills you will gain from this are text preprocessing, NLP, classification models. And if you want to make us video on this project, please comment down below. In number 2, we have image recognition using CNN. Image recognition is one of the core applications of deep learning and computer vision, used in a variety of industries ranging from healthcare to autonomous vehicles. This project will guide you through building an image classifier using CNNs, a deep learning architecture designed specifically for image recognition tasks. The goal is to create a model that can accurately classify images, such as differentiating between cats and dogs. By working on this project, you will gain a solid understanding of the fundamental concepts of CNNs, such as convolutional layers, pooling, and activation functions. This project not only introduces you to the basics of CNS, but also teaches essential skills like image pre-processing, dataset handling, and model evaluation, which can be applied to more advanced computer vision projects in the future. So now let's see how to build this project. In this project, first you have to import dataset. So use a dataset like CIFR10 or Kaggle cats versus dogs with labeled images. The second step is pre-processing. Resize, normalize, and augmented images using libraries like OpenCV or PIL to prepare the dataset. The third step is model architecture. Design a basic CNN model with convolutional, pooling, and fully connected layers using Keras or TensorFlow. The fourth step is training. Split the dataset into training and validation sets and train the CNN model to classify images. The fifth step is model evaluation. Use accuracy, precision, and confusion metrics to evaluate how well the model predicts the correct class label. Tools you will use in this project are Keras, TensorFlow, OpenCV, Pandas. Skills you will gain after doing these projects are image pre-processing, CNN architecture, model evaluation. And if you want to make us video on image recognition using CNN, please comment down below. Second, we have intermediate level projects. In this first, we have AI-based recipe recommendation system. Recommendation systems have become an integral part of modern digital platforms. From e-commerce website suggesting product to users to streamlined services recommending shows and movies. So in this project, you will build a recipe recommendation system that suggests dishes based on the ingredients a user has on hand. This project demonstrates how recommendation algorithms such as content-based filtering and collaborative filtering can be used to provide personalized suggestions. You will also learn how to pre-process data and clean textual data, such as ingredient lists, and implement a machine learning algorithm to match user inputs with recipe databases. This is an excellent project for understanding how recommendation systems work and how they can be applied in various industries, from food tech to personalized content recommendations. So now let's see how to build this. In this project, first step is data collection. Use web scraping tools like Beautiful Soup to scrape recipes from websites, or use datasets like Recipe1M. The second step is pre-processing. Normalize and clean ingredient data by standardizing ingredient names and handling missing values. The third step is recommendation algorithms. Implement content-based filtering and collaborative filtering to recommend recipes. Content-based filtering matches ingredient list, while collaborative filtering uses user preferences model. Fourth step is model training. Use cosine similarity to match user-provided ingredients with recipe ingredient in the dataset. And the next step is interface and tools. So create a simple web interface using Flask where users can input ingredients and receive recipe recommendation. Tools you will use: Beautiful Soup, Pandas, Scikit-learn, and Flask. So you will gain skills like web scraping, data cleaning, recommendation systems using this project by doing this project. And if you want to make us video on this project, please comment down below. Number 4, we have chatbot with sentiment analysis. Chatbots have transformed how businesses and services interact with users, providing 24/7 support and personalized responses. In this project, you will build a conversational chatbot that can analyze the sentiment behind user inputs and respond accordingly. By incorporating sentiment analysis, the chatbot will not only understand the content of the user's messages, but also the emotional tone, such as whether the user is happy, frustrated, or neutral. This allows the chatbot to adjust its tone and responses to improve user satisfaction. For example, a chatbot could offer a more empathetic response if it detects a negative sentiment. This project will give you hands-on experience in building a conversational AI system while learning how to integrate machine learning techniques like sentiment analysis. The skills you develop in this project can be applied to customer service, healthcare, education, and more. So now let's see how to build this project. In this project, the first step is chatbot framework. Use tools like Dialogflow or Rasa to build a conversational chatbot capable of handling various user intents. The second step is sentiment analysis. Integrate a sentiment analysis model using pre-trained models like Veda or BERT. The third step is conversational flow. Adjust the chatbot's responses based on the sentiment, positive, negative, or neutral, detected in the user's input. The fourth step is integration and deployment. So build an interface, website, or messaging platform where users can interact with the chatbot in real time, and deploy the chatbot on a website or app, allowing user to engage with it and receive sentiment-aware responses. So you will use tools in this are Dialogflow, Rasa, Vader, Transformers, Flask. And you will gain skills like sentiment analysis, chatbot deployment, conversational AI. And if you want to make us video on this project, please comment down below. So now let's see some advanced level projects. In this we have AI-powered image colorization. Image colorization is a fascinating application of deep learning that transforms black and white images into color by predicting and applying realistic colors to grayscale images. This project explores how CNN and GANs can be used to learn mapping between grayscale and colored images. You will gather dataset of colored images, convert them into grayscale, and train the model generate color version. This project is especially useful in areas such as film restoration, photography, and artistic creation, where colorization can breathe new life into old black and white images. Moreover, it highlights the power of deep learning in understanding and generating complex visual data, giving you insight into how these models work for tasks like image generation, video prediction, and beyond. The skills you learn in this project will also be useful for other creative AI applications like style transfer and image synthesis. So now let's see how to build this project. So in this project, first step is data collection. Use dataset of colored image, convert them into grayscale, and use the grayscale images as inputs while training the model to output colorized version. The second step is pre-processing. Normalize images pixel values and resize them for training. The third step is model architecture. Implement a unit model or generative adversarial network (GANs) which are well suited for image generation tasks like colorization. Fourth step is training and evaluation. Train the model on grayscale images as input and colored images as output using mean squared error method for guidance. Evaluate with visual inspection and peak signal to noise ratio. The last step is deployment. So create a web interface where user can upload black and white images and get them colorized. So you will use tools like TensorFlow, Keras, OpenCV, and Flask. So we'll gain skills like deep learning, CNNs, JNs, and image preprocessing. And if you want to make a video on AI-powered image colorization project, so please comment down below. And the last we have object detection using YOLO. You only look once. Object detection is one of the most popular computer vision applications, allowing machine to recognize and locate multiple objects within an image or video stream in real time. YOLO is a state-of-the-art object detection algorithm known for its speed and accuracy. This project involves building a real-time object detection system capable of identifying multiple objects in images or videos feeds by drawing bounding boxes around them. Object detection has widespread use in fields such as security surveillance, autonomous driving, and augmented reality, where systems need to understand and interact with their surroundings in real time. By working on this project, you will learn how to pre-process image data, format bounding box labels, and train a YOLO model using a dataset like Coco or Pascal. You will also gain a valuable experience in deploying object detection systems that process video streams, giving you the skills to build application in dynamic environment, from traffic monitoring to industrial robotics. So now let's see how to build this project. So in this project, we will first import dataset. So use a dataset like Coco or Pascal VOC, which contains label objects in images with bounding boxes. The second step is pre-processing. Resize image and normalize pixel values, ensuring bounding box labels are appropriately formatted. The third step is model architecture. Use the YOLO, you only look once architecture, which splits images into a grid and predicts bounding boxes and class probabilities for each object. The fourth step is training and evaluation. Train the YOLO model on labeled data using a framework like Darknet. Evaluate the model using metrics like intersection over union and mean average precision. The last step is deployment. Develop a system that can process video streams in real time, detecting objects and drawing bounding boxes around them. Tool you will use OpenCV, TensorFlow, and Darknet. You will gain skills like object detection, YOLO architecture, real-time video processing. And if you want to make videos on this project, please comment down below. So in conclusion, these Python AI projects not only help you build hands-on skills, but also provide a solid foundation for advancing your career in artificial intelligence. Whether you are working on fake news detection, image recognition, or developing advanced tools like chatbots and object detection systems, these projects offer real-world applications that companies are looking for.
So now let's get started with Excel. So here you can see some rows and some columns. Let's understand from the basics of the rows and columns, and then we can understand the basic fundamentals on Excel, which we will be using on a day-to-day basis if you are proceeding with data analytics. Some of the basics are data validation, conditional formatting, data cleaning, pivot tables, lookups, aggregate functions, and also before we dive into analytics, we have an inbuilt analyze function in Excel. If you can see something on the right-hand top corner of the home tab, you will find something called as analyze data.
don't look into this add-in. So this is one of the co-files that we have added in. But before that, you'll just have analyze data. So this is something from Microsoft which can be considered as an AI analyzing tool. Once you provide this data tool with the data set that you have on your Excel worksheet, it will consider it as its input and it will just build some quick pivot tables for you, and it will be more like an interactive session where you can just ask some basic simple analytical questions to this analyze data tool and it will give you instant results. So now let's get started. So in Excel, if you are entering data, then this is the row and this is the column, and every column will have its own column header. So based on the column header, you will be writing some queries, pivot tables in the future. Now let's understand that fundamental. So now apart from that, you will be having home option. Here you'll be having all the font. Here you'll be having all that font settings, and here you'll be having alignment. And this section where you have the number group, this is really important. So here you will get to decide the data type of the data that you're having in. So most of the columns in your data set might be having date data type, it might be having salary data type, it might be having employee ID data type, right? So all these three or multiple will have a different dedicated data sets. Let's say if you're going to employ number, then you might be having a combination of alphanumeric, or you can have just number, right? So if it is alphanumeric, then you can go with character data type. If it is just number, then you'll have to go with a whole number. And if it comes to phone number, then it's definitely and purely a whole number, right? So you need to focus on that. You cannot just keep that phone number in text format, do you, right? And apart from that, if you come into the date section, you might be having join date, you might be having the last working day, or etc. It can be anything, right? If it is related to date, then make sure that you are choosing the date format, right? And you might also have some other information. So the basic foundation on data types is make sure that you have the right data type for the right data. If you mess up, then it is going to be really having a tough. If you mess up, then trust me, in the analysis phase, you're going to have a tough time. So that's the reason you need to focus on data types first. Don't worry, we will go through that one step at a time. And when we cancel and close this section, you will have conditional formatting here, which we will be exploring down the line. So conditional formatting is something similar to data formatting. So let's say you have some student data set and you wanted to highlight, let's say if you have 10 students, it's really easy for you to identify which student has the passing marks and which student is flunked out, right? But in case if you have about 100 students, or let's say 1,000 students, in that scenario, you might have a tough time to identify or point out the students with failed marks or the passing marks, or, categorization into first class, second class, and, something like failed candidate. So in such scenarios, conditional formatting, which you can see in the Home tab in Styles section, this particular option comes really handy. And apart from that, you have a basic foundation steps where you can insert a row, delete a row, or format. So you can do this on the go, and here you can see some aggregate functions, right? So you have some average count, mean, max. So we will be having this aggregate function in this particular tab. We already have some data set here, so we will be explaining that here. And apart from that, coming back to the data sheet, so here you have some insert options where you can insert the pivot table. So here we have a basic explanation for pivot table as well. So this is just the foundation step. So we will have this for a couple of minutes of discussion. Once we are good with this, we will dive into a sales data set, which has about 10 to 12,000 rows of data. And we will also understand Power Query, where we will combine the year-on-year data together into one consolidated spreadsheet and then continue with it. So there's a lot to learn in this. So stay tuned. Now, coming back to the insert option, here we have pivot table, recommended pivot tables. And if you are going with something like data visualization, then you also have charts here if you go through this. So we have line graph, we have bar graphs, maps, pivot charts, a lot of them. And here you have spark lines. And apart from that, here you have timeline filters and slicers. So we will be going through this timeline filters and slicers in the last phase, where we will have the dashboard of the sales data that we have created. So what we will do is just analyze the sales data, create some pivot tables, then pivot charts, then consolidate all the pivot charts in one single dashboard, and we will have slices into it, and then we will filter. Let's say we wanted sales for a specific product or a specific brand, then we will know what kind of leads are generated, what kind of conversions we have, how many number of orders we did get, and how many number of orders did we get, and how many number of customers we have, a lot of those things. So apart from that, if you go into draw, this is basic foundation. So here you will have some options to draw, or if you wanted to highlight something in your presentation when you're presenting your data or dashboard to your clients. And if you wanted to highlight something, then you can use these pen options to just write something on the screen, something like that. And here you have page layout if you wanted to print your data set, or if you wanted to print your dashboard, then you'll go with page layout here. And you have the basic formulas that we already went through, which is aggregate functions. And rest, we have the data. This tab is also really important for us. Here you have the option of getting data onto your Excel dashboard or Excel workbook. Now, why get data is really important. Do I really need to use Excel to get data? Yes, because Excel happens to be that one Swiss knife still existing in every data analyst pocket, because this is one such friendly tool, or one tool which helps you with all the requirements. You can start cleaning your data. You can make some important changes on your data. It's like a quick, handy tool for you. So Excel is still one of that very important tools that you need to have in your arsenal if you're going with the fight with data analytics. So here you can get data from a wide range of resources coming from Excel workbook. It can be a text CSV, it can be Excel, JSON, PDF, or a folder as well. And if you're having your data on some database, then you can also go with database as well. And don't worry, speaking of databases, we will also export our final sales data onto SQL and specifically MySQL Workbench, and we will also perform some data analytics using the MySQL platform as well. And if you're working with cloud storage like Azure, you can also connect that from Azure to your Excel platform and Pub platforms as well. And apart from that, you have other resources like ODBC, web, etc. You can also do some web scraping and load the data from your websites to your platform as well. Now, you can also directly launch your Power Query from here. And apart from that, if you are having multiple sources of data, then you can just click on the refresh all button, and automatically your dashboard and your data sources will update everything in one single click. And apart from that, if you are focusing into filters, then let's say you wanted to identify the sales happening in one single state. Let's say we have all the states of a country, and you wanted to find out the sales related to one single country. Then you can use the filter option to filter out all the states except one that you want, and then remove all of those. So that is what something you can deal with filters. So here we have it. And if you swipe down, you have data tools group. Here you have data validation, and you have data. So here you can remove the duplicates data. Data duplication is one common thing. And if you wanted to remove all the duplicates in one single go, then remove duplicates option that you have will be really handy. And here we have text to columns option. So text to columns comes handy when you wanted to kind of split the data into different parts. Let's say you have customer first name and customer last name, and you wanted to separate them as two different columns from one single column. Then you can go with text to columns, and you can also provide the delimiter, whether if it is a space delimiter, hyphen delimiter. Based on that delimiter, it will split the data. And in the next group, you have the forecast step. If you have data for this current month, or this current week, or this current year, and you wanted to see how the data could be performing, or the future results, then you can go with what if analysis and provide some steps to it, and you can get the projected data, right? Not just that, if you wanted to, let's say, know the marks of a student, what could happen if, let's say you have 5 subjects in total to learn, and you have got the scores for 4 subjects, and you have reached that limit point, right, to either pass or fail. Now, to identify what number of marks you need to get in that one subject, you can do a what if analysis, and it will give you, let's say you will pass if you get 65 marks in that final subject, And if you get below that, you'll flunk the exam. If you get above that, you'll pass the exam. So you have that logic in your mind, right? And if you're having a different use case and a bigger digit, not just 2 number digits, then you can go with what if analysis and use it in real business use case, and you'll identify what would be the target for me to, achieve that target. Let's say like 6,000 traffic you need to get onto your website to reach that target. You can do that with what if analysis. And you have the data analysis shortcut here. So you can use that. And since we already went through it, you can use that logo to generate some automated Power Pivot tables for you and get the analysis, right? That's what you can do with data. There's another shortcut here. And apart from that, here you have review, which we rarely use, and view and automate. If you're going with automations, then Excel VBA, this is the perfect place for you. And developer, which is also related to Visual Basics and VBA. And this is the Power Pivot, where we will use some Power Pivot options and create some data models and etc. So these are the basics you need to know before you get started with Excel. Now that we have a comfortable understanding on how rows and columns are used in Excel, how you insert data, how you create some formulas in aggregation, and apart from that, how you create some data analysis charts, etc. And apart from that, you have some data validation foundations, condition formatting, etc. Right? Now we will get started with hands-on. So here we have data validation. Let's understand how that really works. So here, let's say we have a small data table, and here we are manually adding the data. So let's say, imagine this is your sales data set, and here you need to add the sales related data, right? Now I receive a new order, which is 1005, and the product I'm selling could be one of the three options, which is tablet, phone, or laptop. Let's say I make a sale of tablet. So I have to manually write tablet, and then how many number of tablets did I sold? I think I'll be selling about 2. And then what's the price? So I think I'll be getting around $800 for this, and I sold it in the central region. This is okay for, I think I have 18 rows here, excluding the row headers. So this is the row header. So excluding the row header, I'll be having about 18 entries. Now what if I have 18,000 entries? That's a little confusing and scary, right? And this could be a little tough as well. Now, for such instance, you can use some automation and you can use some built-in functions of Excel. So let's start with the order ID. Now, let me select these two, and here you can see a small logo has been highlighted. If I expand my screen, you can see a small logo, right? This is called flash fill. If I just click on it, let me go back. So it's like I'm training this particular tool that I have a series entry. If I click on it, it will load the rest of the data entries to an automatic number, right? In the increasing order, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on, right? And in a similar way, I can't do this with these entries. Now for that, I can go with data validation. So I'm basically selling 3 different types of items in my store. So I'll have this around here. And I have 5 regions. So I'll have them around here: north, south, east, west, south, and central. So what are you doing? Why are we getting this, type of thing here? And what's the importance of this? So let me explain that. Now, I'm just trying to create a drop-down option where I can just select the item that I'm selling. So for that, I'll go to data option, and here I have the data validation option. So what I want to do is, I have a lot of options here. You want to go with any value, you can go with any value, a whole number, decimal, list. Coming to list, I want to proceed with list because I already have a list of elements I want to work with. Now I want to provide the source. So where's the source for this? So I can select these cells as my source, and you can also have an input message. So you can provide an option which says select from the drop down. Yeah, this could be my message, and this could be my products, and error alert as well. So we have our repeat. So here we have our drop down, right? So based on the drop down, you can select the items. Similarly, we will drag and drop this to this particular whole length. What we can do is we can right now select everything, and we have an empty drop down here.
and we'll just copy this and drag and drop to the end. So we have the data validation applied for all our sales. Now, whenever I make a sale, I just simply select the item that I've sold, add the pricing. So what's the price for a phone? Could be $200. Let's have made about $400 here by selecting phones to the central or west region. So we'll also go through that region as well. Now here we have another list. Let's say I sold a tablet, and $400 would be the price of one single tablet. So I'll sell one tablet here and the $400 price tag here. Now, can we do the same for the region as well? Yes, we can do that. So it's a simple process. Again, go through the data validation, and here we have the data validation option. And here we go through the settings, and since any value will be our list, so where's the source? This is the source for my region, and you can have the title. So you can have the title as zone, and please select from the drop down there you go, and error alert. From the drop down. Now we are good to go. Now you can also drag and drop this to all the cells we have here. And from the simple drop down, you can see there's a highlight here, and this particular cell is related to zone. Please select from the drop down alone, and can be anything north, south, east, west. And if I write something else, let's say I want to write it as some random name, I'll drop it as Excel and hit enter. I'll have an error. Now you can retry, and we can go to cancel, and then we will go through the region, right? Now what this does is, this has wonderful benefits. You're dealing with a small data set for sample on my screen right now. But if you're dealing with a bigger data set, let's say thousands together, 10,000 or even lakhs of entries, and you have a collection of colleagues or employees or your reportees, let's say 5 to 10 or even more, and they're supposed to enter the data for you on your database, then this really comes handy. This avoids that data corruption or inconsistencies in the data, right? You just get them an option, they just make a sale and select something from the option which is right, and then you will have this data ready for analytics. It kind of minimizes the effort on data cleaning aspect, right? Now we will go into the next stage, which is about conditional formatting. Remember the example that we discussed about students dataset? We have something similar here. We have about 30 students and their scores in their subjects, which is math, physics, chemistry, biology, English, and sports. So a lot of them have cleared their exams and they have passed in their exams. There are a couple of students which did not. Something like we have an example here. Karan Mehta, who might have scored 29 marks in math and 35 in physics, 33 in chemistry, and so on. So there are a couple of more students who might have passed, who might have flunked, right? So you can just eyeball it and mark them. So I want to eyeball this particular section and mark it as red color, indicating that this particular candidate has failed in the exam, right? I want to do that to all these students. Since I have just 30, if I had about 300, what if I had 3,000 students? Will I manually check and add them? No. Even if I work with only just 30 students, manually eyeballing each and every single student could be painstaking and time consuming, right? And from a business perspective, let's say you have a wide variety of products, a wide arsenal of products that are performing sales and everything, right? And there you get a moment where you have to present your sales insights to your client. And if you are manually eyeballing every single sales performance and highlighting it, and what let's imagine that your client identified something which you missed, could be really problematic in real time, right? So to avoid that, do you have any tool in Excel which can, automatically look at each and every single cell for you And does the thing what you're trying to do in just moments or even seconds? Yes, we do have. So that is nothing but conditional formatting. So before that, let's go through this small shortcut, which is Alt HOI, which will automatically adjust the cell width and height. So we have everything in order. And now we can go with conditional formatting. For that, you just need to highlight all the cell elements and go through conditional formatting. I want to highlight the cells in some color which is less than a dedicated number, which is 35. And I can also get to choose the color, red border, red fill. So I'll go with the first one, which is red fill. Enter, and there you go. Now, all the cells where the score is less than 35 is automatically highlighted for you, right? Everything in repeat. So everything is in order. Now, this will be really helpful in real time. And conditional formatting is not just about identifying a number which is greater than or less than an highlighting it with a color. It's a lot more than that. You can also include some logical conditions. You can also use some mathematical conditions. You can also use some complex formulations and then let conditional formatting decide the right decision for you. For now, we'll just, go through the fundamentals, basic examples of understanding how conditional formatting works in real life. That was a brief example for it. But in case if you wanted to explore a lot about conditional formatting, we have a dedicated tutorial on conditional formatting where we have explored each and every possible permutation and combination through conditional formatting, and it will be a great learning experience for you. So we will link it in the description box below, and you can also search that on channel. Now going to the next phase in this particular tutorial, which is about data cleaning. Now data cleaning could be a little too early for you, or even it can be the spot on position for you right now to learn about it. So what's the need for data cleaning could be the question, right? We had a good foundational experience on data cleaning in the section where we discussed about data validation, where you will have your employees or team members adding data for you, right? In real time, one data analyst might have a different perspective of vision for data cleaning or data positioning aspect, and another might have a different perspective, right? If I expand this table here, you can see, if I expand again, some of the entries are a little too different from each other. If I consider date joint column, someone has entered DD, MM, and YY. So the first one, DD 12, second one MM01, last one YYY and Y, which is 2023. In terms of Excel or in terms of data analytics, you mentioned the month as M, you mentioned the date as D, and you mentioned Y as here, right? So here, if you see, the first cell entry is proper according to us, maybe. And the second cell entry is, having a delimiter separated by slash, right? And the third one is having YY and YY format with MM or could be DD as well. We don't know. 2 can be the month of February, or 2 can be a date, and 10 can be a date or the month of October, right? There's a lot of confusion. Now, the fourth one looks a little more pleasing. So it has 10th date and month is February and 23. Again, if you deep dive, 23 can be a date. It should be a date. So, yeah, we don't have a 23rd month. But yeah, in case if it were 3, then it could have been confusing. Would that be the month of March, or 10? Would that be month of October and the date is 3, right? So these kind of inconsistencies can happen in real time. So before we proceed with any kind of analytics, data cleaning or making the data ready enough to proceed with analytics happens to be the most important stage. And here you have amount paid column. So some of them are already mentioned with a currency. So here you can see euro, and some of them are, having some space which can be considered as an inconsistency, right? And apart from that, here you have the first name and last name. There are most of the scenarios, let's say ticket booking, if you're booking an airplane, repeat. Let's say ticket booking, let's say you're going with airline ticket booking, then always the second name comes first and the first name comes after. So let's go with Rahul Verma or Rahul Kumar, right? And in the airline booking system, Kumar comes first, then comes Rahul, or maybe the vice versa. Basically, the thing is, you want a name to be split into first name and second, right? So here, someone has chosen comma as a delimiter. Someone has chosen hyphen as a delimiter. Someone has chosen space as a delimiter, right? There is some inconsistency. Same with the phone numbers. So there are places where they have written hyphen. There are places where they have written brackets, and a lot of problematic thing here as well. Now, city and country. So here we have city and country combined in one place, but I want them to be separate. City as a separate column and country as a separate column, right? So these are the foundational basic examples for data cleaning. So let's get started to understand how it works in real time. But don't worry, in our sales dashboard, we will have a little more complex data cleaning operations where we will change the data type, happen to include some mathematical calculations, create new columns, split the data, and you also have some data related operations where we will be formatting the date, and then we will change the format from MMDDYY to YYDDMM, making it completely ready for SQL data analysis. And we will also have some pivot table analysis, a lot more. But now let's understand the basics of it to basically get the gist of it or wrap head around it, right? Now I will remove this comma and make it as space, and I will remove this hyphen and have the space there. Now I can't do this for every time, right? Let's say I want to eliminate the bracket here, so I can replace it. Find and replace. One has been made, and here another bracket is there, so I'll do that as well. Replace all, and I want to remove hyphen and replace all, and there you go. And you can also manually get into this particular one and remove the space. Now you have numerical values, and if you go through this data and if you go through this data column and into the data type, it is general. But we want more formats, and I want to select text because in case I want to run some text matching operations, find me the details of the customer whose phone number is, then it is basically a text matching operation, right? So in that scenario, I want this data type to be in the text format. So I'll keep it that way, right? And here I want to insert a new column so that I can go with text split operation. So here I'll go with data and here text to columns and go to next, and my delimiter would be hyphen and then next, and here I can see a quick preview. So this would be my city, this could be my country, and then finish. Do you want to replace it? Yes. So here I have cities and here I have countries. Good to go. And here I have numerical values. So I want to eliminate this space and I want to provide a dedicated currency format to all the numbers. Since one of them is already having a euro, I want to add euro for rest of the ones as well. So I would like to go with currency, and here I have the symbols. I'll go with the euro. Might take a little while. So E, C, D, and E. There you go. So I have euro here. Okay. And I have all the currency formats. Rest is date. This might take a little confusion. So first, we will do this in two stages. Since we have dot, slash, and everything, we will do it in two stages. We will go through data and text to columns. Here we will go with delimiter, and here we will unselect everything. We'll have nothing here. And next is here we have to select month, day, or DMY, whichever suits you best, and finish. Let's do that once again. I think I missed something. Yeah, I was supposed to go with month, date, and year and finish, right? Now, what we will do is replace this with good data format. Here I choose year, month and date. This is so far done almost. I'll replace the dots with hyphen and we are good to go. So here we have cleaned data ready for analysis. We can save it. And now here we are at, let me delete this unwanted sheet. And now we are ready with data cleaning. And now we come to the next part of data analysis basics, which happens to be the pivot tables, right? Now, pivot tables, as the name says, pivot, right? They make a pivotal point in data analysis. So we already went through the data validation part here where we had some product and sales related information, right? Now, let's say I have this data table here, which is also related to sales. We have some salespersons, region like north, south, east, west, and product details, units. So all those details. Now I want to find out what is the number of sales we did in a specific region, or let's say I want to find out the sale figures for the employees. We have Rahul, Mohit, Priya, and everyone. I want to find out what's the number of sale or what's the revenue that they generated to my organization. And let's say I wanted to deal with product related data. How many number of products that we sold in the laptop segment, or what's the total revenue we generated via laptop product, right? All those details, you cannot just manually check all those on the worksheet and get the details, right? So we have one such tool to help us with, which is pivot table. So it's really simple. You go to the insert option. We discussed this before, how to get to the pivot tables, right? So we just need to go to insert, and here we select the pivot table option. So here we have two more other options where you can insert the pivot table in the same worksheet, or you can choose to create a new worksheet altogether. I'll go with the new worksheet and create, yes. So we have a skeleton here for pivot table. So to get the results, it's really simple. It's just a drag and drop operation. Let's say I want to get the region-wise sales. So I'll drag and drop regions into the rows. And now I want to find out the unit price, right? So I want to drag and drop unit price to aggregation. So automatically the aggregation function is set to sum, and Excel is intelligent enough that I'm looking for some operation. So I want to find out the total sales, right? So it gave me the total sales. Now, instead of region, let's say I want to find out salesperson. I simply drag and drop salesperson into the rows. And if I don't want that, so we have the details here. Each and every one of them have equally performed. So they made $1,900 sale. And I don't want salesperson. Now I'll just drag and remove the salesperson out of this box. And I want to find out the product level. So I'll drag and drop product into the rows. Now we have the product level sales. So laptop gave us $3,600. Phone gave us $2,400. Tablets gave us $1,600, right? So this could come really handy in terms of real world analytics. And you can also create some, pivot charts as well. You have the pivot chart here, and you can choose any kind. I'll go with the pie chart and press OK. And you have a pie chart here. You can name it as product sales, and you can also choose a dedicated option, and you'll have all of those in one go. So this is really important when we are dealing with dashboards. So we'll have a similar approach. We'll create different pivot tables and then their respective pivot charts, right? So this could be handy. So this is the basic understanding of it. Now we can name it as pivot chart. Now comes lookup, right? So let me have this table positioned somewhere here. Now, what is lookup, or why is lookup really important for us? So most of the times, just like we had the data here, let me close this. So most of the times, data will not be positioned in such a way that all the details are in one place. So we have a different reason for that. That is called data modeling. So you can understand much about data modeling when we land into SQL, Power BI, and Tableau. So in real times, let me go back to the same position. So in real times, we have separate positions or separate places where we store the data. For example, in my sheet, you have employees data table in one place. You have employee name, department, code. This acts as a foreign key here. So we'll have a briefing on foreign keys and primary keys in SQL. So we have department code, we have product code, and the unit code. Similarly, we have a different table for departments. We have department code and department name, and another table for products where we have product code, product name, product pricing, right? So the data will be scattered. So each and every data table will be interconnected with each other via data connections or data relations. So these are done via schemas. One of the popular one is star schema. We have a lot other varieties as well. And we will have one-to-one, one-to-many, many-to-one, many-to-many relationships as well. We will go through them in SQL. So basically, we will try to store data in different locations or different tables, and then pull some strings and establish a connection with each and every other table, right? And then we will segregate all of them to one place via relations and perform data analytics. Now let's take a use case. I have a third table where I want to find out the employee related information. Right now, if I go through employee data table, I find out the department code and the product code, right? Not the actual literal name of the department or the actual literal name of product that we sold. And what's the sale he made, right? I don't have that. Let's take that as a use case and find out what's the department name and product name. So we can do that via VLOOKUP, XLOOKUP, HLOOKUP, right? A lot of options there. But we will go with XLOOKUP alone, because vertical lookup and HLOOKUP are a little too obsolete right now, not completely obsolete, but XLOOKUP is a step ahead or advanced. It's a combination of both, right? And let's also discuss some quick limitations. VLOOKUP looks from left to right. Let's say the lookup value is in the left position and your result is in the right position. Then it looks from left to right. But if it's the other way around, if your lookup is in the left and the result is in the right, VLOOKUP will never work. Similar with HLOOKUP, top and down approach. But if it is XLOOKUP, you just have to give the lookup value and the result value. It will give you the result regardless of the positions of the lookup array and the result array. So to save time and have a stronger dominating approach in data analysis, let's go with XLOOKUP alone. But in case if you want to really explore the lookup functions, we have a dedicated tutorial where we will discuss VLOOKUP, HLOOKUP and XLOOKUP all together, and we will have hands-on experience where we will definitely understand how it works in all the scenarios. Now, without much ado, let's go with XLOOKUP. So here, I want to find out department name. So I'll write a simple XLOOKUP formula here, and I want to provide the lookup array, right? So this is my lookup value, and where is my lookup array? So this is my lookup array. So yeah, we were also supposed to have this in my table. So let's have it. Yeah, now it makes sense. So I want to find out the department name, right? Also, I wanted to have product details. So I'll have this as well to find out them. I need this. There you go. Now, to find out the department name, I want a lookup value. This is my lookup value. And this is my lookup array. And this is my result array. There you go. Now you can simply expand this to all the sections and you will have all the department names. So Rahul Sharma belongs to sales and he also sold a product, right? Now we want the product details. So similarly, XLOOKUP, and I want to look for this particular product, and this product details are here. So this is the lookup column or lookup array, and this is my result array. Hit enter, and this is the item. Now similarly, if I want to find out the pricing details, I'll go with XLOOKUP, and this is my lookup array, and this is my, that was my lookup value, this is my lookup array, and this is my result array. Enter. There you go. Now we have a perfectly analysis ready data table. So we have Rahul Sharma. He belongs to a certain department, and he belongs to or he sold a particular product, and this is the revenue he generated, right? So this is how you use XLOOKUP in real time. And apart from that, we can now deep dive into aggregate. So basically, lookups help you segregate all the data from different tables together in one place, or you can also fetch for some missing data. Basically, they act like search and get the data. And apart from this, we can now deep dive into aggregates. So aggregates help you with some basic mathematical functions like sum, divide, total, average, etc. And apart from that, you can also find mean, median, mode, max, minimum, right? So here we have some examples. So for average, let me remove this. So let's say I want to find out the average pricing. So I'll just write down average of unit price, and there you go. And let's say I want to find out total revenue that I generated. So in that case, I'll use sum function and give this particular array as the input. And I'll also try to find out maximum pricing of a certain product where I'll use max function. And now I'll give this particular array and find out which is the maximum product. So a laptop has been the maximum product so far. And if I want to go with the minimum, then I'll give it as minimum of this particular array. And I'll get the minimum pricing and so on, right? And so on. So these are the basic aggregate functions that you can use on daily basis. And now with that, we will make a transition to the next function in our list for today, which is analyze. So analyze acts as that one automation tool, which is inbuilt in your Excel, which gives you the pivot tables, which it will create by itself, and you can just have so analyze does this thing where it automatically creates pivot tables for you and calculates the things for you and gives you results in a conversation like style. So select the entire data set, go to analyze, and you will have all the pivot tables readily created for you. So there you go, you have sales amount by region, discount sales amount, and you have a beautiful line and bar graph together. Here you have a bar graph which shows you region-wise sales and time-based analysis as well. Apart from this, if you want to have a conversation with your what analysis or analyze data in Excel, let's say I want to find out what's the total amount of sale done by Rahul. So I'll just write down Rahul, total sales. It will give me all the sales which Rahul performs. So he performs sales in the North region. I think he is handling North region. Apart from that, if I expand this particular table to an extent, then I will have a few more details. So we sold about electronics items category. He sold about one laptop, one phone, and one tablet. And yeah, I think he sold 2 units of laptops, 4 phones, and 5 tablets, and units price, and also the revenue that he generated. So that's all about the basic functionalities of Microsoft Excel so far. So with that, you have understood what are the main day-to-day applications that you do along with data analytics when you are on Excel. So you'll be performing some data validation, conditional formatting, data cleaning, creating pivot tables, pivot charts, right? And you'll also use some lookup functions like VLOOKUP, HLOOKUP, and XLOOKUP. I would recommend you to focus more on XLOOKUP than other two. So because XLOOKUP is totally advanced and it is a combination of both V and H together, and it'll save you a lot of time, and the limitations are very less compared to the other two. And apart from that, you'll also have some aggregate functions and mathematical functions where you will apply some basic fundamental mathematics, subtract, multiply, add, right, divide, etc. And aggregate functions like maximum amount, minimum amount, and total revenue to generate average revenue by zone, etc. So far so good. We have a comfortable understanding of Excel fundamentals that you will be using on a daily basis. Now we will make a huge transition to the next part where we will have some real-time sales data from the year 2021 to all the way up to 2026. And we will have separate Excel files for that, year-based, and then we will try to, add them all to one place and do some performance analysis, etc. So let's go with it. Now with that, we will close this sheet, and this particular sheet will be saved for you. This particular sheet will be saved for you just in case if you want to follow along or if you want to have a deep down on this, and I will provide this sheet for you. So that will be saved. Now let's go through the data sets. So here we have sales data from 2021 to all the way up to 2026. Let's have a quick briefing of the data set. So we will be having Okay, let's use that quick shortcut Alt-HOI to adjust the column width. So we have order ID, we have order date, delivery date, order status. So consider this as a social media marketing analytics. So we have a wide variety of platforms. We have Instagram, Facebook, Snapchat. We will have YouTube and Facebook. So we will be running some campaigns on all those platforms. And based on those campaign platforms, we will have generated some traffic here. So we have about so much traffic in the year 2021. Then out of so much traffic, we extracted about so many leads. And if you see on my screen, we have so many converted orders, and those orders have turned into given us some revenue and given us some profits, right? And this particular section will be about the funnel data, and this could be our orders data, and this could be our customers data, where we have customers ID and name of the customer, first name, second name, email of the customer, the location, state, region, pin code, door number, and also phone number, right? So these are the basic things we will be having. Don't worry, we will be also performing some data cleaning operations here. This particular phone number, if you observe, we have +1, which is a country code. Along with that, we will also have some hyphens, so we will be cleaning that all. And in case if you're wondering, can we make that into a country code? Yes, we can convert that into a country code based on the country code provided here. Since you're dealing with only the US-based data, I think the country code is not specifically required here. But in case if you want to go ahead with some logical operations, you can also include the logical operations and identify which country code it belongs to and add the relevant country code as well. Now, this is the quick walkthrough of our dataset. Now, let's proceed with the next section, where we will have a new sheet created. And remember about the data importing operations that we discussed about. We will be importing the data from a folder now. So we have saved all this data in the new DA file. So here we have it. We will make use of the Power Query in Excel and segregate all the data together, apply some data cleaning operations and steps, and then once the data is ready, we will proceed with analytics. Now, let's go to data, and here we will get data from a folder and navigate to the folder. So our folder is in downloads, so new DA, and Power Query is up. So we want to perform some data manipulation here. So we will go with data transformation. So here is our Power Query. Now you can click on this particular expand button, where we will combine and expand the folders altogether, or the files altogether, the workbooks we had dealt with. It will take a little time. And now this is your preview. So you will have order ID, order date. So you can already see the order date has been transformed to a different data type. So we will have to do that. And we will also have the customer details, where we will have customer ID, first name, last name combined together. We will have it split. And then if you scroll further, we have the phone numbers, and next we have the traffic detail, or the funnel detail, where the revenue and profit are not formatted to currency. We will format them to currency. So few changes that we will be doing. So let's click on OK, and we will have the Power Query window opened for us shortly. So there you go. So it has already applied some steps for us, filtered hidden files, invoke custom function, and all those things. In case if you don't want any of these changes to be approved, you can just click on into, and that particular change will be taken off from the list. But I'll continue with what we have so far. I want to perform something from my own. So firstly, I don't want this file name here. I'll remove that. And we have order dates here. So what I'll do is quickly change the type to date. And we will have the DD by format. And apart from that, here we have customer details. So I'll quickly split this, so it's a little more fast in Power Query. So here I'll provide the delimiter and click OK. And I'll name this as customer ID, and this as customer first name, and this as customer last name. And now we have the phone number. Before you change the data type of phone number, I'd like to make some changes to this. So what I'll do is I'll replace the values. So since I have +1 here, I don't want +1. So I'll just replace this with anything and everything or nothing, right? And now again, I'll replace the values, and here we have hyphen left out, nothing again. So now we have proper phone numbers. Then we will deep dive into the last section where we have quantity, traffic, orders. Yeah, this is the one. Now I want to select these two and change the data type to currency. And this is now in dollars format. And I also want to add a new column here, which will tell me about the cost price. So I'll name this as cost price, and I will add revenue into the column and profit into the column. So subtraction of revenue and profit should give me cost to company. So this is the one. I'll also change this type to currency, and all good to go. Now let's have a quick briefing. So we have order ID, we have the order date, delivery date, order status, platform, customer ID, customer name, last name, email, state, region, PIN code, door number, phone number, and subcategory, category, product, quantity, traffic, leads, orders, revenue, profit, and cost price. So far, so good. Now, what I will do is go back to home, close, and load the data. So the data will be now loaded, and here you have the quick query connections and everything that you wanted in one place. And here you have the table design. I'd like to go with the basic design, what we always used to have. And I'll remove the filter. We'll go to filter and sort and clear the filter. And if you come back here, you have this in the form of date. And I don't want that to be in this format. I'll go to year, month, and date format, which is SQL friendly for us in future. And everything is in order. Now you can also do some formatting if you want, but I'm good to go with this. And I'll save this as, before saving, let's go back and remove any other sheets. So this sheet was the original one, which we don't want. This is the one which we care about. So we will save this as downloads, and in here we have created a new file, new TA. We will save it as book2, and also we will save it in the form of a CSV file because we need CSV SQL. There you go. Now it's all good to go. Now what we will do is we will open this particular spreadsheet once again, and okay, I think I opened the CSV file. We're supposed to open the Excel workbook. Now we can continue with some pivot table analysis. There you go. We can select all the data and now go with the insert pivot option. So I'll create a new pivot table. So here I want platform wise analysis. So I'll have platform here and the total number of orders that I have received. Or the revenue that I have received, and it will be here. It will give me a platform wise analysis, and then we will create some pivot table chart, which can be this one, and leave it here and call it as platform based revenue, right? And now we'll go back to this particular one. We'll insert a new pivot table. We will insert a couple of pivot tables so that we have what we need. So we will have region in the rows and revenue in the values. So for this, we will have another pivot chart, which can be a pie chart. And based on this, we will have region-wise sales here. And go back to this particular one. insert a new pivot table. So here we will have state-wise revenue, and we will use it as map. Or a tree map should be good. Bar graph should be good enough. Now we will create another pivot chart, and here we will have category wise analytics. And we can also insert another pivot table here and call it as subcategory level analytics. So we will have the brand based analytics as well. So far, so good. Insert another one. And here we will check the audit date. And revenue as the values. Now we will go to the pivot chart and add the line graph. There you go. Now we have year-on-year analysis of sales and revenue. So we had a spike during 2022 and 23, and then we have a drop. We can see the sales growing in 2026 and so far. Now we have a couple of pivot charts. Now we are good to go with the dashboard. So let's have this copied and pasted in this particular sheet. Click anywhere and paste it. And let's go to sheet number 2. This one, sheet 7. You can select anywhere. We have this. Let me close this particular window. Copy, paste. So we can also have a pie chart for this one. Brand distribution. And lastly, the month on month or year on year analysis, or I can just name it as YOY revenue. Then just copy this and share it to this particular place. And there you go. Now here we can insert slices. So I want slices for region, we want slicer for state, we want slicer for a subcategory, and I think that should be good enough. And press OK. So now, before we do anything, let's place them in order. And this would be the last one. There you go. Now we need to report connections. So we need to connect every other slicer with every other slicer. Similarly, the report connection to this one as well. So if you don't report the connections, the problem is the slicer will work with the only connected papers or the reports that you have got them connected to. But now if you report all the connections, you will have the specific brand alone. If I select Jordan, then I'll have the brand distribution of Jordan alone. Similarly, if I select the central region, you'll have the sales report only for the central region alone. So each and every chart is now interactive. So similarly, if you select any single state, you will have the results based on that single state alone. So this is how you create a completely interactive dashboard in Excel. So far we had a beautiful understanding of the basic functions repeat. So far we had a comfortable understanding of what are the basic functionalities that you will be handling when you're working on data analytics using Excel. And also we have created some Power Query operations, imported data from Excel workbooks, and then we have created a lot of pivot tables and pivot charts. And at the end, we have created a completely interactive and functional dashboard of the sales report. Now with that, we will make a transition to SQL, and we will be using the same Excel workbook there as well, or the Excel CSV file, to create a quick SQL data analytics report using some queries. And we'll also have, before we do that, we'll also have a quick understanding of the basic functionalities of SQL and then dive into the report generation in SQL. So now we have finished Excel, and that particular workbook was completely saved, and it will be attached in the description box below for you to practice, don't worry. And now we have landed onto MySQL Workbench, and here we will start with SQL queries. Don't worry, we'll not hurry. We will start off from fundamentals, how to create a small table, and I'll not take much time in just fundamentals here. So we'll create some simple tables here, and then we will try to extract some basic queries just like we did in back in Excel, so that you have a comfortable understanding of how SQL works in real time. Once these small sections of SQL fundamentals is done, we can directly, you can see on my screen, we can directly drive ourselves into the analytics part, where we will use the same previous sales data set that we created and filtered and query for analysis, and run some queries and extract the data that we are looking for. Now, without further ado, let's get started. So first, we will create the table, which is departments table. So you need to use the create and table keywords and the table name, which is departments. The department ID will be integer, and this will be primary key. So we need to dedicatedly provide the naming convention here that makes SQL understand this is the primary key. Next is department name, which is work here, and you have provided the character limit of 50. So Control Enter will be the shortcut that we will be using. So before that, I think we need to select the database. So we are in interview database now, and then we will create this particular table. The table has been created, and now entering the data is also similar and simple. It is straightforward. Insert into the table, which is department, and the table column, the department ID and name. And here are the values that we will be inserting. So these particular tables are inserted successfully. Now, if you want to check or extract what you have in departments, it's really simple. select star from the table name, and you can just write down the table name here, semicolon to end the command, and there you go. So you have the following entries in your table. Next will be the employees data table, and here we have employee ID, name, salary, department, and hire date. And here we will be having one foreign key, which is department ID. Control enter, and we have successfully created the employee table. Similarly, we will enter the details into employees table. Don't worry if it is getting a little faster. We will have this query document shared with you along with the analytics queries that we will be performing upfront, right? Now you can use those queries and follow along with us, right? Now we will enter these elements into the employees table. Same like before, we will select star from employees table and paste it here, semicolon, enter. So these are the employees we are dealing with. And we'll also have users data table, control enter. We have the following users to be entered into this particular users data table. Yeah. Does not exist. I think, yeah, this is the one. We need to create this. Yeah, we have created the table. Now we need to enter these particular elements into the data table. Control enter. Just like before, you can quickly select star from everything or select everything from users. Place users here, semicolon, enter. So these are the users you will be having. The fourth table is orders data table. Here we'll be having order ID, customer ID, and order date. So if you recall the Excel tutorial, I said you about something, data modeling. So anywhere we will not have all the data elements present in one single table. You can see it here, right? So we are creating 5 different tables. We created a users table, we created an employees table, we created an departments table, and we are creating an orders table. And apart from that, I think we also created a product table as well, right? Departments, we created a department table, we created employees, users, orders, and the other one was sales, right? So we are creating 5 different tables. And if you go along with me here, we have also mentioned dedicated locations which say as foreign. Now, foreign key is something which is used to reference another table, and based on that, remember the lookups, right? We created a 2-column entry, 2 new column entry in a data table, and referencing to one particular element in the present table to the referencing table, we extracted an output, right? In the same way, if you want to put some value to your table using another table, so in that particular instance, you might have to make use of the primary keys and foreign keys, and you might have to reference that particular table and extract the details. So this is about mostly subqueries and joins. We'll also go through that. Now, if you want detailed tutorial on that, we will have a SQL full course included in the description box below. You can go through that. But now we are just skimming through the surface of basics of SQL so that we can deep dive into analytics, right? So we have entered these particular elements and we have extracted them from elements of the table named employee. And the fourth table is orders table. I think we have successfully created orders as well. Or for safer side, did we create it? Yeah, it's already created. Now we need to enter or select star from orders table, semicolon, enter. So we have not entered anything. So we need to enter these elements. Control enter. And now we will have some elements in the orders table. Now let's proceed with the last table, which is about the sales table. We have successfully created it. And these will be the entries into the sales table. Now select everything from sales. And here's the output. There you go. So far, so good. Now let's go ahead with the basic fundamental statements. So to retrieve everything, we have so far used this select star everything and only names. If you are looking for dedicated columns only, then you can provide the column names in specific here and we will get them. And if you want to filter out something, let's say I want employee details of only engineering department, then you can do that with the where filters as well, or the where clause as well. So I want everything from employees, where department is specifically mentioned as engineering. So here we have the engineering department details. At engineering, limit 0. Unknown DPT. So I think we need to go to the departments table. Okay, so department ID, we were supposed to go ahead with department ID. Since we want the department name as well, I think we need to create a join here. That would take just a moment. Join departments. So where is departments table? Yeah, departments. Join departments on employees dot department ID. Did we create a departments table? I think we have created employees table. Yeah, we have created departments. So department ID, department name. We need to copy these both and place it somewhere here. Department ID is equals to employees dot department ID, where department name is equals to engineering. So far so good. Now let's run the query and we have the details. So we have unexpectedly ran into joins a little bit early, but no worries. So basically that's how we join two different tables and extract the insights. So in the employees table, when we created the employees table, we did not specifically mention the department name. I think we mentioned department ID there. So based on the ID, we just roll back to departments table and extract the department name using the employee table via the foreign key department ID. So that's how basically it works. Now we go into another section where we kind of filter the data based on a number. Let's say I want to extract the employee details where salary numbers are greater than 90,000. So we are using a salary clause here with where clause. So greater than 90,000. So these are the employees. And similarly, we have employees in marketing team located in Chicago. So we have and condition here. So where clause along with an and condition, and similarly employees hired. So this is a date and time function. So here we are using a higher date should be greater than this particular year and date. So remember we created year, month, and date, or YYYYMMDD format, because that is SQL friendly. That's the reason we have converted the date format in such way, and here we are using the date and time functions here, right? Now we are going into the sorting and order by function and having by clauses in the future. Now we are selecting everything from employees table, order by salary ascending. So what is happening here is ASC is a keyword which orders in ascending order, smallest to largest, right? Now let's enter. There you go. So these are the employees with least salaries and these are the employees with highest salaries, and higher date descending similarly with date function. And the last one is department and salary. Now we have the limit and distinct function. So let's say you wanted to find out that top 3 employees with highest salaries, then limit function will be helpful for you. What it does basically is it limits down the top 3 rows and rest will be omitted. Now let's go through that. And here we have select distinct from employees. So some of the times you might have used that delete duplicates function in Excel, right? In the same way, here you're not deleting anything, but what you're doing is basically filtering out the distinct entries in a table. So we'll be using distinct keywords for that. Now we have entered into the last segment. Like before in Excel, we'll be using the aggregate functions, right? In the same way, if you wanted to find out the total count of employees, you can go with the count function. Total salary expenditure on all the employees, go with the sum function. And if you wanted to filter out the average salaries in a dedicated department, you can do with that as well. Department name is equals to engineering. I think we were supposed to use the joint clause here as well, just like before. Or we can just quickly use the same query that we used before. Yeah, this one. Copy. Go back to aggregate functions. So here we have used a keyword called as, right? So it's used for aliasing. Now we'll place it here, join departments. This should probably work. There you go. So we have 90,000 as the average salary, minimum and maximum in just one query. So this is the minimum salary and this is the maximum salary. And now count the employees per department. This is where we come across group by. Group by is like creating a pivot table and looking into the numbers based on a specific department. So just quickly enter and there you go. Department, I think it was department name. Select. There is some error here, but not to worry much about it. Let's quickly try to resolve it. There you go. So we have 9 people in engineering. Okay, so far so good. Now we can just quickly dive into, without much ado, we can quickly dive into analytics section. So this is our analytics, right? We will frame some questions, and based on the questions, we will derive some answers in the query format. So consider this particular question as a quick homework for you, and you can tell me the answer in the comment section. This is your homework. You need to count the total number of employees per department. Now we have entered the analytics section. So we will be having some analytical based questions here. So I'll explain you what the question is about and why is this question asked. And then we will write a query, right? Now let's start with the first question. We will be having this data in data basics database. Now this is a different database. Now the first question is year-wise revenue trend. So this analysis focused on calculating the total revenue generated in each year to understand overall business performance. By comparing revenue across years, we can clearly identify growth patterns, shutdowns, or revenue instability. This helps stakeholders evaluate whether the business is scaling consistently over time or not. The outcome supports high-level decisions related to forecasting, budgeting, and long-term strategy. Now let's quickly look at the query. So let's go through the database first. So this is the same data that we created. We have order date, order ID, delivery date, status, platform, first name, last name of the customer, customer email, state, location, etc. And we also here have the revenue, profit, and cost price that we recently created. Now what we are basically doing is we are selecting the year section of the overall order date. So you can extract month, date, or year based on the time functions over here. And we are aliasing it as year. And we are using an aggregate function, which is sum, to calculate the total revenue as revenue from the database, which is DVA. And we are grouping by order date and order by year. Now, let's quickly run this query to get the output. So here we have so much revenue generated in 2021, which is about 1.2 million. And down the line in 2026, we came down to 1.19 million. So we have a consistent kind of revenue generated. So our peak was in 2023, which was compared to the 1.2 million in the previous year. Now we have the next question, which asks about platform performance analysis. Since we discussed, we have a wide variety of platforms, which is YouTube, Facebook, Meta, Meta or Facebook, Snapchat, Instagram, and everything, right? Now I want to deep down a little bit and understand which platform is really working for us. So that gives us the second question. This analysis evaluates how different sales platforms contribute to overall business revenue. The goal is to identify which platforms are performing strongly, which ones are not, and which are the ones we need to focus on. Understanding platform level performance helps businesses allocate marketing budgets or operational efforts more effectively. The insights support data-driven decisions on platform optimization and future investments. Now, let's go through the query and answer the question. So here we will be selecting platform, and here we will also be using an aggregate function, which is sum of revenue, and we will be aliasing it as sum of revenue or total revenue, and we will be extracting this from the data table, which is DBA, and we will be grouping by platform and order by descending, right? So we will be having platforms which are performing top on the top position and the least ones in the last position. That's the meaning of descending order, right? Now we have Instagram performing on the top, next is YouTube, next is Snapchat, and so on. So WhatsApp is a little too low here, maybe due to some privacy concerns or spam reports, right? So we need to make our ads a little bit more realistic so that they reach to our customer in the best place possible, so that we can position our products in the best way possible, right? Now that brings us to the third question, which says about order fulfillment status distribution. So you might be having a question, what is order fulfillment status? So order fulfillment status distribution. This analysis examines how orders are distributed across different fulfillment statuses, such as delivered, pending, or cancelled. The objective is to assess operational efficiency and identify potential bottlenecks in the order lifecycle. A high proportion of non-delivered orders may indicate logistics or process issues. These insights help improve fulfillment performance and customer satisfaction. Now, let's go through the query and extract the answer for this. So I will be selecting the order status. So basically the order status is about delivered, cancelled, in transit, right? So that status will be in this particular column, and we are counting the total number of orders and we are aliasing it as total orders, and we are using multiple aggregate functions here. So the first external function is round. That particular round function is basically used to kind of give a round figure. So let's say if I have 4.7 marks, then it will be rounded as 5, and if I have about 4.1, then it will be rounded as 4. So based on the closest number, it will roundify the outcome. So then we have count aggregate function, which counts total number of orders, and it will be divided by a total number of over, and then it will be giving us a percentage, right? And it will be extracted from the DBA status database, and we'll have the group by clause here by status, right? Now the status delivered, total orders were 8,370, and the percentage of success is satisfaction is 69%. In trans, so this can be either converted into delivered or cancelled. So both are possible. So let's eliminate the 20%, and the rest is cancelled is 10%. So quite good. We are doing really great. So we have about at least, if we take an average, we have about 75% of success rate in our delivery, right? Now that brings us to the question number 4, which deals with average delivery time analysis. Now, what is time analysis? This analysis measures the average time taken to deliver orders from placement to completion. The intent is to evaluate logistics efficiency and identify delays in the delivery process. Longer delivery times can directly impact customer experience and repeat purchases. The result helps businesses optimize supply chain operations and improve service reliability. Now let's go through the query and answer this. So similar to the previous one, we will be using round function, average function, and we'll also be using date difference function. So why is date difference here? It will basically subtract the delivery date with the order date, right? Now that gives us a number of days taken to deliver the days. So we'll alias it as average days of delivery. And we will be extracting this from data table DBA, where order status is delivered. So we'll be filtering out the status table where only delivered products are calculated. And let's quickly enter. And there you go. So we have about 6 average days to deliver the product from the order date to the delivery date. Now, that takes us to the fifth question, state-wise revenue distribution, where we might have to analyze which state is giving us highest revenue. So state-wise revenue collection or contribution, this analysis breaks down total revenue by state to understand regional performance. The goal is to identify high revenue and low revenue regions across the business. These insights help stakeholders focus marketing, logistics, and expansion strategies on high potential states. It also supports region-specific planning and resource allocation. Now, let's quickly go through the query and understand it and execute it. So we will be selecting state column and we'll also be selecting the revenue column. We'll be using an aggregate function, which is total sum of revenue, and we'll be aliasing it as total revenue from the database DBA. We will group by state and order by total revenue in the descending order so that we have the top performing states in the first place. So we have, and in case if somebody asks you, give me the top one state, then you can limit it by 1, or top 3, you can limit it by 3. So here you have top 3 performance, right? And that brings us to the next question, which is about product category profitability. So product category profitability. This analysis evaluates profitability across different product categories to understand which segments generates the most value. The intent is to identify high margin categories versus low performing ones. These insights help businesses optimize product mix and pricing strategies. It also supports decisions on where to invest, scale, or discontinue offering. Now, let's go through the query and understand the output. So here we are selecting category column. We are also using a sum aggregate function from the profit column, the one which we created using some mathematical calculations, right? Now, order by descending. There you go. So we have training equipment on the highest profitability product category. Then we have team sports, running, outdoor, etc. Now that brings us to the 7th question, which talks about top 5 best selling products by revenue. So this analysis identifies the top 5 products based on total revenue generated. The objective is to understand which products contribute most significantly to overall sales performance. These insights help prioritize inventory planning and marketing focus. Highlighting top sellers also supports strategic decisions around promotions and product scaling. Now, let's go through the query and understand it. So we will be selecting the product column. We will be using an aggregate function of sum on the revenue column. We will be selecting this from the DBA data table. We will be grouping by product and we'll be ordering the revenue in descending order, and we will be selecting the top 5. So we'll be using limit 5. Jerseys, sweatshirts, helmets, pants, and shorts are the highest selling products. Now that brings us to the question number 8, which is about funnel analysis or conversion funnel analysis. So conversion funnel analysis. This analysis examines how orders move through different stages of sales funnel, from placement to final delivery. The intent is to identify where customers drop off or where processes slow down. Understanding these gaps helps improve conversion efficiency and reduce order losses. The insights directly support funnel optimization and revenue growth. Now, let's go through the query and understand how to execute. So we will be using some aggregate function and we'll be using some mathematical operations here. Sum of orders multiplied by 100 and divided by total traffic, which gives us conversion rate percentage from the table DBA. Now let's quickly execute this query. So here we have about 0.52, which is also known as 52% conversion rate, which is really good. Now that brings us to question number 9, which is about customer repeat purchase analysis. So this analysis looks at how frequently customers make repeat purchases over time. The goal is to evaluate customer loyalty and identify patterns in repeat buying behavior. Insights from this analysis help design retention strategies, personalized marketing, and loyalty programs. Ultimately, it supports efforts to increase customer lifetime value and sustained revenue growth. Now, let's look at the query and understand how it is going through. So we will be using a count function and we will be using a subquery as well. So here the subquery is, so we will be selecting customer ID from DBA and we will be grouping by customer ID and we'll be using a having clause, and order ID or total orders So basically, we can choose any of the columns. So we'll be going with order ID. So if the count of order ID is greater than 1, then automatically it is considered as a repeated customer. Now let's execute this query and see the output. So we have about 717 repeated customers in all in total. Now that brings us to the question number 10. So the question number 10 is about profit margin analysis. This analysis evaluates profit margins across products, categories, or overall business operations. The goal is to identify where the company earns the most and least profit relative to the revenue. These insights help in pricing strategies, cost management, and resource allocation. Understanding profit margins supports sustainable growth and informed financial decisions. Now, let's take a look at the query and execute that. So we have selected the profit and sum division, and we'll be rounding off it as a profit percentage from DBA. This is just a simple mathematical calculation. And we have about 24% profit margin. That's really good. And now that brings us to question number 11, which is about platform-wise conversion efficiency. This is a little deep down. This analysis measures how effectively each sales platform converts visitors into paying customers. The goal is to identify which platforms are most efficient and which need improvement. Insights from these analysis help optimize marketing efforts and platform-specific strategies. Improving conversion efficiency ultimately drives higher revenue and better return on investment. Now let's go through the query. So here is our query. So we will be selecting platform, and we will also be selecting the orders and leads. So we will be dividing orders by leads, total orders by total leads, and we will be rounding off to 2 positions in the decimal value. And we will be aliasing it as lead to order conversion ratio and from DBA platform or the database. And we will be grouping the platform and order by lead conversion in descending order. So highest lead conversion platform is YouTube with 3.40 conversion. Next is WhatsApp, Instagram. So in the first question, we have seen YouTube to be in the second position in terms of leads, but WhatsApp is in the last position in terms of leads. Now the lead to conversion ratio speaks a different language. WhatsApp is in the top second, right? So based on this, you can strategize which platforms to focus more, pay more on marketing, right? So you can run some paid promotions on these platforms and expect good conversion ratios. And with that, we come to the last question in this particular analysis, which is about monthly sales trend. It could be a little advanced, but simple in execution. Don't worry about that. But let's understand the intent behind it. Monthly sales trend. This analysis tracks sales on a month-by-month basis to uncover seasonal patterns and short-term fluctuations. The goal is to identify peak periods, slow months, and emerging trends within the year. These insights help with inventory planning, marketing campaigns, and sales forecasting. Monitoring monthly trends ensures the business can respond proactively to demand changes. Now, let's go through the query and execute it and understand what's the output. So we are selecting the order date and we are splitting it from the date, and we're expecting only the month and year. And we'll also be using revenue column, and we'll be using the sum aggregate function as total revenue from the database DBA. Now let's execute the query. So here we have year on year until 2026. So month on month evaluations. So in the year, so we have total number of so and so numbers of total revenue generated every month of every year.
My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on NumPy arrays and pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. It is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might in the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Find the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our Discover It. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then averages the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph. Always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. The next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket, and it doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, directory, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible on Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. aggregate functions can be used. And the syntax is select column names from table, where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program. And what you come up with is you have, in this case, it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array, and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in pandas? Well, we can do it by initializing a list. So you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so it's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen, uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive: where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive: what can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set, population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling, that's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things a group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example: there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example: there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP ordered by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee, or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those two currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the dataset. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample superstore dataset. In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import NumPy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array, np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your NumPy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are two arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created two different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see in the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in sales rep and item onto row labels. It will give the sum of the cells made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select percentage of grand total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total cell. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table. Find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, two separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as cells. And then we have our pp.product.id from production product as pp inner join, cells.sales order detail as SOD on pp product ID equals SOD.product ID, group by pp.name, pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the sum, the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare a variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between 2 user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your 2 different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin, we're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstored dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np, random arrangement equals np.random.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the InUnique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where InUnique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplotlib. Plot a sine graph using NumPy and Matplotlib in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sine of x. If you print out x, you'll see a whole value here. Our Matplotlib PyPlot as PLT. If you're working in Jupyter Notebook, make sure you understand the Matplotlib inline, that little percentage sign Matplotlib inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, there's our groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
Now, let's get started with our course. And with that, we have come to the end of our course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply to you as soon as possible. Thank you and keep learning with Simplilearn.